The difference between integers and non-integers in 36 seconds. Let's go. A quick reminder then on the differences between our integers and our non-integers. Our integers are going to be our whole numbers. We could have, for example, 4, we could have 17, we could have -8, or we could have 0. 0, guys, is an integer. It is a whole number. And then our non-integers, guys, they're going to be our non-whole numbers. We could have decimals such as 0.8. We could have fractions like 3/4. And percentages, they're also technically non-integers such as 34%. That, guys, then is the difference between integers and non-integers. Square, cube, and prime numbers in 56 seconds. Let's go. Okay, guys, the difference between square, cube, and prime numbers, what's it going to be? As square numbers are going to be any numbers we get as a result of multiplying a number by itself. For example, 4 times 4 is 16, so 16 is a square number. We could also say that 81 is a square number because 9 times 9 is 81, and 144 is a square number. Why? Because 12 times 12 is 144. Now, what about cube numbers? Cube numbers are going to be any numbers we get as a result of multiplying a number by itself and then itself again. For example, 2 times 2 times 2 is 8, so 8 is a cube number, and we would say that 27 is a cube number because 3 times 3 times 3 is 27. Finally, we could say, for example, that 1000 is a cube number. Why? Because 10 times 10 times 10 is 1000. Finally, prime numbers. Prime numbers are going to be any numbers which have exactly 2 factors. For example, 2, 3, 5, 7, and 11. How to identify rational and irrational numbers in 40 seconds. Let's go. This is one which trips a lot of students up, guys. What's going to be the difference between rational and irrational numbers? Rational numbers are going to be any numbers that can be written as a fraction. That would include any whole numbers, such as 8, any terminating decimals, such as 0.4, and also any regular fractions we see. Let's take, for example, 1/4. Irrational numbers, they're going to be any numbers that we cannot express as a fraction with a whole number on the top and the bottom. These include, for example, the square root of 2, that's quite a common one, the square root of 7, and that magical number pi, which we use so often in maths. They're all going to be examples of irrational numbers, numbers which cannot be written as a fraction. How to find multiples and factors in 50 seconds. Let's go. You might be surprised, but this actually trips a lot of students up. Let's have a look. The multiples of a number, guys, are going to be any numbers which that number goes into, otherwise known as our times tables of that number. Let's say the first 5 multiples of 8, then what are they going to be? We're going to have 8. We're going to have 16, we're going to have 24, we're going to have 32, and we're going to have 40. What about factors then? What's going to be the difference? Well, our factors are going to be any numbers which go into that number. So in the case of 24, what are the factors of 24 going to be? Well, we're going to have 1 and 24. We're going to have 2 and 12, we're going to have 3 and 8, and we're going to have 4 and 6. That's because each of these numbers can be multiplied by another number to give 24. How to apply BIDMAS with numbers in 54 seconds. Let's go. BIDMAS is a useful acronym which describes the order of operations in a given calculation. Our B stands for brackets, I for indices, D for division, M for multiplication, A is for addition, and S is for subtraction. So let's say we want to do this calculation up here. What are we going to do first? Well, first we're going to deal with our brackets. We're going to do our 3 plus 2. So we write down our 4 times by 3 plus 2 is 5. So we're going to square that and subtract 6. Next step, we're going to deal with our I, which is our indices. So we're going to do that 5 squared. So we copy down our 4 times by 5 squared is 25. So we're going to write that in. Copy down our subtract 6. Next up D, but we don't have any division. So let's move on to our M for multiplication. 4 times by 25 is going to be 100. Copy down our subtract 6. And finally, guys, 100 take 6. That's going to be 94. And that is how we're going to apply BIDMAS. How to use BIDMAS with algebra in 49 seconds. Let's go. This is a super common exam style question, guys. How are we going to do it? Well, we're going to have to apply BIDMAS because we have a bunch of different operations going on. As we know, BIDMAS stands for brackets, indices, division, multiplication, addition, and subtraction. So we're going to go ahead and apply our operations in that order. First, our brackets. So we're going to copy down our 2x multiplied by, and then we're going to simplify our 2x plus 3x. That's going to be 5x. Copy down our subtract 4x squared. Next, we can do our multiplication. 2x times by 5x, what's that going to be? 2 times 5 is 10, and x times x is x squared. So we have 10x squared subtract 4x squared. Next up, 10x squared take 4x squared. That's going to be 6x squared, and there we have our answer. Don't forget, when we have algebraic terms, we also have to use BIDMAS. Prime factorizations in 56 seconds, let's go. This is a super common exam question, guys. Let's have a look. It asks us to express 150 as a product of its prime factors. What are we going to do? This is where we're going to use our factor tree. So we're going to write 150 at the top, and we're going to break it down into smaller and smaller factors until all that we are left with is prime numbers. So let's firstly write this as 15 times by 10. That's equal to 150. Neither of these are prime, so let's keep going. 15 can be written as 3 times by 5. We're going to circle both of these because they're both prime. And 10 can be written as 5 times by 2. Again, circle both of these because they're both prime. Finally, writing 150 as a product of its prime factors, then we're going to multiply our circled numbers together. We have 2 times by 3 times by 5 times by 5, and we can simplify this, giving it in product notation as 2 times by 3 times by 5 squared. How to find a lowest common multiple in 44 seconds, let's go. So, how are we going to find the lowest common multiple of 12 and 16? There are going to be a couple of different ways to do this, but the easiest one is going to be by far to just write out the multiples of both of the numbers and check which the lowest number is, which is in both of our lists. So, let's do that now. Our multiples of 12, what are they going to be? We're going to have 12, 24, 36, 48, 60, and so on. And our multiples of 16, we're going to have 16, 32, 48, 64, 80, and so on. And we can quickly see that the lowest number, which is in both of our lists, is 48. So that is going to be our lowest common multiple. How to find the highest common factor in 54 seconds, let's go. What's going to be the best way to find the highest common factor of 35 and 56, guys? It's going to be to write out our factors of 35, our factors of 56, and find the highest number, which is a factor of both. Let's do that now. Factors of 35, what are they going to be? Remember, these are the numbers which go into 35. We can have 1 times by 35, so they're both factors. 2 doesn't go, 3 doesn't go, 4 doesn't go. We can have 5 and 7. 6 doesn't go, and then we get back to 7, so we can stop there. What about 56? Our factors of 56. We have 1 and 56. We have 2 and 28. 3 doesn't go. 4, we have 4 times by 14. 5 doesn't go. 6 doesn't go. 7, does it go? Yep, 7 times by 8 is going to be 56. Again, we can stop there because we're going to repeat ourselves. We can see then that the highest number, which is in both lists, is 7. So that's going to be our highest common factor. How to use the Venn diagram method to find the lowest common multiple and the highest common factor in 102 seconds. Let's go. This, guys, is a pretty tricky topic, so pay close attention. Let's have a look. How are we going to find the lowest common multiple and the highest common factor of 24 and 90? One method, guys, would be to write out the multiples and the factors of both of these numbers and to do it that way, but that's going to take quite a long time. So here we're going to have a look at the Venn diagram method. Step number 1, guys, that's going to be to do a prime factorization of both of our numbers, and that's going to look like this. We can see that we can write 24 as 3 times by 2 times by 2 times by 2, and we can write 90 as 3 times by 5 times by 3 times by 2. Guys, if you're not sure how to do that, have a look at our video on prime factorizations. Next step, guys, that's going to be to draw out a Venn diagram, which is going to look like this. And we can see that we put all of the factors of our numbers into our Venn diagram. The factors which are in both 24 and 90, we put in the middle. We can see we have 1, 3 in both of them and 1, 2 in both of them. Then the factors which are only in our 24, which is going to be an additional 2 2s, we put in the only 24 side. And finally, we put the numbers which are only in our 90, the 5 and the additional 3 in the right-hand side of our Venn diagram. Now, guys, final step, to find our highest common factor, we're going to multiply the two numbers on the inside, in the kind of overlapping section, I should say, of our Venn diagram. Here we have 3 times by 2, and that is going to give us 6 as our highest common factor. And finally, guys, to find our lowest common multiple, what are we going to do? We're going to multiply all of the numbers in our Venn diagram. We can see that we do 2 times by 2 times by 2 times by 3 times by 3 times by 5. Guys, and when we do that, typing it into our calculator or working it out by hand, we're going to get 360 as our answer.
Adding integers, guys, is definitely one of the most important skills in the entire course. It's used in so many different types of questions. Let's have a look at how to do it using this example here. Here we get asked to calculate 4,872 plus 36,717. Guys, to do this, we're going to use a method called column addition. We're going to start off by writing one of our numbers on top of the other. In this case, I'm going to write 36,717 on the top, 36,717, and we're going to write below plus 4,872. You could have put the 4,000 on the top or the 36,000, doesn't matter either way, guys. Now, the next step is going to be to fill in all of our gaps with a 0. We can see that we have one gap over here, so we're going to fill it in with a 0. Now, I want to mention that you have to be super careful when writing one number on top of the other. We have to make sure that all of our columns line up. So we have to make sure that our ones are above our ones, our tens are above our tens, our hundreds and our hundreds, our thousands and our thousands, and finally our tens of thousands and our tens of thousands. Now, guys, we are ready to add each of our rows together in each of our columns. So we're going to start from right to left. We're going to do 7 plus 2 in the far right hand column. That is going to be 9. Moving one over to the left, we're going to do 1 plus 7. That is going to be 8, guys. Next up, we have 7 plus 8. Now, 7 plus 8 is going to be 15. We're going to write the 5 down below, and we're going to write the 1 on top of our 6. Now, this was because we actually got a number bigger than 10. When we get a number bigger than 10, well, I should say 10 or bigger, so 10 is included in that, we're going to write the 1 in the column to the left, and we're going to write the ones part of the number down below. So in the ones here, we had the 5 from the 15, and in the tens column, we had the 1. So we write the 1 on top of the 6, and we write the 5 down below. If, for example, the number was 27, because the tens part of that is a 2, we would write the 2 up above, and because the ones part of that was a 7, we would write the 7 down below where we wrote that 5. Next up, guys, we're going to add together the 1, the 6, and the 4. 1 plus 6 is 7, plus 4 is going to be 11. We can write the 1 down here below and the other one down here above. This was the second one from the 11, and this was the first one from the 11. Now, guys, finally, we're going to do 1 plus 3. That is going to give us 4. And I didn't mention, but we also technically added 0 there. But like I say, we don't need to do that because the 0 doesn't actually make a difference. Now, we have our answer, guys. 41,589, a little bit easier to read if we write that comma in there. Subtracting integers, guys, is another super important key skill. Let's have a look at this one here. This question asks us to calculate 34,942, subtract 1,289. Just like in column addition, guys, in column subtraction, we're going to start off by writing one of our numbers on top of the other. In this case, the number on the top is always going to be the first number, and the number on the bottom is going to be the one that we're subtracting. So it's going to be the second number over here. So we're going to start off by writing out 34,942 on the top. We're going to write a minus in there, and then we're going to write in 1,289. Now, again, with this example, guys, I've been super careful to make sure that my ones line up, my tens line up, my hundreds line up, my thousands line up, and also my tens of thousands. Again, just like with column addition, we're going to fill in those gaps. We're going to write a 0 in the gap here. Final step, guys, is going to be to do our subtractions working through from right to left. So what we're going to do is we're going to always subtract our bottom number from our top number. So in this case, we're going to do 2 subtract 9. However, whenever we get a subtraction that we can't do because we have a smaller number on the top than on the bottom, what we're going to do is we're going to borrow 1 from our number to the left. So because we can't do 2 subtract 9, we're going to turn this 4 into a 3. We're going to borrow 1 from it, and we're going to write a 1 in front of our 2, giving us 12. We can do 12 subtract 9. 12 subtract 9, guys, is going to be 3. So we can write that in. Next up, we're going to do our 3 subtract our 8. Again, we can't do that because 8 is bigger than 3. So we're going to borrow from our 9 this time. The 9 is going to turn into an 8. It's going to get 1 smaller, and we're going to write a 1 in next to our 3. So we're going to do 13 subtract 8, and that is going to be 5. A little bit nicer, this next one. 8 subtract 2, we can do that straight away. That's going to be 6. Then we're going to have 4 subtract 1. That is going to be 3. And finally, 3 subtract 0, guys. that is going to be 3 as well. So we actually have our answer now. It's going to be 33,653. So that is how we do column subtraction. Again, we line up our numbers, making sure this time that the number we're subtracting is on the bottom and the number we're subtracting from is on the top. Then we work from right to left, doing each of our subtractions. Whenever we can't do a subtraction because the top is smaller than the bottom, we're going to borrow 1 from the left, turn it into a 1 in front of that number, and then do our subtraction. Feel free to watch that one again, guys. We did it pretty quickly. Hopefully everything made sense.
The grid method for long multiplication in 76 seconds, let's go. This is going to be a super common question at the start of our exams, guys. Let's have a look. Calculate 342 times by 28. The grid method is going to be one method for doing this, so let's have a look. The first step is going to be to draw out our grid, which looks like this. We can see that we have 340 and 2 across the top. That's split up 342, and then 20 and 8 down the bottom, which is 28 split up. Our next step is going to be to do all of our multiplications. We're going to do 300 times by 20, 3 times 2 is 6, add on 3 zeros. We're going to do 300 times by 8, 3 times 8 is 24, add on 2 zeros. We're going to do 20 times by 40, 2 times 4 is 8, add on 2 zeros, 40 times by 8, 4 times by 8 is 32, add on a 0, 2 times by 20, that's going to be 40, and 2 times by 8 is 16. Our next step, guys, is going to be to add all of these numbers together. Here we can see that we have all of our numbers in a column, and we just need to add them up. 6 plus a bunch of zeros is going to be 6. 2 plus 4 plus 1 is going to be 7. We have 4 plus 8 is 12, plus 3 is going to be 15, right in our 5. Carry our 1, we have 1 plus 6 plus 2. That's going to be 9, guys, and we can see that our answer is 9,576. How to do column multiplication in 126 seconds. Let's go. Let's say, guys, we want to calculate 162 times by 18 using column multiplication. What are we going to do? Step number 1, we're going to write out our numbers in a column. We have 162 times by 18, making sure that we line up our units. Next, we're going to multiply each of our numbers by each of our numbers, making sure that whenever we go one column across, we add in a 0 before writing down our number. Let me show you what we mean. So first off, we're going to do 8 times by 2, and that is going to be 16. Next, we're going to do our 8 times by our 6, but because the 6 is one column across, we're going to write in a 0 first, then 8 times 6 is going to be 48. Next, we're going to do our 8 times by our 1. However, this time our 1 is 2 columns across. So we're going to write in 2 zeros before writing in our 8. Now, we need to multiply our 1 by each of our numbers. However, we're going to recognize that the 1 is 1 column across, so that's going to add in another 0 before each of our numbers. Let's have a look. So, first of all, 1 times by 2, that's going to be 2, but we're going to write in 1 0 because our 1 is a column across. Next, we're going to do 1 times by 6, but our 1 is 1 column across and our 6 is 1 column across, so we're going to write in 2 zeros altogether. So we're going to have 0, 0, 6. Finally, we're going to do 1 times by 1. However, because our 1 is 1 column across and our second one is 2 columns across, we need to write in 3 zeros in total. So we're going to write in 1, 2, 3 zeros, then we're going to have 1. Finally, guys, we can add together all of our numbers. Let's get it done. 6 plus a bunch of zeros, that's going to be 6. 1 plus 8 plus 2, that's going to be 11. Write in 1, carry our 1. 1 plus 4, that's going to be 5. Plus 8 is 13. Plus 6 is 19. Write in our 9, carry our 1. And finally, we're going to have 1 plus 1. That's going to be 2, guys, giving us our final answer of 2,916. Using the lattice method for multiplication in 81 seconds, let's go. This is a bit of a bonus method, guys, but it's pretty interesting, so let's have a look. How are we going to calculate 87 times by 32? Well, the first step is going to be to draw out a grid which looks like this. Now, this may look pretty weird at first, but let's break it down. Because we're multiplying a 2-digit number by a 2-digit number, we're going to have 2 rows and 2 columns. And what we can see is that we've also drawn these diagonal lines which come out to the bottom left-hand side. Our next step then is going to be to write our 87 across the top like this and our 32 down the right-hand side. Now we're going to multiply each of the numbers in the rows and columns to fill in our gaps. What are we going to have? Top right, we're going to have 7 times by 3, that's going to be 21. Bottom right, we're going to have 7 times by 2, that's going to be 14. In the top left-hand side, we're going to have 8 times by 3, that's going to be 24. And finally, bottom left, 8 times by 2 is going to be 16. Now what we're going to do is we're going to work across our diagonals like this, adding together each of the numbers. So starting from the bottom right hand side, we only have a 4. Then adding the numbers in this diagonal, 6 plus 1 plus 1 is 8. Adding the numbers now in this diagonal, 2 plus 4 plus 1 is going to be 7. And finally, we just have the 2 up here. Now we can read our number and it actually can be read across like this diagonally. So it's going to be 2,784. Hey, that was an interesting method. How to use the bus stop method in 105 seconds, let's go. Whenever it comes to dividing a large number by another number, the bus stop method is always going to be best. So how do we do it? Our first step is going to be to write out what we call our bus stop, which is this kind of rotated inverted L shape. Next, what are we going to do? We're going to write out the number we're dividing on the inside of our bus stop. Here we have 9,282, and we're going to write the number we're dividing by on the outside. Here we're dividing by 6. Next, we're going to go through and work out how many times the number on the outside goes into each of the numbers on the inside, making sure that whenever the number doesn't go in perfectly, we carry over the remainder. Let me show you what I mean. So, how many 6s go into 9? Well, there's going to be 1 6 in 9 because the second multiple would get us to 12, which is too big. However, 9 is going to be 3 bigger than 6, which is the multiple of 6 we used. So we're going to have to carry over our 3. Next, how many 6s into 32? We know that 6 times by 5 is 30. So it's going to go in 5 times. If we tried to go for another multiple of 6, it would have taken us to 36, which is too big. However, 32 is too bigger than the multiple of 6 we used, 30, so we're going to have to carry over our remainder of 2. Next, how many 6s into 28? It's going to go in 4 times. That's because 6 times by 4 is 24. 30 would have been too big. 28, however, is 4 bigger than the multiple of 4 we used, so we're going to carry over our remainder of 4. And finally, how many 6s into 42? Guys, it's going to go in 7 times exactly, so we can see that we now have our final answer. 9,282 divided by 6 is going to be 1,547. How to use the bus stop method with larger numbers in 97 seconds, let's go. This question asks us to calculate 1,680 divided by 48. Guys, how are we going to do it? Well, normally we would just use the bus stop method, but here we're in a little bit of a sticky spot. Why? Because 48 is a big number to have on the outside of our bus stop. So the first thing we're going to do is we're going to split 48 into 6 times by 8. What that means is that dividing by 48 is going to be the same as dividing by 6 and then dividing by 8. So we're going to do this in 2 stages. Firstly, dividing by 6 and then dividing by 8. Let's draw out our first bus stop. Write 1,680 on the inside and 6 on the outside. Now working through with the bus stop method. How many 6s go into 1? It's going to be 0, remainder 1. 6s into 16 is going to be 2, remainder 4. 6s into 48 is going to be exactly 8. And then 6s into 0 is going to be 0. So first stage done. Now let's do the second. We're going to do our 280 divided by our 8. How many 8s go into 2 is going to be 0, remainder 2. How many 8s into 28 is going to be 3, remainder 4. And finally, how many 8s into 40 is going to be exactly 5. So we can see that our final answer is going to be 35. That's how we're going to do bus stop method with larger numbers. Adding and subtracting negative numbers in 69 seconds, let's go. Here we have 4 questions, guys, which cover all of the different situations. Let's have a look. First off, we're going to do 4 subtract 9. So we're going to start at 4 on our number line, and we're subtracting a regular number, so we're going to move to the left. We're going to move 9 spaces, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we can see that we end up at negative 5, so that's going to be our answer. What about this time? Negative 2 plus 7. We're going to start at negative 2 this time, move 7 spaces to the right because we're adding a number, 1, 2, 3, 4, 5, 6, 7, and we can see that we end up at positive 5. What about this one then? A little bit trickier. We're going to be doing 5 plus minus 4. Now, whenever we add a negative number, we're actually going to take that number away. So this is the same as doing 5 minus 4. And again, we're going to start at 5 on our number line this time, and we're going to move 4 spaces to the left, 1, 2, 3, 4. We're going to end up at 1, so that's going to be our answer. And finally, 7 minus 11. Whenever we subtract a negative number, it's going to be the same as adding that number. So this can be swapped for an add, and we don't really need our number line here. 7 plus 11, that's going to give us 18. How to multiply and divide negative numbers in 45 seconds. Let's go. When it comes to multiplying and dividing negative numbers, guys, we're going to use the simple rule that whenever we have no negatives, our answer is going to be positive. Whenever we have exactly one negative, our answer is going to be negative. And whenever we have two negatives, the answer becomes positive. Again, let's have a look at these examples. 4 times by 7, we have no negatives here, so the answer is going to be positive 28. 6 times by negative 8, we have one negative here, and 6 times by 8 is 48, so we have minus 48. Likewise, in this next example, we have exactly one negative, so our answer is going to be negative. It's going to be minus 20. And finally, minus 8 times minus 11. 8 times 11 is 88, and two negatives here, so we have a positive. How to simplify fractions in 50 seconds. Let's go. To simplify fractions, guys, what we're going to need to do is we're going to need to divide our numerator and our denominator by any common factors until we can't do that any further. Let's have a look at these two examples. 14 over 35. Well, both of these numbers can be divided by 7, so we're going to divide top and bottom both by 7, and when we do that, we're going to get 2 over 5, which can't be simplified any further. What about 72 over 162? What are we going to do? Well, these are both multiples of 2, so firstly, let's divide top and bottom both by 2. 72 divided by 2 is 36, and 162 divided by 2 is going to be 81. And we can see that the numerator and the denominator both here have a common factor of 9. So we can divide top and bottom both by 9. And when we do that, we're going to get 4 over 9, our final answer, because this can't be simplified any further. How to write fractions as mixed numbers in 48 seconds. Let's go. How, guys, are we going to write the following fractions as mixed numbers? What we're going to do is we're going to work out how many times our denominator goes into our numerator. Then we're going to work out our remainder, and that's going to give us the fraction part. Let's have a look. So the multiples of 8 are 8, 16, 24, 32, and we can see pretty clearly that 8 is going to go into 27 3 times completely. So that's going to give us the number part. And what's our remainder? Well, 27 is 3 bigger than 24, so the remainder is going to be 3, and we're going to write that over our original denominator, which was 8. In the case of 47 over 9, what's it going to be? Well, 9 is going to go into 47 5 times fully. That's going to take us up to 45. So our remainder then is going to be 2, and that's because 47 is 2 bigger than 45. Finding a fraction of an amount in 36 seconds. Let's go. Luckily, this is not too bad, guys. What are we going to do? We're going to divide by our denominator and then multiply by our numerator. Let's have a look at these three examples. 3/4 of 36. We're going to do 36 divided by 4, which is 9, then times that by 3, which is 27. Moving on to our second one, 7/8 of 64. 64 divided by 8, that's going to give us 8. Then we're going to do 8 times 7, our numerator. That's going to be 56. And finally, 3/2 of 20. What are we going to do? We're going to do 20 divided by 2, which is 10. And then times that by our numerator, which is 3. And that's going to give us our answer of 30. How to write one number as a fraction of another in 46 seconds. Let's go. To write one number as a fraction of another, guys, what we're going to do is we're going to simply write our first number over our second and then simplify if we can. Let's have a look at these three examples. 3 is a fraction of 5. That's going to simply be our first number 3 over our second number 5, and we cannot simplify this because we have no common factors. What about 18 as a fraction of 27? Again, first number over second, 18 over 27, but this time we can divide top and bottom both by 9, and when we do that, we're going to get 2 over 3. Finally, last example, 14 as a fraction of 8. Again, first number over our second, 14 over 8. Again, we can simplify this, dividing top and bottom both by 2, we're going to get 7 over 4, our final answer. Writing fractions with common denominators in 48 seconds. Let's go. How, guys, are we going to express the following fractions with a common denominator of 28? What we're going to have to do is we're going to have to either multiply or divide the denominator of the fraction by whatever it takes to get it to 28, and then we're going to have to do the same to the top as we did to the bottom. Let's have a look to see what I mean. So 4 over 7. In order to get from 7 to 28, we're going to need to times it by 4. So we're going to do the same to the numerator. 4 times 4 is going to be 16. What about 3 over 14 then? To get from 14 to 28, we're going to need to times it by 2. So we're going to do the same to the top. 3 times 2 is going to be 6. Finally, 70 over 280. To get from 280 to 28, we're going to have to divide it by 10. So we're going to do the same to the numerator. 70 divided by 10 is going to be 7. And that is going to give us, guys, our answer.
This, guys, is a key skill which is really often used in our foundation papers. Let's have a look at this question here. This question asks us to shade 2/5 of the shape below, and then we're given this shape here which has 5 columns and 3 rows. Now, the best way to do this, guys, a method which is always going to work, is going to be to find the number of parts in our shape and then to find the fraction of that number and then to shade that number of parts. Let's get it done just like that. So step number 1, we're going to work out how many parts our shape has. Now, we could just count all of them. Counting from left to right, we're going to have 5 on the top row. That's going to be 5, another 5 in the middle row, I should say, another 5 on the bottom. 5 plus 5 plus 5, that's going to be 15. So we have 15 in total. A different way to do that would be to work out that there were 5 columns, 1, 2, 3, 4, 5, and that there were 3 rows, 1, 2, 3, and then to have done 5 times by 3, that is going to be another way to work out the total number of parts. That one's going to be extra helpful when we have, for example, 100 parts or 150 parts, then it's a little bit annoying to count them. So where do we go from there? We want to shade 2/5 of the shape. And here we have 15 parts of our shape. So we're going to find 2/5 of our total number of parts to the shape. To do that, we're going to do 2/5 of 15, so we're going to do 2/5 times by 15. Now, to multiply a fraction by a number, what we need to do, guys, is divide by the number on the bottom and then multiply by the number on the top of our fraction. So we're going to do 15 divided by 5, that is going to give us 3. So we're going to have 3 times by the number on the top of the fraction here is a 2. So we have 3 times by 2, which, guys, is going to be 6, telling us that we need to shade in 6 parts of our shape. It can be any of the 6 parts. We're going to go for 1, 2, 3, 4, 5, and 6. Just to reiterate, guys, it can be any 6 parts of that shape. I know a few of you might be thinking, well, because we had 5 columns, and we wanted to shade 2/5, we could have just shaded 2 of the 5 columns. Guys, if you were thinking that, you are absolutely right. The reason why I went through this method, like I said towards the start of the video, was because this is going to be super helpful when we have a larger number, for example, 50, 60, 70 parts in our shape. Guys, hopefully that was clear enough. Good luck with the next video. Questions like this, guys, which ask us to add mixed numbers, are actually getting more and more popular in exams, whether it's at Excel, AQA, OCR, higher or foundation. These questions are coming up all the time. Let's have a look. The key, guys, when it comes to adding mixed numbers is going to be to firstly write them as improper fractions, then to add those improper fractions by finding a common denominator, and then to, if we have to, convert that number back into a mixed number. Let's have a look and see how it's done for this example here. This one asks us to calculate 2 2/3 plus 1 4/5. Step number 1, guys, we're going to convert these mixed numbers into improper fractions. First off, 2 2/3, to convert this one into an improper fraction, we're going to do our 2 times by our current denominator of 3. That is going to give us 6. And then we're going to add that 2 on the top. That is going to give us 8. So we can write 2 2/3 as 8 over, and then we have our denominator of 3. Again, what did we do? We did our 2 times by our 3, that gave us 6, and then we added the 2 on the top of the fraction, that gave us 8 for the top, and that is over 3 because of the over 3 here. Now, applying that same principle to the 1 4/5, we're going to do 1 times by 5. That's the 1 here times by the denominator of 5. That, guys, is going to give us 5. And then we can do the 5 plus the numerator of 4. 5 plus 4 is going to give us 9. So we have 9 over 5 as our fraction here. The next step to this, guys, is going to be to add together these 2 fractions. How do we add fractions? We firstly find a common denominator. The quickest way to find a common denominator is going to be to multiply the 2 current denominators together. We can do 3 times by 5. That is going to give us 15 as a common denominator. So writing both of our fractions over 15, what are we going to have? To get from the 3 to the 15, we multiplied by 5. So we're going to do 8 times by 5. That is going to give us 40 as our new numerator. On the right-hand side, how do we get from 5 to 15? We multiplied it by 3. So we're going to do our 9 on the top times by 3. That is going to give us 27. We can simplify this, guys, adding together our fractions. We are just going to add those numerators because we have the same denominator now. So we can write this as 67 over 15. From there, guys, we can actually convert this back into a mixed number if we want to. How do we write a fraction as a mixed number? We're going to start off by seeing how many times our denominator goes into our numerator. So, writing out our multiples of 15, we're going to have 15, 30, 45, 60, and then 75. We can see clearly that 15 is going to go into 64 times because we have 1, 2, 3, 4 multiples of 15 before we get to a number which is bigger than that 67. So the whole number part of this is going to be 4. And then what are we going to have left over? Well, our fraction is out of 15, so we're going to have something over 15. Final step, guys, we're going to see how much bigger that numerator is than the multiple of 15 that we used. In this case, the multiple of 15 that we used was 60. 67 is going to be 7 bigger than 60, so we can write our answer as 4 and 7/15. I'm conscious here that my head blocked a little bit of this on the vertical video. Hopefully that was clear enough for you guys. 4 and 7/15. To summarize the steps, the process, what did we do? We firstly converted our two fractions into mixed numbers. I didn't mean that. To summarize the process, what did we do? We converted our mixed numbers into improper fractions. Then what we did was we rewrote our improper fractions over common denominators. We added the numerators, then we rewrote that as a mixed number. Guys, if that made sense to you, awesome, awesome, awesome. If not, consider watching it again.
Adding fractions in 56 seconds, let's go. When it comes to adding fractions, guys, what we're going to have to do is we're going to have to firstly rewrite our fractions over a common denominator, and then we're going to have to add only the numerators. Let's have a look at this first example. We're going to firstly rewrite both of our fractions over the common denominator of 12. How do we get from 4 to 12? We times it by 3, so we're going to do the same to the numerator. 1 times 3 is 3. And from 3 to 12, what do? We times it by 4. So we're going to times the top by 4 as well. 2 times 4 is 8. And then we're going to add only our numerators. 3 plus 8 is 11, so we have 11 over 12. What about this next example? Let's have a look. 8 and 12 both go into 24, so we're going to write them both over 24. From 8 to 24, we times it by 3, so we'll do 3 times 3 for the top. From 12 to 24, we times it by 2, so we'll do 7 times 2, which is 14 for the top. Adding then only our numerators. 9 plus 14 is 23, so we get our answer of 23 over 24. How to subtract fractions in 57 seconds. Let's go. Let's have a look at this couple of examples for subtracting fractions. What we're going to have to do, guys, is firstly rewrite our fractions with a common denominator and then subtract only the numerators. 7 over 6 subtract 1 over 4. Both of these can be written as fractions over 12. How do we get from 6 to 12? We times it by 2, so we'll do the same to the top. 7 times 2 is 14. What about from 4 to 12? We times it by 3, so 1 times 3 on the top is going to be 3. Next, we subtract only the numerators. 14 take 3, that's going to be 11, so we have 11 over 12. What about this next example? 17 over 6 take 2 over 9. Both 6 and 9 go into 18, so we can write both of these as fractions over 18. 6 times by 3 is 18, so we do 17 by 3 for the top, that's going to be 51, and then 9 times 2 is 18, so 2 times 2 for the top is going to be 4. 51 take 4, guys, we're going to get 47 as our numerator, giving us our answer of 47 over 18. Multiplying fractions in 41 seconds, let's go. Luckily, guys, multiplying fractions is not too bad. All that we have to do is multiply our numerator by our numerator to get our new numerator, and our denominator by our denominator to get our new denominator, and then simplify if we can. Let's have a look at these two examples. 3 over 5 times 5 over 12. To get our new numerator, 3 times 5 is 15, and denominator 5 times 12 is going to be 60. We can then simplify by dividing top and bottom both by 15 to get 1 over 4. Next up, 6 over 7 times by 3 over 8. Top by top gives us 18, and bottom by bottom gives us 56. Again, we can simplify, dividing top and bottom both by 2 this time. We're going to get 9 over 28 as our final answer. Dividing fractions in 50 seconds, let's go. To divide one fraction by another, guys, what are we going to do? We're going to use the method copy, swap, flip, or as some people like to call it, keep, flip, change, KFC. What we're going to do is we're going to copy down our first fraction. In this first example, it's going to be 4 over 7. Then we're going to swap our divide 4 8 times. Then we're going to flip our second fraction. 5 over 6 is going to go to 6 over 5. Then we're going to do our simple fraction multiplication times the top by top. 4 times 6 is 24, and the bottom bottom times the bottom. 7 times 5 is 35. Let's have a look at this next example. 3 over 4 times a half, copy. 3 over 4 swap. I'll divide 4 8 times and flip. 1 over 2 goes to 2 over 1. We can do 3 times by 2 to get our new numerator, 6. And we have 4 on the bottom. Simplifying this, divide top and bottom, both by 2. We get 3 over 2 as our final answer.
Questions like this, guys, which ask us to add mixed numbers, are actually getting more and more popular in exams, whether it's at Excel, AQA, OCR, higher or foundation. These questions are coming up all the time. Let's have a look. The key, guys, when it comes to adding mixed numbers is going to be to firstly write them as improper fractions, then to add those improper fractions by finding a common denominator, and then to, if we have to, convert that number back into a mixed number. Let's have a look and see how it's done for this example here. This one asks us to calculate 2 2/3 plus 1 4/5. Step number 1, guys, we're going to convert these mixed numbers into improper fractions. First off, 2 2/3, to convert this one into an improper fraction, we're going to do our 2 times by our current denominator of 3. That is going to give us 6. And then we're going to add that 2 on the top. That is going to give us 8. So we can write 2 2/3 as 8 over, and then we have our denominator of 3. Again, what did we do? We did our 2 times by our 3, that gave us 6, and then we added the 2 on the top of the fraction, that gave us 8 for the top, and that is over 3 because of the over 3 here. Now, applying that same principle to the 1 4/5, we're going to do 1 times by 5. That's the 1 here times by the denominator of 5. That, guys, is going to give us 5. And then we can do the 5 plus the numerator of 4. 5 plus 4 is going to give us 9. So we have 9 over 5 as our fraction here. The next step to this, guys, is going to be to add together these two fractions. How do we add fractions? We firstly find a common denominator. The quickest way to find a common denominator is going to be to multiply the two current denominators together. We can do 3 times by 5. That is going to give us 15 as a common denominator. So writing both of our fractions over 15, what are we going to have? To get from the 3 to the 15, we multiplied by 5. So we're going to do 8 times by 5. That is going to give us 40 as our new numerator. On the right-hand side, how do we get from 5 to 15? We multiplied it by 3. So we're going to do our 9 on the top times by 3. That is going to give us 27. We can simplify this, guys, adding together our fractions. We are just going to add those numerators because we have the same denominator now. So we can write this as 67 over 15. From there, guys, we can actually convert this back into a mixed number if we want to. How do we write a fraction as a mixed number? We're going to start off by seeing how many times our denominator goes into our numerator. So, writing out our multiples of 15, we're going to have 15, 30, 45, 60, and then 75. We can see clearly that 15 is going to go into 64 times because we have 1, 2, 3, 4 multiples of 15 before we get to a number which is bigger than that 67. So the whole number part of this is going to be 4. And then what are we going to have left over? Well, our fraction is out of 15, so we're going to have something over 15. Final step, guys, we're going to see how much bigger that numerator is than the multiple of 15 that we used. In this case, the multiple of 15 that we used was 60. 67 is going to be 7 bigger than 60, so we can write our answer as 4 7/15. I'm conscious here that my head blocked a little bit of this on the vertical video. Hopefully that was clear enough for you guys. 4 7/15. To summarize the steps, the process, what did we do? We firstly converted our two fractions into mixed numbers. I didn't mean that. To summarize the process, what did we do? We converted our mixed numbers into improper fractions. Then what we did was we rewrote our improper fractions over common denominators. We added the numerators, then we rewrote that as a mixed number. Guys, if that made sense to you, awesome, awesome, awesome. If not, consider watching it again. Multiplying mixed numbers like these, guys, is another really important skill. Again, this is one which has been coming up more and more in recent years. So how do we multiply one mixed number, here 1 1/4, by another mixed number, here 3 4/7? Well, just like with adding and subtracting our mixed numbers, the first step is going to be to rewrite these as improper fractions. So We're going to start off by converting 1 1/4 into an improper fraction. To do this, we're going to do our 1 times by our 4, that's going to give us 4. Then we're going to add our numerator of 1, that's going to give us 5. Writing this as an improper fraction then, we have 5/4. Now, what about this 3 4/7? Again, we're going to multiply this number on the left-hand side, the 3, by the denominator. Here it's a 7, so we're going to do 3 times by 7. That is going to give us 21. And then we're going to add the number on the top, the 4. That is going to give us 25 in total. So we have 25/7. Now, how do we multiply one fraction by another? We're going to multiply the numerator by the numerator and the denominator by the denominator. So on the top, we're going to have 5 times by 25. That is going to be 125. And on the bottom, 4 times by 7. That is going to be 28. Now, converting this into a mixed number, we're going to need to work out how many 28s go into 125. So let's start off by writing out our multiples of 28. We're going to have 28. We're going to have 56. We're going to have 84. We're going to have 112. Adding 28 again, what are we going to have? We're going to have 140. So how many times does 28 go into 125? We're going to have 1, 2, 3, 4 times completely, and then we're going to have a remainder. So it's going to go in 4 times completely. That is going to take us up to 112. So what can we do? We can move this down a little bit. Just give me a second, guys, and then we can write our whole number. That's going to be 4, and that's because it goes in 4 times fully. Then working out our remainder, how many bigger is 125 than 112? It's going to be 13 bigger. So we can write our remainder 13 over our fraction of 28, and we get our answer, guys, 4 13/28. So what did we do? We started off by converting our mixed numbers into improper fractions. From there, we multiplied our improper fractions. We got 125, I should say, over 28. Then we converted that into a mixed number. How many times does 28 go into 125? It goes in 4 times fully, with a remainder of 13, giving us that fraction of 13/28. Just like when it comes to adding and subtracting and multiplying, when we divide one mixed number by another mixed number, guys, the key is going to be to firstly write them as regular improper fractions, then to do our division, and then if we need to convert back into a mixed number. Luckily, in this question, they ask us to give our answer as a fraction, so that final conversion is not going to be necessary. So step number 1, we're going to be writing this as an improper fraction. We have 4 2/3. So we're going to do 4 times by our 3. That is going to give us 12, and then we're going to add our 2 from our numerator. 12 plus 2 is 14. So we have 14 over, and then our 3. Next up, we copy down our divide by, and then we have 2 1/5. 2 times by 5 gives us 10, and then 10 plus 1 is going to give us 11. So we have divide by 11/5. Next step, we're going to do our 14/3 divided by our 11/5. Now, guys, how do we divide one fraction by another? We use the method copy, swap, flip. In other words, keep, flip, change, KFC. So I'm going to use copy, swap, flip, or I'm just going to call it copy, swap, flip. They're actually the same method. So copy down our first one. We're going to have 14/3. We're going to swap our divide for a times, so we have times by, and then we're going to flip our final fraction. 11/5 is going to become 5/11. Final step, guys, this is going to be to do our multiplication. So we're going to do our top times by our top. 14 times by 5 is going to be 70. And then we're going to do our bottom times by our bottom. 3 times by 11 is going to be 33. Now, I don't want to block that with my head on the vertical video. Hopefully you guys can see over there. So 70/33, that is going to be our final answer. Any common factors to simplify? 11, 3, neither of them work. Neither does 1, because we can't divide by 1 when it's a fraction. Neither does 33. So that is going to be our final answer, guys, 70/33. What did we do? We converted our mixed numbers into improper fractions, and then we did the division of our fractions using copy, swap, flip.
Adding decimals in 50 seconds, let's go. When it comes to adding decimals, guys, the best method is by far going to be the column method. Let's have a look. Calculate 0.28 plus 0.042. Step number 1, let's write our numbers out on top of each other in a column. 0.28 plus 0.042. Step number 2, we're going to fill in any gaps that we have with a 0. We can see the only gap here is in the top right. We're going to put in a 0. Finally, we're going to do our additions working from the right to the left. 0 plus 2 is going to be 2. 8 plus 4 is going to be 12. Write in the 2, carry the 1. 1 plus 2 is going to be 3. And 0 plus 0 is going to be 0. Final step, absolutely crucial. We need to write in our decimal point just down there. And there we have our answer, 0.322. Subtracting decimals in 50 seconds, let's go. Just like when we add them, guys, the best method for subtracting decimals is going to be to use the column method. Let's have a look. Calculate 4.97, subtract 1.074. Step number 1. Let's write our numbers out on top of each other in a column. 4.97 on the top minus 1.074. Absolutely crucial, guys, that we line up our decimal points. Step number 2, let's fill in any gaps with zeros. We can see that there's only one gap here in the top right-hand side. And finally, we're going to do our subtraction. 0 take 4, we cannot do, so we take 1 from the 7, turn it into a 6. Write in our 1, 10 take 4, that's going to be 6. 6 take 7, we cannot do, so we borrow 1 from the 9, turn it into an 8, carry our 1. 16 take 7, that's going to be 9. 8 take 0, that's going to be 8. Write in our decimal point, and 4 take 1 is going to be 3, guys. We get our answer, 3.896. Multiplying decimals in 57 seconds, let's go. To multiply decimals, guys, what we're going to do is we're going to remove all of our decimal places. We're going to do our new multiplication, and then we're going to put all of our decimal places back in. Let's have a look at this example. Calculate 0.42 times by 0.17. Step number 1, let's remove our decimal places. We're going to turn 0.42 into 42 and 0.17 into 17. Next, we're going to do our new multiplication. We're going to do 42 times by 17 using our column method here. 7 times 2 is 14. Write in a 0. 7 times 4 is 28. Write in a 0. 1 times 2 is 2. Write in 2 zeros. 4 times 1 is 4. Then we're going to do our addition. 4 plus a bunch of zeros is 4. 1 plus 8 plus 2 is 11. Write in 1, carry 1. 4 plus 2 plus 1 is 7, and we're going to have 714 as the answer to 42 times 17. But finally, we need to put our decimal places back in. Firstly, we removed 4 decimal places, so now we need to put 4 decimal places back in. We need 4 numbers after the decimal point, so what we're going to have is 0.0714, so that we have 4 numbers after the decimal point. Dividing decimals in 58 seconds, let's go. This is going to be pretty tricky, guys, so pay close attention. Calculate 0.678 divided by 0.06. What are we going to do? Step number 1, we're going to multiply the number we're dividing by some power of 10 to remove all of the decimal places. Here we have 2 decimal places, so we're going to times it by 100, and that is going to give us 6. Next, we're going to do our division, dividing by this new number that we've just worked out. So inside of our bus stop, what are we going to have? We're going to have 0.678, and on the outside we're going to have 6. 6 is into 0 is going to be 0. Write up our decimal point. 6 is into 6 is going to be 1. 6 is into 7 is going to be 1, remainder 1, and 6 is into 18 is going to be exactly 3. Now, final step, we're going to multiply this number that we get here by the number that we multiplied the number we divided by in the first place. So we're going to do 0.113 times by 100. That is going to give us 11.3, our final answer. How to find a percentage of an amount with and without a calculator in 70 seconds. Let's go. The best method to find a percentage of an amount is going to depend on whether we do or don't have a calculator. I'm going to show you both. Firstly, 18% of 1,700 without a calculator. What are we going to do? Firstly, we're going to find 10%. We're going to get that by dividing our number by 10. That's going to be 170. And then we're going to find 1%. We're going to get that by dividing our 10% by 10. That's going to give us 17, which is 1/10 of 170. Now, what are we going to do? We're going to multiply our 1% by 8 to get 8%. We're going to do 17 times by 8. That is going to be 136. Now we can combine our 10% and our 8% to get 18%. So we're going to do 170 plus 136, which, if we work it out, is going to be 306. And that is our answer to 18% of 1,700. Now, with a calculator, what we're going to do is we're going to multiply our original number by our percentage written as a decimal. So in this case, we would have 1,700 times 0.18, which is 18% as a decimal. If we binged that into our calculator, guys, we would in fact get 306, the same as for the other method. percentage change with and without a calculator in 55 seconds. Let's go. Guys, how are we going to increase 108 by 11%? Firstly, without and then with a calculator. So without a calculator, we're going to find our 11% first. So we're going to find 10%, that's going to be 10.8. And then we're going to find 1%, that's going to be 1.08. And we're going to add those together to find 11%. That's going to be 11.88. Then to increase 108 by 11%, we're going to add on our 11%. So we're going to do 108 plus our 11%, which was 11.88. What are we going to get? We're going to get 119.88 as our answer. Though, what about with a calculator? We're just going to do our original number, 108, multiplied by 1 plus our percentage as a decimal. That's going to be 0.11. Typing that into our calculator, guys, we would get 119.88, exactly the same answer. How to write one number as a percentage of another in 47 seconds. Let's go. How, guys, would we express 18 as a percentage of 72? We're going to firstly express 18 as a fraction of 72, and then we're going to convert that fraction into a percentage. Let's have a look. So 18 as a fraction of 72, that's going to be 18 over 72. Then we can simplify this fraction. Firstly, let's divide top and bottom both by 2. We're going to get 9 over 36. And then we can divide top and bottom both by 9. That's going to give us 1 over 4. This is now something which is easier to convert to a fraction out of 100. We can times the denominator by 25. And we're going to do the same to the numerator. That's going to give us 25 over 100. The hard work is done now, guys. All we have to do is read the number on the top of our fraction, 25. So it's going to be 25% as our answer. Reverse percentages in 58 seconds. Let's go. This is a topic which trips a load of students up, guys. Let's have a look. We're told that a coat is reduced in price by 20% and the new price is £168. We're then asked how much the coat costed before it was reduced. What are we going to do? Well, we're told that it's been reduced by 20% and now it's £168. So what does that mean? It means that £168 is going to be 80% of our original price. Now, we can use this to find 1% of the original price. What are we going to do? To get from 80% to 1%, we can divide by 80. So we're going to do 168 divided by 80. That's going to give us 2.1, and that's going to be equal to 1% of our original price. The final step then to get from 1% to 100% is going to be to multiply by 100. So we're going to do £2.1, otherwise known as £2.10, times by 100, and that's going to give us our original price, guys, of £210. Working with percentages greater than 100 in 56 seconds, let's go. The key thing to note is this: percentages greater than 100 represent numbers greater than 1, and they work just like any other regular percentages. Let's have a look and see what I mean. Question number 1 asks us to express 1.47 as a percentage. We're going to follow the regular process and just multiply it by 100. We're going to do 1.47 times by 100, and that's going to give us 147% as our answer. What about this next one? 93 as a percentage of 30. Again, we're going to follow our regular procedure, writing it firstly as a fraction, 93 over 30. Simplifying it, we're going to write it as 31 over 10, dividing top and bottom by 3 there. Now we're going to multiply top and bottom both by 10. We're going to get 310 over 100, and finally we can read our number off the numerator. That's going to give us our percentage. We have 310%.
Guys, I would say that this is definitely one of the trickier types of percentages questions. Let's have a look at how to do it. This question says that a number is increased by X%, and that takes it from 40 to 48. We're asked then to calculate X. What is X? X is our percentage change when we go from 40 to 48. How are we going to find percentage change, guys? We're going to start off by finding our change, and then we're going to work that out as a percentage of our original number. So how do we work out our change? Well, we go from 40 to 48. What is our difference? We can do 48 subtract 40, that is going to be a difference of 8. So the actual change is 8. How do we find this as a percentage of 40? To find 8 as a percentage of 40, we're going to start off by writing it as a fraction. So we have 8 over 40. We're then going to convert this into a fraction which has 100 on the bottom. The numerator is then going to give us our percentage. So we're going to start off by dividing top and bottom both by 4. That is going to give us 2 on the top and 10 on the bottom. This is going to then be pretty easy to scale up to having 100 on the bottom. What do we multiply by 10? What do we multiply 10 by to get 100? We times it by 10. So we're going to do the same to our numerator there. We're going to do 2 times by 10. 2 times by 10, that is going to give us 20, giving us 100 as our fraction. Sorry, 20 over 100 is what I meant. That is a percentage then. 20 over 100, we just read that number on the top. Our percentage change, guys, is going to be 20%.
Decimal and percentage conversions in 55 seconds, let's go. This is a topic which comes up all the time, guys, and the key is this. To go from a decimal to a percentage, we're going to multiply by 100. And to go from a percentage to a decimal, we're going to divide by 100. Let's have a look at these 4 examples. To go from 0.38 to a percentage, we're going to times it by 100. That's going to give us 38%, moving that decimal point 2 places to the right. What about 0.02? Again, we're going to times it by 100. That's going to give us 2%. What about these percentage to decimals? 46.7. We're going to divide that by 100, moving the decimal point 2 places to the left. That's going to give us 0.467. And finally, 0.7. Again, we're going to divide it by 100. That is going to give us 0.007 as a decimal. Percentages and decimals as fractions in 42 seconds. Let's go. Okay, guys, how do we go from percentages and decimals to fractions? Let's have a look. To go from a percentage to a fraction, we're going to simply write our percentage over 100, and then we're going to simplify. Here we can divide top and bottom both by 2. That's going to give us 19 over 50. What about decimals then? With a decimal, we're going to firstly convert it into a percentage by multiplying it by 100. 0.48 times by 100 is going to be 48. Then we're going to write it out of 100. Now that it's a percentage, we have 48 over 100. This we can simplify, dividing top and bottom both by 4. We're going to get 12 over 25, which is our answer. How to express fractions as decimals and percentages in 76 seconds. Let's go. This question asks us to express the following fractions as decimals and percentages. Guys, what are we going to do? We're going to firstly write them as percentages and then convert those percentages into decimals. How though do we write them as percentages? What we're going to do is we're going to write our fractions out of 100. Then our numerators are going to give us our percentages. Let's get into it. So 7 over 10, what are we going to do? Well, writing this as a fraction out of 100, we're going to multiply our denominator by 10. To get from 10 to 100. So we'll do the same to our numerator. We're going to get 70. Then the number on the top is going to be our percentage. So it's going to be 70%. Converting that then into a decimal, we know how to do that. We divide by 100. We're going to get 0.7. What about 9 over 20? This time writing it over 100, we're going to times top and bottom both by 5. So we're going to get 45 over 100. Numerator is going to give us our percentage, 45%. Then as a decimal, divide by 100, 0.45. And finally, 12 over 25, again, writing it out of 100 times the denominator by 4 to get to 100. So we'll do the same to the numerator. 12 by 4 is 48. Copying down then our numerator, which is going to be our percentage, we have 48%. And as a decimal, divide by 100, 0.48.
This, guys, is a type of conversion question which actually trips quite a few people up. Let's have a look at how to do this one. This question asks us to convert 47 over 4 into a decimal. Now, what's a little bit different about this one? It's going to be the fact that we have an improper fraction here because the numerator is greater than the denominator. So what do we do? A couple of different ways to think about this one. My personal advice would always be to firstly convert this improper fraction into a mixed number, and then we can write the mixed number and then the fraction written as a decimal. Let me show you what I mean. So 47 over 4 into a mixed number. How many times does 4 go into 47? It's going to go in 11 times fully because 4 times by 11 is 44. 4 times by 12 would give us 48, which is too big, so it goes in 11 times fully. So the number part of our mixed number is going to be 11. And then what's the fraction going to be? Well, how many bigger is 47 than 44? It's 3 bigger, so we have 11 and 3/4. Where do we go from there then, guys? It's going to be a little bit easier from here, because what we can do is we can just write our 3/4 as a decimal and then add that onto the end of our 11. 3/4 as a decimal. To convert a fraction into a decimal, guys, what do we do? The best way is going to be to firstly write it as a fraction out of 100. So we're going to write down 3/4 is equal to something over 100. Now, how do we get from 4 to 100? We're going to times it by 25. So we're going to have to do the same to our numerator here. 3 times by 25, that is going to give us 75. So we have 75 over 100. That means that our percentage would be 75%. And our decimal would be 0.75. If you're not sure how to do that, guys, consider having a look back at my video on converting fractions into decimals and percentages. From here, guys, we know that our 3/4 is equal to 0.75, so we can write 11 and 3/4 as 11.75. So what we've done there is we've just swapped the fraction of 3/4 for our decimal of 0.75, giving us our final answer of 11.75.
Reoccurring decimals as fractions in 78 seconds, let's go. This is a tricky topic, guys, and best thought of as a process to be memorized, so let's have a look. Express 0.17 reoccurring as a fraction. What are we going to do? First step, we're going to write out x equals our decimal, 0.1717, etc. Then we're going to find powers of 10 of our decimal until we have 2 which have a match after the decimal point. Let's see what I mean. So firstly, we're going to find 10x. That's going to be equal to 1.7171, etc. And we're going to find 100x. 100x, moving the decimal point once more, is going to be 17.1717, etc. Now we can see that our x and our 100x have the same thing after the decimal point. So we're going to subtract our x from our 100x. That's going to cancel out the decimals. Let's have a look. 100x subtract x is equal to 17.17, etc. Take 0.17, etc. 100x take x, that's going to be 99x. And on the right, 17.171717 take 0.171717 is going to be 17. Finally, we can divide both sides by 99 to make x the subject. X is going to be equal to 17 over 99, guys. And remember, that was our original decimal, so we have our answer. How to write fractions as reoccurring decimals in 56 seconds, let's go. This question asks us to express 6 over 11 as a reoccurring decimal, guys. What are we going to do? Well, we're going to recognize that 6 over 11 really means 6 divided by 11, so that's what we're going to do using our bus stop. Let's draw out our bus stop. Let's put our 6 on the inside and 11 on the outside, write in a decimal and a few placeholder zeros, and we're going to also put a decimal on our top. Let's work through it. 11's into 6, that's going to be 0, remainder 6. 11's into 60 is going to be 5, remainder 5. Let's draw those in. 11's into 50, that's going to be 4, remainder 6, because it takes us to 44. 11's into 60 once again, we can see that it's 5. Again, we're going to have a remainder of 5 this time, and we can see that the pattern's going to repeat itself. 11's into 50, again, it's going to be 4, and so on and so forth. So our decimal is 0.545454, or in other words, 0.54 reoccurring. How to order integers in 130 seconds, let's go. Let's say we get asked to order these numbers from smallest to largest, guys. What are we going to do? Now, our first step is going to be to write out 4 columns which look like this. We can see that we have a column for our thousands, hundreds, tens, and ones. Our next step then is going to be to write out each of our numbers in these columns, making sure that we line up the units correctly. Let's get it done. First off, we have 4,464. Next up, we have 4,442. Up next, 4,003. And finally, 460. Making sure that we put our 4 in the hundreds column, our 6 in the tens, and our 0 in the ones. Next, we're going to fill in the one blank that we have down in the bottom left-hand corner. Finally, we're going to work across our columns from left to right, checking which the smallest number in each case is. Whenever we have two of the same number, we're going to have to move over to the next column. Let's see what I mean. So looking at our thousands column, what do we have? We have 3 4s and a 0. So this number is going to be the smallest because the 0 is smaller than all of the 4s. So 460 is going to be our first number. Let's write that in down here. And just to make things easier, we're going to cross out the 460 so we don't get confused. Now, because each of the other numbers have a 4, we're going to move on to our hundreds column. We can see that we have a 4, and a 0. Again, it's pretty clear that this number, 4003, is going to be our next smallest number because the 0 is smaller than the 4 and the 4. Let's write in that number then. We have 4003 as our next smallest. Again, we're going to cross that out to prevent confusion. Now, moving on to our next column, the tens. Why? Because we have a 4 and a 4 in the hundreds column, the same number, so we can't tell which is smaller. Looking at our tens, we see that we have a 6 and a 4. 4 is smaller than 6, so that's going to be our next smallest number, 4,442. Let's write that in and cross it out. And finally, the last remaining number, 4,464. Let's get that written in, 4,464. That's going to be our biggest number, and let's cross it out. How to order decimals in 143 seconds. Let's go. This is going to be very similar to ordering integers, guys. Let's have a look. This question asks us to order these numbers from smallest to largest, and we're given 4 decimals. What are we going to do? First step is going to be to draw out some columns which look like this. We can see that we have a column for our ones, our tenths, our hundredths, and our thousandths. Next step, we're going to write each of our numbers in, making sure that we line up our units correctly, and don't forget our decimal points. So in the first case, 0.012, we're going to have 0.012. Next, 0.2, we're going to have 0.2, nothing in our hundredths or thousandths. Next up, we have 0.27, and after that, 0.208. Now, crucially, next step, to make our lives easier, we're going to fill in all of our gaps with 0. We have 1, 2, 3 gaps to fill in. Next step, we're going to work across from left to right, checking in each case which our smallest number is. That's going to give us our next smallest number. Let's get it done. So we can't tell anything from our ones column because we have all the same number. Let's move on to our tenths, and we can see that we have a 0, 2, 2, and 2 because 0 is the smallest number here. 0.012 is going to be our smallest number. Let's write that in, 0.012, and we're going to cross that out just to prevent any confusion. Now moving on to our next column, because all of these numbers are the same, we can see in our hundredths column that we actually have a 0, a 7, and a 0. So we know that this number and this number are going to be smaller than this number, but because they both have zeros, we don't know which is going to be smaller. So we're going to move over to our next column, and we can see that our 0.2 has a 0 in the thousandths column, and our 0.208 has an 8. So we're going to know that 0.208 is bigger than 0.200. So that tells us that our next number is going to be 0.200. Let's write that in, 0.2, and we don't have to write in those zeros here. Next up, we know we're going to have 0.208 because that was our other one we were just talking about. 0.208. Finally, our last number then is going to be the last one remaining, 0.270. And again, when we write this out properly, we don't have to put that last 0 on. So we have 0.27 as our final and largest decimal. Ordering fractions in 88 seconds, let's go. This question asks us to order these numbers from smallest to largest and then gives us 4 fractions, guys. What are we going to do? When it comes to ordering fractions, our key is going to be to firstly write them over a common denominator and then to compare the numerators. Let's get it done. We need to firstly find a common multiple of 4, 12, 6, and 24. They all go into 24, so we're going to write them all with a common denominator of 24. Let's just prepare this now, all of them over 24. How do we get from 4 to 24? We times it by 6, so we do the same to the numerator. 1 times 6 is 6. From 12 to 24, we times it by 2, same to the numerator. 5 times 2 is 10. From 6 to 24, we times it by 4. Going to do the same to the numerator. 5 by 4 is 20. And finally, from 24 to 24, we just leave it the same, so we're going to do the same to our numerator. Now, guys, we can compare our numerators. to see which is our smallest, which go in the middle, and which is our largest. 6 over 24 is going to be our smallest because 6 is the smallest numerator. That was originally our 1 over 4. This is going to be followed by 10 over 24 because 10 is smaller than 20 and 17. That was originally our 5 over 12, so let's write that in. This is going to be followed by 17 over 24. Originally, that was also in the form 17 over 24. And finally, our last number is going to be 20 over 24, otherwise known as originally 5 over 6. That, guys, is going to be how we order our fractions. How to order negative numbers in 50 seconds, let's go. The best way to think about ordering negatives, guys, is going to be to use a number line. We can see here that we have a number line which goes from -5 to +5. And what I'm going to tell you is this. The further right on the number line in number is, the larger it is, and the further left on the number line in number is, the smaller it is. So, looking at these numbers here, -3, 6, 1, -1, and -4. The furthest left on the number line is going to be -4, so that's going to be our smallest number. The next number is going to be -3. That's because it's the next furthest left on our number line. This is going to be followed by -1, then by 1, and then by 6. Sometimes it's easy to get confused, but always remember to draw out a number line and think about the fact that the further right it is, the larger it is, and the further left it is, the smaller a number is. Rounding to decimal places in 55 seconds, let's go. To round to a certain number of decimal places, guys, this is what we're going to do. We're going to have a look at the number which is in the decimal place we're rounding to. In this first example, we're rounding to 1 decimal place, so we're going to have a look at the first decimal place, the first number after the decimal point, and we can see it's a 5. We're then going to have a look at the next number. We can see in this first example that it's a 7, and if it's 5 or above, we're going to round up. And if it's 4 or below, we're going to round down. In this case, because it's a 7, we do have 5 or above, so we're going to round up. We're going to turn this 5 into a 6, and we're going to get, as our answer, 4.6. What about this next example? 0.643 to 2 decimal places. This time, look at the number in the second decimal place. It's a 4. We're going to have a look at the next number now. We can see that it's a 3. Because this is less than 5, we're going to round down. That means that we're going to keep the 4 the same, and we're going to have our answer of 0.64. That's rounding to decimal places. How to round to a certain number of significant figures in 77 seconds. Let's go. The key thing to remember, guys, when rounding to significant figures is going to be that our first significant figure is the first digit in our number, which is not a 0, and then every single digit after that, even if it is a 0, is another significant figure. Let me show you what I mean with these 3 examples. First off, around 467 to 2 significant figures. Our first significant figure is our 4, our second is our 6, so we're going to look at our next one, which is going to be our 7, because it's 5 or above, we round up, and we get 470, turning that 6 into a 7. What about this next one? Around 0.0174 to 1 significant figure. Our first significant figure is going to be our 1, because that's our first non-zero digit. So we're going to look at our next significant figure, which is a 7, because it's 5 or above, we're going to round up, and we're going to get 0.02. Finally, what about this one? Around 0.1072 to 3 significant figures. This time, guys, our first significant figure is our 1, our second significant figure is our 0, because it's after a number, we're going to count it, and our third significant figure is our 7. So we're going to look at our next significant figure here, it's a 2, because it's below 5, sorry, we're going to round down, and that is going to give us 0.107 to 3 significant figures. Rounding to powers of 10 in 65 seconds, let's go. These 3 examples are going to show us everything we need to know, guys, when it comes to rounding to powers of 10. Let's have a look. First off, round 47 to the nearest 10. We're going to have a look at the number in our tens column. Here it's a 4. Then we're going to have a look at the next number. If it's 5 or above, we're going to round up, and if it's 4 or below, we're going to round down. Here we have a 7, so we round up, and the 4 becomes a 5. Then we fill in the rest of our digits as 0, so the next number, the 7, turns into a 0. What about then 1,146 to the nearest 100? Now we're going to have a look at the number in our 100s column. Here it's a 1. Then we're going to have a look at the next number. It's a 4. Because it's below 5, we're going to round down. That means that our 1 stays the same, so we get 1, 1. Then we fill in the last 2 digits with zeros, so we get 1,100. Finally, 3,467 to the nearest 1,000. What's it going to be? Let's have a look at the number in our thousands column. Here it's a 3. Then we have a look at the next number. It's a 4. Because it's below 5, we round down. The 3 stays the same. We get a 3. Then we fill in the rest of our digits with 0. We have 3 digits to fill in. So we get our answer, guys, of 3,000. Truncating decimals in 42 seconds, let's go. This, guys, is a topic which is forgotten about so often in revision. Let's have a look. First of all, how would we truncate 4.237 to one decimal place? Guys, when it comes to truncating a number, all that we're going to do is we're going to chop off every single number after the degree of accuracy that we're rounding to. Here we're rounding to one decimal place, so we're going to chop off every single number after our first decimal place. So we're going to chop off our 3 and our 7, guys, and our answer is going to become 4.2. What about this time, guys? Truncating 6.328 to 2 decimal places. This time, truncating to 2 decimal places. So we're going to chop off every single number after our second decimal place. Our second decimal place is our 2. So we're just going to chop off that 8 from the end. What are we going to be left with, guys? We're going to be left with 6.32 as our answer. How to estimate calculations in 66 seconds. Let's go. The key when it comes to our estimating questions is going to be to round all of the numbers in our calculations to a suitable degree of accuracy. What does that actually mean? It means round it to something which you can fairly easily work out by hand without a calculator. Let's have a look at this one. Estimate 98 times by 4.6 divided by 23.8. What are we going to do? I'm going to round our 98 up to 100. I'm going to round our 4.6 up to 5, and I'm also going to round our 23.8 up to 25. You could also round it down to 20. That would also be okay, but it's closer to 25, so we're going to go with that for now. Now let's simplify. This should be pretty easy to work out. 5 times by 100 is going to be 500. So we have 500 over 25. Now we can simplify top and bottom, dividing them both by 5 first of all. 500 by 5 is 100. 25 by 5 is 5. Now we have 100 divided by 5, which is going to be 20. And that is going to be our estimate. Guys, if we type this into our calculator, it would be 19.4 to one decimal place. So we can see that our estimate is pretty good. We're not too far off at all. Estimating roots in 59 seconds. Let's go. This is not going to be exact science, guys, but it's a useful method to know nonetheless. Let's have a look. How would we estimate the square root of non-square numbers such as 17? What we're going to do is we're going to use what we know about the square roots of other numbers to get a kind of ballpark estimate. Let's see what I mean. Well, we know that the square root of 16 is equal to 4. And we also know that the square root of 25 is equal to 5. Why is that useful? It's useful because 17 is in between 16 and 25, which means our square root has to be in between 4 and 5. Now, we also know that 17 is a lot closer to 16 than it is to 25, so our square root is going to be a lot closer to 4 than it is to 5. We're going to go with an estimate of 4.1. Why? Because 17 is only a little bit greater than 16, so our number is going to be only a little bit greater than 4. If we bring this into our calculator, guys, we would see, in fact, that the square root of 17 is equal to 4.12 something, 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 so we were pretty close. Applied estimating in 52 seconds. Let's go. Let's have a look at this question, guys, which asks us to estimate the area of a football pitch, which has a width of 62.6 meters and a length of 88.2. Now, how are we going to do this? Just like when we estimate calculations, we're going to round our measurements to a suitable degree of accuracy, which make the calculation a lot easier. How would we calculate the area of a football pitch? We would multiply the width by the length. So that's what we're going to do. But firstly, let's round them. 62.6, we're going to round that down to 60. That's going to be a lot easier to work with. And 88.2, we're going to round that up to 90. Again, a lot easier to work with. Now, timesing our width by our length, we have 60 times by 90. 6 times by 9 is going to be 54, and then we're going to whack on those 2 zeros, and our units, guys, meters squared. Why? Because we multiply one number in meters by another number in meters. Bounds and error intervals in 80 seconds. Let's go. These are super common questions at the start of our exam papers, guys. Let's have a look. When a number x is rounded to 2 decimal places, it gives 1.64. Write down the error interval for x. Now, the error interval for x is going to represent the different possible values that x could have been before it was rounded. And our answer is going to be this. Now, why is this our answer? We're told that x is greater than or equal to 1.635 and x is less than 1.645. Why do we write it like this? Well, 1.635 is the smallest number that would actually round up to 1.64 because of this 5 on the end. You'd round this 3 up to a 4, and it would give 1.64 to 2 decimal places. However, 1.645, that would actually round up to 1.65. However, we adjust for that fact by having a less than sign, which doesn't include 1.645. The biggest number is actually 1.644999999. However, it's not convenient to write down that reoccurring. That's why we write it like this. Now, what's a quick way to figure this out? The quickest way is going to be to just take 1 away from our last number and add a 5 onto the end to get our lower interval. And to get our upper bound, what we can do is simply put a 5 on the end of whatever number we have. That's going to be the quickest way. Bounds and error intervals involving calculations in 76 seconds. Let's go. This one's going to be tricky, guys. Stay with me. We're told that a football pitch is 49 meters wide to the nearest meter and 104.5 meters long to the nearest half meter. Then we're asked to calculate bounds for the area, guys. What are we going to do? Well, to find the smallest possible area, we're going to multiply the smallest possible length by the smallest possible width. And to find the largest possible area, we're going to multiply the largest possible length by the largest possible width. We can see here that we have bounds for our width and our length. The width is going to have to be between 48.5 meters and 49.5 meters. If you're not sure how to find that, watch our previous video on bounds. And our length is going to have to be between 104.25 meters and 104.75 meters. Now then, to find the smallest possible area, we're going to multiply the smallest possible width by the smallest possible length. And to find our largest possible area, we're going to multiply our largest possible width by our largest possible length. And we can see that when we bring that into our calculator, we're going to get 5,056.125 meters squared as our smallest possible area and 5,185.125 meters squared as our largest possible area. Guys, that was a mouthful. Hopefully it was clear enough. Combining upper and lower bounds in 117 seconds. Let's go. This is a topic which trips pretty much everybody up, guys. Let's have a look. We're told that Tom ran 100 meters to the nearest meter in 17 seconds to the nearest second. We're then asked to calculate bounds for Tom's average speed. Guys, what are we going to do? Just like with any other bounds calculation question, we're going to start off by finding bounds for our distance and our time, the two variables that were given in the question. We can see that the lower bound for Tom's time is going to be 16.5 seconds and the upper bound is going to be 17.5, and the lower bound for Tom's distance is going to be 99.5 meters and the upper bound is going to be 100.5. Now, where do we go from there? We need to recognize that to calculate our speed, we need to use the formula that speed is equal to distance over time. In other words, to find our speed, we take our distance and we divide it by our time. Here's where things get detailed. Now, to find the smallest possible value for our speed, we're going to need our numerator to be as small as possible. So we're going to need our smallest possible distance, and we're going to need our denominator to be as big as possible. So we're going to need our biggest possible time. We can see that this is represented in our bound by the 99.5 meters on the numerator and 17.5 seconds on the denominator. In the same way, if we wanted to calculate our upper bound for our speed, we're going to need the biggest possible distance, 100.5, and the smallest possible time, 16.5 seconds. However, one final thing to note is going to be this. Both of our inequality signs don't have the or equal to. Why is that? That's because we've used ingredients in both our lower bound and our upper bound that cannot actually be in our boundaries. So whenever we combine lower bounds with upper bounds, we need to make sure that both of our inequalities don't have any or equal to signs. How to find error intervals for truncated decimals in 91 seconds. Let's go. This is a topic, guys, which doesn't come up too often in exams. However, when it does, not many people get it right at all. Let's have a look at this one. The question says a number is truncated to 1 decimal place and becomes 4.7. We're asked to write down the error interval. The error interval, guys, is going to describe the different possible values that our number could have taken before it was truncated. We're going to call our number x, and we're going to have a less than or equal to sign here and a less than sign here. Now, what are our values going to be? The smallest possible value that x could have been before it was truncated is going to be 4.7. Why is that? That's because that's going to be the smallest possible number that when we chop off every single number after the 7 would give us 4.7. Try and wrap your head around that, guys. It's a little bit tricky. Now, what about on the right hand side? What are we going to have? If we think about it, the largest possible number that x could have been before it was truncated would essentially be 4.7. 99999 reoccurring. That would go on forever. Why? Because this is the number which is the largest possible number that when we chop off the values after the 7 would give us 4.7. In reality, it's not very practical to write 4.79999 reoccurring. So instead we use a less than sign instead of a less than or equal to sign to signify the fact that it's going to have to be less than 4.8. Now, the quickest way to think about this, guys, is simply going to be that the smallest possible value is going to be exactly the number that it was truncated to, and the largest possible value, to get that, we're just going to add 1 to the degree of accuracy that we rounded to.
Bounds questions like this, guys, have been coming up more and more in recent exams, and that's because so many students are getting confused with them. Let's have a look. The question says that some students have gone on a school trip to the theme park. We're told that there are 60 students to the nearest 10. We're asked to calculate bounds for the number of students on the trip. Guys, first off, why do so many people make mistakes? When we look at a typical bounds question, we look at the number that it's been rounded to, which is 60. We look at the degree of accuracy it's been rounded to, which is 10, and we say, okay, what's the smallest possible number and largest possible number that would round it down and up to this value? For a normal bounds question, our answer would be that 55 is less than or equal to x, which is less than 65. The reason is because that 55 is the smallest possible number that would round up to 60, and 64.99999 is the largest possible number that would round down to 60. Why don't we write 64.999? Instead of writing 64.999, we just write a not equal to sign here, so a inequality sign, I should say, which doesn't include the or equal to, and we say 65. So what this sign basically tells us is that x can be as close as possible to 65 without ever getting there, hinting that it's actually 64.99999. Now, why is this not the answer here? The reason that this is not the answer here is because you can't have 0.99999 of a student. This implies that the true range is between 55 and 64.999, when in reality, because we're working with numbers of students, we don't actually have that 0.999. Instead, our bound would actually look like this. We would have 55, the same on the bottom side, is less than or equal to x, which is less than or equal to 64 here. Again, why has this come about? This has come about because we cannot have that 0.999 of a student. The largest possible number of students is actually 64. Above that would be 65, which is not included in the boundary. So instead, with this bounds question, we do have the or equal to on the right-hand side of the bound, but instead of doing 65, we do 64. Hopefully that makes sense, guys. If you have any questions, make sure to let me know in the community page. I know this one might trip a few people up. I know there are also a few other good videos online.
Standard form conversions in 100 seconds. Let's go. To write numbers in standard form, guys, what we're going to do is we're going to write them as some number between 1 and 10 times by 10 to some power, where that power can either be positive in the case of writing bigger numbers in standard form or negative in the case of writing smaller numbers in standard form. Let's have a look at these 4 examples. 1758. Writing this as a number between 1 and 10 is going to be 1.758. times by 10 to some power. Now, what do we need to multiply this number by to get to our original number, 1758? Well, we moved our decimal point 1, 2, 3 places to the left, so we're going to have to multiply it by 10 to the power of 3. What about this next one, 274.2? Writing it firstly as a number between 1 and 10, we have 2.742. Now, what are we going to times it by? How many places did we move the decimal point? We moved it 1, 2 places, so it's going to be times by 10 to the power of 2. What about these examples with smaller numbers? First up, we have 0.0182. Writing it firstly as a number between 1 and 10, we're going to have 1.82. And how many places did we move the decimal point? This time we moved it 2 places to the right. Because we moved it to the right, our power is going to be negative, so we're going to have times by 10 to the power of -2. What about this next example? 0.784. Writing it as a number between 1 and 10, we have 7.84 times by how many places did we move the decimal point? We moved it 1 place to the right this time, so our power is going to be -1, and that's going to be our final answer. Adding and subtracting in standard form in 89 seconds, let's go. To add or subtract numbers in standard form, guys, the key is going to be to firstly convert them out of standard form, then to do our addition or subtraction using column method, then to write it back into standard form if we have to. Let's have a look at this example to show what I mean. Firstly, let's convert 1.48 times by 10 to the power of 4 out of standard form. Timesing it by 10 to the power of 4, that's going to move our decimal point 4 places. Moving it 1, 2 is going to get rid of those decimal places. Then we're going to move it 2 more places, so that's going to add 2 zeros on the end. We're going to get 14800. What about then 3.78 times by 10 to the power of 2? This time, because the power on the 10 is a 2, we're going to have to move the decimal point 2 places, 1, 2. We're going to get 378. Now what we can do is we can line our numbers up and add them using the column method. We have 14,800 plus 378. Make sure you line them up properly. 0 plus 8 is going to be 8, 0 plus 7 is going to be 7, 8 plus 3 is going to be 11, write in the 1, carry the 1, 1 plus 4 is going to be 5, and then we have our 1. Our final answer then, guys, is 15,178. We could, if we wanted to, write this in standard form. What's it going to be? Writing it as a number between 1 and 10, we're going to have 1.5178. How many places did we move our decimal point? We moved it 1, 2, 3, 4 places, so our power is going to be 4. That's going to be our answer in standard form. Multiplying and dividing in standard form in 64 seconds, let's go. This is not the most intuitive method, guys, so pay close attention when it comes to multiplying numbers in standard form. What we're going to do is we're going to multiply our number by our number. In this case, 3.2 times by 3, that's going to be 9.6. And we're going to multiply our 10 to the power by our 10 to the power. Now, thinking back to our laws of indices, when we have a base to a power and we multiply it by the same base to another power, we add those powers. So in this case, 10 to the power of 6 is what we're going to get, because 4 plus 2 is going to be 6. Now, what about in the case of dividing? It's pretty similar, but a little bit different. In the case of dividing, what we're going to do is we're going to do our number divided by our number. 4.8 divided by 4, that's going to be 1.2. And then we're going to do our 10 to the power divided by our 10 to the power. In this case, 10 to the 7 divided by 10 to the 3. Again, think back to our laws of indices. When we divide a base to a power by the same base to another power, we subtract those powers. So 7 take 3, that's going to give us 4 as our new power, guys. And that is multiplying and dividing in standard form. Squaring and square rooting in 49 seconds, let's go. So what does it mean to square and square root a number? To square a number means to multiply that number by itself. For example, we would have 4 squared as 4 times by 4, which is 16. 7 squared as 7 times by 7, which is going to be 49. 1 squared as 1 times by 1, which is just 1. And negative 8 squared as negative 8 times by negative 8, which is going to be positive 64. And square rooting, what's that then? Square rooting is going to be to find what number we multiply by itself to give that number. For example, the square root of 16, that's going to be 4. Why? Because 4 times 4 is 16. The square root of 81, that's going to be 9, because 9 times 9 is 81. The square root of 1, and that's just going to be 1, because 1 times 1 is 1. And finally, the square root of 9, that's going to be 3. Why? Because 3 times 3 is 9. Powers and roots greater than 2 in 72 seconds, let's go. Sometimes, guys, questions are going to ask us to calculate powers and roots which are greater than 2. What do we do in those situations? Let's have a look at these examples. First off, 4 to the power of 3. 4 to the power of 3 is going to be 4 times by 4 times by 4. And we've done it 3 times. Why? Because the power is 3. If we multiply those out, we're going to get 64 as the answer to 4 cubed. What about then 2 to the power of 5? Well, that's going to be 2 times by 2 times by 2 times by 2 times by 2. Again here, because the power is 5, we have 5 2's multiplying by each other. What's that going to be? If we multiplied it out, it's going to be 32. Now, what about these roots? If we want to work out the third root of 27, also known as the cubed root, we need to find the number which, when we multiply it by itself and itself again, gives us 27. That's actually going to be 3, because 3 times 3 times 3 is 27. Finally, the fifth root of 32, that is going to be asking us what number, when we raise it to the power of 5, gives us 32. And luckily earlier we worked it out. We saw that 2 to the power of 5 was 32. That means that the fifth root of 32 has to be 2. Powers of 0 and 1 in 42 seconds. Let's go. Luckily, guys, when we know what to do with them, powers of 0 and 1 aren't too bad. Any number to the power of 0 is going to be 1. So we could say that 3 to the power of 0 is going to be 1. 72 to the power of 0 is also going to be 1. And x to the power of 0 as well is going to be 1. Any number to the power of 0 is 1. What about, though, all of our powers of 1 over here? What's going to be the rule? The rule is going to be this. Any number to the power of 1 is just itself. So 12 to the power of 1 is going to be 12. 587 to the power of 1 is going to be 587. And finally, y to the power of 1 is going to be y. Those guys are our powers of 0 and 1. Simplifying powers in 48 seconds. Let's go. When it comes to simplifying powers, guys, there are going to be 3 main cases to be aware of. Let's have a look. First off, when we have a number to a power and we multiply that by the same number to another power, what we're going to do is we're going to add those powers together. Here, x to the power of 2 times by x to the power of 4, that's going to be x to the power of 6, because 2 plus 4 is 6. Now, what about in the dividing case? When we have a number to a power and we divide that by the same number to another power, we're going to subtract the powers. Here, we're going to have 8 to the power of 6 again. This time it's because 8 subtract 2 is going to give us 6. Finally, when we have a number to a power and we raise that whole thing to another power, what we're going to do is we're going to multiply those powers together. In this case, 5 times by 3 is going to give us 15. So we have x to the power of 15 as our final answer. How to work with negative powers in 44 seconds. Let's go. The key when it comes to working with negative powers, guys, is that we're going to make it 1 over whatever it otherwise would have been. Let me show you what I mean. First off, 3 to the power of negative 2. Because the power is negative, we're going to make it 1 over. And then we have our 3 to the power of 2. 3 to the power of 2, that's going to be 9. So we can write our answer as 1 over 9. What about this next one? 4 to the power of negative 3. It's going to be 1 over, because the power is negative, 4 to the power of 3. 4 to the power of 3, guys, that's going to be 4 times by 4 times by 4, which is going to be 64. So we have 1 over 64. This final example, x to the power of negative 2, we could write this as a fraction, writing it as 1 over x to the power of 2, 1 over whatever it otherwise would have been. That's going to be our 3 examples. How to work with fractional powers in 65 seconds. Let's go. Whenever we're dealing with a fractional power, guys, what we're going to do is we're going to take the root of whatever number is on the bottom of our fraction and then raise the result to the power of whatever's on the top of the fraction. Let's have a look at these 3 examples. First off, 27 to the power of 2 over 3. Firstly, we're going to take the third root of 27 because we have a 3 on the bottom of our fraction, and then we're going to raise it to the power of 2 because we have a 2 on the top. The cube root of 27 is going to be 3, so we have 3 to the power of 2, which is going to be 9. What about then 16 to the power of a half? First off, we're going to raise it to the second root because we have a 2 on the bottom. Then we're going to raise it to the power of 1 because we have a 1 on the top. The square root of 16 is going to be 4. 4 to the power of 1. That's just going to be 4 because any number to the power of 1 is itself. And finally, 49 to the power of 3 over 2. First off, we're going to square root it because we have a 2 on the bottom of the fraction. Then we're going to raise it to the power of 3. The square root of 49 is going to be 7. We're going to raise that to the power of 3. 7 times by 7 times by 7. That's going to be 343, guys. Our final answer for our final question.
A lot of students know how to raise a number to a negative power. However, not many at all know how to raise a fraction to a negative power. So what do we do when we have a question like this, for example, which asks us to do 2 over 3 to the power of negative 3? Let's say we had a regular number to a negative power. We would have to do 1 over whatever that otherwise would have been. What about in the case of a fraction? In the case of a fraction, it's actually exactly the same, but the effect of that we can kind of think of simply as just that it flips that fraction. So 2 over 3 to the power of negative 3 is going to be 1 over 2 over 3 to the power of 3, which actually becomes 3 over 2 to the power of 3. So the negative here makes a fraction 1 over, which flips that fraction. So here we have 3 over 2 to the power of 3. To raise a fraction to a power, we do the top and the bottom both to that power. So on the top, we're going to have 3 cubed, 3 times 3 times 3. That is going to be 27. And on the bottom, we're going to have 2 cubed, 2 times by 2 times by 2. That is going to give us 8. So we get our answer 27 over 8. Summarizing the method, what we do is we flip that fraction and raise it to the power, just as we would with any other fraction.
The 6 laws of surds in 114 seconds, let's go. Let's have a look at the 6 laws of surds, guys. What are they going to be? First off, whenever we multiply one surd by another surd, we're going to multiply the number outside by the number outside and the number inside by the number inside. In this case, on the outside, we're going to have 2 times by 4, which is 8. And on the inside, we're going to have 3 times by 5, which is 15. What about the second one then, guys, which is dividing one surd by another? What are we going to do? Very similar to multiplying. We're going to divide the number outside by the number outside and the number inside by the number inside. Let's get it done. On the outside, we're going to have 6 divided by 2. That is going to be 3. And on the inside, we're going to have 14 divided by 2. That is going to be 7, giving us our answer of 3 root 7. Next up, what do we do when we add one surd to another surd and crucially we have the same number inside the surd? What we're going to do is we're going to simply add the numbers on the outside and leave the number on the inside. In this case, 3 lots of root 5 plus 4 lots of root 5, that's going to be 7 lots of root 5. What about this next example then? Law number 4, where we're again adding 2 surds, but this time we have a different number on the inside. In the first one, we have a 3, and in the second one, we have a 5. Guys, in this case, there is absolutely nothing we can do to simplify. So I'm going to put a cross there. We cannot simplify 2 root 3 plus 4 root 5 because they have different numbers on the inside of the surd. What about number 5 then, which involves taking the square root of a fraction? What we're going to do is we're going to separate this, taking the square root of the numerator and the square root of the denominator separately. The square root of 9 we know is going to be 3, and the square root of 16, guys, we know that's going to be 4, so we can write this as 3 over 4. And finally, what would we do if we have a surd in brackets added to a regular number and we square that? What we have to remember, guys, is to multiply the whole bracket by the whole bracket. So in this case, we're going to have 2 plus root 3 times by 2 plus root 3. We're going to have to expand these double brackets using FOIL and then simplify our answer, which, guys, if we did, would give us 7 plus 4 root 3. See if you can prove why that is. Simplifying surds in 59 seconds, let's go. When it comes to simplifying surds, guys, the key is going to be to firstly write it as the square root of a square number times by the square root of another number, and then to simplify the square root of the square number because we can actually calculate that. Let me show you what I mean. Firstly, the square root of 27, what's it going to be? Well, we know that 9 times by 3 is 27, and 9 is a square number. So we can write this as the square root of 9 times by the square root of 3, and then because 9 is square, we can calculate the square root of 9 is going to be 3, so we can write this as 3 root 3. What about this next one then? The square root of 72. We know that 36 times by 2 is 72, and 36 is a square number, so we can write this as root 36 times by root 2. The square root of 36 is going to be 6, so we can write this as 6 root 2. Finally, what about the square root of 300? Well, we know that 100 times by 3 is 300, and 100 is a square number, so we can write this as root 100 times by root 3. Root 100 is going to be 10, so this is going to be 10 root 3, guys, and that is going to be our final example. Rationalizing when we only have one number on the bottom in 46 seconds, let's go. This question asks us to rationalize 5 over the square root of 2. First of all, what does it even mean to rationalize a fraction? What it means is to rewrite the fraction in another form without a surd on the bottom. So how are we going to do it? Well, what we're going to do is we're going to multiply the numerator and the denominator by the current denominator. Let me show you what I mean. First off, let's rewrite our fraction 5 over the square root of 2. Then, because we have a root 2 on the bottom of our fraction, we're going to multiply the top and the bottom by the square root of 2. What's that going to give us? On the top, we're going to get 5 times by root 2. That's just 5 root 2. And on the bottom, root 2 times by root 2. Root 2 times root 2 is root 4. And root 4 is just 2. So we're going to get 5 root 2 over 2. And we can see that we've gotten rid of our surd. So this has been rationalized. Rationalizing fractions with more than one number in the denominator in 97 seconds, let's go. This is definitely one of the trickiest topics in the course, guys. Pay close attention and see if you can get it. This question asks us to rationalize 3 over 3 plus root 2. What are we going to do? Well, we're going to have to multiply our numerator and our denominator both by our denominator. However, we're going to have to swap our plus for a minus. Why? Because there are two numbers on the bottom. Let's have a look and see what I mean. So we're going to firstly copy down our fraction 3 over 3 plus root 2, and then we're going to multiply the top and the bottom both by the bottom, but we're going to swap the plus for a minus. So on the top, what are we going to have? Well, we have 3 times by 3 minus root 2. We're going to do 3 times by 3, that's going to be 9, and then 3 times by minus root 2, that's going to be minus 3 root 2. What about the bottom? We have 3 plus root 2 times by 3 minus root 2. We're going to have to multiply each of our numbers by each of our numbers. This is going to be easiest by writing them out as double brackets. Let me show you what I mean. We have 3 plus root 2 times by 3 minus root 2, and we're going to expand these. 3 times by 3, that's going to be 9. 3 times by minus root 2, that's going to be minus 3 root 2. Root 2 times by 3, that's going to be plus 3 root 2. And then we have root 2 times by minus root 2, that's going to be minus root 4. Now, we can see that minus 3 root 2 and plus 3 root 2 are going to cancel each other out. So we're going to be left with 9 minus the square root of 4. What's the square root of 4? It's going to be 2. So we have 9 minus 2, that's going to be 7. So we can see, guys, that 3 plus root 2 times 3 minus root 2 is going to be 7. So that's going to be our denominator. And now we have rationalized our fraction because we've removed all of these surds from the bottom.
When it comes to expanding and simplifying double brackets like these guys, we're normally going to be dealing with quadratics. We're normally going to have an x at the start of the first bracket, an x at the start of the second bracket, two numbers, and then we're going to have to use the FOIL method to expand those double brackets. Now, when we expand double brackets with surds, we're actually going to be using a very similar method. In fact, it's pretty much the same method. We're going to be using FOIL again. So we're going to multiply each of the terms in our first bracket by each of the terms in our second bracket. What does FOIL stand for? FOIL stands for first, outer, inner, and last. We're going to multiply the first number in the first bracket by the first number in the second bracket. Then we're going to multiply our outer number by our outer number. Next up, our inner number by our inner number, and then our last number in the first bracket with the last number in the second bracket. Now, we're going to have to use our knowledge of multiplying surds here to finish this off. So, what are we going to have? We're going to have, first off, 2 times root 3. That is going to be our first. So, we have 2 times root 3. That is going to be 2 root 3. Next up, our outer, 2 times by minus 2 root 2. That is going to be minus 4 root 2. Next up, we're going to have our inner. That's going to be 2 root 3 times by root 3 over here. We're going to do our number inside the surd times the number inside the surd. We're going to do square root 3 times square root 3. That, guys, is going to be the square root of 9. So we can write this as plus 2 root 9. Let me write that plus in there. Next up, guys, 2 root 3 times by minus 2 root 2. We're going to do the number on the outside times the number on the outside. 2 times minus 2, that is going to be minus 4. And then the number on the inside times by the number on the inside. So we're going to do our 3 times by our 2. That, guys, is going to give us 6. Next step, can we simplify this? We can't do anything with these surds, root 3, root 2, and root 6. However, we can simplify this root 9 over here. The square root of 9, guys, we know that is going to be 3. So we can actually think of this as 2 times by 3. Instead of 2 times root 9, 2 times 3 is 6. So we can actually rub that out, or on a new line of working out, swap our 2 root 9 for 2 times 3, which is 6, giving us our final simplified answer, guys. 2 root 3 minus 4 root 2 plus 6 minus 4 root 6.
Collecting like terms in 69 seconds, let's go. When it comes to collecting like terms, guys, the key is going to be to remember that we only combine the terms which have the same variables attached to them. Let me show you what I mean. In this first example, we have 2x plus 3x plus 4y minus 2y. We're going to combine the terms which have an x in them with the terms which have an x in them, and the terms in y with the terms in y. First of all, 2x plus 3x, we have 2 lots of x plus 3 lots of x. That's going to be 5 lots of x. And then we have added to that 4 lots of y minus 2 lots of y. That's going to give us 2 lots of y in total. What about this next example? We're going to combine the terms in x squared with the term in x squared. We have 3x squared minus x squared. That's going to be 2x squared, because when we don't see a number next to the x squared, that symbolizes the fact that it's actually 1x squared. We're going to combine the terms in x with the terms in x. We have 3x minus x. That's going to give us plus 2x. And finally, we're going to combine the terms in y with the terms in y. We have plus 5y minus 2y. That's going to give us plus 3y altogether. Remember, guys, the terms in x squared go with the terms in x squared. The terms in x go with the terms in x, and the terms in y go with the terms in y. We can only combine the terms which have the same combinations of variables. Multiplying in algebra in 49 seconds, let's go. When it comes to multiplying in algebra, guys, the key thing to note is that we're always going to multiply our numbers by our numbers and our individual letters by our individual letters. Let me show you what I mean. First off, 3x squared times by 4xy squared. What's it going to be? Numbers by numbers. 3 times by 4, that's going to be 12. X squared times by x, that's going to be x cubed. And finally, we tag on our y squared at the end. What about this next example? We have 5x times by 2y times by 3x cubed times by y squared. First off, our numbers by our numbers. 5 times 2 is 10, times by 3 is going to be 30, so we have 30. Then our individual letters, our x's, we have x times by x cubed, that's going to be x to the power of 4. And finally, y times by y squared, that is going to be y cubed. Last up, our last example, 3x times by y squared times by 2z squared times by x cubed times by z. First off, our numbers by our numbers. 3 times by 2, that's going to be 6. Next up, our x's, we have an x over here and an x over here. X times by x to the power of 3, that's going to be x to the power of 4. What about our y's? We have only one number in y, so that's going to be y squared that we have. And finally, z squared times by z, that's going to give us z cubed, guys, as our final part to our final question. Substitution in 54 seconds, let's go. Let's say we're asked to calculate the value of 2x plus 7 when x is equal to 4. Guys, what are we going to do? Well, what we're going to have to do is we're going to have to do what's called substitute in our value of x to our expression. So we know that x is equal to 4, so we can write this as 2 times by 4. Originally it was 2 times by x, so we swap x equals 4 plus 7. 2 times by 4 is going to be 8, so we have 8 plus 7. That's going to give us 15 altogether. What about this next example? Calculate the value of 2x squared minus 7y when x equals 4 and y equals 2. Guys, it works exactly the same as before, but this time we sub in one value for x and one value for y. Let's get it done. So we're going to have 2 times by x squared, so 2 times by 4 squared minus 7 times by y, so 7 times by 2. 2 times by 4 squared. 4 squared is 16 times 2, that's going to be 32, minus 7 times by 2, that's going to be 14. 32 take 14, that, guys, is going to be 18, giving us our answer.
This, guys, is a crucial key skill for both foundation and higher students. Let's have a look at how to do this question. This question says that Jane's distance from home at time t is given by the formula d is equal to 0.2 plus 4t. We're then asked to find Jane's distance from home when t is equal to 2. Guys, what are we going to do? We're actually going to sub our value of t into our formula. We know that our distance is equal to the number 0.2 plus 4 times the value of t. We also know that the value of t is 2, so we can substitute that into our formula. What are we going to get? We're going to get that d is equal to 0.2 plus 4 times by t. T is 2, so we have 0.2 plus 4 times by 2. We can simplify this, guys. This is going to be 0.2 plus 4 times by 2 is 8, so it's 0.2 plus 8. 0.2 plus 8, guys, that is just going to be 8.2, giving us our answer to this one. Our distance is going to be 8.2, and I haven't actually put a unit in there. Let's just go with kilometers for this one. Distance, 8.2 kilometers.
Understanding key vocabulary in 87 seconds, let's go. This is a topic which drives students crazy, guys. Let's have a look. First of all, we have an expression which might look like this. 2x squared plus 4x plus 2 can be a combination of letters and numbers. However, the key thing is going to be that it does not contain an equal sign. That would make it an equation. We can see that this one here would be an equation. 7x plus 4 equals 32. The key thing, guys, is going to be this equal sign. Think about equation and equals as both starting with EQ. Next up, we're going to talk about a formula. A formula is going to be anything which is going to be useful for working out something else. Here we have the area equals half times by base times by height formula, which is useful for working out the area of a triangle. Next, we have an inequality. An inequality is going to be something which contains an inequality sign, which looks like this. It can either say that one thing is greater than, less than, greater than or equal to, or less than or equal to another thing. Those are going to be our key signs. Think about those crocodile's mouths. Next, we have terms. This is going to be an expression which contains 4 terms, 2x squared, 6x plus 2y plus 7. Each of these individual parts is going to be one term. Those are going to be terms. Next up, finally, we have identities. Identities aren't used very often, often in GCSE maths. They're going to come up mainly in our proofs topic. The thing which makes this an identity is going to be this tripled line kind of looking equals here, and it is going to tell us that the thing on the left-hand side is equivalent to the thing on the right. How to expand single brackets in 42 seconds, let's go. The key when it comes to expanding single brackets, guys, is going to be this. We're going to multiply the number on the outside of our brackets by each of the terms on the inside. Let's have a look and see what I mean. First off, 7 times by 2x plus 5. What are we going to do? We're going to do 7 times by 2x. That's going to be 14x. And then we're going to do 7 times by 5. That's going to be 35. And we get our answer, 14x plus 35. What about this next example? 3 times by 3y plus 7 minus 2x. Again, the number on the outside by each of the numbers on the inside. 3 times by 3y, that's going to be 9y, plus 3 times by 7, that's going to be 21, and then 3 times by minus 2x, that's going to give us minus 6x, guys, and that's going to be our expanded version. Factorizing into single brackets in 112 seconds, let's go. When it comes to understanding factorizing, guys, the best way to think about it is going to be as being the opposite to expanding. Let me show you what I mean. In the previous video, we learned how to expand an expression like this, 2 times by 2x plus 4. What we do is we multiply the 2 by each of the numbers on the inside. If that's what it means to expand, what does it mean to factorize? It actually means to write it in the form where it goes back into having brackets. How do we do that? What we're going to do is we're going to look for all of the common factors of each of our terms and then write those on the outside of our brackets. On the inside, we're going to work out what we multiply by that number to get our original terms. Let me show you what I mean. Factorizing 6x plus 9, what are we going to get? On the outside, we're going to have 3, and on the inside, what do we multiply by 3 to get 6x? We multiply it by 2x. What do we multiply by 3 to get 9? We multiply it by 3, so we get 3 brackets, 2x plus 3, close brackets. How did I know, though, that the 3 goes on the outside? That's because 3 is going to be the only common factor of 6x and 9. What about this final example? We have 3x squared plus 6xy plus 9x. What we can see is that 3, 6, and 9 have a common factor of 3, so we can put that on the outside. And then we can also see that each of our terms have a common factor of x, so we can also put an x on the outside. Then, what do we multiply by 3x to get 3x squared? We're just going to multiply it by x, so that's going to be our first term inside the brackets. What do we multiply by 3x to get 6xy? Well, we're going to multiply the 3 by 2 to get 6, and we're going to multiply the x by y to get xy, so we're going to have 2y on the inside. Finally, what do we multiply by 3x to get 9, we multiply it by 3, so our final term inside the brackets is going to be our 3, and that's going to be our factorized form. How to expand double brackets in 98 seconds, let's go. When it comes to expanding double brackets, guys, the key is going to be to multiply each of the terms in our first bracket by each of the terms in our second bracket, and then to simplify. Let's see what I mean. So in this first example, what are we going to do? X plus 3 times by x plus 4. We're going to do x times by x first of all, that's going to give us x squared, and then we're going to do x times by 4, that's going to give us plus 4x, and then we're going to do 3 times by x, that's going to give us plus 3x, and then we're going to do 3 times by 4, that's going to give us 12. Next, we can simplify 3x plus 4x. What's that going to give us? It's going to give us 7x, so we have x squared plus 7x plus 12 as our first expanded version. What about this next example? X plus 6 times by x minus 2. Again, each of the terms in our first bracket by each of the terms in our second bracket. X times by x, that's going to give us x squared. X times by minus 2, we're going to get minus 2x, and then 6 times by x, that's going to give us plus 6x, and finally 6 times by minus 2, that's going to give us minus 12. Then we can simplify minus 2x plus 6x, that's going to give us plus 4x, so we're going to have x squared plus 4x minus 12 as the answer to our second one. And finally, we have 2x plus 8 times by 3x minus 2, the hardest one so far. What's it going to be? First off, 2x times by 3x, that's going to give us 6x squared, followed by 2x times by minus 2, that's going to be minus 4x. Up next, 8 times by 3x, that's going to give us plus 24x. Up next, 8 times by minus 2, that's going to be minus 16. And finally, collecting our like terms, minus 4x plus 24x, that's going to give us positive 20x. So we're going to have 6x squared plus 20x minus 16, guys, as our expanded answer to our final question. Factorizing quadratics into double brackets in 117 seconds, let's go. To factorize quadratics like these into double brackets, guys, what are we going to do? We're going to start off by writing out a pair of double brackets, and at the front of both of those brackets, we're going to add an x. Then we're going to look for two numbers which multiply to give our number on the end and add to give our number in the middle. In this case, we're going to have 4 and 3. Why? Because 4 times by 3 is 12, and 4 plus 3 is 7. Then we're going to simply write those into our brackets, just like that. And crucially, it doesn't matter which way round our numbers go. What about this next example? Let's have a look. X squared plus 8x plus 7. Again, we're going to need two numbers which multiply to give our n number 7 and add to give 8, our number in the middle, writing out our double brackets with x's at the front. This time it's going to be 7 and 1, so plus 7 and plus 1. Again, it doesn't matter which way round. Finally, let's have a look at this example where we have a negative on the end. The key thing to note, guys, is this. We can have negatives involved in these questions, but they work in exactly the same way. This time, we're going to need two numbers which multiply to give negative 18 and add to give positive 3. It can be super helpful, guys, to write out our factors in this case. Let's write out our factors of negative 18. What could we have? We could have negative 1 and positive 18. We could have negative 2 and 9. We could have negative 3 and 6. Alternatively, we could have positive 1 and negative 18. We could have positive 2 and negative 9, or we could have positive 3 and negative 6. Having a look for a pair of these then, which add to make positive 3, we're going to have negative, nope, we're not. We're going to have positive 6 and negative 3. That is going to be our combination. Why? Because 6 times by negative 3 is negative 18, and 6 plus minus 3 is positive 3. So again, we're going to write out our double brackets. We're going to write x's at the front, and then we're going to have negative 3 and positive 6. Again, it doesn't matter which way around those two go. How to expand triple brackets in 108 seconds. Let's go. Let's say, guys, we want to expand and simplify x plus 3 times by x plus 4 times by x plus 6. What are we going to do? First of all, we're going to expand and simplify our first two brackets. Then we're going to multiply that by our third bracket. Let's get it done. So first off, x plus 3 times by x plus 4. Let's do our FOIL method. We're going to do our first x times x is x squared. Our outer x times by 4, that's going to be plus 4x. We're going to do our inner 3 times by x, that's going to be plus 3x. And we're going to do our last 3 times by 4, that's going to be plus 12. Let's put that in our brackets. And remember, we're multiplying that by x plus 6. Next step, let's simplify our first bracket. We can collect our like terms. 4x plus 3x, that's going to be 7x. So we're going to have x squared plus 7x plus 12, and we're going to be multiplying that by our x plus 6. Now, what are we going to do? We're going to multiply each of the terms in our first bracket by each of the terms in our second. Let's do it now. So first off, we're going to do x squared times by x. That's going to be x cubed. Then we're going to do x squared times by 6. So we're going to have plus 6x squared. Next up, we're going to do 7x times by x. That's going to be plus 7x squared. And we're going to do 7x times by 6. That's going to give us plus 42x. Finally, we're going to do our 12 times our x. Let's write that down here. That's going to give us plus 12x. And finally, we're going to do 12 times by 6. That's going to give us plus 72. Final step, guys, let's collect our like terms, our x squareds with our x squareds, and our x's with our x's. What are we going to get? Moving back to orange, we're going to get x cubed plus 13x squared plus 54x plus 72. That is going to be our final answer. Watch that one again, guys. That was quick. How to use the difference of two squares in 82 seconds. Let's go. The difference of two squares method, guys, is going to be super useful whenever we have to factorize an expression which involves one square term subtract another square term. Now, what are we going to do? We're going to start off by writing out a pair of double brackets. And then at the start of our double brackets, we're going to write the square root of the first number in our expression. In the case of our first example, it's going to be x. Then we're going to write a plus in the first bracket and a minus in the second bracket, and then we're going to have the square root of the second term in our expression. In this case, the square root of 64 is going to be 8. Now, this can be used when we have just an x squared, but also when we have a number in front of our x squared, it's going to be exactly the same. So first off, write out our double brackets. At the start of our double brackets, we're going to have the square root of our first term. The square root of 4x squared is going to be 2x, so we're going to write that in. Then we're going to write a plus in the first bracket and a minus in the second. Then we're going to take the square root of our second number in our expression. The square root of 81 is going to be 9. So we're going to have plus 9 in the first and minus 9 in the second. That, guys, is how we can use the difference of two squares to factorize. The fundamentals of rearranging equations in 84 seconds. Let's go. Let's say we're going to ask to rearrange 2x minus 2y plus 16 equals 28 to make x the subject, guys. What are we going to do? We need to make x the subject, which means it needs to end up as x equals. What we're going to do is move each of our terms and numbers to the other side until we have the x on its own. Let's start off by rewriting our equation. We have 2x minus 2y plus 16 equals 28. Step number 1. Let's move this 16 over to the other side. We're going to do that by subtracting 16 from both sides. What's that going to give us? We're going to have 2x minus 2y equals 12. That's because on the left-hand side, we had plus 16 minus 16 cancelled out to give us nothing. And on the right, we had 28 minus 16, which was 12. Next, let's move our minus 2y. How are we going to do that? We're going to add 2y to both sides. That's going to cancel it out. That's going to leave us with 2x on the left-hand side, and on the right, we're going to have 12 plus 2y. And finally, what's preventing the x from being on its own? At the moment, it's being multiplied by 2. So to cancel that out, we're going to divide both sides of our equation by 2. What is that going to give us? On the left, we're going to have x, and on the right, we're going to have to do 12 divided by 2. That's going to give us 6. And then we're going to have to do 2y divided by 2. 2y divided by 2, that's just going to give us y. So we get our final answer, guys, of x equals 6 plus y. How to rearrange harder equations in 138 seconds. Let's go. This one's going to be tricky, guys, but it's super important, so pay close attention. We get asked to make x the subject of y equals x plus z squared over x plus z. Now, what is it that makes this one tricky to rearrange? It's going to be the fact that we have an x on the top and the bottom of our fraction. So the first thing we're going to need to do is move our x plus z over to the other side, then rearrange and factorize. Let me show you what I mean. So first off, to move the x plus z over to the other side, we're going to multiply both sides of our equation by x plus z. Let me write that up here and put it in brackets. Times by x plus z times by x plus z. What's that going to give us? On the left hand side, we're going to have y times by x plus z. And on the right hand side, we're going to have x plus z squared. Why? Because the times by x plus z and the divide by x plus z there cancel out. Now, we're going to need to make x the subject, but at the moment we have an x in this bracket. So we're going to need to expand these brackets next. So we're going to do y times by x. That's going to be yx. And then y times by z. That's simply going to be yz. That's going to be equal to x plus z squared. Now, the next step is going to be to move all of our x's over to one side and all of our other letters over to the other side. Let's do that now. So we're going to subtract x from both sides. That's going to move this x over to the left-hand side. And then we're going to subtract yz from both sides. That's going to move the yz over. Let me just quickly write that in. Minus yz minus yz. Now, what are we going to have on the left-hand side? We have yx minus x, and on the right-hand side, we have z squared minus yz. Finally, what are we going to do? Well, here we have two separate terms in x, but we cannot do the subtraction because one's got a letter attached to it. So we're actually going to have to pull the x out and factorize this, pulling out a factor of x. So on the left-hand side, we're going to have x times by y minus 1. That's because x times by y is going to give us xy, and x times by minus 1 is going to give us minus x. That is going to be equal to our right-hand side, which was z squared minus yz. And finally, guys, to move our y minus 1 over to the other side, at the moment it's being multiplied by the x. So we're going to divide both sides by y minus 1, divide by y minus 1, divide by y minus 1. And what is that going to give us? It's going to give us x on the left-hand side, and on the right-hand side, it's going to give us z squared minus yz over y minus 1, guys. Our final answer. That one was tricky, but make sure you understand it because it comes up all the time. The fundamentals of solving equations in 112 seconds. Let's go. What does it mean to solve an equation, guys? It means to find the value of x which satisfies that equation. In other words, in this first example, find the value of x, which when we multiply it by 2 and then subtract 16, gives us 24. Now, the method is going to be actually exactly the same as when we rearrange to make x the subject. What we're going to have to do is rearrange this equation to make x the subject. That's going to give us x equals some number. So what are we going to do? First off, we're going to plus 16 to both sides, moving that minus 16 over to the other side. We're going to get 2x equals 24 plus 16. That's going to be 40. And then what's preventing the x from being on its own? It's being multiplied by 2. So we can divide both sides by 2. What's that going to give us? It's going to give us x equals 40 divided by 2, which is going to be 20. What about this next example then? When we have an x on both sides of our equation, the key, guys, is going to be to firstly move all of the x's onto one side of the equation and then to move everything else to the other side. Let's see what I mean. So we have a 4x on the left-hand side and a 2x on the right-hand side. We're going to move this 2x over to the other side by subtracting 2x from both sides. Minus 2x minus 2x. We're going to get on the left-hand side 2x plus 7. And on the right-hand side, that plus 2x and that minus 2x are going to cancel each other out, and we're just going to be left with minus 11. Next, what can we do to get the x on its own? Well, we want to move that plus 7 over to the other side, so we're going to subtract 7 from both sides. What's that going to give us when we do it? Minus 7 minus 7. We're going to get 2x equals minus 11 minus 7. Using our knowledge of subtracting negatives, guys, that's going to be minus 18. And finally, at the moment, the x is being multiplied by 2, so we're going to divide both sides of our equation by 2. Divide by 2, divide by 2. When we do that, we're going to get x equals minus 18 divided by 2. That's going to give us 9, guys, giving us x equals minus 9 as our solution to the second question. Solving harder equations in 96 seconds. Let's go. How, guys, we're going to solve 2 times by x plus 3 equals 4x minus 6 over 3. We've got a lot going on here. We've got some brackets over here. We've got a fraction over here. But guys, when we break it down, it's not going to be too bad. So we're going to work through step by step, dealing with each challenge as it comes up. First off, let's simplify this left-hand side by expanding these brackets. We're going to have 2 times by x, that's going to give us 2x. And then 2 times by 3, that's going to give us 6. So we have 2x plus 6 equals 4x minus 6 over 3. Next, we don't really like the fact that we have this fraction here, so we're going to get rid of that divided by 3. What's the opposite to dividing by 3? It's going to be timesing by 3. So we're going to multiply both sides of our equation by 3. On the left-hand side, what are we going to get? Well, we're going to get 2x times by 3, that's going to be 6x, plus 6 times by 3, that's going to be 18. That's going to be equal to 4x minus 6. On the left-hand side, we multiplied both of our terms by 3. And on the right-hand side, we simplified this by cancelling our divide by 3 with our times by 3. Next, we're going to have to move all of our x's over to the left and all of our numbers over to the right. So first off, x is over to the left. We're going to minus 4x from both sides, minus 4x minus 4x. On the left-hand side, we're going to get 2x plus 18. And on the right-hand side, we're going to get minus 6. Now, we can move our plus 18 over to the other side. So we're going to subtract 18 from both sides, minus 18 minus 18. That is going to give us 2x equals minus 6 minus 18, guys. That's going to be minus 24. And finally, we're going to get the x on its own by dividing both sides by 2, divide by 2, divide by 2. That's going to leave us with x equals minus 12, guys, as our final answer to this question.
I've got to say, guys, this is a pretty tricky topic. It's one which is really annoying if you haven't seen before. Let's have a look at this question here. The question asks us to calculate the value of c and d, given that c minus 2 times by x squared plus 3 times by d is equivalent to 7x squared plus 9. Now, what do we have to do here? We have to find a value of c, and we also have to find a value of d. And now those two values have to be such that c minus 2 times by x squared plus 3 times by d is always the same as 7x squared plus 9, whatever the value of x. How are we going to do this? What we're going to spot is that our c minus 2 is being multiplied by our x squared. And over on the right-hand side of our equivalency, we have a 7 next to our x squared. On the right-hand side of the left-hand side of our equivalency, we just have a constant, 3d. And on the right-hand side of the right-hand side of our equivalency, we also have a constant there. We have the number 9. What we spot is that this c minus 2 has to match up to this 7, and the 3d has to match up to the 9. What that basically tells us is that c minus 2, so c minus 2 is going to be equal to 7, and that 3d is going to be equal to 9. If c minus 2 is equal to 7, we can add 2 to both sides. We're going to get that c is equal to 9. And if 3d is equal to 9, we're going to divide both sides by 3 to find the value of d. We're going to get that d is equal to 3. So what did we do there, guys? We used our equivalency. We matched up the coefficient of the x squared with the coefficient of the x squared, and we matched up the constant with the constant. We said that the coefficient on the left-hand side of our equivalency had to be the same as the coefficient on the right-hand side of our equivalency. That gave us this equation up at the top, c minus 2 equals 7. And then we did the same with our constant down here. Hopefully that made sense, guys. A pretty tricky topic there. Shoot me a message or comment if you have any questions.
Solving quadratics with the quadratic formula in 102 seconds. Let's go. The quadratic formula tells us that the solutions to a quadratic, ax squared plus bx plus c equals 0, are given by the following formula. We have minus b plus or minus the square root of b squared minus 4ac over 2a. Guys, how are we going to apply this formula to solve 2x squared plus 3x plus 1 equals 0? Our first step is going to be to realize our a, b, and c. Our a is going to be the number next to our x squared. So in this case, we're going to have a equals 2. Our b is going to be the number next to our x. So we're going to have, in this case, b equals 3. And finally, our c is going to be the number on the end. In this case, we're going to have c equals 1. Next, guys, we're going to substitute this into our quadratic formula, swapping all of our b's for 3, all of our a's for 2, and all of our c's for 1. Let's get it done. So we're going to have minus b, which is going to be minus 3, plus or minus the square root of b squared. So it's going to be 3 squared minus 4ac minus 4 times by 2 times by 1. And we're going to divide all of that by 2a, which is going to be 2 times 2. Now, guys, what do we have to do? We have to do this twice. Once with a plus and once with a minus. That's going to be what our plus or minus means. So we're going to type this all into our calculator. Once having this as a positive sign, I'm going to write our answer to that down here. And once with a negative sign down here, guys. It's absolutely crucial that we get both of our solutions. When we type this into our calculator with the positive sign, we're going to get minus a half as our root. And when we put this in with our negative sign, what are we going to get? We're going to get minus 1 as our answer. As a bonus, guys, see if you can solve this, finding the solutions without a calculator. How to solve quadratics by factorizing when a is equal to 1 in 82 seconds. Let's go. How, guys, would we solve these two quadratics by factorizing? Let's have a look firstly at how to solve x squared plus 7x plus 12 equals 0. Step number 1, we're going to factorize our quadratic, guys, writing it as double brackets. What are we going to have? We need two numbers which multiply to give 12 and add to give 7. That's going to be 4 and 3. So we're going to have x plus 4 times by x plus 3, and that is going to be equal to 0. Next, how can we have this left-hand side of our equation equal to 0? Well, either we need our left bracket to be equal to 0, then we're going to have 0 times by something, and that's going to be 0, or alternatively, we're going to need this bracket to be equal to 0, because then we're going to have something times by 0, and that's going to be equal to 0. Now, what value of x would make this bracket equal to 0? It's going to be x equal to negative 4, and what about this bracket? That's going to be x equals minus 3. That, guys, is the logic for why we have to flip those signs. Now, what about this next example? It's going to work in exactly the same way. Firstly, factorizing. What are we going to have? Right out our double brackets equal to 0. We're going to have an x at both of the start, two numbers which multiply to give negative 36 and add to give positive 9. That's going to be positive 12 and minus 3. Then we can flip those signs. It's going to be x equals minus 12 or x equals positive 3. Again, they're going to be the values of x which make those brackets equal to 0. That, guys, is going to be how to solve quadratics by factorizing. Solving quadratics by factorizing when a is greater than 1 in 135 seconds. Let's go. This is a topic which students really don't like, guys. Let's try and make it clear. How are we going to solve 2x squared plus 7x plus 3 equals 0 by first factorizing it? Now, what is tricky about this one is going to be the fact that we have a 2 next to our x squared. Normally, when we factorize a quadratic, we find two numbers which multiply to give our end number and add to give our middle number. But in this case, it's going to be a little bit different. Pay close attention. Our first step is going to be to write out our double brackets just like we usually would, and that's going to be equal to 0. However, in this case, we're actually going to have a 2x at the start of our first bracket and an x at the start of our second bracket. And that's because when we expand these in theory, they would have to expand to give 2x squared. That's why we need a 2x at the start of the first and an x at the start of the second. Now, what else is going to be different? We're still going to be looking for two numbers which multiply to give 3. However, in this case, we need one of our numbers, our number here, to be multiplied by 2x and our number here to be multiplied by x. And when we do that, for the results to add to make 7x. So it's a little bit different this time because we're not multiplying this number by x, we're multiplying it by 2x. What are those numbers going to be? So the numbers need to multiply to give 3, so it's going to have to be 3 and 1. The question is, are we going to have a 3 here and a 1 here? Or are we going to have a 3 here and a 1 here? Well, if we had it this way round, we would have 2x times by 1, that's going to be 2x, and then 3 times by x, that's going to be 3x. 2x plus 3x is 5x. That's not 7x, so or is it going to be the other way around? Let's give it a go. We're going to have 1 here and 3 here. If we have it this way around, what are we going to have? We're going to have 2x times by 3, that's going to be 6x, plus 1 times by x, that's going to be x, and that would give us 7x, so it is in fact going to be this way around. Let's write it in. So we're going to have plus 1 here and plus 3 here. Finally, guys, we can work out our answers. We need the value of x, which is going to make this bracket equal to 0. In order for this bracket to be equal to 0, 2x plus 1 is going to have to be equal to 0. That's going to give us x equals minus a half. And in order for this bracket to be equal to 0, x is going to have to be equal to minus 3, guys. So we have our two answers. X equals minus a half and x equals minus 3.
This, guys, is an absolutely classic question. Why? Because it pretty much always trips people up. Let's have a look at how to solve x squared plus 7x is equal to 0. What we see here, guys, is that we actually have a quadratic equation. We know that because we have an x squared term here. In this case, the coefficient of x squared, the number next to the x squared, is actually this 1, which hasn't been written in because 1x squared is just x squared. And then we have a 7 next to the x. Normally, with a quadratic equation, we also have a number on the end. For example, this could be x squared plus 7x plus 12 equals 0. We would then find two numbers which multiply to give the number on the end, add to give the number on the middle, and then factorize and reverse the signs in the brackets. If you're not sure what I meant there, have a look at the previous video, which went through factorizing regular quadratics. How, though, do we solve one like this, where we don't have a number on the end, where the value of c is technically equal to 0? The key here, guys, and people always miss this out, is that we can factorize pulling out a factor of x. We have a common factor of x squared and 7x. That common factor would be x. So we can actually write this as x times by x plus 7. That's because the x times the x would give us the x squared, and then the x times by the 7 would give us the 7x. From here, what do? We find the two different values of x, which would make this equation work out. We find the two different values of x, which mean that x times by x plus 7 is equal to 0. Now, one of the values is going to be that x is equal to 0, because then we have 0 times by whatever this is, and that is going to give us 0. The other value of x would be whatever value makes this bracket equal to 0, because then we would have this bracket of 0 times by whatever this value of x is, and that would also work out to be 0. So, to summarize, what would we have? We'd have that the two values are x equals 0. That would be for this left-hand value of x. And then for the right hand, what value of x would make this bracket equal to 0? It would be x is equal to minus 7, because negative 7 plus 7 would be equal to 0, making that bracket equal 0. So we're going to have as our second value of x that x is equal to minus 7, and those are going to be our two answers. To summarize that very quickly, guys, how do we solve one like this? We actually just factorize, pulling out a factor of x. Then we have our two values of x equals 0, and whatever value would make this bracket equal to 0.
How to complete the square when a is equal to 1 in 67 seconds. Let's go. What, guys, are we going to do if we get asked to express x squared plus 10x plus 27 in the form x plus a squared plus b? Guys, this is going to be a hidden completing the square question. So to convert this quadratic, which is in the form ax squared plus bx plus c, into the form x plus a squared plus b, what we're going to have to do is we're going to have to complete the square. Now, this is best thought of as a process to be memorized. So what are we going to do? The first thing that we're going to do is we're going to open our bracket and we're going to write x plus. Then we're going to look at the number next to our x in our quadratic. We're going to halve it. Half of 10 is going to be 5. And then we're going to close our bracket and we're going to square it. Then we're going to copy down the number on the end. So we have plus 27 here. And finally, crucially, we're going to look at this number in our bracket. We're going to square it and we're going to take it away. 5 squared is going to be 25. So we're going to take that away. Now, guys, all that we have to do is simplify. We're going to have x plus 5 in our brackets squared, and then plus 27 minus 25, that's going to be plus 2 simplified, so we're going to have plus 2 on the end, guys, and that is now in the form x plus a squared plus b. We had to complete the square. How to complete the square when a is greater than 1 in 97 seconds. Let's go. This is definitely one of the hardest topics in the course, guys. What are we going to do? This question asks us to complete the square for 2x squared plus 16x plus 18. Now, what is it that makes this so hard? It's going to be the fact that the x squared has a coefficient. In other words, we have a number next to the x squared. So how are we going to deal with this? The first step is going to be to factorize our expression, pulling out the factor which is the coefficient of our x squared. So we're going to rewrite our expression. We're going to pull the factor of 2 out from all of our terms. We're going to have x squared plus 8x plus 9. Then what we're going to do is we're going to complete the square for the expression which is now on the inside of our brackets. So we're going to write down our 2, we're going to copy down our big brackets, then we're going to complete the square for x squared plus 8x plus 9. What are we going to get? We're going to write in our brackets, we're going to take the number next to the x, we're going to halve it, so we're going to have x plus 4. We're then going to square our bracket, copy down that plus 9, and then we're going to subtract our 4 squared. What's 4 squared? It's going to be 16, so we're going to minus 16 there. Then we're going to close our brackets. Next stage of working out, we're going to simplify that expression inside our big bracket. So what are we going to have? We're going to have x plus 4 squared, and then we're going to have 9 minus 16. That's going to be minus 7, so we can write that in, close our big brackets. Now, guys, our final step is going to be to expand these brackets, and all that we're going to do is we're going to write our 2 next to our brackets at the front. So we're going to have 2 lots of x plus 4 squared. Then we're going to do our 2 times by our minus 7. That's going to give us minus 14. And we have our final answer, guys. 2 times by x plus 4 squared minus 14. The fundamentals of inequalities in 70 seconds. Let's go. When it comes to understanding our inequalities, guys, the first thing to know is absolutely going to be the meaning of our 4 different signs. We can see that we have them all on the screen here, so let's have a look. We can see this first one. What's it going to mean? This one is going to mean that a is greater than 7. If we imagine this as being kind of a crocodile's mouth, there's my very bad drawing of a crocodile. We can see that the crocodile's mouth is facing towards the bigger number. This means that a is greater than 7. What about this next one then? We can see this time that the crocodile's mouth is facing towards the 8. What does this mean? It's going to mean that b is less than 8. In other words, we could say that 8 is greater than b. Now, what's going to be the difference when we have these lines under our inequality signs? These are going to add the extra meaning of or equal to. So, what does this one mean? This one's going to mean that c is less than or equal to minus 3. So c could be minus 3, minus 4, minus 5, or any number which is either minus 3 or a lower number. What about this final one then, guys? What's it going to be? This is going to be that d is greater than or equal to 4. It's going to be greater than because the crocodile's mouth is facing towards the d, and it's going to be or equal to because we have that line. How to draw inequalities on number lines in 58 seconds. Let's go. How, guys, are we going to express the following inequalities on the number lines below? We have 3 examples. Let's get them done. First off, we have that x is greater than negative 3 and x is less than or equal to 1. What are we going to do? What we're going to do is we're going to draw in a hollow circle above our negative 3, and we're going to draw in a filled in circle above our 1, and then we're going to join them with a line. Now, what's the lesson here? It's going to be this. Whenever we don't include the number, we're going to draw in a hollow circle, and whenever we do include the number, we're going to draw a filled in circle. Let's look at this next example. We have that x is greater than 2. So what are we going to do? We're going to draw in a hollow circle above our 2 and a line off to the right. Since we don't have an upper bound this time, we don't have a second circle. What about this final one then? X this time is going to be greater than or equal to negative 4. So we're going to draw in a filled in circle above our negative 4, and x is going to be less than 2. So a hollow circle above our 2. Finally, joining those with a line, guys, we have our final answer. How to solve linear inequalities in 66 seconds. Let's go. How, guys, are we going to solve linear inequalities which look like this? Here we have 2 examples. What we're going to do is we're going to treat them exactly like solving regular equations. However, we're just going to make sure that we don't multiply or divide by negative 1. Let's get into it. First off, solve 2x plus 2 is greater than 8. We're going to balance this equation. We're going to subtract 2 from both sides. That's going to give us 2x is greater than 6. Then we're going to divide both sides by 2. That is going to give us x is greater than 3. What about this next example? A little bit more involved, but again, we're just going to treat it like solving an equation. First off, let's expand these brackets. We're going to have 2x plus 6 on the left-hand side, and on the right-hand side, we're going to have 8 minus 4x. Next step, move all of the x's onto one side and all of the numbers onto the other. First off, let's plus 4x to both sides, plus 4x plus 4x. We're going to get 6x plus 6 is less than 8. Next up, let's minus 6 from both sides. Moving that plus 6 over, we're going to get 6x is less than 2. And finally, let's divide both sides by 6, guys. We're going to get x is less than 2 over 6, and we can simplify that fraction, dividing top and bottom both by 2. X is less than 1 over 3. Solving compound inequalities in 58 seconds, let's go. This question looks super challenging, guys, but trust me, when we know what we're doing, it's not actually too bad. Let's have a look. It asks us to solve -4 is less than or equal to x plus 3 over 2, which is less than 5. Just like with our other linear inequalities, we're going to do whatever we need to do to get our x on its own. However, this time, because we have two inequality signs, we're going to need to do it to all three parts of our inequality. Let me show you what I mean. First off, to get the x plus 3 over 2 on its own, at the moment it's being divided by 2, so we're going to multiply each of our components by 2. Let's do times 2 times 2 times 2, -4 times by 2, that's going to be -8, which is less than or equal to x plus 3. That divide by 2 and times by 2 cancel out, which is less than 5 times by 2. That's going to give us 10. And finally, how do we get our x on its own? Well, at the moment, we're having 3 added to it, so we're going to -3 from it. So we're going to -3 from all three parts of our inequality. -8 minus 3, that's going to be -11, which is less than or equal to x, which is less than 7, which was our 10 minus 3, guys. And that's going to be our final answer. How to solve quadratic inequalities in 81 seconds. Let's go. This is definitely one of the hardest topics in the course, guys. Let's have a look. It asks us to solve x squared plus 7x plus 12 is greater than 0. What are we going to do? Our first step is going to be to sketch the graph of y equals our quadratic. So here we have y equals x squared plus 7x plus 12. How are we going to sketch that graph? Showing the x-intercepts. Well, we're firstly going to factorize it. So we have y equals x plus 3 times by x plus 4. Why are those going to be the factors? It's going to be because 4 times by 3 gives us 12, and 4 plus 3 gives us 7. Next, to find the x-intercepts, remember, guys, we're going to swap these signs from pluses to minuses. So our x-intercepts are going to be -4 and -3, drawing those on roughly. Then we can use our shape of our quadratic. We know that it looks like this, to draw an approximate sketch. Finally, how are we going to solve it? Well, looking back at our original equation, we need to know where x squared plus 7x plus 12 is greater than 0. In other words, where this graph is greater than 0, we can see that when the graph is to the right of x equals -3 or to the left of x equals -4, that is satisfied. So that is going to give us our solutions. What are they going to be? We're going to have x is greater than -3, or x is less than -4. Watch that one again, guys. It's going to really help you get your head around it. How to solve linear simultaneous equations in 172 seconds. Let's go. Let's say, guys, we're asked to solve 4x plus 3y equals 25 and 2x plus 4y equals 20. What are we going to do? Well, here, guys, we have two linear equations with two unknowns. We have two equations, and in total we have two variables, x and y. What are we going to do? Well, we're going to solve these using elimination. We're going to subtract one multiple of one of the equations from the other equation in order to eliminate one of our variables, solve the resulting equation for the other variable, then sub it in. Let me show you what I mean, because that was a mouthful. First of all, we need to make sure that both of our equations have at least one of the variables with the same coefficient. We can see that we have a 4 next to the x here and a 2 next to the x here, so they're not a match. And we have a 3 next to the y here and a 4 next to the y here, so they're not a match. But what we can do is we can multiply one of our equations by a number in order to get a match. And because we have a 2 next to our x here and a 4 next to our x here, what we're going to do is we're going to multiply our entire second equation by 2, and that's going to give us the same number next to the x. Let's do it now. So timesing that equation by 2, we're going to get 4x plus 8y is equal to 40. Now what we can do is we can subtract our first equation from our second equation, and when we do that, our x's are going to cancel out. Let me show you what I mean. So writing out that second equation, we have 4x plus 8y equals 40, and subtracting our first equation, we have minus 4x plus 3y equals 25. Now this is a little bit weird, but what we're going to do is subtract our x from our x, our y from our y, and our number from our number, making sure that we write in that equals. Let's get it done. So 4x minus 4x, that's going to be 0. 8y minus 3y, that's going to be 5y, and 40 minus 25, that is going to be 15. Now what we can do is we can divide both sides of this equation by 5, and that's going to give us our value of y. So let's do that now. Dividing both by 5, we're going to get that y is equal to 3. Now we have our value of x, but in order to find the solutions to these, we're also going to need a value for x. How are we going to do that? Well, what we're going to do is we're going to take our value of y and we're going to sub it into either one of our original equations. Let's choose this one on the left-hand side. So subbing it in, what are we going to have? We're going to have 4x plus 3 times by y, y was 3, so 3 times by 3 equals 25. Simplifying, what are we going to have? We're going to have 4x plus 9 is equal to 25. Now we can solve this. Let's subtract 9 from both sides. We're going to get 4x is equal to 16. And finally, divide both sides by 4. We're going to get that x is equal to 4. Now, guys, we have actually solved our simultaneous equations because we have a value for x and a value for y. That's going to give us our final answer then, guys. Let's write it down here. It's going to be that y is equal to 3 and x is equal to 4. And that, guys, is going to be solving linear simultaneous equations. How to solve applied simultaneous equations questions in 131 seconds. Let's go. See if you can follow this one, guys. It's definitely a tricky one. Let's have a look. If 4 pens and 3 rulers cost £4.70 and 6 pens and 6 rulers cost £8.40, how much does 1 pen cost? Here, guys, we have a hidden simultaneous equations question. How do we know? We're given the first set of information that 4 pens and 3 rulers cost £4.70, which is going to allow us to form one equation, and a second piece of information, 6 pens and 6 rulers costing £8.40, which is going to allow us to form that second equation. Let's get it done. Forming the first. We know that 4 pens plus 3 rulers, so we can say that 4p plus 3r is going to be equal to £4.70, let's say 4.7, and then forming the second equation, 6 pens plus 6 rulers, so let's say 6 pens plus 6 rulers is equal to £8.40. Let's write it as 8.4. Next, we need to multiply one of the equations by something to make the coefficients the same. Watch our previous video if you didn't get that part. And then we're going to subtract one equation from the other, eliminating our variables. Let's get it done. We can see that we have 3r on the top and 6r on the bottom. So we're going to multiply our first equation by 2. That's going to allow us to subtract those r's. So multiplying this first equation by 2, we're going to get 8p plus 6r is equal to 4.7 times by 2. That's going to be 9.4. Now, guys, what we can do is we can take our third equation it is now and subtract that from our second. What are we going to get? Well, we're going to do 8p subtract 6p. That's going to give us 2p. We're going to do 6r take 6r. That is going to give us 0. We did that deliberately. And then we're going to do £9.40. 9.4 subtract 8.4. That is going to give us 1. We know, therefore, that 2p is equal to 1. We can divide both sides of our equation by 2 now. We're going to get that p is equal to 0.5. Now, let's think about the context. What did we do? We swapped £4.70 for 4.7, £9.40 for 9.4. That means that if a pen is 0.5, that's going to mean that it's 0.5 pounds, which is 50 pence. So how much does 1 pen cost? A pen costs 50 pence, 0.50 pounds. That's going to be our answer. How to solve quadratic simultaneous equations in 173 seconds. Let's go. This is definitely one of the hardest topics in the course, guys. Let's have a look. It asks us to solve y equals x squared plus 6x plus 7 and y equals x plus 1. What are we going to do? Well, here we have a quadratic simultaneous equations question. Why? Because we're given 2 equations which have 2 unknowns. We have an x and a y to work out, but this time we can see that we have an x squared in one of our equations. And what that means is that we're actually going to get 2 values for x and 2 values for y. Now, the best way to do this is going to be to substitute one of our equations, normally our linear one, into our other equation, our quadratic one. Now, how do we do that? Well, our second equation tells us that the value of y is equal to x plus 1. And our first equation tells us that the value of y is equal to x squared plus 6x plus 7. Now, if that's true, then it has to be the case that our x plus 1, which is equal to y, is equal to x squared, plus 6x plus 7. Why? Because that's also equal to y. So what we can actually say is we can say that x squared plus 6x plus 7 is equal to x plus 1. Why? Because they're both equal to y. Now, this is actually a quadratic equation which we can solve. Why? Because we've gotten rid of all of our y's. So we're going to move our x and our 1 over to the other side by taking both of those away. What are we going to get? We're going to get x squared plus 5x because we took away x, plus 6 because we took away 1, is equal to 0. Now, guys, how are we going to solve this quadratic? We could either factorize it, use the formula, or complete the square. We're going to factorize it. We're going to need 2 numbers which multiply to give 6, add to give 5. They're going to be 3 and 2, so we can write this as x plus 3 times by x plus 2. That's going to be equal to 0. Now, finding our 2 values for x is going to be equal to minus 3 in the left-hand side case, so we have x equals minus 3, or in the right-hand case, x is going to be equal to minus 2. Now, we haven't actually finished. Why? Because we haven't found our corresponding values for y. So how are we going to do that? We're going to sub each of our values of x into our one of our original equations. We're going to choose y equals x plus 1 because that one's going to be the easiest, and that is going to give us our final answers, guys. Let's get it done. So let's say when x is equal to minus 3, y is going to be equal to, we know it's equal to x plus 1, so we can say it's going to be minus 3 plus 1. What's the value of minus 3 plus 1? That's going to be minus 2. So one of our answers is going to be when x equals minus 3, y equals minus 2. What about our last one then? We're going to have when x equals minus 2, y is going to be equal to minus 2 plus 1, which is going to be minus 1, guys. So we now have our two pairs of answers. We have when x equals minus 3, y equals minus 2, and when x equals minus 2, y equals minus 1. That, guys, is how to solve quadratic simultaneous equations. The fundamentals of functions in 102 seconds. Let's go. Okay, guys, what's this idea of a function? A function, for example, f of x or g of x, is going to take an input, in this case x, and turn it into an output, in our first case, 2x plus 1. So, in other words, you put x in and you get 2x plus 1 out. How, though, guys, would we find something like f of 3? Well, what we recognize is that the only difference between f of x and f of 3 is that we've swapped our x for a 3. So, when it comes to finding the value of f of 3, what we're going to do is we're going to take our output and we're going to swap our x for a 3, and then we're going to calculate the value. Let me show you what I mean. So f of 3, what's it going to be? We know that f of x is equal to 2x plus 1, so f of 3 is going to be equal to 2 times by 3 plus 1, 2 times by 3, that's going to be 6, plus 1 is going to be 7, so that is going to be the value of our output. What about this next example, guys, which is going to be a little bit more challenging, but work in exactly the same way. This time we're told that g of x equals 2x squared minus 5x, and we're asked to find g of minus 2. Again, we're going to swap all of our x's for minus 2's, and then calculate the value. What's it going to be? So g of minus 2 is going to be equal to 2 times by x squared, so 2 times by minus 2 squared, and then we're going to have minus 5 times by x. Our x, we're swapping for minus 2. Let's simplify that, guys. So we're going to have 2 times by minus 2 squared is going to give us 4, so we're going to have 2 times by 4, and then we're going to be taking away 5 times by negative 2. 5 times by negative 2, that's going to give us negative 10. Taking that away, guys, so we're going to have to add 10 because we're subtracting a negative. 2 times by 4 is going to be 8, so we have 8 plus 10, which, guys, we can simplify to 18, and that is going to be the basic idea of functions. Function machines in 66 seconds. Let's go. I'd say this one is a pretty nice topic, guys. Let's have a look and see what you think. The question says, given the following function machine, number 1, find the output when the input is 5. So, guys, our function machine, which is up here, tells us that to get from our input to our output, what we need to do is we need to plus 3 and then multiply by 4. So that is exactly what we're going to do. So when the input is 5, what are we going to have? We're going to firstly have 5 plus 3. That's going to give us 8, and then we're going to do 8 times by 4. That's going to give us 32, guys, and that's going to be the answer to our first one. What about this one then? Find the value of the input when the output is 24. So in order to go from our output to our input, what are we going to need to do? We're going to need to do exactly the opposite and move from right to left in our function machine. So the first thing we're going to do is we're going to take that output 24 and we're going to divide it by 4 because that's the opposite to timesing by 4, and that is going to give us 6. Then we're going to subtract 3. Why? Because that's the opposite to adding 3. I'm going to get 6 minus 3 equals 3, guys, and that is going to be our input when the output is 24. Composite functions in 124 seconds. Let's go. This is a super common topic in exams, guys, and it's pretty tricky, so let's have a look. The question says, given that f of x equals 2x plus 4 and g of x equals 3 minus x squared, calculate, first of all, g of f of x, then f of g of x, then f of g of 2. Guys, what are we going to do? When it comes to finding a composite function, what we're going to do is we're going to plug our inside function, which is closer to our x, into our outside function. So in this first case of finding g of f of x, what we're going to do is we're going to plug f of x into g of x. How, though, are we going to do that? What we're going to do is we're going to take our f of x, in this case 2x plus 4, and we're going to swap it for our x in our outside function. Let's get it done, though. Then, so 3 minus x squared, that's going to become 3 minus, we're going to swap our x for 2x plus 4, so it's going to be 3 minus 2x plus 4 squared, and we could simplify that if we wanted to, but the question doesn't ask us to, so it's not necessary here. Then what about the difference then between g of f of x, which we just found, and f of g of x? This time the g is closer to the x, so this time we're going to plug the g of x into the f. Let's see what we get. So f of x we know is 2x plus 4. This time we're going to swap our g of x, 3 minus x squared, for our x. That's going to give us 2 times by 3 minus x squared. Close those brackets. And we're going to copy down our plus 4, so we're going to have our plus 4 on the end. Finally, what about f of g of 2? This time, we're taking our f of g of x, and we're going to swap our x for our 2. So we're going to take our f of g of x here, and we're going to plug in x equals 2. Let's do that and see what we get. We're going to get 2 times by 3 minus x squared, x is 2, so 3 minus 2 squared, close those brackets, copy down that plus 4. This time, what are we going to get? We're going to have 2 times by 3 minus 2 squared. 2 squared is 4, 3 minus 4, that's going to be minus 1. So we write that in, add in our plus 4. Finally, 2 times by minus 1, that's going to be minus 2. Copy down our plus 4, minus 2 plus 4. That, guys, is going to be positive 2, our final answer to f of g of 2. Hopefully that made sense. If it didn't, feel free to watch again. How to find inverse functions in 81 seconds. Let's go. This question, guys, says given that f of x equals 2x plus 3, find f to the minus 1 of x. What are we going to do? Well, first of all, what actually is f to the minus 1 of x? That's going to be our inverse function. If we remember, we said that a function takes an input x and turns it into an output. In this case, the output is 2x plus 3. Our inverse function then, guys, is going to be the function which is the opposite to that. It's going to be the function which takes our input and turns it into our output. Now, how do we actually find it? This one is going to be best thought of, guys, as a process to be memorized. So listen carefully. What we're going to do is we're going to write out a new equation, which is going to be y equals our function 2x plus 3. So we have y equals 2x plus 3. Then we're going to rearrange this equation to make x the subject. First of all, subtract 3 from both sides. We get y minus 3 equals 2x. And then we're going to divide both sides by 2. What's that going to give us? It's going to give us y minus 3 over 2 equals x. Now, guys, final step, we're simply going to swap our x for f to the minus 1 of x. So we're going to write out f to the minus 1 of x equals, then for our other side of the equation, we're going to take our y minus 3 over 2, and we're going to simply swap our y for an x. We're going to get x minus 3 over 2. I know that was a little bit weird, guys, but trust me when I say this one is best just memorized. This is going to be the function which takes our output and turns it into our input. Using iteration equations in 93 seconds, let's go. These can be pretty tricky to get our head around, guys. Let's take a look and see what we can do. The question says, given that x0 equals 2 and xn plus 1 equals 2xn minus 1, find x4. What we're going to do is we're going to use our iteration equation to go from one value in our series to the next value. Notice this equation tells us how to get from one value, the nth value, to the next value, the n plus first value. So if n was 1, n plus 1 is going to be 2. In other words, it tells us how to get from the first value to the second value, or from the fifth value to the sixth value. It's always going to be the next value because we're just adding 1 to the number which is current. So what are we going to do? First of all, let's write out our x0 equals 2. Then to find x1, what we're going to do is we're going to plug in x0 to our equation up here. X of 0, that's going to be 2. So we're going to have 2 times by x0, so 2 times by 2, minus 1. 2 times 2 is 4, minus 1, that's going to be 3. So we found the value of x1. Now to find the value of x2, we can plug x1 in. What's that going to give us? Well, we're going to get that x2 is equal to, substituting 3 in, we're going to get 2 times by 3, minus 1. 2 times by 3, that's going to be 6 minus 1. That is going to be 5. So we have x2 as 5. What about x3 then? This time we're going to plug x2 in. x2 is 5. So we're going to have 2 times by 5. And then we're going to take our 1 away. 2 times by 5. That's going to be 10 minus 1. That's going to give us 9. And finally, x4, we're going to plug x3 in to find that. So we're going to go 2 times by x3. x3 was 9. So we're going to plug that in. 2 times by 9. Close our brackets. Minus our 1. What's that going to be? 2 times by 9 is 18. Subtract 1 is going to be 17. And that, guys, is going to be how we use our iteration equations to find next values in our series. The change of signs method in 82 seconds. Let's go. Luckily, guys, when it comes to the change of signs method, there's not too much we need to know. Let me tell you everything. The question says, the table below shows values of x and y for y equals x cubed minus 8x minus 10. It gives us a table of values. It then says, between which two consecutive integers is the solution to x cubed minus 8x minus 10 equals 0. Now, crucially, we can see that the equation we have up here is going to be the same as the equation down here. The only difference is that we swapped y for 0. Now, how are we going to use the change of signs method? The change of signs method tells us that if we have a change of signs between two input values, when it comes to the output values that it gives, there's going to be a solution between them. We can see that when we plug in x equals 3, we're going to get y equals minus 7, which is negative. And when we plug in x equals 4, we're going to get y equals 22, which is positive. That means that there has to be a solution between x equals 3 and x equals 4. We can see that in all of the other cases, guys, the outputs go negative, 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 negative. Therefore, that's our only change of signs. Therefore, that's the only two values of x for which we can guarantee there's a solution between, only using the information we've been given. So if there's a change of signs between two input values and the associated output values, then there has to be a solution between those values. Simplifying algebraic fractions in 111 seconds, let's go. When it comes to simplifying our algebraic fractions, guys, the logic is actually going to be exactly the same as for simplifying regular fractions. We're simply going to divide our numerator and our denominator by any common factors. The only difference here is going to be that we're going to have common factors which are letters as well as numbers. Let's have a look and see what I mean. This question asks us to simplify 2x squared y cubed z over 4xy to the power of 4z. What are we going to do? First of all, to illustrate this, I'm going to divide our top and bottom into its respective factors. So on the top, we're going to have 2 times by x times by x. That was our x squared. Then we're going to have times by y times by y times by y. That's going to be our y cubed. Then we're going to have times by z on our bottom. What are we going to have? 4. That can be split into 2 times by 2. Then we're going to have y times by y times by y times by y. That was our y to the power of 4. I realized I forgot our x, so let's write that in, times by x. Then we're going to have times by z. Now what can we do? We can divide our top and bottom by any common factors, and when we do that, we're going to cancel them out. So first of all, divide top and bottom both by 2, cross those out. Then we can divide top and bottom by x. That's going to cross this x with this x. There's no more x's on the bottom. What about our y's? Then we can divide top and bottom by y once. Then we can divide it again twice. Then we can do it a third time, crossing those out, no more to be done. Then we can divide top and bottom both by z. When we do so, we're going to cross those out. Now, what do we have left after all of that dividing? On the top, we're going to have 1x, and on the bottom, we're going to have a 2, and we're also going to have a y. That's going to give us our final answer then, guys, of x over 2y. Now, I know a few of you might be thinking we didn't have to write all of that out, and you are right. We could have just done it using our knowledge of the laws of indices. However, I wanted to illustrate it just for the understanding. Our answer, guys, x over 2y. How to simplify algebraic fractions which involve factorizing in 64 seconds. Let's go. This is definitely one of the hardest topics in the course, guys. Let's have a look and see what we can do. The question asks us to simplify x squared plus 5x plus 6 over x squared plus 2x minus 3. What are we going to do? Well, we can see that we have a quadratic on both the top and the bottom of our fraction. So our first step is going to be to factorize our top and bottom, writing this as one thing times by another thing over one thing times by another thing. Let me show you what I mean. First of all, two numbers which multiply to give 6 and then add to give 5. What are they going to be? That's going to be 3 and 2. So we can write this as x plus 3 multiplied by x plus 2. And on the bottom, what are we going to have? Two numbers which multiply to give negative 3 and add to give 2. This time we're going to have positive 3 and minus 1. So we can write this as x plus 3 times by x minus 1. Now, what can we do from there? We can see that the top and the bottom both have a common factor of x plus 3, so we can divide top and bottom both by x plus 3, and when we do that, what are we going to get? We're going to be left with our x plus 2 over our x minus 1, and that, guys, is going to be our simplified version. Multiplying and dividing algebraic fractions in 127 seconds. Let's go. This is a super tricky question, guys, but don't worry, we're going to make it clear. Let's have a look. It asks us to work out and fully simplify 2x plus 6 over x squared plus 6x plus 8 multiplied by x squared plus 7x plus 12 over x plus 3. What are we going to do? 3 steps. Step number 1, we're going to fully factorize everything. Step number 2, we're going to combine our fractions. Step number 3, we're going to cancel out our common factors. Let me show you what I mean. So first step, we're going to fully factorize everything. First of all, this 2x plus 6, what are we going to get? Well, we can factorize this, pulling out a common factor of 2. So we can write this as 2 multiplied by x plus 3. What about the denominator? Here we have a quadratic. So we're going to need to find two numbers which multiply to give 8 and add to give 6. That's going to be 4 and 2. So we can write this as x plus 4 multiplied by x plus 2. Now copy down our times by sign right over our fraction. Now we have a quadratic up here on the top right to factorize two numbers which multiply to give 12 and add to give 7 this time. That's going to be 4 and 3. So we can write this as x plus 4, times by x plus 3, and finally we have our x plus 3 on the denominator. Now what are we going to do? We're going to combine our fractions. We know to multiply one fraction by another, we need to multiply our top by our top, and we need to multiply our bottom by our bottom. So we're going to do that. We're going to write this as 2 times by x plus 3 multiplied by x plus 4 multiplied by x plus 3. We've combined the denominators, the numerators of both of those fractions there. Now we need to combine the denominators. What are we going to get? Let's switch over to that orange, copy down. We have our x plus 4 multiplied by our x plus 2 multiplied by our x plus 3. Now, final step, guys, we're going to cancel out any common factors. What are we going to have? We can see that we have an x plus 4 on the top and the bottom. We also have an x plus 3 on the top and the bottom, so we can cancel those out. And we see that we don't have any more common factors, so now all we have to do is copy down what we have left over. On the top, we're going to have 2 multiplied by x plus 3, and on the bottom, we're going to have our x plus 2, and that, guys, is going to be our final answer. That one was quick and a little bit of a mouthful. I just want to quickly add that in the case of dividing, we would do exactly the same thing. What would be the difference? So the difference would be that instead of multiplying our top by our top and our bottom by our bottom, we would have to use our keep, flip, change. So we would keep the first fraction, flip the terms for a divide, and then swap the numerator and the denominator of the second fraction. Then we can multiply as with this one. Proving equivalence in 80 seconds, let's go. This is a super common type of question in exams, guys, but luckily when we know how to do it, it's not actually too bad. Let's have a look. It asks us to show that 2 times by x squared plus 2x plus 3x times by 2x plus 1 is equivalent to x times by 8x plus 7. What are we going to do? What we're going to have to do is rewrite the left-hand side of our equality, showing that it's exactly the same, or can be written in exactly the same way as the right-hand side. Let me show you what I mean. So first of all, we're going to simplify the left-hand side by expanding our brackets. What's that going to give us? 2 times by x squared, that's going to be 2x squared. Then we're going to have 2 times by 2x, that's going to give us plus 4x. Next up, 3x times by 2x, that's going to give us plus 6x squared. Next up, 3x times by 1, that's going to be plus 3x. Now, guys, we can simplify this by collecting our like terms. What are we going to have? We're going to have 2x squared plus 6x squared is 8x squared. 4x plus 3x, that's going to be 7x. Now, what can we do? Finally, to write this in the same form as this, we see that we're going to need to pull out the common factor of x. Let's get it done. So pulling out a factor of x, what do we times by x to get 8x squared? We times it by 8x. And what do we times by x to get 7x? We times it by 7. So we're going to have x times by 8x plus 7. And we can see, guys, that we've written this left-hand side in exactly the same form as the right. So we've got our answer. Proof with multiples in 59 seconds. Let's go. This is definitely a lot of people's least favorite topic, guys. Let's have a look. It asks us to show that 3x times by 2x plus 1 plus 9 is a multiple of 3 for all integer values of x. What are we going to do? We're going to rewrite our expression, showing that it can be factorized, pulling out a factor of 3. If the overall expression has a factor of 3, then it's true that it has to be a multiple. Let's get it done. So first of all, we're going to copy down our expression. We have 3x times by 2x plus 1, and then we copy down our plus 9. Now we can expand these brackets. 3x times by 2x, that's going to be 6x squared. Then we're going to have 3x times by 1, that's going to be plus 3x, and then we can copy down our plus 9. Now we see, guys, that all three of our terms, our 6x squared, our 3x, and our 9, have a common factor of 3, so we can factorize this. Pulling out a factor of 3, we can have 3 times by 2x squared plus x plus 3. Now we have shown, because this has a factor of 3, the overall thing must be a multiple of 3. How to do proof by counterexample in 45 seconds. Let's go. In this question, guys, we're given a quote from Tom, who says, if I square a number and add 1, then the result is always a prime number. We're asked, is Tom correct? And also told to show our working. What do we reckon? In this case, guys, we're going to come up with an example of a number which, when we square it and add 1, doesn't give us a prime number, and hence show with an example that Tom isn't correct. Let me show you what I mean. Let's take the number 3, for example. If we take this number and we square it and plus 1, what do we get? Well, 3 squared is 9. 9 plus 1, that's going to be 10. Is 10 a prime number? No, it isn't. Why? Because 10 is equal to 5 times by 2. So we've shown with an example that when we take the number 3 and plug it in, we in fact don't get a prime number. So what can we say? We can say, no, Tom is not correct. Proof with even numbers in 48 seconds. Let's go. How, guys, are we going to show that the product of two even numbers is always an even number? What do we reckon? Well, the fundamental property, guys, of an even number is going to be that it has a factor of 2. So when it comes to writing two generic even numbers, we can write one of them as 2m and the other one as 2n. And we're showing that the product of these is even, so we're going to multiply those together. Now, when we multiply by 2m by 2n, what are we going to get? 2 times by 2 is 4, and then we have mn. Now, how can we show that this, the result of the two even numbers, is even? Well, remember, the fundamental property is that it has a factor of 2. So we can factorize this, pulling out a factor of 2. We have 2 times by 2mn. There we've shown that our result has a factor of 2. Therefore, our result also has to be even. How to do proof with odd numbers in 102 seconds. Let's go. This is a super tricky topic, guys. Let's have a look. The question says, show that the sum of 3 odd numbers is always an odd number. What do we reckon? Well, in the previous video, we said that we could write an even number as 2x, 2y, 2z, or 2 times by any other letter. Why? Because an even number is always going to be a number which has a factor of 2. What about an odd number then? Well, if an even number can be written as 2x, we're going to write an odd number as 2x plus 1. Why? Because an odd number is always going to be either one more or one less than an even number. So we can write our first odd number as 2x plus 1, and then our second two odd numbers, what are they going to be? We're going to write these as 2y plus 1 and 2z plus 1. Now, simplifying this expression, what are we going to get? We're going to get 2x plus 2y plus 2z plus 3. Now, what we're going to do is we're actually going to use a little trick, and we're going to swap our plus 3 for a plus 2 and a plus 1. That plus 1 is going to allow us to show that the resulting expression is one more than our even number. Let me show you what I mean. So separating this out, what are we going to get? We're going to get 2x plus 2y plus 2z plus 2 plus 1. Now what we can do, guys, is we can factorize the first part of our expression, pulling a factor of 2 out of all 4 of our first 4 terms. So what are we going to get? We're going to get 2 times by x plus y plus z plus 1. And then we're going to have our plus 1 on the end. Now, guys, we've successfully shown that this is an odd number. Why? Because this first part of our expression is going to have to be even because it has a factor of 2, but our resulting expression overall is going to be one more than that even number. Therefore, it must be odd. How to do proof with consecutive numbers in 53 seconds. Let's go. This is going to be a little bit of a weird one, guys. Let's have a look. The question says, show that the sum of two consecutive integers is always an odd number. What do we reckon? What does it mean? First of all, for two integers to be consecutive, it means that we need for one number to come straight after the other. For example, 4 and 5 are consecutive, or 25 and 26 are consecutive. Now, how are we going to show that in general algebraic terms? Well, we're going to let our first integer be x, and then we're going to add to that our next integer. How can we write down our next integer? Well, we're just going to call it x plus 1. In other words, the number which comes one after x. Now, how can we show that this is an odd number? First of all, we're going to collect our like terms. X plus x is going to be 2x, and then we're going to have 2x plus 1. Now, this is the general form of an odd number. We can see that it's one more than an even number. Therefore, 2x plus 1 is going to be odd.
It's safe to say, guys, that proof is one of the most difficult and most annoying areas of the entire course, especially ones like this, which involve square numbers, even numbers, whatever it might be. Let's have a look, though, and clear up how to do this one. This question says, show that the sum of the squares of any two even numbers is always a multiple of 4. Whenever you have a question like this, guys, the key is going to be to identify what the key facts from the question are. So we know that we're dealing with the sum of the squares of any two even numbers, and we need to show that that's a multiple of 4. So, showing that something's a multiple of 4, we know that at the end of this question, we're going to have to factorize, pulling out a factor of 4. But what do we have to factorize from? So, we know that we're dealing with the sum. Okay, so we're going to be adding together of the squares. So we're going to be squaring our two things. So let's do this. And then we're dealing with any two even numbers. Now, what's the fundamental property of an even number, guys? It's going to be that it has a factor of 2. So two generic even numbers, then we can use the number 2n and also the number 2, let's say m. Now, oh, that's not an M, is it? Let me write that again, 2m. What's the key here? The key is that both of these numbers have to have a factor of 4. Why? Because we have a 2, which is component to those two numbers. So we have two even numbers here. Some people might be thinking, could we use 2n and 2n plus 2? We actually cannot. And that's because that would specifically be two consecutive even numbers. Even though that would be a multiple of 4 still, it needs to be any two even numbers. So we're going to do 2n and also 2m. So 2n squared plus 2m squared, 2n squared, that is going to be 4n squared. We have to square that 2 and also square the n, and then with the 2m squared, we're going to have 4m squared again. Now, factorizing this, pulling out the factor of 4, if you're watching the vertical video, hopefully my head doesn't get in the way, I'll lean back a little bit. We're going to pull out that factor of 4. We have 4 times by n squared plus m squared. And that, guys, is going to show that the sum of any two even numbers has to be a multiple of 4. Tricky one there. If that made sense to you, you're really doing well. Keep up the good work.
The different types of sequences in 104 seconds. Let's go. Let's have a look at our 4 main types of sequences, guys, and give a quick example for each. What are we going to have? First off, we have our linear sequences. In a linear sequence, to get from one term to the next, we're going to add the same number each time. For example, we would say that 4, 7, 10, 13 is a linear sequence because to get from one term to the next, we always add 3. What about then, guys? Our geometric sequences. In a geometric sequence, we're going to multiply by the same number each time when we go from one term to the next. For example, we would say that 5, 15, 45, 135 is a geometric sequence. Why? Because to get from one term to the next, we're always going to multiply by 3. Next up, guys, our famous Fibonacci sequence. In a Fibonacci sequence, to get from one term to the next, we're going to add the previous 2 terms. Let me give you an example. So let's say that our sequence starts with 2, 3. To get our third term, we're going to do 2 plus 3, which is 5. To get our fourth term, we're going to do 3 plus 5, which is 8. And to get our fifth term, we're going to do 5 plus 8, which is going to be 13. In each case, we add the previous 2 terms to get the next term. Finally, guys, our hardest one, I would say, the quadratic sequences. In a quadratic sequence, the common difference is actually going to change, but it's going to change at a constant rate. Let me show you what I mean. We would say that the sequence 2, 5, 10, 17, 26 is a quadratic sequence. Why? Because if we work out our first differences, they would be 3, 5, 7, and 9. And this first difference is changing at a constant rate of 2. So we can say that there's a constant second difference, making it a quadratic sequence. How to find the nth term of a linear sequence in 60 seconds. Let's go. How, guys, would we find the nth term of these two linear sequences? Let's have a look. Step number 1, we're going to find the common difference between each of our terms. What's it going to be? From 4 to 7, we add 3. From 7 to 10, we add 3. And 10 to 13, we also add 3. So our common difference is 3, and that's going to be the number which we write next to our n. Next, we're going to look how we get from this number, our common difference, to our first term. In this case, to get from 3 to 4, what do? We plus 1, so that is going to give us the end of our nth term. What about this next example, guys? Dealing with some negative numbers. What are we going to do? First off, finding our common difference from minus 5 to minus 8. We subtract 3. It's going to be the same each time because it's a linear sequence. That's going to tell us the number which goes next to our n. So we have minus 3n. Then we need to see how do we get from this number next to our n to our first term. What are we going to do? From minus 3 to minus 5, we're going to subtract 2. So that is going to give us the last part of our nth term, guys. That is going to be finding the nth term of a linear sequence. Deciding whether a term is in a sequence in 75 seconds. Let's go. This is a pretty interesting question, guys. Let's have a look. It asks us whether 119 is in the sequence with nth term 4n plus 7. What do we reckon? First of all, what we're going to do is we're going to set up an equation which says that 4n plus 7, which is our nth term, is equal to 119. Now, how is this going to help us? If we remember, our nth term tells us how to work out a given term in our sequence. For example, to work out the 10th term, we would substitute in n equals 10 and we would get 47, telling us that the 10th term is 47. How is this going to help us, though, work out whether 119 is in our sequence? Well, if 119 is in our sequence, then there's going to be some value of n, which when we substitute it into here, gives us 119. So what we can do is we can solve this equation to find what n has to be to give us 119, and if it gives us a whole number, we're going to see that 119 is in fact in our sequence. Let's have a look. So solving this equation, we're going to get 4n equals 112, subtracting 7 from both sides there, and then to get our n on its own, we're going to divide both sides by 4, and when we do that, we get n equals 28. So guys, we can see that 119 is in fact in our sequence. It is going to be our 28th term. How to find the quadratic nth term of a sequence in 166 seconds. Let's go. This one's going to be pretty heavy, guys. Don't say I didn't warn you. What are we going to do? How do we find the quadratic nth term of the sequence 3, 5, 9, 15, 23. Step number 1, we're going to find our first difference and our second difference. Let's get it done. So from 3 to 5, what do? We plus 2. From 5 to 9, plus 4. From 9 to 15, plus 6. And from 15 to 23, we're going to plus 8. Now to find our second difference, our difference of our differences, from 2 to 4, we plus 2. From 4 to 6, we plus 2. And from 6 to 8, we plus 2. Now, guys, we have enough information to find the first term of our quadratic nth term. What's it going to be? Well, we're going to halve our second difference. Half of 2 is 1, and that's going to give us the coefficient of n squared. So the first term in our quadratic nth term is going to be 1n squared. Now, this part's going to be tricky, so pay close attention. What we're going to do is we're going to rewrite our term numbers 1, 2, 3, 4, and 5. That's because we have 5 terms up here in our sequence, and then we're going to rewrite our original sequence. So our original sequence, that was 3, 5, 9, 15, 23. Next step, guys, we're going to subtract the first term in our quadratic nth term from our original sequence. Now, remember, this n represents our term number. So if we're going to subtract 1n squared, we're going to subtract 1 times by our term number squared. So let's calculate what that's going to be. 1 times by each of our term numbers. For our first term, that's going to be 1. For our second term, it's going to be 4. For our third term, it's going to be 9. For our fourth term, it's going to be 16. And for our fifth term, it's going to be 25. Now, guys, what we're going to do is we're going to subtract this from our original sequence. What is that going to give us? 3 take 1, that's going to be 2. 5 take 4, that's going to be 1. 9 take 9 is going to be 0. 15 take 16, that's going to be minus 1. And 23 take 25, that, guys, is going to be minus 2. Now, our final step is going to be to find the nth term of this new sequence and tag that onto our 1n squared. What's it going to be? So, finding our nth term of this linear sequence, we're going to find our common difference. From 2 to 1, we minus 1. 1 to 0, minus 1. 0 to minus 1, minus 1. And minus 1 to minus 2, we minus 1. That's going to tell us that the first part of our nth term there is going to be minus 1n. Then how do we get from our minus 1, which is the number next to our n, our common difference, to our first term, our 2? From minus 1 to 2, we add 3. So that is going to give us the last part of our nth term, guys. So now we can combine all of our components. We can combine our 1n squared with our minus 1n plus 3, and we're going to get, guys, our final answer for our quadratic nth term as 1n squared minus 1n plus 3. Watch that one again, guys. I know it was very quick.
Questions like this, guys, which require us to find the nth term from a sequence of shapes, technically can come up in foundation and in higher. However, they are far more common in our foundation papers. Let's have a look at this one. This question asks us to find the nth term of the following sequence, where n is the number of circles in a given term. We can see that our first term has 3 circles, so let's write that in. Our second term has 5. And our third term has 7. Our next step, guys, is going to be to find the common difference between the terms. From 3 to 5, we plus 2. From 5 to 7, we also plus 2. Now, this is going to give us the coefficient of our n in our sequence, so we can start off by writing this as 2n, and then we need to see how we get from this common difference to our first term. The common difference here is 2. Our first term is 3. How do we get from 2 to 3? We add 1. So, guys, we now have our nth term. It's going to be 2n plus 1. So, guys, what did we do there? Step number 1, we converted our sequence of shapes into a sequence of numbers. Step number 2, we found the nth term of that new sequence of numbers. Fibonacci sequences, guys, are an absolute classic in exams, especially towards the start of the paper. Let's have a look at this one. The question asks us to calculate the next 2 terms in the following Fibonacci sequence. And then we're given the terms 3, 5, 8, 13, and then our two gaps to fill in. Guys, what are we going to do here? Well, to get from one term to the next in a Fibonacci sequence, what we need to do is we need to add the previous two terms. Now, that's not relevant in the case of the second term because there's no term before that, so we're always going to be given the first two terms. We can see to get from the term 5 to the term 8, we add the previous two terms, the 3 and the 5. To get from the 8 to the 13, we add the previous two terms, the 5 and the 8. So to get from our 13 to the next term, we're going to do 8 plus 13, 8 plus 13, and that is going to give us 21 as the next term. Finally, filling in this last term, we're going to add together the previous two this time, so we're going to do 13 plus 21, 13 plus 21, and that, guys, is going to give us 34 as our next term. Guys, we get our next two terms of our Fibonacci sequence, 21 and 34.
Identifying regular polygons in 37 seconds. Let's go. Let's have a look, guys, at what a regular polygon is, as well as 8 common examples. What are we going to say? First of all, a regular polygon is going to be any 2D shape in which all of the angles and all of the sides are the same. So that's the meaning of a polygon. What about some common examples? We have a 3-sided shape, which is going to be a triangle, a 4-sided shape, which is going to be a square, a 5-sided regular polygon, that's going to be called a pentagon, 6 sides a hexagon, 7 sides a heptagon, 8 sides an octagon, 9 sides a nonagon, and 10 sides a decagon, guys. Those are going to be common examples of regular polygons. All of the angles are the same and all of the sides are the same. How to identify different types of quadrilaterals in 104 seconds. Let's go. As a lot of you guys might know, a quadrilateral is going to be any polygon, any two-dimensional shape, that is, which has exactly 4 sides. Let's have a look at these, which are going to be our most common examples. First off, we have a square and a rectangle. Now, in both a square and a rectangle, we're going to have 4 90-degree angles in each of our corners. And also, we're going to have 2 pairs of opposite parallel sides. Here we can see that that's going to be the case in our square and our rectangle. Our difference, though, is going to be that in a square, we have all 4 of the sides which are the same length, and in a rectangle, only our opposite side lengths are going to be the same. Now, what about our rhombus and our parallelogram? Our rhombus is going to be our tilted square, and our parallelogram is going to be our tilted rectangle. Let's have a look then. Rhombuses and parallelograms, both of them are going to have 2 pairs of opposite angles which are the same. We have 1 pair there, and then we're going to have our other pairs in the other corners. Rhombus, all 4 of our side lengths are going to be the same. And in a parallelogram, our opposite side lengths are going to be the same, but crucially, not all of our side lengths are going to be the same. Next up, we have a kite and a trapezium. Now, a kite, in a kite, we're going to have 2 pairs of side lengths which are the same. We have 1 pair there and 1 pair there, and we're also going to have 1 pair of opposite angles which are the same. Next up, trapezium. Now, a trapezium, that's going to depend on the particular example, but in this case, we have 4 angles which are different, and we also have 1 pair of parallel lines. We have the top and the bottom. Now, we could have a couple of different angles which are the same in a trapezium. It's really going to depend on the example. And finally, we have our irregular quadrilateral. That's going to be any quadrilateral in which all of the angles are different and all of these sides are also different. How to identify different types of triangles in 58 seconds. Let's go. For some reason, guys, triangles are a lot of people's favorite type of shape. Let's have a look. A triangle is going to be any polygon, any 2-dimensional shape, which has exactly 3 sides. And we can see that we have 5 main types. Let's have a look at them all. First off, an equilateral triangle. That's going to be any triangle in which all 3 of our side lengths are the same and also all 3 of our angles. What about an isosceles triangle? An isosceles triangle is going to have 1 pair of side lengths which is the same, and the other side is going to be different, and we're also going to have 2 angles which are the same, and the other angle is going to be different. Next up, a right angle triangle. That's going to be, as the name suggests, any triangle which has a right angle. We also have a right angled isosceles triangle. That's going to be kind of, again, as the name suggests, any right angle triangle, which is also an isosceles triangle. We have the right angle here and 2 side lengths which are the same here and 2 angles which are the same. Finally, guys, a scalene triangle. That's going to be any triangle in which all of the side lengths and all of the angles are different. Naming conventions for the sides and angles of triangles in 40 seconds. Let's go. When it comes to labeling the sides and angles on our triangles, guys, there are going to be 3 key principles to be aware of. Let's have a look. Number 1, our angles are going to be labeled with capital letters. Number 2, our side lengths are going to be labeled with lowercase letters. And number 3, our opposite sides and angles are going to be labeled with the same letter. Let me go ahead and show you what I mean. So first of all, let's label our angles. We're going to have angle A angle B, and angle C. They're all capital letters. Now, opposite capital A, we're going to have side length lowercase a. Opposite capital B, we're going to have side length lowercase b, and opposite capital C, we're going to have side length lowercase c, and there we can see that we've applied all three of our principles.
This, guys, is a topic which really often gets forgotten about in school. Let's have a look at a couple of our key triangle facts. First of all, we're asked which is larger, angle X or angle Y. We can see that angle X is down here in the bottom right and angle Y is down here in the bottom left. What we see is that the X is opposite a side length of 7 and that the Y is opposite a side length of 11. Guys, the larger angle is going to be angle Y, and that is because the larger the angle, the larger the side length. I should have said that the other way around. The larger the side length, the larger the angle which is opposite it. So that follows then that the largest angle is always opposite the largest side. In this case, the larger angle is going to be Y because it is opposite the larger side length of 11. Next up, the question that we have here says, is the following triangle possible to draw to scale? So we have a triangle which has a side length of 19 centimeters, one which has a side length of 7, and one which has a side length of 8. What does it mean? Is it possible to draw this to scale? It means, is it actually possible to draw this triangle? Is this a possible triangle? Is it possible for a triangle to have one side length of 7, one of 8, and one of 19? Guys, it is actually not possible to draw this triangle to scale, and that is because the largest side on a triangle can never be greater than the sum of the other two sides. Let me say that again. The largest side length on a triangle can never be greater than the sum of the other two sides. In this case, the largest side length is 19, and the other two side lengths are 7 and 8. Adding those together, guys, 7 plus 8 is 15. 7 plus 8 is equal to 15. And what that means is that the largest possible side length for the third side would be 15. It is impossible to have a side length of 19, which means that it is actually impossible to draw this triangle to scale.
How to identify different types of angles in 37 seconds. Let's go. Here, guys, we have the 4 main types of angles to be aware of, working from smallest to biggest. Let's have a look. First off, our acute angles, they're going to be any angles which are less than 90 degrees. Think of those as being less than our right angles, which are going to be exactly 90 degrees. They look like an L. What about then, guys? Our obtuse angles, they're going to be any angles which are between 90 degrees and 180. Think of those ones as being greater than a right angle, but less than a straight line. A straight line is 180 degrees. And finally, we have our reflex angles. They're going to be any angles which are greater than 180 degrees, which are greater than the angle which we would have on a straight line. How to use angle notation in 52 seconds. Let's go. Here, guys, we have a pretty funky shape. We can see we have 5 points. We have point A, B, C, D, and E, and the goal is to specify our orange angle, our purple angle, and our green angle. What are they going to be? Our orange angle, first of all, that is going to be BAE. Now, how did we know it was BAE? Well, if we drew a line from point B to A and then from A to E, we can see that those two lines would perfectly encapsulate our orange angle. Doing a similar thing then for our purple angle, we could go from A to E and then to B. So our purple angle, that one would be AEB. Let me quickly write that in. We have AEB. And finally, guys, our green angle, what's it going to be? We can see if we drew a line from B to C to E, that would perfectly encapsulate it. So that is going to be BCE. Our final one, guys. Think about which two lines you can draw to enclose that angle. How to work with angles on straight lines in 82 seconds. Let's go. Guys, when it comes to working with angles on straight lines, the key thing to be aware of is going to be the fact that angles on straight lines always add up to 180. We can see in this first example that we're told that this angle is 140 and this one is equal to x. If we wanted to find x, we would have to use the fact that our 140 plus our x is going to have to be 180. What would x have to be in order for 140 plus x to be 180? It would have to be 40. So we could say that in our first example, x would be equal to 40. Now, what about this next one, which is a little bit more complicated, but doesn't actually involve too much more work? So in this case, we're asked to work out this angle here. How are we going to do it? Well, we can see that we're given this angle in the triangle, and we want to work out this one. So if we knew this angle here, we could use the fact that angles in triangles add to make 180, but we need to work that one out. So what are we going to do? We're going to use the fact that angles on a straight line add up to 180 to say that this one is equal to 100. Now, why would that be? That would be because this one is 80 degrees and 80 degrees plus 100 degrees would give us 180. Now we can use the fact that our angles in a triangle have to add to make 180. 50 plus 100 plus x is going to have to be 180. 50 plus 100 is 150. 180 take 150 is 30. So that tells us, guys, that in this next example, x is going to have to be equal to 30 degrees. How to work with angles around a point in 38 seconds. Let's go. Guys, whenever we're dealing with angles around a point, the key thing to note is going to be that all of our angles are going to add up to 360 degrees. In this example, we're given a bunch of angles. We have those green ones, and we're asked to find x. What are we going to do? First off, we're going to add all of those angles together. We're going to get 40 plus 85 plus 25 plus 35 plus 105, and when we add those together, we're going to get 290. Next step, because all of our angles add to make 360, we're going to do 360, subtract 290, which is going to give us 70, and that is going to be our value for x. Working with opposite angles in 41 seconds. Let's go. Whenever we're working with opposite angles around the same point, guys, the key thing to note is that those opposite angles are going to be exactly the same. Let's say we're given this diagram down here and asked to calculate the values of x and y. What are we going to do? Well, the first thing we see is that our angle x is vertically opposite our 80-degree angle, which means that our angle for x is going to have to be the same as that. It's going to have to be 80 degrees. Now, what about y? We know that the angles in a triangle add up to 180, and we know the value of x now. So what we can do is we can do 60 plus 80, which is going to be 140, and then we can do 180 take 140, which is going to give us our value for y. We're going to get that y is equal to 40 degrees. How to work with the angles in triangles in 76 seconds. Let's go. Whenever it comes to working with the angles in triangles, guys, the key thing to note is going to be that the angles in triangles always add up to 180 degrees. Let's have a look at these two examples, which are going to illustrate that point. First of all, we can see that we're given this triangle here. We're told two angles, 80 degrees and 54 degrees, and we're asked to find x. The first thing we're going to do is work out what 80 degrees plus 54 degrees is. That's going to give us 134 degrees, and then we can do 180, the sum of all of the angles, subtract 134, which is going to be 46, and that is going to tell us the value of x. X is going to be equal to 46 degrees. Now, what about this next example? We can see that we're given an isosceles triangle indicated by these two lines here, and what that tells us is that this angle here and this angle here are the same. Therefore, the angle on the left is also going to have to be y. Now, we know that all of the angles add up to give 180, so we can say that y plus 40 is equal to 180. Next up, we can simplify this. Y plus y is 2y, and we can move this 40 to the right-hand side of our equation. We can take 40 from both sides. That is going to give us 2y equals 140. Finally, we can divide both sides by 2 to find the value of y. We're going to get y is equal to 140 divided by 2, which is 70. How to work with the angles and quadrilaterals in 98 seconds. Let's go. Whenever we're working with the angles and quadrilaterals, guys, the first key thing to note is going to be the fact that angles in quadrilaterals always add up to 360 degrees. Let's have a look at this first example. What are we going to do in this example? We're given three angles, 100, 70, and 30, and we're asked to find the value of x. So what we're going to do is we're going to add together those other angles, and then we're going to take that number away from 360 to find our remaining angle. What's that going to give us? We're going to do 100 plus 70 plus 30, that is going to give us 200. Then we're going to do 360, take 200, 360, take 200, that is going to give us 160. So we found the value of x. X is going to be 160 degrees. What about this next example, guys? Along with our next key point, it's going to be that opposite angles in rhombuses and parallelograms are always equal. We can see here that we're given a parallelogram, and in this question, guys, we're going to try and find these three angles. What are we going to do? Well, first of all, we're going to use the fact that opposite angles are equal to say that this angle is equal to 63 degrees. Now, where can we go from there? We know that all four of our angles are going to add up to give 360 degrees. So what we can do is we can do 63 plus 63. That is going to give us 126, which is these two added together. Now, to find the sum of the other two angles, we can take that away from 360. So we're going to do 360, take 126. When we do that, that is going to give us 234. And finally, we know that both of these are equal. So we can simply divide this by 2. We're going to do 234 divided by 2. That is going to give us 117, guys. And that is going to be our final two angles, 117. How to work with the internal angles in regular polygons in 71 seconds. Let's go. Guys, when it comes to working with the interior angles of a regular polygon, there are going to be a couple of different ways we can go around the questions. My personal favorite is always going to be to use the formula that the sum of the interior angles in a regular polygon is equal to n the number of sides, subtract 2 times by 180. Let's see how we can use this formula to help us find x. In this case, what do we have? We have a pentagon, a 5-sided shape, and we don't want to find the sum of all of the angles, we just want to find one of them. However, what we can do is we can firstly find the sum of all of them, and then because it's a regular polygon, we can divide it by the number of angles, in this case which is 5, to find the size of one of our angles. Let's get it done then. Firstly, substituting in n equals 5, because we have a 5-sided shape, we're going to do 5 minus 2 times by 180. 5 minus 2 is going to be 3, so we have 3 times by 180, 3 times by 180, that is going to be 540. Now, because we have 5 angles in our shape, we can do 540 divided by 5 to find the value of x. 540 divided by 5, and that, guys, is going to be 108, so we can see that x is going to be equal to 108 degrees. How to work with the external angles in regular polygons in 32 seconds. Let's go. Whenever it comes to working with the external angles in a regular polygon, for example, in this question, where we're asked to find the size of angle x, what we're going to do, guys, is we're going to use the formula that any external angles in regular polygons are equal to 360 divided by our number of sides. In this case, we have a pentagon, so our number of sides is 5. So to calculate the size of angle x, we're going to do 360 divided by 5. And if we calculate that, it would give us 72. So our value of x is going to be 72 degrees. How to calculate the areas of squares and rectangles in 37 seconds. Let's go. Luckily, guys, finding the areas of squares and rectangles isn't too bad. All that we have to do is multiply our base by our height. Now, in the case of this first example, we're also going to have to use the fact that in squares, all of our side lengths are the same. That's going to allow us to find the height of 4 centimeters. Finding the area then, we're going to do 4 times by 4. 4 times by 4, that's going to give us 16. So our area, guys, is going to be 16 centimeters squared. What about this rectangle? We have a base of 8 and a height of 3. So again, we're going to do base times by height. We're going to do 8 times by 3. 8 times by 3, that's going to give us 24. So our area, guys, is going to be 24 centimeters squared. How to calculate the areas of rhombuses and parallelograms in 41 seconds. Let's go. When it comes to calculating the areas of our rhombuses and our parallelograms, guys, we're going to do exactly the same thing as when we're working out the areas of our squares and our rectangles. We're going to multiply our base by our vertical height. Let's have a look at these two examples. In the first case, we have a rhombus which has a base of 10 and a height of 7. So we're going to do 7 times by 10. 7 times by 10, that's going to be 70. So our area would be 70 centimeters squared. What about this next example? We have a base of 15 and a height of 5. Again, we're going to do 5 times by 15. So our height times by our base, that's going to be 75. So our second area, guys, is going to be 75 centimeters squared. How to find the area of a triangle using a half AB sine C in 55 seconds. Let's go. Let's say we're given this triangle here, guys, and we're asked to calculate our area. What are we going to do in this situation? We've not been given a base or a height, so we can't use the formula that area equals a half times base times height. Instead, we're going to have to use this formula over here, which tells us that the area of a triangle is equal to a half times by AB times by sine C, where crucially A and B are two of our side lengths and C is the angle in between them. So we can substitute these values into that formula and let's see what we get. What are we going to have? We're going to have that our area is equal to a half times by A times by B. Now it doesn't matter which one is A and which one is B. So we're going to do times 8 times by 7 and then we're going to multiply that by sine C, which is going to be sine of our angle. Here that's going to be sine 48, writing that in sine 48. Now we can type that into our calculator, guys, and if we bing it in, what we're going to get is we're going to get that our area is equal to 20.81 centimeters squared, and that is to 2 decimal places. How to find the area of a trapezium in 43 seconds. Let's go. When it comes to finding the area of a trapezium, guys, what we're going to do is we're going to use the formula that the area of a trapezium is equal to a half times by A plus B times by H, where crucially A and B are our top and our bottom of our trapezium. Let's sub in our values and see what we get. So writing this out, we're going to have area equals a half times by a plus b, that's going to be 4 plus 12. Now it doesn't matter which one is a and which one is b, as long as they're our top and our bottom, times by 6, because that's our vertical height. Simplifying this, what are we going to have? We're going to have a half times by 4 plus 6, that's going to be 16 times by 6. What's that going to give us then? A half of 16 is 8, and 8 times 6 is 48. So we're going to get, guys, that our area is equal to 48 centimeters squared, our final answer. How to find the perimeters of squares and rectangles in 54 seconds. Let's go. Whenever it comes to working out the perimeter of a shape, guys, we're going to use the fact that the perimeter is going to be all of our side lengths added together. Now, in the case of finding the perimeter of this square, we're also going to use the fact that all of the side lengths on a square are the same. So we can say that this side is 4, this side is 4, and this side is also 4. Now what we can do is add together all of those side lengths. So we're going to do 4 plus 4 plus 4 plus 4, and that is going to give us 16 centimeters, the perimeter of our square. Now, what about our rectangle? We're going to use the fact that in a rectangle, the opposite sides are the same length. That's going to allow us to work out the fact that this top side is 8 centimeters and the side on the left is 3 centimeters. All that we have to do then is add together all of our different side lengths. We have 8 plus 8 plus 3 plus 3. When we add those together, what are we going to get? We're going to get 8 plus 8 is 16, plus 3 is 19, plus another 3 is 22, and we get our answer there, guys, of 22 centimeters, our final answer. How to calculate the perimeters of rhombuses and parallelograms in 54 seconds. Let's go. How, guys, are we going to calculate the perimeters of our rhombuses and our parallelograms? Now, in the case of a rhombus, just like in a square, we're going to use the fact that all of our side lengths are the same. So we could say that for this rhombus up here, our right-hand side is 10 centimeters, just like the bottom. Our top side is also 10 centimeters, and also on the left. Now, all we need to do to find our perimeter is add all of those together, and that is going to give us 40 centimeters as our answer. Now, what about in our parallelogram? In a parallelogram, just like in a rectangle, our top and bottom side are going to be the same, and our left and right side are going to be the same. So we can say that our top side is going to be 25 centimeters. Let's write that in, 25, and our left-hand side is going to be 5 centimeters. Now, all we need to do is add all of those together, top and bottom. They're going to add to give 50. Left and right, they're going to add to give 10. 50 plus 10 is 60. So, guys, our final answer is going to be 60 centimeters for the perimeter of our parallelogram. How to calculate the perimeter of different types of triangles in 105 seconds. Let's go. Here, guys, we're asked to calculate the perimeters of the following triangles, and then we're given 3 different types of triangles. Let's have a look at them one by one. Up first, let's deal with our equilateral triangle in the top left corner. Now, how do we know this is equilateral? We know it's equilateral because all of our angles are 60 degrees, and that tells us that all of our side lengths are going to be the same. So we know that this bottom length is 4. That tells us that the right-hand side is also going to be 4, and the left-hand side is also going to be 4. So to calculate the perimeter, we're just going to do 4 plus 4 plus 4, which is going to give us 12 centimeters, our answer. Now, what about this triangle over here? This triangle over here is going to be an isosceles triangle. How do we know that? We know that because these two angles are the same and this angle is different. Now, what does that tell us? It tells us that our left-hand side is going to be 5 centimeters. Why? Because it's going to be the same as this side here. Now, all that we have to do is add together those side lengths, 5 plus 5 plus 3. That is going to give us 13 centimeters as our answer. Now, this one, guys, arguably the most difficult is going to be our right angle triangle. Now, to calculate the length of this side over here, we're actually going to have to use Pythagoras' theorem. Now, Pythagoras' theorem, what does it tell us? It tells us that a squared plus b squared equals c squared, where our two side lengths, which are not the hypotenuse, are a and b, and our hypotenuse is c. Now, how can we apply this? We're going to do 4 squared plus 3 squared, that is going to be equal to our c squared. 4 squared is 16 plus 3 squared. 3 squared is 9. 16 plus 9 is 25. So that tells us that 25 is equal to c squared. And that tells us that c is going to be equal to 5, square rooting both sides there. So we finally found that our hypotenuse is 5 centimeters. Now to find the perimeter, guys, we're going to do 4 plus 3, that's going to be 7, plus 5, that's going to be 12. And we get our answer, guys, that our perimeter to our right angle triangle is 12 centimeters. How to calculate the perimeter of a trapezium in 48 seconds. Let's go. Believe it or not, guys, questions like this are super common at the start of our exam paper. Let's have a look. The question asks us to calculate the perimeter of the following trapezium, and then we're given a trapezium and a bunch of information. Now, the key skill here, guys, is going to be working out which information we do need and which information we don't. We can see that we're given the top, the bottom, the left-hand side, the right-hand side, and the vertical height. Now, to calculate our perimeter, we add together all of our side lengths. So the key values here are going to be our 4.5, 2.5, 8.5 and 4.2. We can completely ignore this 2.4. To calculate the perimeter, we add them together. So let's do that now. We're going to do 4.5 5 plus 2.5 plus 8.5 plus 4.2. And if we add those together, what are they going to give us? They're going to give us 19.7 centimeters as our answer.
Believe it or not, guys, this actually trips a lot of people up in exams. How do we calculate the perimeter of the following circle? Now, why do I say this trips people up? Normally, we don't actually get asked to work out the perimeter of a circle. In the case of a circle, we actually call the perimeter something else. We call it the circumference. Now, this actually trips a lot of people up because as soon as they think of the perimeter of a circle, they think, wow, how do I work out the perimeter? Without realizing that the perimeter and the circumference are actually the same thing. The circumference is the length all the way around the circle, which is actually the definition of the perimeter of a circle. So how do we work it out? We use our formula for the circumference of pi d or 2 pi r. The reason that pi d and 2 pi r are the same thing is because the 2 times by the r means 2 times by the radius, and 2 times by the radius is equal to the diameter. That's why pi d and 2 pi r are both interchangeable for this. In this case, we've been given the radius, we've been given the length from the center of the circle to the edge of the circle, so we're going to use 2 pi r. We're going to do 2 times by pi times by our radius of 7. The units for this, guys, it's the perimeter, and we have our length here in centimeters, so it's going to be 2 times pi times 7 centimeters. We're going to leave this in terms of pi. 2 times 7, guys, is 14, so we can give our answer here as 14 pi centimeters. If we wanted to, we could bring it into the calculator. It would be roughly 43, 44, but we don't have to. In this case, we're just going to leave it in terms of pi. Questions like this, guys, are pretty annoying. They actually come up quite often in exams, and a lot of students get them wrong, mainly because of silly mistakes. Let's have a look at this one. The question asks us to calculate the perimeter of the following semicircle. Now, we know how to work out the perimeter of a circle. The perimeter of a circle is the circumference of the circle. We use pi times by diameter. So let's write that up at the top for now. We're going to have that the circumference of a circle is equal to pi times by diameter. In the case of this semicircle, to work out the perimeter, we have 2 side lengths to consider. We have this 10 centimeters down at the bottom. We have this arc length up at the top. How do we work out the arc length? Well, the arc length of this semicircle is going to be half of what the circumference of the overall circle would have been. I've continued that circle down there just to make it clear. What we can do is we can work out the overall circumference of what the circle would have been and then divide it by 2. How do we work out the circumference of a circle? Pi times by diameter. So we're going to do, in this case, at the arc length, let's call it L, is equal to pi times by our diameter. Our diameter here is 10, the length all the way across our semicircle, and then we're going to have to divide this by 2. Pi times by 10 would be 10 pi. 10 pi divided by 2, guys, that is going to be 5 pi. And we're going to leave our answer in terms of pi here. So we're going to have 10 plus 5 pi centimeters as our overall perimeter for this semicircle. We had to consider that bottom side of 10 and the top arc length of 5 pi. That gives us our answer to this one.
How to find missing side lengths in compound shapes in 57 seconds. Let's go. Questions of this kind are going to be super common in at least one of our papers, guys. Let's have a look. This question asks us to find the missing side lengths for the following shape, and then it gives us this shape, and we have our side lengths in orange. Now, we're going to do this by thinking of this as kind of being a couple of different shapes glued together. And in particular, to find our side lengths, we're going to use the differences between other side lengths. Let's have a look at this side length here then. What we can see is that this side length is actually going to be the difference between the total height of our shape and this side length here. So to calculate the height of that line, we're going to do our 18 centimeters, subtract our 14 centimeters, and that is going to give us 4 centimeters. So this side length here is 4. Now to calculate this side length here, what we're going to do is we're going to take the difference of the total bottom length of our shape and this side length here. So this time we're going to do 20 subtract 9. Let's do that down here. 20 minus 9, that is going to give us 11, guys. So this side length here is going to be 11. How to calculate the perimeter of a compound shape in 56 seconds. Let's go. Let's say we have this question here, guys, where we're given this shape and asked to calculate the perimeter. What are we going to do? Our first step is going to be to find all of our missing side lengths. We have this length here and this length here, and then we're going to add together every single side length of our shape, what are we going to have? So working out this top side length here, well, that's going to be the difference between the bottom side and this side length here. To work that out, then we're going to do 10 subtract 3, and that is going to give us 7, writing in our 7 centimeters. Working out then our other missing side length, that's going to be this length here. What's that going to be? Well, it's going to be the difference between this total height of our shape, which is 12, and this side length here. 12 take 4, that is going to be 8, so this side length here is 8. Now, final step, working out the perimeter, we're going to add together all of our side lengths, so we're going to do 8 plus 10 plus 12 plus 3 plus 4 plus 7, which if we calculate is going to be 44, and that, guys, is going to be our answer. How to find the areas of compound shapes in 79 seconds, let's go. Let's say we're given this funny looking shape here, guys, and we're asked to calculate the area. What are we going to do? Our first step is going to be to find our missing side lengths. Our second step is going to be to divide our shape into 2 smaller shapes, and our third step is going to be to find the area of those shapes and then to add them together. Let's get it done. First off, finding our top side. That is going to be the difference between our 10 centimeters down here, which is our total width of the shape, and our side length here, which is 3 centimeters. 10 subtract 3, that is going to give us 7, so our top side is going to be 7. Next up, we have our side on the left-hand side. What's it going to be? Well, that's going to be the difference between our total height of our shape, which is 12, and this side length here, which is 4. So we're going to do 12 take 4. That is going to give us 8 centimeters as our left-hand side. Now, dividing our shape into 2, this is going to be a nice, convenient place to divide it. And finally, finding the area of those 2 smaller shapes. What are we going to have? Well, this shape over here is going to be a rectangle with a width of 7 and a height of 12. So we're going to do 7 times by 12. That is going to give us 84. What about this smaller rectangle over here? Well, that is going to have a height of 8 and a width of 3. Multiplying those together is going to give us 24. So that is going to give us 24 centimeters squared as that area. Finally, adding those 2 together, guys, we're going to do 84 plus our 24, and that is going to give us 108 centimeters squared as our final answer. Identifying the key 3D shapes in 47 seconds, let's go. These guys are going to be the 8 most important 3D shapes to be familiar with. Have a look and see if you can name them all. Up first, we have a cube, then we have a cuboid, then we have a sphere. Number 4, we have a triangular prism. Up next, we have a square-based pyramid. We can see we have a square as our base. Up next, we have a triangular pyramid. This time, funnily enough, triangle as our base. Next up, a cylinder. That's going to be a prism with a circle on the top and the bottom. And finally, guys, we have a cone. That is going to be number 8. All of our faces, edges, and vertices in 203 seconds. Let's go. Let's have a look at the following 3D shapes, guys, and how many faces, edges, and vertices each of them have. Up first, let's look at our cube and our cuboid. I'm going to put those together because they're actually the same faces. What is it going to be? It's going to be 1, 2, 3, 4, 5, and 6. Our edges, what's it going to be? It's going to be 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, and 12. And finally, our vertices, moving back to our cuboid, it's going to be 1, 2, 3, and 4, 5, 6, 7, and 8. And like I say, faces, edges, and vertices for our cube and our cuboid are going to be exactly the same. Up next, we have our sphere, and this trips a lot of people up. It is actually going to have 1 curved face. It's going to have 0 edges and 0 vertices. Sounds a little bit weird, but have a look at our sphere. It should make sense. What about up next? We have our triangular prism. Let's look at our faces. We're going to have 1 and 2, our end faces. Then we're going to have 3 faces around the side for a total of 5. Next, our edges. We're going to have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And finally, our vertices. We're going to have 1, 2, 3, 4, 5, and 6. Next up, guys, let's look at our square-based pyramid. Faces up first, we're going to have 1 bottom face. We're going to have 4 faces around the edges. That's going to be a total of 5 faces. Our edges, what's it going to be? We're going to have 1, 2, 3, 4, and we're going to have 5, 6, 7, and 8. And finally, our vertices, we're going to have 1, 2, 3, 4 around the bottom, and we're going to have 5 on the top. Up next, our triangular pyramid, very similar. How many faces are we going to have? We're going to have 1, 2, 3, and 4. How many edges? We're going to have 1, 2, 3, 4, 5, and 6. And finally, how many vertices? We're going to have 1, 2, 3, and finally 4. Up next, we have our cylinder. Our cylinder is going to be another bit of a weird one. What are we going to have? We're going to have three faces. We have our top face, our bottom face, and we have our curved face around the side. We're going to have two edges. That's going to be our top edge and our bottom edge, and we're actually going to have no vertices at all. Finally, our cone, guys, what's it going to be? Our cone is going to have two faces. It's going to have this bottom face, and it's going to have the curved face around the sides. Edgewise, it's going to have one edge around the bottom. And finally, to finish us off, we're going to have one vertice. That is going to be the top of our cone. Finding the volumes of cubes and cuboids in 49 seconds. Let's go. When it comes to calculating the volumes of our cubes and our cuboids, guys, we're going to use the formula that our volume is equal to our base times by our width times by our height. Now, in the case of a cube, we're also going to have to sometimes use the fact that our base, our width, and our height are all the same. So we're given the base of this cube. We're told that it's 4. That tells us that our width and our height are also going to be 4. So what we can do is we can do 4 times by 4 times by 4, and that is going to give us 64, and centimeters cubed is going to be our unit. What about our cuboid then? This time we have a base of 8, a width of 3, and a height of 4. Multiplying all of those together, what are we going to get? 3 times by 4 times by 8. 3 times 4 is 12. 12 times 8 is going to be 96. So we get, guys, 96 centimeters cubed as our second answer. How to calculate the volume of a prism in 45 seconds. Let's go. When it comes to calculating the volume of a prism, guys, what we're going to do is we're going to work out the area of our end face, and then we're going to multiply that by our width. In this case, because we have a triangular prism, when we work out the area of that end face, we're going to use a half times by base times by height, and then we're going to multiply that by our width. Let's get it done. So in this case, what are we going to have? We're going to have volume equals a half times by base times by height. The base of our triangle is 7, and the height of our triangle is 10, and then we're going to multiply that by our width of 11. Let's simplify this and see what we get. Half times 7 is 3.5. 3.5 times 10 is 35, and 35 times 11, guys, that's going to be 385. So our answer is going to be 385 centimeters cubed as our units. How to calculate the volume of a cylinder in 58 seconds. Let's go. To calculate the volume of a cylinder, guys, what we're going to do is we're going to use the formula that our volume is equal to pi r squared h. Now, where does this formula actually come from? The pi r squared bit, that's going to work out the area of the circle on the top, and the height, that's going to multiply it by the height of our cylinder. Now, this is just like with any other prism where we multiply the area of the end face by our height. Now, let's ping in our actual numbers and get it done. What are we going to have? We're going to have that our volume is equal to pi times by our radius squared. Our radius is 5, so we're going to have 5 squared times by our height of 12. Now simplifying this, what are we going to have? 5 squared, that's going to be 25. 25 by 12, that's going to be 300. So we can write this then as 300 pi. Now, if they ask us to, we could write this as a decimal. And if we did, we're going to get 942.47. Now, don't forget to write in our units because we're working with volume and all of our measurements were in centimeters. Our units, guys, are going to be centimeters cubed. And that is going to be our answer to 2 decimal places. How to calculate the volume of a cone in 56 seconds. Let's go. When it comes to calculating the volume of a cone, guys, what we're going to do is we're going to use the formula that the volume is equal to 1 over 3 times by pi times by our radius of our circle squared times by our height. Let's have a look at how to apply it to this example. What are we going to have? In this case, we're going to have our volume equals 1 over 3 times by pi times by our radius squared. Our radius here is 4, so we're going to have 4 squared. Let's write that in, 4 squared times by our height. Our height is 10. Let's simplify this and see where we get. Well, 4 squared, that's going to be 16. 16 times 10, that's going to be 160. And 160 times by 1 over 3, that is going to be simply written as 160 over 3. And then don't forget to copy down your pi. Now, guys, if we were asked to write this in terms of pi, this would be our final answer. However, we can bing this into our calculator. And when we do so, what we're going to get is that our volume is equal to 167.55 centimeters cubed is going to be our unit.
If we weren't given a formula, guys, these questions which ask us to work out the volume of a square-based pyramid would be an absolute nightmare, but luckily we are, which means that they're really not too bad. Let's have a look at this one. The question says, calculate the volume of the following pyramid. We're then told that the volume of a pyramid is equal to 1 over 3 BH, where capital B is equal to the area of the base and H is the vertical height of the pyramid. Now, luckily, we can see that we've been given the height of this pyramid. It's 8 centimeters, and we've also been given the side lengths of the square on the bottom. We have two side lengths of 4 centimeters. So what we're going to do, guys, is we're going to sub in our values and we're going to calculate this volume using the formula. So we have that the volume is equal to 1 over 3 times by the area of the base. Now the base is a square with side lengths of 4, so to work out the area, we're going to do 4 times by 4, that is going to give us 16. So we have 1 over 3 times by 16 times by h, where h is the vertical height. We can see here that it is 8. So we have 1 over 3 times 16 times by 8. What's that going to give us? 16 times by 8, guys, that is going to be 128. So we have 128 over 3. That can't actually be simplified any further. So we've got our answer, 128 over 3. We just don't want to forget our units. It's going to be centimeters cubed because we're dealing with volume and all our measurements are in centimeters.
How to calculate the volume of a sphere in 64 seconds. Let's go. When it comes to calculating the volume of a sphere, guys, what we're going to do is we're going to use the formula that the volume is equal to 4 over 3 times by pi times by our radius cubed. Now, this is going to be a formula which is given to us in our exam. However, doesn't mean that it's going to be easy to apply. Let's have a look at this particular example. What are we going to have here? We're going to have that our volume is equal to 4 over 3 times by pi times by our radius cubed, and in this situation our radius is 6, so we're going to have 6 cubed. Let's simplify this and leave it in terms of pi. What are we going to have? We're going to have volume equals 4 over 3 times by pi times by 6 cubed. 6 cubed is 6 times 6 times 6. 6 times 6 is 36, and 36 times 6 is going to be 216. Now we want to simplify this, doing 4 over 3 times 216. In order to do that, we're going to do 216 divided by 3 and then times by 4. That is going to be 216 divided by 3 is 72, times 4 is going to be 288. So guys, our final answer, we're going to have that our volume is equal to 288 pi, and don't forget those units is going to be centimeters cubed because we're working in volume. How to calculate the volume of a frustum in 120 seconds. Let's go. This is always a topic which trips a lot of students up, guys, but don't worry, we're going to make it clear. Let's have a look. It asks us to calculate the volume of the following shape, and the shape that we have is a frustum. Now, a frustum is essentially going to be a larger cone with a smaller cone cut off the top of it. So to work out the volume of that shape, what we're going to do is we're going to work out the volume of the bigger cone, and we're going to subtract the volume of our smaller cone. Now, what's that going to give us? We know that the volume of a cone can be calculated using 1 over 3 pi r squared h. That's going to be a formula which is given to us in the exam. So, working out the volume of our bigger cone, what's it going to be? We're going to have 1 over 3 times by pi times by the radius of that bigger cone. The radius is going to be 5 times by the height is going to be 10. So we're going to have times by 5 squared times by 10. And we're going to subtract the volume of our smaller cone. Now, for our smaller cone, we're going to have a radius of 4 and a height of 4. Sorry, that was a radius of 2 and a height of 4. That's going to give us 1 over 3 times by pi times by our radius squared, so 2 squared times by 4. Now, simplifying this, what are we going to have? 5 squared, that's going to be 25. 25 times 10, that's going to be 250. And 250 times 1 over 3, we can write that as 250 over 3. So we can simplify the whole of our left-hand side to 250 over 3 pi. If that was a bit confusing, slow it down, pause it, and try and work it out. Now, what about this right-hand side? What are we going to have? We're going to have 1 over 3 times by 2 squared is going to be 4. 4 times 4 is going to be 16. 16 over 3 is going to be the result of doing 16 times 1 over 3. So we're going to have minus 16 over 3 pi. Now, simplifying this further, what are we going to have? 250 over 3 pi minus 16 over 3 pi. 250 takes 16, that's going to be 234. So we can write this as 234 over 3 pi. Simplifying that even further, 234 divided by 3, that, guys, is going to be 78. So our answer is going to be 78 pi, guys. And what about our units? Our units is going to be centimeters cubed, giving us our final answer of 78 pi centimeters cubed. How to calculate the surface areas of cubes and cuboids in 112 seconds. Let's go. Let's say we get given this question, guys, where we get asked to calculate the surface area of the following shapes. First off, dealing with our cube, what are we going to do? We're going to firstly use the fact that all of our edges are the same length to say that our height is 4 centimeters and our length is 4 centimeters. Now, we're then going to use the fact that all of our faces are squares of the same side length. So what we can do is we can effectively do 4 times by 4 to calculate the area of one of our faces, and then we can multiply this by 6 because we have 6 faces. So So we're going to do 4 times by 4 times by 6. 4 times 4 is 16, times by 6 is going to be 96, and we're going to have centimeters squared as our unit. What about our cuboid then? What are we going to do? Well, this time we're going to use the fact that we have 3 pairs of opposite faces, which are all at the same area. So we're going to firstly do 3 times by 4. That's going to work out the area of our end rectangle. And then we're going to multiply that by 2 because our opposite face is the same. So we're going to have 3 times by 4 times by 2. 3 times 4 is 12, times 2, that's going to be 24. Now, working with these faces here, this one and this one, what are we going to do? Well, we have a height of 4 centimeters and a width of 8. So we're going to do 4 times by 8. That's going to work out the area of one of them. And then we're going to multiply that by 2 because we have 2 opposite faces which are both the same. 4 times 8 is 32, times by 2, that's going to be 64. And finally, dealing with our top and bottom faces, what are we going to do? This time we have a width of 3 centimeters and a length of 8. So we're going to do 3 times by 8. And then we're going to multiply that one by 2. 3 times 8 is 24, times by 2 is going to be 48. And finally, guys, we need to add together all of our pairs of faces. What are we going to get? Well, we're going to firstly do 24 plus 64. That is going to give us 88. Then we're going to add 48. 88 plus 48 is going to be 136. So our final answer, guys, is going to be 136 centimeters squared. What are we going to get? Well, we're going to firstly do 24 plus 64. That is going to give us 88. Then we're going to add 48. 88 plus 48 is going to be 136. So our final answer, guys, is going to be 136 centimeters squared. How to calculate the surface area of a triangular prism in 89 seconds. Let's go. Let's say we want to answer this question, guys, where we get given a triangular prism and we get asked to calculate the surface area. What are we going to do? Well, we're going to work out the areas of each of our faces, and then we're going to add together those individual areas. Let's get it done. First of all, let's work out the areas of these 2 triangular faces. On the end, we know to calculate the area of a triangle, we can do a half times by base times by height. So that's exactly what we're going to do here. We're going to do a half times by our base of 3 times by our height of 4, and then we're going to multiply that by 2 because we have 2 of these end faces. Next, let's work out the areas of these rectangular faces on the sides of our prism. Now, we can see that both of these faces have this diagonal length of 5 centimeters and a width of 11, and both of them are rectangles. So to calculate the area of each of them, we can do 5 times by 11, and then we're going to multiply that by 2 because we have 2 of these rectangular faces. And finally, we need to add the area of this bottom face. What's it going to be? We have a width here of 3 centimeters and a length of 11 centimeters. So we can work out the area of this rectangular face by doing 3 times by 11. Let's write that in, 3 times by 11. Finally, simplifying, what are we going to get? A half times 3 times 4 times 2, that is going to be 12. So we're going to have 12 plus 5 times 11 times 2, that's going to be 110. So we can write that in. And finally, 3 times 11, that's going to be 33. Adding all of those together then, guys, that's going to be 155. So that is our final answer, 155 centimeters squared. How to calculate the surface area of a cylinder in 84 seconds. Let's go. This is a topic which trips a lot of students up, guys. Let's have a look. The question asks us to calculate the surface area of the following shape, and then we're given this cylinder. Now, to calculate the surface area of a cylinder, we're going to use the formula that the surface area is equal to 2 pi r squared plus 2 pi r h. Now, where does that formula actually come from? The 2 pi r squared, that's going to work out the areas of the circles on the top and the bottom of our cylinder. That's because the area of a circle is pi r squared, so 2 pi r squared is going to give us 2 of those circles, and the 2 pi r h, that's going to give us the area of our curved face. Now, why is that? 2 pi r, that's going to give us the length of the circumference on the top of our cylinder, and then when we multiply that by the height, in this case 12, we're going to get the area of that curved face. Let's get it done. For this example here, what are we going to have? We're going to have that our surface area is equal to 2 times by pi times by our radius, which is 5 squared. Then we're going to add that to 2 pi r h, so 2 times by pi times by our radius, that's going to be 5, times by our height, that's going to be 12. Simplifying this, guys, what are we going to get? We're going to get 5 squared, that's going to be 25, times by 2, that's going to be 50. So we're going to have 50 pi for our first part, and then looking at simplifying this second part, 5 times by 12 is going to be 60, times by 2 is going to be 120, so we're going to have 120 pi there, so we're going to have plus 120 pi, 50 pi plus 120 pi, that's going to give us 170 pi, guys, and that's going to be our final answer in terms of pi, 170 pi centimeters squared. How to calculate the surface area of a cone in 49 seconds. Let's go. To calculate the surface area of a cone, guys, what we're going to do is we're going to use the handy formula that the surface area of a cone is equal to pi times by the radius of our circle on the bottom times by L, which is going to be our slant height. Here it's this length 10 plus pi r squared. Now, the pi r L part is going to work out the area of this curved face, and then the pi r squared, that's going to work out the area of our circle on the bottom. Let's get it done. What are we going to have? We're going to have that our surface area is equal to pi times by our radius, which is 4 times by our slant height, which is 10, plus pi r squared. So we're going to have pi times by our radius is 4, so we're going to have 4 squared. Pi times 4 times 10, that's going to be 40 pi. Pi times 4 squared, that's going to be 16 pi. 40 pi plus 16 pi, that is going to give us 56 pi. And our units, guys, centimeters squared, we can't forget those.
Surface areas of pyramids, guys. This is definitely one of the most challenging types of surface area questions that we can get. Let's have a look at how to do this one. The question says, work out the surface area of the following pyramid. We see that we have a square-based pyramid, which has side lengths of 6 on the square, and then has also a height of 8 centimeters for the triangles on the outside faces of the pyramid. Now, it's really important to notice, guys, that this is not the vertical height of the pyramid itself. This is the vertical height of the triangles on the outside faces of the pyramid. So how are we going to work out surface area? We're going to work out all of our areas and then add them together. First off, looking at the square on the bottom, how do we work out the area of a square? We do the width times the length. In this case, 6 times 6 is going to give us 36. Now, what about those outside faces? How do we work out the area of a triangle, guys? We use the formula that area is equal to, so area is equal to a half times by the base of the triangle times by the vertical height of the triangle. In this case, we have 4 of these triangles, so we're going to do a half times base times height for one of the triangles and then multiply that by 4. In the case of our triangles, what measurements do we have? We see that we have a base of 6 for the triangles, so we're going to do a half times by 6 times by a vertical height of 8 there. We can work this out. A half times by 6, that's going to be a half of 6, which is 3. And then 3 times by 8, guys, that is going to be 24. So each of those 4 triangles have an area of 24. Working out all of the triangles then, we can do 24 times by 4, 24 times by 4, which is going to be 96. Now, final step, guys, we can add together that square face and those 4 triangular faces. We're going to do our 36 plus our 96. 36 plus 96, guys, that is 132, and our units centimeters squared because we are working out an area, and all of our measurements are in terms of centimeters. What did we do there, guys? We worked out the area of the square on the bottom. We worked out the area of each of the triangles using a half times base times height. Then we multiplied that by 4 to get all of our triangles. Finally, we added together all 4 of those triangles with the area of the base on the bottom.
How to calculate the surface area of a sphere in 36 seconds. Let's go. Luckily, guys, despite what you might think, finding the surface area of a sphere really isn't too bad. All that we're going to do is we're going to use the formula that the surface area of a sphere is equal to 4 times by pi times by our radius squared. Let's get it done for this particular example. What are we going to have? We're going to have that our surface area is equal to 4 times by pi times by our radius squared. Our radius here is going to be 7, so we're going to have 7 squared. 7 squared is 49. 49 by 4, that's going to be 196. So, guys, our final answer is going to be 196 pi. Leaving that in terms of pi and our units, that's going to be centimeters squared. There we have our answer.
This question, guys, is a little bit of a mammoth. Let's have a look and see what we can do. The question says, calculate the surface area of the following shape. And then we're given this compound shape, which consists of 2 cuboids kind of fused together. Now, to work out a surface area, guys, what do? We work out the areas of all of the faces and add them together. Let's get through this, doing them one by one. First step, let's divide this compound shape into the couple of separate cuboids. Now, there's a couple of different ways we could do this. We could divide them over here like I've done. We could have also chosen to divide it over at the left like this. Either way is going to be fine there. Next step, let's start working out the areas of our faces. So first off, let's think about this area over here, what's it going to be? To work out the area of a rectangle like this, we need the base, we also need the height. We have the height here, which is 6 centimeters. Can we work out the base? Well, we see that this side length here is going to be the difference between this 8 centimeters on the bottom and this 6 centimeters here. It's going to be the difference between this side length and this side length. 8 subtract 6, guys, that is going to be 2. Now that we have this side length, we can do some work in working out the areas of our faces. So this front face, which I highlighted, that is going to be base times height, 2 times by 6, that is going to be 12. We have 2 of those faces. We have the one on the front. We also have the one on the back. So we can do 12 times by 2, and that is going to adjust for those 2. Next up, let's work out the areas of the faces on the top and the bottom. So we have this kind of rectangle down here. I'll draw a line there just to make it a little bit clearer. Let me just go back to, draw that line there. So this rectangle down at the bottom and this rectangle up at the top. What about these ones, guys? We need the base of the rectangles. We have it already, it's a 2. And what about the width? We can read over here and see that it's going to be 1 centimeters from this side length over here. So let me write that in. Working out the area then, we can do 2 times by 1, so that is going to be 2, and then we can do 2 times by 2 to represent the fact that we have 2 of those, one on the bottom and one on the top. Next up, guys, we're going to work out the area of this face on the left-hand side. We have the base, it is 1, we have the height, it is 6, so we can do 6 times by 1, so plus 6 times by 1, that will be 6, but we can simplify that a bit later on. Where are we going to go from there, guys? Let's work out this rectangle on the outside. We have a height of 4. We're going to have a base of 1 because it's going to be the width of the overall shape, the same as this side length down here. So 4 times 1 is going to be that one. Let's write that in as plus 4. Next up, where can we go from there? Well, we have a few more faces to work out. This face on the bottom, it's going to have a width of, so this one down here, I should make that pretty clear. It's going to have a width of 6 because of this side length here, and a length of 1. So we can do plus 6 times 1. And then we have 2 of those. So we're going to do times by 2. We have the one on the bottom down here, and then also the one on the top up there. Which faces do we have left, guys? We have this face on the front, and then the corresponding, didn't mean to do that, and then the corresponding face on the back of the shape. What's that going to be? We're going to have a base of 6 again. We're going to have a height this time of, what's the height going to be? We don't currently have the height, we don't have a side length for this over here, but we can work it out. It's going to be the difference between the overall height of the shape, which is 6, and the height of this top portion, which is 4. 6 subtract 4, guys, that is going to be 2, telling us that the height over there is going to be 2. Moving on then, what are we going to have? We're going to have our 2 times by our width of 6, so we can do plus, let's write that on another line, 2 times by 6 times by 2. Guys, this is getting pretty long. Hopefully everything is clear enough. So we've done the base face and the top face. We've done the front face and the back face. Finally, guys, let's deal with this face on the right-hand side, a height of 2 and a width of 1. So plus 2 times 1, or we're just going to write that as 2. Now doing this super long calculation, guys, what are we going to get? Simplifying. 12 times by 2 is 24, so we're going to have 24, plus 2 times by 2 is 4, so plus 4, plus 6 times by 1 is 6, plus 4, plus 6 times 1 times 2 is going to be 12. We can combine those together. The 4 and the 12 is going to be 16, plus 2 times by 6 times by 2. 2 times 6 is 12, times 2 is 24. Then we have another 2 over there, so plus 26. Now, guys, finally, combining all of these together, if you're watching on the vertical video, you can see that my head has gone a little bit in the way there. What's it going to be? 24 plus 4, that is going to be 28, plus 6, that is going to be 34, plus 16 is going to be 50, plus 26, guys, we're going to get 76 as our answer. And of course, we can't forget our units there, centimeters squared. Now, that was an absolute mammoth of a question, guys. I'm conscious that the explanation might not have been so crystal clear just because there was so much going on. Pause the video, watch it back, and check that you understand. This is going to cover so much of the surface area topic.
How to calculate the surface area of a frustum in 167 seconds. Let's go. This, guys, is definitely one of the most challenging topics in the course. Pay close attention and see if you can get it. The question asks us to calculate the surface area of the following shape, and we can see that we've been given this frustum over here, which is essentially a larger cone with a smaller cone cut out of the top. Guys, what are we going to do? We're going to work out what the surface area of the larger cone would have been. Then we're going to subtract the area of the curved face of the smaller cone. Then we're going to be adding on this area here, which is the circle on the top of our frustum. Let's get it done. First of all, what would the surface area of the larger cone have been? Well, we know that the formula, I should say, for the surface area of a cone is pi times by r times by L, where r is going to be the radius of the cone and L is going to be the slant height of the cone, this diagonal length here, plus pi r squared. The pi rl, that's going to be the part of our formula which works out the area of the curved face, and the pi r squared, that's going to be the part of the formula that works out the area of the circle on the bottom. So guys, what are we going to do? First of all, working out the surface area of the larger cone, what are we going to have? We're going to have that the surface area of the larger cone would be, we're going to have pi times by r times by L. So we're going to have pi times by our radius, which is 5, times by that slant height, which is going to be 25. Then we're going to be adding pi r squared. That's going to give us the area of this face on the bottom. Pi r squared, here the radius is 5, so we're going to have pi times by 5 squared. Now what do we need to do? We need to take away the curved area of this cone here, which has been cut off of the top. How are we going to work out the area of that curved face? It's going to be pi times by r times by L, where this time our radius is 2 and our slant height is 10. So we're going to have minus pi times by our radius of 2 times by our slant height of 10. Then guys, what do we need to do? We need to add on this circular face on the top. What's that going to be? It's going to be pi r squared, where the value of the radius is 2. So we're going to add to that pi times by 2 squared. Now guys, simplifying, what are we going to have? You can do this on your calculator if you want to. Pause the video now, see if you can work it out. Pi times by 5 times by 25. 25 times 5 is 125, so that's 125 pi. This is going to be 25 pi because 5 squared is 25. 125 pi plus 25 pi is going to be 150 pi. Then we're going to have minus pi times by 2 times by 10. So that's going to be minus 20 pi. 150 pi minus 20 pi, that's going to be 130 pi. Then guys, we need to add pi times by 2 squared. That's going to be 4 pi. 130 pi plus 4 pi. That, guys, is going to be 134 pi. As our final answer, what's our units going to be? We're working in surface area, and we can see that all of our measurements are in centimeters, so we're going to be in centimeters squared, guys. That was all a bit of a mouthful. Hopefully it was clear enough. If it wasn't, feel free to watch again. Identifying plans and elevations in 78 seconds. Let's go. This is going to be a super common topic in our foundation papers, guys. Let's have a look. The question asks us to sketch the front plan and side elevations of the following shape, and we can see from the annotations I've done in orange that our front view is going to be this one here. Our plan view is going to be from the top looking down, otherwise known as kind of a bird's eye view, and our side view is going to be this one here. First of all, drawing our front view, it's going to look like this. And why is it going to look like this? It's going to look like this because we can see from the front that we have one across here, and we have two up, we have this unit up, and then this one up here. What about our plan view, guys? Moving on, we can see that our plan view is going to be that it's going to be 3 back, and it's going to be 1 across. Now, why is that? That's because if we can imagine looking from the top down, we're going to have a length or a width, you could say, of 3 units, 1, 2, and 3. We could look at it from the base as well, 1, 2, and 3, and just like with that front view, we only have 1 across. Finally, guys, our side view, we can see that our side view is going to be this weird shape here, drawing it out quickly. And why is that? That's because if we imagine looking from this side here, we can see that the shape we would be seeing is this, and this. If we wanted to, guys, we can draw these in as well, but we don't have to. They're going to be pretty lenient with that. So we need to make sure that the overall shape is right, but we don't necessarily need these lines here. How to sketch a shape with given projections in 64 seconds. Let's go. Let's say we get given this question here, guys, where we get asked to draw a 3D shape with the following elevations. First off, what does this actually mean? It means that we want to draw a 3D shape, which when we look at it from the front, it's going to be 2 units up and 1 unit across. When we look at it from the top down, otherwise known as a kind of bird's eye perspective, it's going to be 3 units back and 1 unit across. And finally, when we look at it from the side, it's going to have this view here. What is this shape going to look like? It's going to look like this. Now, why is the shape going to look like this? It's going to look like this because this is going to be the only shape which, when we look at it from the front, is going to be 2 units up. We can see that it has 1 unit here, and this second unit would be here, and it's also 1 unit across. And then when we look at it from the plan view, it's going to be 3 units along, we could say, 3 units kind of diagonally or horizontally, whatever you want to call it, and it's going to be 1 unit across. That's going to be true all of the way down the shape. And finally, when we look at this shape from the side view, it's going to look like this. It's going to have this shape here, and that's going to be the silhouette when we look at it from the side view. So guys, that is going to be our answer. Identifying lines of symmetry in 77 seconds. Let's go. In this question, guys, we get asked how many lines of symmetry the following shapes have. Now, a line of symmetry is going to be a mirror line. Essentially, it's going to be a line which divides our shape exactly in half, so that if we folded our shape over that line, it would fold exactly onto itself. So let's have a look at each of these shapes here and how many lines of symmetry each of them have. First off, our square, that's going to have 1, 2, 3, 4 lines of symmetry. Next up, our rectangle, that's going to have 1, 2 lines of symmetry. Next up, we have our triangle, equilateral triangle, I should say. That's going to have 1, 2, and 3 lines of symmetry. Next up, a rhombus, that's going to have 1, 2 lines of symmetry. And it's worth me quickly mentioning that a rhombus is a little bit tricky because sometimes it doesn't look like these two would be diagonal lines of symmetry, but if you checked it, they actually would be. Next up, a pentagon, that's going to have 1, 2, 3, 4, and 5 lines of symmetry. Next up, our parallelogram. That is actually going to have no lines of symmetry at all. Have a think about that one. And finally, our kite, guys, that's going to have exactly 1 line of symmetry going straight through the middle. Now, of course, when I drew those lines of symmetry on there, they weren't exactly perfect, but I hope you got the gist from what I did. How to work with rotational symmetry in 94 seconds. Let's go. Unfortunately, guys, this is a topic which is forgotten about so often in school, but don't worry, we're going to make it clear. Let's have a look. Rotational symmetry. First off, what does it mean for a shape to be rotationally symmetrical? What it means is that if we rotate that shape around the center point, we can end up with exactly the same shape, looking in exactly the same way as we started out with. So if a shape, for example, has rotational symmetry of order 2, there are going to be 2 different rotations of that shape which look exactly the same. Now, that might sound a little bit weird at the moment, so let's have a look at these 4 shapes to show what I mean. So, first off, our square. We would say that a square has rotational symmetry of order 4, and that's because there are going to be 4 different rotations, 1, 2, 3, and 4, which look exactly the same when we rotate the shape around the center point. What about our pentagon? A pentagon, we would say, would have rotational symmetry of order 5, and that's because there are going to be 5 different rotations, 1, 2, 3, 4, and 5, which look exactly the same. Next up, our kite. Our kite, we would actually say, has rotational symmetry of order 1, and that's because there's actually going to be only one version of this, one rotation of this, which looks exactly the same as the start point, and that is if we rotated it a full 360 degrees. That's the only way to get a shape which looks like this. Finally, our compound shape down here in the bottom right-hand corner, guys, we would say that that would have rotational symmetry of order 2, and that's because there are going to be 2 rotations, 1, 2, which look exactly the same when we rotate this around the center point. How to translate shapes in 121 seconds. Let's go. In this question, guys, we get asked to translate shape A firstly by the vector 2, 3, and then by the vector -1, -2. Let's have a look and see what we do. When it comes to translating a shape, guys, what we're going to do is we're essentially going to pick that shape up and move it. The top number of our column vector is going to tell us how many units horizontally we move that shape, and the bottom number is going to tell us how many units vertically. Let's have a look at this first example, moving it by the column vector 2, 3. Because our top number is a 2 here, we're going to move every point in our shape 2 units to the right, and because our bottom number is a 3, we're also going to move them 3 units up. Let's take our top right hand point to show you what I mean. First off, moving this point 2 units to the right, we're going to go 1, 2, and then 3 units up, we're going to go 1, 2, 3. So our new coordinate for our top right point is going to be 4, 5. Let me write that on. Now, a quick little trick, guys. What we can do is we can actually use the fact that our bottom right hand point is 2 units below our top right point to write that one on. So we can draw this one in here because it's going to be 2 units below our top right hand point. Then coming up to our, we could say top left hand point, we can say that this one's going to be 1 unit across from this top right hand point, and then you can kind of get the gist of what I mean. We can draw in the rest of our shape, and this is going to be our new location. What about this next part then? Question B, moving it by the column vector -1, -2. What are we going to do? Well, again, we're going to go 1 unit to the left this time, and then we're going to go 2 units down. The top number tells us how many units horizontally, the bottom number tells us how many units vertically. So let's start this time at our bottom left hand point, moving 1 unit to the left. We're going to go here, and 2 units down. We're going to go 1, 2 units down. The new location is going to be -1, -2. Let me draw that on just now. And from there, we can work to draw the rest of our shape. We're going to go 1 unit up to get this new point. Then we can go 1 unit right and 1 unit up, and that's going to give us this crease here. We're going to go 1, 2, and from there we can draw the rest of our shape, drawing it in just like this, and we can see the new location of our shape. Rotating shapes in 97 seconds, let's go. Whenever we have a question which involves rotation, guys, the best method is always going to be to use some tracing paper. Let's have a look exactly how this one's done. The question asks us to rotate shape A 90 degrees anti-clockwise about the point -1, -1. Let's have a look. Step number 1, that is going to be to draw on our center of rotation and also to layer on top our tracing paper. We can see here that our center of rotation would be down here, -1, -1, and I've used this gray square to denote where our tracing paper would be. Step number 2, that is going to be to trace over our center of rotation and also to trace over the shape that we're rotating. Step number 3 then, guys, that's going to be to put our pen on the center of enlargement and to rotate our whole tracing paper about that point, absolutely making sure that we don't move our pen and we don't let that tracing paper slip. It's going to be a little bit different here. Let me show you. I'm going to circle around here and I'm going to rotate 90 degrees anti-clockwise. That's going to be a quarter of a turn. A full turn would be 360 degrees. 90 degrees is a quarter of 360, so it's going to be 90 degrees, a quarter of a turn anti-clockwise. So we're going to go the opposite way to the clock. So in other words, you could say we're rotating left, rotating 90 degrees and quarter of a turn, moving this. What are we going to have? 90 degrees. We're going to end up exactly here. And guys, that is going to tell us the new location of shape A. Just to be very clear, I'll draw on the original location. That is going to be just in 1 second. Here, 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 and here. We can now see where our shape was, where it ended up, and that is going to be, guys, our 90 degrees turn anti-clockwise. Reflecting shapes in vertical and horizontal lines in 82 seconds. Let's go. In this question, guys, we get asked to reflect shape A in the line x equals -1. What are we going to do? Step number 1, that is going to be to draw on our line of reflection. We can see that here we have a vertical line which goes through the point where x is equal to -1. At every single point on this line, the value of x is -1. Step number 2, then, that is going to be to count how we get from each of our points to the line of symmetry, and then to do that the other side of the line of symmetry as well. Let me show you what I mean. So going from this bottom left hand point to our line of symmetry, we go 1 unit to the left. So to get to our new coordinate, we need to go 1 more unit to the left. That is going to take us to the point -2, 0. What about this coordinate here then? We could say this is our bottom right coordinate. We're going to go 1, 2, 3 places to the left to get to our line of symmetry. So we need to go 1, 2, 3 places to the left to get to our new coordinate. That's going to be -4, 0. What about this top right hand point then? How do we get from here to our line of symmetry? It's going to be 1, 2, 3 places to the left. So getting to our new point, that's going to be 1, 2, 3 more places to the left, writing that in. Now, guys, if we were to draw on the rest of those points, they would be here, here, and here. And final step then, guys, that's going to be to join all of our points together, doing that now using our straight lines. Okay, that went a little bit wonky, but you can see how it was supposed to look, and we have our new shape just there. Make sure you use a ruler and make sure you do it carefully. Enlargements with positive integer scale factors in 107 seconds. Let's go. When it comes to enlarging shapes, guys, there are going to be a couple of different methods. I'm going to show you my personal favorite. Let's have a look. This question asks us to enlarge shape A by scale factor 2 about the point -1, -2. Step number 1, that is going to be to draw on our center of enlargement, the point -1, -2, drawing that on now. Now, how are we going to find the new coordinates of each of our points? What we're going to do is we're going to count how to get from our center of enlargement to our point. Then we're going to multiply that distance in the x and y direction by our scale factor. Let me show you exactly what I mean. So how do we get from our center of enlargement to our bottom left-hand point? Well, we're going to move 1 unit to the right and 2 units up. So to get from our center of enlargement to our new bottom left-hand point, we're going to double both of those distances. We're going to go 2 units to the right, and we're going to go 4 units up, because it was 1 unit to the right, 2 units up. Now it's going to be 2 units to the right and 4 units up. Let's do that now. So we're going to go 2 units to the right, and we're going to go 4 units up, drawing on our point then. That is going to be our new bottom left-hand point. What about then? Let's take this coordinate here to do as our next one. How do we get from our center of enlargement to this point? Well, we're going to go 1 unit to the right, and we're going to go 1, 2, 3 units up. So to get to our new point, which is going to be corresponding with that point, we're going to go 2 units to the right and 6 units up, doubling that 1, 3 to get 2, 6. So drawing that on now, then we're going to go 1, 2 units to the right and 1, 2, 3, 4, 5, 6 units up. That is going to give us our new coordinate. Now, we could do this for every single one of our points, but an easier way is actually going to be to use the relationships between all of the different points on our shape before and after. So we can see, for example, before that the distance between those 2 points was 1 unit, but now it's going to be 2 units. That's because our shape has gotten twice as big because it's been enlarged scale factor 2. So we can now use these 2 points to find all of the new points on our shape, and that's going to save us a bit of time. So how to find this point? Well, originally it was going to be 1 unit to the right of this point. Now it's going to be 2 units to the right. So we're going to go from here 2 units to the right, and that is going to give us our new point. It's going to be here. Now going from this point, which is now this point, to this point, we're going to go 2 units up instead of 1 unit up. So it's going to be here. We can then do that for the rest of our points, guys. And if we did, it's going to give us this shape here. We can then connect all of our points together, and we can see that our new enlarged shape, once I've drawn it, just a couple of seconds, guys, is going to be here. And we have our new enlarged version of shape A. All of the distances from the center of enlargement have been doubled, and all of the side lengths of the shape have also been doubled because our scale factor is 2, so they're 2 times as big. Enlargements with positive fractional scale factors in 151 seconds. Let's go. This is a topic which trips a load of students up, guys. If you haven't already, make sure you watch our video on enlargements with positive integer scale factors. It's going to help with this one. So this question asks us to enlarge shape A by scale factor a half about the point -4, -2. It's worth quickly noting that the method is going to be exactly the same as with our integer scale factors. Let's have a look. So first up, we're going to draw on our center of enlargement, -4, -2, writing that on here, -4, -2. Next, we're going to count how we get from our center of enlargement to each of our points, and we're going to multiply that distance by our scale factor. The difference here is that because our scale factor is a fraction, our distance is going to get smaller. Let me show you what I mean. So counting how we get from our center of enlargement to our bottom left-hand point here, what are we going to do? Well, we're going to go 1, 2, 3, 4 units to the right and 2 units up. So multiplying that distance by our scale factor of a half is going to go from 4, 2 to 2, 1. That's because a half of 4 is 2 and a half of 2 is 1. So from 4, 2 to 2, 1, let's draw on that new point. We're going to go 2 units to the right, 1 unit up, and this is going to be our new bottom left-hand point, drawing that on here. Now we can do that with another point. Let's take this point, for example. How do we get from our center of enlargement to this point? We go 1, 2, 3, 4 units to the right and 1, 2, 3, 4 units up, multiplying both of those distances by a half. A half of 4 is going to be 2, so it's going to go from 4, 4 to 2, 2. Let's draw that new point on then. So we're going to go 1, 2 units to the right and 1, 2 units up, drawing that on. And now, just like with our integer scale factors, we can use our new points, or a couple of our new points, to find the rest of our new points. How are we going to do that? Well, we can see that the distance between these 2 points was originally 2, and then it became 1. That's because we enlarged it by a scale factor of half. We made it a half as big. So all of our distances, which were all originally actually 2, apart from these ones over here, which were 4, are going to be half as big. So going from this point to this point, originally it was 2 units, right? Now it's going to be half as many. It's going to be 1 unit to the right. So we can draw that new point on here, and we can follow that exact same logic to draw the rest of our points, which are going to be there, there, and there. Final step, joining those points together then. Hopefully we can be a little bit more accurate with this one than our previous few, drawing these on, joining our points together, and we can see that our new shape is going to be just like this. Remember, guys, all of our distances are now half as big as they were before, and our overall shape is also exactly half as big as it was before the enlargement. How to enlarge by negative scale factors in 124 seconds. Let's go. Whenever it comes to enlarging by a negative scale factor, guys, our method is actually going to be very similar to enlarging by a positive one, with one key difference. Let's have a look at this example. The question asks us to enlarge shape A by scale factor -2 about the point 1, 1. Step number 1, guys, we're going to draw on that center of enlargement, which is going to be the point 1, 1. Next, we're going to choose our first coordinate to work with, our first point, and let's choose this bottom left-hand one. Now, what we're going to do, just like with any other enlargements question, is we're going to work out how we get from our center of enlargement to that point. In this case, we're going to go 1 unit to the right and 1 unit up. And now we're going to multiply this movement by our scale factor of -2. Now, how do we deal with the negative in this situation? Well, the negative is going to flip the direction. So instead of going 1 unit to the right and 1 unit up, the negative part of our -2 is going to make us go left and down, like I say, instead of right and up. Then the 2 part of that is going to take it from a movement of 1 right and 1 up to 2 left and 2 down. So let me show you what I mean by drawing this point in. We're going to go, instead of 1 right and 1 up, we're going to go 2 left and 2 down. We're going to go 1, 2 units left and 1, 2 units down. That is going to get us to -1, -1. Now let's choose another point to work with. Let's choose this time our bottom right-hand point. How do we get from our center of enlargement to that point? We're going to go 1, 2, 3 units to the right and 1 unit up, timesing this by -2. Instead of going 3 right and 1 up, we're going to go 6 left and 2 down. Let's draw that in now. We're going to go 1, 2, 3, 4, 5, 6 to the left and 1, 2 down. We're going to end up at -5, -1. Let's draw that in. Now we can choose another point. Drawing in this time, let's choose this top left-hand point here. How do we get from our center of enlargement to that point? We're going to go 1 unit right and 1, 2, 3 units up. So now, timesing that by -2, we're going to go 2 units to the left and 6 units down. So we're going to go 1, 2 units to the left and 1, 2, 3, 4, 5, 6 units down, drawing that point in there then. And now we can draw in all of our other points where they would be. We would have 1 here, 1 here, and 1 here. And finally, we can join all of those together, which is going to give us this shape here. How to identify invariant points in 65 seconds. Let's go. In this question, guys, we get asked to identify the invariant points when shape A is reflected in the line y equals 0. First of all, what actually is an invariant point? An invariant point is going to be any point which is in exactly the same place before and after our shape has been moved. It's going to be any point which doesn't change place after this transformation has been done. Let's have a look then. First of all, let's reflect our shape in the line y equals 0. Drawing on our line y equals 0 is going to be this horizontal line here and doing our reflection. If you're not sure how to do this, watch our video on reflections, but it's going to look just like this. Drawing this in, dot, 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 and one more line, dot, and we can see, guys, that there are actually going to be 2 points on our shape that haven't moved, that are in exactly the same place before and after. It's going to be this point here, before it was in 0, 0, and after it's in 0, 0, and the other invariant point, guys, is going to be this one here. It's going to be 2 to the right and 0 up, so it's going to be the point 2, 0. Those are going to be the points of our shape which haven't moved after a transformation has been made. How to work with alternate angles in parallel lines in 38 seconds. Let's go. In this question, guys, we're given 2 parallel lines. We have one here, and we know they're parallel because of these arrow signs. Now, we're asked to calculate the value of x, which is going to be this angle down here. The key thing to note in this question, guys, is going to be that whenever we have alternate angles in parallel lines, they're going to be the same. Now, our 62 degrees and our x degrees are going to be alternate because we can draw this kind of Z shape, which goes along one of our parallel lines, down the line which links them, and then along our other parallel line, and these two are going to be inside the corners of our Z shape, which means they're going to be alternate. Alternate angles are the same, like I said. That means that our angle x is going to be 62 degrees. How to work with co-interior angles in parallel lines in 38 seconds. Let's go. In this question, guys, we're asked to calculate the value of x, and we're given 2 parallel lines denoted by these arrows here. We're told that this angle is 117, and we're told that this angle is x. What are we going to do? We're going to use the fact that co-interior angles in parallel lines always add up to 180 degrees. Now, why are these 2 angles co-interior? They're co-interior because they're kind of inside this C shape. We can see that we can draw a C shape here, and our 117 and our x are the ones which are inside this C shape. So they add up to 180. So to calculate the size of angle x, we can do 180, subtract our 117. That is going to give us 63, guys. So the size of angle x is going to be 63 degrees. How to work with corresponding angles in parallel lines in 50 seconds, let's go. In this question, guys, we're asked to calculate the value of x, and we're given this diagram here, which has two parallel lines. We have one here and one here shown by these arrows. We're told that this angle here is 117 degrees, and this angle here is x. So how are we going to find it? The quickest way is going to be to use the fact that corresponding angles in parallel lines are the same. Now, our corresponding angles, they're going to be our angles which are kind of in the bottom corners of this F shape. We can see from what I've highlighted here with the green pen that we have this kind of F shape going on, and these angles are both on the inside corners of our F shape, and that is what makes them corresponding. So like I say, corresponding angles are the same. This angle is 117, this angle is x, and that is going to tell us, guys, that our angle x is going to have to be 117 degrees. How to calculate scale factors in 43 seconds, let's go. In this question, guys, we're given two triangles. We have one here, and we're asked to calculate the scale factor for the enlargement from triangle A to triangle B. Now, because this is an enlargement, we know that triangle A and triangle B have to be similar, which means they're exactly the same shape. But how are we going to find the scale factor for the enlargement? What we're going to do is we're going to divide one of our side lengths on triangle B by one of our side lengths on triangle A. Now, it has to be a corresponding side length, which means it has to be the same side length from A versus B. In this case, we're given the bottom side length of A and the bottom side length of B. So we can do 18 divided by 12. If we do 18 divided by 12, guys, we would get 1.5. You could work that out by simplifying your fractional using a calculator, and that is going to give us our scale factor. How to work with similar side lengths in 56 seconds, let's go. In this question, guys, we're told that triangle A and triangle B are similar, and we're asked to calculate the size of side length x, guys. What are we going to do? Well, we're going to firstly calculate the scale factor for enlargement from triangle A to triangle B, and we're going to do that by dividing one of our side length on triangle B by the corresponding side length on triangle A. So we're going to do our bottom of triangle B, which is going to be 10, divided by our bottom side of triangle A, which is going to be 8, and 10 divided by 8, that can be written as 1.25. So we know that the scale factor of enlargement between triangle A and B is 1.25. Finally, then, to calculate the size of side length x, we're going to multiply the corresponding side on triangle A, which is 12 centimeters, by our scale factor. So we can do our 12 times by 1.25. If we calculate that using a calculator or in our head, it's going to be 15, and that's going to tell us, guys, that our value for x is going to be 15 and our side length is 15 centimeters. How to work with similar areas in 76 seconds, let's go. It has to be said, guys, that this is a topic which trips students up so often, and it does come up all the time, so let's have a look. The question says, given that triangle A and triangle B are similar, and the area of triangle A is 48 centimeters squared, calculate the area of triangle B. Guys, what are we going to do in this question? We're going to firstly find our scale factor in side lengths, then we're going to square it to find our scale factor in areas, and then we're going to apply that scale factor to our area of triangle A. Let's get it done. So firstly, finding our scale factor in our side lengths. We know to do that, we're going to divide one of our side lengths on our bigger triangle by one of our side lengths on our smaller one. Here we can do 16 divided by 8. 16 divided by 8, that is going to give us 2. So we know that our scale factor in side lengths is 2. Now to find our scale factor in areas, we're going to have to square this. So let me write scale factor and A for areas. We're going to do 2 squared. 2 squared is going to be 4. So we know our scale factor in areas is going to be 4. Now finally, we're going to multiply the area of triangle A, which was 48 centimeters squared, by our scale factor in areas. So we're going to do our 48 times by 4, 48 by 4, 40 by 4 is 160, and 8 by 4 is 32. 160 plus 32, that's going to be 192, guys. So our area is going to be 192 centimeters squared. How to work with similar volumes in 79 seconds, let's go. This is another one, guys, which trips people up all the time. Let's have a look. The question says, given that cylinder A and cylinder B are similar, and that the volume of cylinder A is 480 centimeters cubed, calculate the volume of cylinder B. Guys, what are we going to do? Step number 1, we're going to calculate our scale factor in lengths. Then we're going to cube that number to find our scale factor in volumes. Then we're going to multiply the volume of our first cylinder by that scale factor in volumes to find the volume of the second one. Let's get it done. So first of all, calculating our scale factor in lengths, we're going to divide one of our lengths on shape B by one of our lengths on shape A. We can see here that the radius of shape B is going to be 12 and the radius of shape A is going to be 4, so they can be our lengths that we use. So our scale factor in lengths then, guys, that's going to be 12 divided by 4. 12 divided by 4 is 3, so our scale factor in length is going to be 3. Finding our scale factor in volumes, then we're going to cube that number. So scale factor in volumes, that is going to be 3 cubed. So we're going to do 3 cubed, 3 times 3 times 3. That's going to be 27. Finally, multiplying our volume of shape A, which is going to be 480 centimeters cubed, by that scale factor in volume. So we're going to times it by 27. If we type that into a calculator, guys, I'll do it in our head. It's going to be 12,960. Hopefully, 12,960 then, guys, is going to be our answer. 12,960 centimeters cubed. How to work with maps and scale drawings in 73 seconds. Let's go. This, guys, is a topic which comes up all the time in foundation papers. Let's have a look at this one. The question says, given that the distance between A and B on the map below is 3 centimeters, calculate the distance between A and B in reality. Now, guys, in your exam, you probably wouldn't actually be told that it's 3 centimeters. You would have to use your ruler and measure it. I want to quickly mention, on your screen, it's probably not 3 centimeters. Some people are on phones, some people are on computers, so it's going to be different for everybody. In your exam, you would actually measure it. So, assuming that the distance on the actual piece of paper in our exam is 3 centimeters, how would we answer this question? Well, what we're going to need to do is we're going to have to use the scale down here. And we can see from the scale that 1 centimeter is going to be equal to 500 meters in reality. In this case, we don't have 1 centimeter, we have 3 centimeters. So to work out the value in actual reality, we would have to do our 3 centimeters times by 500, and that is going to give us 3 times by 500. 1,500 meters as our final answer. 1 centimeter is 500 meters. So to find 3 centimeters, we do 500 meters times by 3, and that gives us 1,500 meters as our answer. The fundamentals of congruence in 105 seconds. Let's go. First of all, guys, what does it actually mean for two triangles to be congruent? We would say that two triangles are congruent if they have exactly the same side lengths and, crucially, exactly the same sides. Now, a really common question is going to ask us to identify whether two triangles are congruent, and there are going to be 4 different rules we can use to identify whether two triangles are congruent. Our first rule is going to be SSS, which stands for side, side, side. If two triangles have exactly the same side lengths, we can see that this triangle here has 3, 4, and 5, and this triangle up at the top also has 3, 4, and 5. They are going to be congruent, so that's rule number 1, SSS, side, side, side. Next up, we have RHS, which stands for right angle, hypotenuse, side. If two triangles both have a right angle, like this and this, the hypotenuse the same, like this and this, and one other side the same, like this and this, we would also say that they're congruent. Third up, we have SAS, which stands for side, angle, side. We can see in this triangle here that we have a side, an angle in between, and another side, which are 3 centimeters, 53 degrees, and 5 centimeters, and we have the same with the triangle at the top. We have 3 centimeters, 53 degrees, and 5 centimeters. It's absolutely crucial there, guys, that the angle is in between those two sides. Finally, we have ASA, our last one, which stands for angle, side, angle. We would finally say that these two triangles, this one and this one, are also congruent. Why? Because they have an angle and a side in between and another angle, which are all the same. We have 37, 5, 53, and at the top we have 37, 5, 53. Now, if you are paying attention, you would notice that because each of these triangles are congruent with the triangle at the top, they would all also be congruent with each other. Try and wrap your head around that and see if you can get it. Identifying congruent triangles in 57 seconds. Let's go. In this question, guys, we're given two triangles and we're asked to identify whether they are congruent. We're also asked if they are congruent, how we know that that is the case. Guys, what are we going to do? Well, we know from the previous video that there are going to be 4 different ways to identify whether two triangles are congruent. Either we're going to have 3 side lengths which are the same, side, 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 or we're going to have angle, side, angle, so 2 angles which are the same and a side length which is the same in between them, or we're going to have SAS, side angle side, the same but with sides and an angle in between. And finally, we're going to have right angle hypotenuse side as our final rule. Looking at these two triangles then, what do we think? Can we identify whether they are congruent? Well, in both cases, we're given two side lengths. We have 5 and 7, 5 and 7. So we have side, side. And do we have an angle in between them, which is the same? Well, this angle is 95 degrees and this one is also 95 degrees. So we can say that yes, they are congruent. And how do we know that they are? We know that they are because we have side angle side as our rule. All of the key circle terms to be aware of in 70 seconds. Let's go. Feel free to save this one for later, guys, if you think it might help. Here we have all of the key circle terms to be aware of. Let's have a look. First of all, we have the center of our circle. That one's kind of self-explanatory. Next up, we have a radius. That's going to be a straight line which joins our circle to the center of our circle. Next up, we have our diameter. That's going to be a straight line which runs all the way across our circle, going through the middle, and our diameter, crucially, is going to be 2 times our radius. See if you can explain why that is in the comments. Next up, what are we going to do? We're going to do a sector. That's going to be a section of our circle which is bound by 2 radiuses. Next up, we're going to have a chord. That's going to be a straight line which joins one point on our circle to another point on our circle, and linked to that we have a segment, and that's going to be the space which is bound by the chord to the center of the circle. Next up, let's talk about an arc. That is going to be a section of the circumference of a circle, and crucially then our circumference, that's going to be the length all the way around the side of our circle. So we can say that an arc is a part of a circumference. Now, finally, we're going to talk about our tangent. A tangent, what's that going to be? That's going to be a straight line which touches our circle at exactly 1 point. Crucially, it's only 1 point, not more than that. Calculating the circumference of a circle in 48 seconds. Let's go. In this question, guys, we're asked to calculate the circumference of the following circle. Whenever we're working out the circumference, guys, the formula to use is going to be that the circumference of our circle is equal to pi times the diameter. Now, we could also see this written as 2 pi r. And why is that? That's because 2 pi r and pi d are actually exactly the same thing. Why? Because 2 times by our radius would give us our diameter, because our diameter is double our radius. So those two versions, exactly the same thing. Let's get it done. So what's it going to be? It's going to be that our circumference is equal to pi times diameter. If our radius is 4, our diameter is going to be 8. So we're going to have pi times by 8. Now we can write this in a simpler form as 8 pi. And if we wanted to, we could bring it into our calculator. And if we did, we would get 25.13 to 2 decimal places. How to calculate the area of a circle in 37 seconds. Let's go. In this question, guys, we're asked to calculate the area of the following circle. Now, whenever we want to work out the area of a circle, we're going to use the formula that the area is equal to pi r squared, where r is the radius of our circle, and the radius, remember, guys, is going to be the distance joining the edge of our circle to the center with a straight line. Here we can see that our radius is going to be 4, which is going to tell us that our area is equal to pi times by our radius, which is going to be 4. So pi times by 4 squared. What's that going to be? 4 squared is 4 times 4, which is 16. So we have 16 pi. And don't forget, our units is going to be centimeters squared because it's area, and our units is centimeters. Calculating the area of a circle sector in 74 seconds. Let's go. This is a topic which comes up all the time, guys. Let's have a look. The question says the following shape is a sector from a circle. Calculate its area to 2 decimal places. Now, if we remember, guys, a sector of a circle is going to be a part of a circle which is bound by 2 radiuses. Now, what we're essentially going to do is we're going to work out what the area of the overall circle would have been, and then we're going to multiply that by the share of the circle that we have. We can see that we have this formula up here for the area, and the formula is that we're going to do the angle that we have divided by 360 times by pi r squared. Now, where does that come from? Pi r squared, that would work out the area of the total circle, and then when we multiply that by our angle divided by 360, that would be multiplying by the share of the circle that we have. Here we have essentially 87 degrees out of the full 360 degrees that would make up that full circle. So that's going to be how we're going to do it. Now let's get it done. We're going to have that our area is equal to our angle, which is 87 degrees, divided by 360 times by pi times by our radius, which is 4 squared. Now we want to give our answer to 2 decimal places, guys. How we're going to do it? We're just going to bring that into our calculator, and I've already done that. When we do that, we're going to get 12.15 to 2 decimal places. Don't forget your units. Centimeters squared is what it's going to be. How to calculate the arc length of a circle sector in 84 seconds. Let's go. In this question, guys, we're given a sector of a circle and we're asked to calculate the arc length to 2 decimal places. Now, if we remember from a few videos ago, the arc length is going to be this length here. And to work it out, we're going to use the formula that the arc length is equal to the angle that we have, which here is 87 degrees, divided by 360 times by 2 pi r. Where actually does this formula come from, though? Because that's going to help us understand it. So what we're essentially doing is we're going to be working out a share of the circumference of the full circle. So if we were working out the circumference of the full circle, we would do 2 pi r, otherwise known as pi d. Those two things mean exactly the same thing, but here we don't actually have the full circumference of a circle, we only have a fraction of it. In fact, the full circle, that would have represented 360 degrees here, but we only have 87 degrees. So we have a share of 87 parts out of 360 parts of our full circle. So we need 87 parts out of 360 parts of our full circumference. So let's work that out then. Let's say that our arc length, let's call it L, that's going to be equal to our angle, which here is 87 degrees out of 360 times by 2 pi r. So 2 times by pi times by our radius, which is 4. Guys, if we binged this into our calculator, because I can't do that in my head, we would get 6.07 to 2 decimal places. And our units, guys, what would it be? It would be centimeters, because this is a length. A quick reminder of the key circle theorems in 100 seconds. Let's go. I've got to be honest, guys, this is probably the least popular topic in the entire course. Here we have a quick reminder of every single circle theorem that could come up in your exam. First off, we have the fact that opposite angles in a cyclic quadrilateral add to make 180. Next up, we have the fact that the angle at the center of the circle is going to be double the angle at the circumference of the circle. Up next, we have the fact that angles in the same segment are going to be the same. Here we have that if this angle here is x, this angle here is also going to be x. Up next, we have the fact that the angles in a semicircle, we see here that we have a semicircle here, are going to be 90 degrees. We see that at this point here, the angle which is made is 90 degrees. Up next, we have the fact that if a radius meets a chord at a right angle, here we can see that there's a right angle here, the two sides either side of where those points meet are going to be the same. Here we can see that if this side length is x, then this is also going to be x. Up next, we have the fact that a radius always meets a tangent at 90 degrees. That's going to be number 6. Number 7, guys, we have the fact that if there are two tangents to a circle, we have one here and one here, and they meet at a point here, A, then these two side lengths, this one here and this one here, are going to be the same. What's the point of the 90-degree angles here? They just show that both of these tangents meet those radiuses at a right angle, kind of similar to this rule up here. Finally, guys, this one's going to arguably be the most annoying. It's kind of the most abstract. We have the fact that the angle at the point where a chord meets a tangent is going to be the same as the angle which is subtended by that same chord. So if this angle here between AC and our tangent was equal to x, then this angle here up at the top of this triangle here would also be x. Combining circle theorems in 94 seconds, let's go. These questions, guys, which require us to combine different circle theorems, are pretty difficult, but I've got to be honest, they come up quite a lot and they're worth a lot of marks. Let's have a look at how to do this one. The question says, calculate the value of x, which is going to be this angle over here. Now, how can we think about the best way to find the value of x? Well, first of all, we're going to use the fact that the opposite angles in a cyclic quadrilateral add up to 180. And what that's going to allow us to do is recognize the fact that if we had this angle here, then we'd be able to find the value of x by doing 180 minus this angle here. Now, how do we know it's a cyclic quadrilateral? Because the points B, C, D, and A are all on the circumference of our circle, and if we were to draw lines connecting them, we can see pretty quickly that we have a quadrilateral. So we know if we had this angle here that we'd be able to find x. But now, how do we find the size of that angle there? We're going to use a different circle theorem, which is going to be the fact that the angle at the center of a circle is double the angle at the circumference. So we've been given this angle here, 168, and we know that this is going to be double this angle here because of that circle theorem. So to find the size of angle CBA, that angle there, we can do 168 divided by 2, 168 divided by 2, and if we do that, guys, we're going to get 84. That tells us that this angle here is 84 degrees, and now, like I said before, we can do 180 minus 84 degrees, and that's going to give us 96 degrees, guys. So we found the value of x. The value of x is 96 degrees. How to draw a locus of points in 61 seconds, let's go. Here guys, we have a quick reminder of how to draw a locus of points from either a given point or from a line. What are we going to do now? I'm going to have to ask you to use your imagination a little bit here because of course I cannot use a compass on the iPad, but I'm going to explain it, so don't worry. First of all, drawing a locus of points from a given point. What we're going to do is we're going to set our compass to that length by measuring it out on our ruler, and then we're just going to draw a circle around that point. So we put the pointy end on the dot and then draw a circle around it. Now, what about in the case of a line? We're actually going to do exactly the same thing. However, there's going to be a little bit of a difference. So what we're going to do is we're going to draw a locus of points around the end of our line. So we're going to draw a circle here, and then we're going to do the same with the other end of our line. So we're going to put our compass here and draw our circle. Next, what we're going to do is we're going to join the top of our circles with a straight line using a ruler, and we're going to join the bottom with a straight line using a ruler as well. And that, guys, is what's going to give us that locus of points, which is a given distance from a line. How to construct a perpendicular bisector in 47 seconds. Let's go. Here guys, we have a quick reminder of how we can use a compass to construct a perpendicular bisector of a line between 2 points. Step number 1, we're going to get our compass and we're going to set it to over half of the distance between our 2 points. Step number 2, we're going to put our pointy side of our compass on one of our points and we're going to draw a large arc like this, and then we're going to keep the compass exactly the same width. We're going to put the pointy side on the other point and we're going to draw a second arc. Now, once we've done this, we can see that we're going to get a point here and a point here, and when we connect these 2 points with a straight line like I've done here, make sure you use a ruler for that, we're actually going to get our perpendicular bisector. So this line is exactly halfway between point A and point B, and crucially it's perpendicular to the line which connects them. How to draw a perpendicular line from a point in 79 seconds. Let's go. This method, guys, is going to be super similar to drawing a perpendicular bisector. In fact, it's going to use that whole technique. So if you haven't already, watch our previous video on that. Let's have a look. This question wants us to use a compass to draw a line which is perpendicular to the line AB. So it has to meet it at a right angle and the point has to go through the point C. We have loads of construction lines here, guys. Let's have a look and see what we did. Step number 1, what we're going to need to do is we're going to need to get our compass, put it on point C and draw a mark here and a mark here. We're going to make sure that those marks are exactly the same distance from point C. So we need to make sure that we don't change the width of our compass between drawing those 2 marks. Then, guys, the method from there is actually exactly the same as for our perpendicular bisector. What we're going to do is we're going to do a perpendicular bisector of this point and this point. So just a quick reminder on that, what we're going to do is we're going to use our compass and we're going to set it to a distance which is over halfway between those 2 points. Next step, we're going to put it on one of our points, let's say this one here now, and we're going to draw this line here, a nice big arc. Then we're going to keep our compass the same length, we're going to put it on this point here and draw this second arc. Now finally, guys, all that we have to do is draw a line which goes through this point here and this point here. So we use our ruler and we draw a nice long line like this, and that's going to be the answer to this one. How to bisect an angle with a compass in 57 seconds. Let's go. Here, guys, we have a quick reminder of how to use a compass to bisect an angle. Step number 1, we're going to take the pointy end of our compass and we're going to put it here on point B. Step number 2, we're going to set our compass to a reasonable length and we're going to draw this nice long green arc here, making sure that it crosses through this line here connecting A and B and this line here connecting B and C. Next step, what we're going to do is we're going to change the length of our compass and we're going to put the pointy end here and make sure that that length that we change it to means that we cover over half of the distance between the 2 lines, and we're going to draw this line here. Then we're going to move the pointy end of our compass to this point here, making sure that we keep the width of the compass the same. I'm going to draw this arc here. Now, guys, our final step, all that we have to do is get our ruler and draw a straight line which goes through this point here and this point here. So we draw that line over like this and we've bisected our angle. Remember, guys, an angle bisector is going to cut that angle exactly in half. How to use a compass to construct a 60-degree angle in 54 seconds. Let's go. Here, guys, we have a quick reminder of how to use a compass to construct a 60-degree angle. Step number 1, we're going to take the point of our compass and we're going to put it on point A. Step number 2, we're going to set our compass to a reasonable width and we're going to draw this green line here. Now, make sure you don't take that compass off the page. Make sure you do a nice clear line. Now, step number 3, what we're going to do is we're going to take our compass, we're going to move our point to this point here, which is going to be where that line we drew crosses our original line. Now, we're going to keep our compass width exactly the same, and we're going to draw this curve here, which crosses through that original curve that we draw. Finally, guys, step number 4. I think we're on step number 4 now. We're going to draw a line which goes from our original point, point A, and crosses straight through the point where those two lines cross. Now, this is going to make sure that the angle that we draw down here is 60 degrees, and it's going to make sure that we get all of the marks in this question. How to construct a 90-degree angle in 70 seconds, let's go. Here, guys, we have a quick reminder for how to use a compass to construct a 90-degree angle. Now, it's worth me quickly mentioning that this is going to be exactly the same method as for drawing a perpendicular bisector. Why? That's because perpendicular lines themselves meet at 90 degrees. So, enough about the relationship between this and something else. How do we actually do it? Step number 1, we're going to draw 2 points, A and B, if they haven't drawn them for us already, and we're going to connect them with a line. Step number 2, we're going to take our compass, we're going to set it to over half of the width between point A and point B. Then we're going to get our pointy end, we're going to put it on either point A or point B, and if it's point B, we're going to draw this arc here. Then we're going to take our compass and we're going to put the pointy end on our other point, and we're going to draw this second arc here, making sure that we haven't changed the width of the compass. Now, final step, guys, we can see that we've generated 2 points here, and these are actually the points that we're going to take our ruler to and connect with a straight line. When we do that, we get this orange line here, and that is going to be our 90-degree angle constructed. We have a 90-degree angle here, and actually we have a 90-degree angle here, here, and here as well. But guys, that is going to be the method. How to measure bearings in 79 seconds, let's go. Whenever it comes to measuring our bearings, guys, the key thing to note is going to be that our bearings are always going to be measured from our north line. Remember, the north line is going to be a straight line which goes vertically upwards from our point, and we don't have to worry about it too much because it's always going to be drawn on for us. So how would we first of all measure the bearing of B from A? Well, our first step, that's going to be to draw a straight line which connects our 2 points, and that's going to look like this. Step number 2, that is going to be to use our protractor to measure this angle here. Now, why is it going to be that angle there? It's going to be that angle there because that's the line which goes from our north line to the line which connects those 2 points. And I can't do it on the iPad, but like I say, you would use your protractor and you would put it like this and measure this angle here. What about then the bearing of A from B? What would it be this time, guys? We're going to need to have this angle here. Now, why would it be that angle? It would be that angle because that's going to be the angle which goes from our north line all the way round to the line which connects the 2 points. The best way to measure this, guys, is going to be to draw a vertical line like this, which goes down from our north line, to recognize that this angle here is 180 degrees because it's going to be the angle on a straight line. And then we would measure this angle here and add that to it to find our overall bearing, guys. That's going to be a quick reminder of how to measure bearings. How to work with bearings problem-solving questions in 110 seconds, let's go. It's true, guys, this topic is pretty tricky and it does trip people up a lot. However, when we know the common trick in these questions, it's not actually too bad. Let's have a look. This question says that C is due south of B and then asks us to work out the bearing of C from A. We want the bearing of C from A, so we're going to want this angle here. That is going to be the line which connects the north line from A to the line which connects A to C. Now, what are we going to do? The key thing with these questions, guys, that trick I just mentioned, is going to be that they very often involve parallel lines. We can see that we have 2 north lines here, which means that these lines both go vertically upwards, and because of that fact, they're both going to be parallel. So we can think of our alternate, co-interior, and corresponding angles and how they might be able to help us. So what are we going to have here? We're actually going to have 2 alternate angles, which is going to be our 62 degrees and this angle here. Because they are both inside the corners of that Z shape, they're going to be alternate, and that means that they are the same. So we can use that fact to say that this angle here is also 62 degrees. Next step, what we're going to do is we're going to use the fact that these 2 lines are the same length to ascertain that this is actually an isosceles triangle. And what that means is that this angle here and this angle here also have to be the same. So what we can do is we can do 180 subtract 62, 180 subtract 62, which is going to be 118. And then we can divide that by 2, and dividing that by 2 is going to calculate each of those angles, this angle here and this angle here. 118 divided by 2, that's going to be 59 degrees. So we can say that this angle here is 59 degrees and this angle here is also 59 degrees. Finally, we wanted, remember, the bearing of C from A, so we can do our 62 degrees plus our 59 degrees. 62 plus 59 is going to be 121, guys. So that is going to be our bearing of C from A. How to work with column vectors in 92 seconds, let's go. This, guys, is a topic which comes up pretty much every year. Let's have a look. First off, what do the vectors 4, 3 and -2, -1 actually represent? Our column vectors, guys, are going to represent movements in the x direction and the y direction. Our top number, that's going to be our movement in the x direction, so the horizontal movement, and our bottom number is going to represent the movement in the y direction, that is a vertical movement. So first of all, our vector 4, 3. So this one's going to be 4 units to the right because our top number is positive. That's going to be a rightwards movement. If it was negative, it would be a leftwards movement, and it's going to represent a movement of 3 units up because that 3 is positive. What about then -2, -1? Well, because we have a negative number on the top this time, it's going to be a movement of 2 units to the left. And because we have a negative number on the bottom as well, our -1, that's going to represent a movement, of 1 unit down. Okay, so that's what our vectors actually mean. But what about if we want to, for example, add them or multiply them? So when it comes to adding our column vectors, we actually are just going to simply add our top number to our top number and our bottom number to our bottom number. 4 plus -2, that is going to be +2, and 3 plus 1, that is going to be 4. So we can add our vectors like this. What about then if we wanted to calculate 2 multiplied by the column vector 3 minus 2? This one's going to work pretty similarly to expanding our brackets, guys. We're going to multiply our top number by 2. That is going to give us 6 because 3 times 2 is 6. And our bottom number by 2. 2 times 1 minus 2, guys, that's going to be -4. So we can multiply it to get the vector 6 minus 4. How to work with vector problems in 213 seconds, let's go. In this question, guys, we've got quite a lot going on, so let's break it down and take a look. The question asks us to express the vectors BA and OF in terms of A and B. Given that OACB and BCFG are parallelograms, B is the midpoint of OG, and A is the midpoint of OE. So loads of information there. Let's firstly write on all of the information we can to our diagram. So first of all, we've been told that OACB, we have OACB, is a parallelogram. So how can we use this information? Well, we know that for parallelograms, our opposite side lengths are going to be parallel, which means that they move in exactly the same direction. And we also know that our opposite side lengths are going to be exactly the same length. And what that basically means is that if they move in the same direction and they're the same length, they're going to be the same vector. So we can say that our side length, which is opposite to our A vector, is also going to be A, and our side length, which is opposite our B vector, is also going to be B. So we can write on that this side length here is going to be a vector of B, and this movement here is going to be a vector of A. Now, what about this next piece of information? Well, we're told that BCFG is also a parallelogram, and what that allows us to do, BCFG, is identify that this side length over here, this movement over here, is also going to be a vector of A. That's because this movement is A, and it's opposite it, which means it's the same length and moves in the same direction. So we can say that this side length is also A. Now, what about that top side length and the bottom side length? We could have a guess and say that it's B, but why is that going to be the case? What have we been told? Well, we've also been told that B is the midpoint of OG. So in other words, this point here is the midpoint of OG, the movement of this entire line. And what that basically means is that this right-hand side vector is going to have to be the exact same as this left-hand side vector, because if B is the midpoint, it's going to have an equal distance on either side. That's going to allow us to work out that that movement there is also a B. And by what we were saying previously about the parallelograms, that top side is also going to be a B. Now we finally have all of the information that we're going to need to work out our vectors B to A and O to F. So B to A, how can we get from our point B to our point A? Well, one way we could do it is to go up along here from B to C and then to go from C to A. Now that movement from B to C, that's going to be a vector of A, and we can see that it's moving in the correct direction, so it's going to be positive. Then when we go from C to A, that's going to be a vector of minus B. Why is it going to be minus? It's going to be minus because we're going in the opposite direction to that arrow. So summarizing all of that information, guys, our vector from B to A, what's it going to be? B to A is going to be B to C, which was A, plus our movement from C to A, which is minus B, so we can write that as A minus B. What about then, guys? Our movement of O to F, we're going to be going from O over here to F over here. We're going to go from O to B, which is going to be B. Then we're going to be adding another B when we go from B to G, and then we're going to add an A when we go from G to F. Now we can see that we're going along the same direction as our arrows, which we're going right, right, and up respectively. We have two B's, so we're going to have our vector as O to F equals 2b, and then we're going to have plus our a, and that, guys, is going to be a breakdown of all of the information in this question and how to do that. I know that one was pretty long. Hopefully it all was clear. How to work with vector ratio problems in 111 seconds. Let's go. This, guys, is definitely one of the hardest topics in the course, but don't worry, I'm going to do my best to make it clear. Let's have a look. The question says that the ratio of b to m to m to c is 1 to 3, and it asks us to express the vector b to m in terms of a and b. What are we going to do? Well, our first step is going to be to use the fact that the ratio of b to m to c is 1 to 3 to look at what fraction of our total side length b to c is represented by b to m and what fraction is represented by m to c. Now, this ratio here has 4 parts in total. We got that by doing our 1 plus our 3. One of those parts is our b to m, and 3 of them are our m to c. And what that basically tells us, guys, is going to be that our length b to m is going to be 1/4 of the total side length. That's going to be 1 part out of 4 parts in total, and the length m to c is going to be 3/4 of our total side length. We got that by doing our 3 out of our 4 total parts. Now what we can do is basically use the fact that b to m is going to be 1/4 of the length of b to c, and we can find our vector b to c and then find 1/4 of it, and that is going to give us our vector of b to m, which is what we want. So what we're going to write down here, guys, is going to be that our vector b to m is going to be 1/4 of our vector b to c. Then we're going to find our vector b to c, and how are we going to do that? Well, we know to get from b to c, we can go firstly from b to a, that's going to be the vector b, and then we can go from a to c, and that is going to be the vector minus a, because we're going in the opposite direction to this vector a. So we can write this as then 1/4 of b minus a. Finally, guys, if we want to, we can expand this to write it in its simplest form. What are we going to have? We're going to have that our vector b to m is going to be equal to 1/4 b minus 1/4 a, and that, guys, is going to be our final answer for our vector b to m. Hopefully that was clear enough. Working with vectors along a straight line in 145 seconds. Let's go. This, guys, is definitely one of the most difficult parts of our vectors topic. Let's have a look. The question says, given that O to m is 2/3 a plus 4/3 b, and m to n is 1/3 a plus 2/3 b, show that OMN is a straight line. So we want to show that this line here is a straight line. What are we going to do? Well, first of all, we've been told that our vector from O to m, which is this line here, is 2/3 a plus 4/3 b, and we've also been told that m to n, which is going to be this line here, is 1/3 a plus 2/3 b. Now, how can we show that this is a straight line? What we're going to do is we're going to show that one of our vectors is a multiple of the other. We can say that if one of our vectors is a multiple of the other, then those two vectors are parallel, and because they have a point in common, this point m, they have to be not only parallel but also along one single straight line. So how are we going to show that one vector is a multiple of the other? Well, we see that O to m is 2/3 a plus 4/3 b, so we can write that 2/3 a plus 4/3 b is equal to. Now, what can we multiply our other vector by to get 2/3 a plus 4/3 b? If this vector is going to be a multiple of the other, then we have to be able to multiply our other vector by some whole number to get this vector here. And in fact, we can see that if we multiply this vector by 2, if we multiply 1/3 a plus 2/3 b by 2, we're going to get 2/3 a plus 4/3 b. So we can write that 2/3 a plus 4/3 b is equal to 2 times by 1/3 a plus 2/3 b. And what that basically tells us is that one vector is a multiple of the other. So we can say, so we know that OM is a multiple, sorry for all this writing, guys. We know that OM is a multiple of MN, and they have a point in common, and they have point M in common. I'm writing as quickly as possible. So they must be on a straight line. That took a while to write out, guys. Hopefully everything was clear. Let me know in the comments if you have any questions. How to write ratios as fractions in 54 seconds, let's go. Whenever it comes to writing a ratio as a fraction, guys, the key thing to note is going to be that we're going to write how many parts of our ratio represent that object out of how many parts we have in our ratio as total. That sounded a little bit weird, so let me show you what I mean with this example. The question says, if the ratio of blue counters to red counters in a bag is 4:3, what fraction of the counters are firstly blue and then red? In this case, what are we going to have? Well, how many parts of our ratio represent blue counters? The ratio of blue to red is 4:3, so the 4 is going to represent the blue. That means that we're going to have 4 parts blue. And how many parts are we going to have in total? We have 4 parts blue, we have 3 parts red, so 4 plus 3, that's going to be 7. So we have 7 parts in total. So our fraction of blue counters is going to be 4 out of 7. What about red then, guys? Applying exactly the same logic. This time we're going to have 3 parts which are red out of how many parts in total? Again, it's going to be 7. So we get 3/7 as our fraction. How to simplify ratios in 77 seconds, let's go. When it comes to simplifying ratios, guys, the key is going to be to treat them very similarly to how we would treat fractions. We're simply going to divide all parts of our ratio by any common factors. Let's have a look so I can show you what I mean. The question says, express the following ratios in their simplest form. First off, we have 4:8, and the key, guys, is going to be to simply divide both of our numbers by any common factors that they have. 4 and 8 both have a common factor of 4, so we can divide them both by 4. 4 divided by 4 is going to be 1, and 8 divided by 4 is going to be 2, so we can write this as 1:2. What about the ratio 27:9? This time they're both going to have a common factor of 9, so we can divide them both by 9. 27 divided by 9, that's going to be 3, and 9 divided by 9 is going to be 1. Finally, 48:144, what are we going to do? Well, first off, we can recognize that these are both going to have a common factor of 12, so we can divide them both by 12. 48 divided by 12, that's going to be 4, and 144 divided by 12, that's going to be 12. Now, we see that when we simplify this by dividing them both by 12, we actually get another 2 numbers which have a common factor, and that means we can simplify again. 4 and 12 both have a common factor of 4, so we can divide them both by 4. 4 divided by 4 is going to be 1, and 12 divided by 4 is going to be 3, so we can simplify 48 to 144 to 1 to 3 when it's in its simplest form. How to scale up ratios in 61 seconds, let's go. Guys, this topic comes up pretty much every single year. Let's have a look. The question says, if the ratio of apples to pears in a bag is 4:3 and there are 24 apples, how many pears are going to be in the bag? What we're going to have to do, guys, is work out how many times we have this ratio using our number of apples and apply that to our number of pears. Let's have a look. So we know from the question that the ratio of apples, let's call them A, to pears, let's call it P, is going to be 4:3. And we also know that we don't actually have 4 apples. How many apples do we have? We have 24 apples. So we can write 24 in a new ratio. And now what we're going to need to do is we're going to need to work out how many times we have this ratio. How do we get from 4 to 24? We multiply it by 6. And that means we have 4 times as many apples as we actually have in the ratio. So we're going to have to do exactly the same thing with our number of pears. We're going to have to multiply the number of pears in the ratio by 6. 3 times by 6 is going to be 18. And that tells us then that if we have 24 apples, we're going to have 18 pears, and that is going to be our answer. How to do proportional division in 106 seconds, let's go. Whenever we have a question which involves proportional division, guys, the key is going to be to firstly work out the size of one part and then use that to work out the size of however many parts we actually want to work out. Let me show you what I mean. This question tells us that Tom, Bill, and Fred share 1,080 pounds, lucky Tom, Bill, and Fred, in the ratio 4 to 5 to 3, and then we're asked how much each of them have. Step number 1, we're going to work out the size of one part of our ratio, then we're going to use that to find the size of 4 parts, 5 parts, and 3 parts respectively. So how are we going to do that? Well, first off, how many parts in our ratio do we have in total? Well, we're going to have 4 parts for Tom, plus 5 parts for Bill, plus 3 parts for Fred. 4 plus 5 plus 3 is going to be 12. Now, how are we going to find out the size of one part? Well, in total, we have 1,080 pounds. That's split between 12 parts, so we can do 1,080 pounds divided by 12, that's going to give us 90. So we know that one part of our ratio is worth 90 pounds, but we don't want one part, do we? For Tom, how many parts do we want? For Tom, we want 4 parts because Tom's got 4 parts in our ratio. So we're going to do 4 times by 90 pounds to work out Tom's share, and that's going to be 360 pounds. What about Bill's share? Well, we're told in the question that Bill has 5 parts, so we're going to do 5 times by £90. 5 times by 90, that's going to be 450. And finally, Fred, the lucky man, he's going to have 3 parts, 3 times by 90. That is going to give us £270. And if we're right, guys, all of these numbers are going to have to add to give 1080. We can check that now. Do they? Yes, they do. So, guys, we know that our answer is correct. Tom has £360. Bill is going to have £450. And Fred is going to have 270. How to use ratio differences in 71 seconds. Let's go. Questions like this come up all the time in exams, guys. Let's have a look. The question says, if the ratio of yellow blocks to blue blocks is 4:7 and there are 12 more blue blocks than yellow blocks, how many blocks are there in total? What we're going to have to do is use the difference in parts and the difference in number of blocks to find the size of one part, and then use that to find the size of all of our parts put together. What do I mean? So first of all, what is the difference in parts between our blue blocks and our yellow blocks? Well, we have 7 parts blue and 4 parts yellow, so we can do 7 minus 4, which is going to be 3, to work out the difference in parts. Now, how many blocks does that difference in parts actually represent? Well, those 3 parts are going to represent a difference of 12 blocks. So we can then do 12 divided by 3, 12 divided by 3, which is going to be 4, to work out the number of blocks in one part. Now, finally, how many parts do we have in total? Well, we have 4 parts yellow, 7 parts blue, so we can do 7 plus 4. That is going to give us our total number of parts, which is going to be 11. We have 4 blocks per part, and we have 11 parts in total, so we can do 4 times by 11, which is going to give us 44, our total number of blocks all together. How to express ratios as equations in 86 seconds. Let's go. Believe it or not, guys, this super short question trips up almost everybody come exam day. Let's have a look. The question says, if the ratio of x to y is 2:3, express y in terms of x. So what we need is an equation which links y to x, and crucially, because y is in terms of x, it needs to have y as the subject. How are we going to do it? Well, this is going to be the best way. We're going to firstly rewrite our ratio. So we have that our ratio of x to y is going to be 2 to 3. Now, what we're going to do is we're going to simplify our ratio, dividing both sides of our ratio by whatever we need to until we have a 1 for our x. Now, what do I actually mean by that? So we're going to have a 1 for our x. How do we get from 2 to 1? We're going to divide it by 2. So if we're going to divide our x part by 2, we're also going to have to divide our y part by 2. So dividing 3 by 2, what are we going to get? We could write this as a fraction if we wanted to, or we could write it as a decimal. 3 divided by 2, that's going to be 1.5. Now, it's pretty clear how we get from our value of x to our value of y. If x is equal to 1 and y is equal to 1.5 in this ratio, how do we get from x to y? We times it by 1.5. So we can say in our ratio then, or in our equation, I should say, that y is equal to 1.5x. How do we get from x to y? We times it by 1.5, so y is equal to 1.5x. How to combine multiple ratios in 138 seconds. Let's go. This, guys, is a pretty tricky part of our ratios topic. Let's have a look. The question says that the ratio of apples to pears is 4:3 and that the ratio of pears to oranges is 5:7. We're then asked to find the ratio of apples to oranges in its simplest form. Guys, what are we going to do? We're going to start off by writing out both of our ratios in a very clear form. Then we're going to scale up the number of parts to the item which is in common to our ratios, and from there it's going to be pretty clear how to combine these into one. Let's have a look. First of all, writing out our ratio of apples to pears, we're going to have that the ratio of apples to pears is 4:3. And writing down our other ratio, we're going to have that the ratio of pears to oranges is 5:7. Now, guys, we want to scale up these ratios so that we have the same number of parts representing our pairs. Why pairs? Because that's the item which is in common to both of our ratios. So what's going to be a number that 3 and 5 both go into? They both go into 15. So we can write both of these as ratios where the number of parts representing pairs is 15. Now, going to our left-hand ratio, how do we get from 3 to 15? We times it by 5. So we're going to times our 4 by 5. 4 times by 5, that's going to give us 20. What about on the right-hand side? How did we get from 5 to 15? We times it by 3. So we're going to do the same to our 7. We're going to do 7 times by 3, and that's going to give us 21. Now, let's have a think about what these ratios actually show. They show that when we have 15 pairs, we have 20 apples, and when we have 15 pairs, we have 21 oranges. From there, guys, it's pretty clear to see that when we have 20 apples, we're going to have 21 oranges. Why, guys? Because that's going to be the time when the number of pairs in the ratios are the same. So we could write this firstly as we wanted to, as a ratio with all three of them, apples to pears to oranges. We would have 20 to 15 to 21, and then if we wanted to, guys, we could get rid of pairs altogether. Getting rid of that pairs, we're just going to be left with the ratio of apples to oranges as 20 to 21. Now, guys, this is already going to be in its simplest form, so we don't have to worry about simplifying. Why? Because 20 and 21 don't have any common factors that we can divide by. So, guys, that was going to be our combining ratios. I did warn you, it's a pretty difficult one. Feel free to watch again if you think it might help. Real-world direct proportion problems in 38 seconds. Let's go. Real-world problems like this come up all the time, guys. Let's have a look. The question says, if 3 packs of crisps cost £1.80, calculate the price of 7 packs. What we're going to do is we're going to use the first piece of information to work out the price of 1 pack, and then we're going to times this by 7 to work out the price of 7 packs. Let's get it done. So, first of all, we're going to do £1.80. divided by 3 to work out the price of 1 pack. £1.80 divided by 3, that is going to give us 60 pence. And then we can times this by 7, guys. So 60 pence times by 7 to work out the price of 7 packs. What's that going to give us? It's going to give us £4.20 as our answer. Real-world problems involving inverse proportion in 107 seconds. Let's go. These questions can be super confusing, guys, but don't worry, we're going to do our best to make it clear. Let's have a look. The question says that 4 bakers can decorate 100 cakes in 5 hours, and then it asks us how long it would take 10 bakers to bake 150 cakes. What do we reckon? Well, the key thing to notice here, guys, is that there's going to be one thing which is going to be, in theory, reducing our time, and there's going to be one thing which is, in theory, increasing our time. Now, what are they going to be? We go from having 4 bakers to 10 bakers. In other words, we have 2.5 times as many bakers as before. You can do that by doing 10 divided by 4. And what that implies is that it's going to take 2.5 times less time to make those cakes. So we can start off by doing our initial 5 hours, divided by 2.5, because we have 2.5 times as many bakers. However, that thing which is increasing our time, what's that going to be? Well, we've gone also from 100 cakes to 150 cakes. So we have 1.5 times as many cakes to make. We could do that by doing 150, our new number of cakes, divided by 100, our initial number. So we're now going to have to multiply this number by 1.5. Why? Because we have 1.5 times as many cakes to make. So we can then simplify this. What are we going to have? 5 divided by 2.5, that's going to give us 2, and then 2 times by 1.5, that's going to give us 3. So in theory, it would take 10 bakers 3 hours to make 150 cakes. What did we do? We divided by 2.5 because we have 2.5 times more bakers, which is going to bring down the time by a multiple of 2.5. But then we had to multiply our answer by 1.5. Why? Because we're having to bake 1.5 times as many cakes, which is going to bring up our answer by 1.5 times. Algebraic direct proportion in 77 seconds. Let's go. When it comes to questions which involve algebraic direct proportion, guys, the method is going to be pretty much the same every single time. Let's take a look. The question says that y is directly proportional to x, and then says given that y equals 21 when x equals 7, find an equation for y in terms of x, and hence find x when y equals 60. What is that method going to be? Step number 1, we're going to write out that y is equal to kx. Then what we're going to need to do is find the value of k, and that's going to give us our equation. And we're going to do that using the first piece of information we're given, that when y is equal to 21, x equals 7. So we can write that 21 is equal to k times by 7, substituting in there the value of y and the value of x. Then we can solve this equation dividing both sides by 7. We're going to get that k is equal to 21 divided by 7, which is 3. So we've now done the first part of this question. We found that y is equal to kx and k is equal to 3, so y is equal to 3x. Now we want to find the value of x when y is equal to 60, so we can substitute in that y is equal to 60 and then solve to find x. We're going to have that 60 is equal to 3 times by x. We can divide both sides by 3, and that is going to give us our answer. 60 divided by 3 is 20. So we're going to get that x is equal to 20, and that is going to be both parts of our question complete. Algebraic inverse proportion in 57 seconds, let's go. This question, guys, tells us that y is inversely proportional to x, and then says, given that y equals 3, when x equals 7, find an equation for y in terms of x. Whenever we have an inverse proportion question like this, guys, we're going to start off by writing out our general relationship between two variables which are inversely proportional, and that is going to be, in this case, that y is equal to k over x. Our next step is going to be to substitute in the two values for y and x that we know, and then that's going to allow us to solve to find k. Let's get it done. So we know that when y is equal to 3, so we're going to have 3 equals k over x is going to be equal to 7, so that value of x is going to be 7. Now we can rearrange this to make k the subject. We're going to multiply both sides by 7, and when we do, we're going to get 21 equals k. Now when it comes to writing out the relationship between x and y, we can simply substitute in that value of k that we've just worked out, and we're going to get that y is equal to 21 over x as our final answer. Direct and inverse proportion with functions in 117 seconds, let's go. Whenever it comes to doing direct or inverse proportion with functions, guys, the key is going to be to treat it exactly how we would treat any other situation with algebraic, direct, or inverse proportion. The only difference is going to be that when we write out our formula, we're going to have that function in our formula. Let me show you exactly what I mean. This question says that q is inversely proportional to the square root of r. We're then told that when q is equal to 2, r equals 16. We're then asked to find an equation for q in terms of r and use it to find q when r is equal to 36. Here we're dealing with inverse proportion, guys. So the general equation would be y is equal to k over x. But in this case, we're dealing with q, and that's inversely proportional to the square root of r. So our formula is going to become that q is equal to k over the square root of r. Now, guys, just make a note of the fact that we use that function of r in our formula, and that's how we're going to deal with these functions. So step number 2, we're going to substitute in the values that we know for q and r. So we know that when q is equal to 2, so we're going to have 2 is equal to k over the square root of r is equal to 16, so we have the square root of 16. We can simplify this, guys. What's it going to give us? Well, the square root of 16, that's going to be 4, so this is effectively k over 4. Then to move that 4 to the other side, getting the k on its own, we can multiply both sides by 4. 2 times by 4, that's going to be 8, so we're essentially going to get that 8 is equal to k. Now we can write out the relationship between q and r, guys, substituting in that value of k to our original formula that we wrote out. We're going to get that q is equal to 8 over the square root of r. Now, guys, we can use this to find the value of q when r is equal to 36. We're going to substitute r equals 36 into our formula. What's that going to give us? We're going to get that q is equal to 8 over the square root of 36. The square root of 36 is 6, guys. 8 over 6 divides top and bottom both by 2, we get 4 over 3. So we're going to get that q is equal to 4 over 3 when r is equal to 36. How to calculate price changes in 72 seconds, let's go. Questions involving price changes, guys, are super common. Let's have a look at this one. The question says a shop has a sale and reduces the price of all items by 25%. Calculate the new price of a coat, which is originally £150. Guys, what we're going to do is we're going to find 25% of our price, and because the sale is reducing the price by that much, we're going to subtract that from our original price. How are we going to find 25%? Well, we could find 10%, double it, and then add 5%, but I think the best way is going to be to firstly find 50% and then halve that to get 25%. So firstly finding 50%, we're going to halve our original price. So we can say that 50% is going to be £75. 75 is half of 150. Then finding 25%, what's it going to be? Well, 25% is going to be half of our 50%, half of £75, then that's going to be £37.50. Final step then, we're reducing the coat by 25%, so we're reducing that original price by £37.50, so we're going to do £150, subtract £37.50, guys, and when we calculate that, we're going to get our new price of £112.50, our final answer. How to make like-for-like comparisons in 105 seconds, let's go. Whenever it comes to making like-for-like comparisons, guys, the best method is going to be to work out how much each of our options charge for the same number of units of the given item. That's going to tell us which one's better value for money. Let me show you what I mean with this question here. The question says, what is better value? 2 kilograms of pasta for £4.40 or 1.5 kilograms of pasta for £3.60? Now, this is pretty hard to compare. Why? Because the first one's going to get you 2 kilograms and the second one's going to get you a little bit less, 1.5 kilograms. So what we're going to do is we're going to work out how much each of the options effectively charge for 1 kilogram and compare that. So let's first of all do option A, which is going to be this 2 kilograms of pasta. Let's call this option A. What's that going to charge? So option A. We know that 2 kilograms of pasta are £4.40. So if we do £4.40 divided by 2, we're going to work out how much they would charge for 1 kilogram. £4.40 divided by 2, that's going to be £2.20. Now, we can do the same thing with our second option. Let's call that option B. Let me just put a nice little arrow in here, call it option B, put a B and underline it. Now, how would we go from this price to the price for 1 kilogram? Well, 1.5 kilograms is essentially 1.5 times as much as 1 kilogram, so we can divide our price of £3.60 by 1.5. That's going to scale it back to 1 kilogram. So we're going to do our £3.60 divided by 1.5, £3.60 divided by 1.5, that's going to be £2.40, guys. So now we've seen that option A would be £2.20 for 1 kilogram, and option B would be £2.40 for 1 kilogram. So we can confidently say that option A is going to be better value for money because it's less money for the same amount of the product. How to work with profit and loss in 117 seconds, let's go. It's true, guys, these questions involving percentage profits do trip people up all the time, but don't worry, we're going to make it clear. Let's have a look. The question says that Bob buys 17 sports tops for £8 each, and unfortunately, 2 of them get damaged in the post. Poor Bob. He sells the remaining tops for £14 each and can't get a refund on the damaged tops. Again, poor Bob. I don't know where he got them from. Calculate his overall percentage profits. Guys, what are we going to do? To work out our percentage profits, we're going to need to divide our profits by our costs and then times it by 100. But how are we going to work out our profits? Well, we're going to work out our profits by doing our overall revenue, all the money coming in, subtract our costs. So we're going to have to work out all of those parts. Let's get it done. So first of all, how much does Bobby Boy spend? He buys 17 tops at £8 each. So his costs are going to be 17 times by our £8, 17 times 8, that's going to be 136. Let me write in that 8. Now, what about our revenue? How much money does Bob have coming in? So our revenue, this time we're going to have to work out how many tops he actually sells, and that's going to be the 17 that he bought minus the 2 that got damaged in the post. So we're going to have 15 tops times by how much does he sell them for? £14 each. 15 times 14, that's going to be 210. Now, when it comes to finding our profit, guys, we're going to do our revenue subtract our costs. So writing in our profit there, what's it going to be? It's going to be £210 minus our £136, and that is going to be £74. Now, finally, working out our percentage profit, guys, we're going to do our profit, £74, divided by our original cost, which was £136. So 74 divided by 136, then to write that as a percentage, we're going to have to multiply it by 100, guys. And if we bing that into our calculator, we would get 54.41% to 2 decimal places, our final answer. Applied Best Buys questions in 119 seconds. Let's go. Longer problems involving money like this, guys, are super common in exams. Let's have a look at this one. The question says, which is better value? 6 350 milliliter cans of cola for £3.40 with a 10% discount, or 3 1-litre bottles of cola for £7? Guys, the key here is going to be to make a like-for-like comparison. We're going to end up working out the price of 1 litre of cola in each of the situations. Let's get it done. So first of all, 6 350 milliliter cans of cola. How much cola would that actually get you? So we're going to do 6 times by 350 milliliters, and that is going to give us 2,100 milliliters. Now, how much would that cost? We know that it's £3.40 with a 10% discount, so we're going to find 10%. That's going to be 34 pence, and we're going to subtract that, so we're going to get £3.06. Let's write that in. So we're going to do £3.40 times by 0.9, that's another way to work it out, we're going to get £3.06. Now, to work out the price of 1 litre of cola, guys, how many litres of cola do we have at the moment? Well, we have 2,100 millilitres, that's going to be 2.1 litres. So, to go from 2.1 litres to 1 litre, what we're going to do is we're going to divide by 2.1. So, to work out the price of 1 litre, then what we can do is we can do our £3.06 divided by 2.1. That, guys, we're definitely going to need a calculator for. Let's type it in. 3.06 divided by 2.1. That, guys, is going to give us 1.46 to 2 decimal places. And if we think about that in terms of money, that's going to be £1.46. Now, what about the price of 1 litre of cola in this second situation? Well, we know that 3 1 litre bottles would be £7. So to find the price of 1 litre, we can do that £7 divided by 3. £7 divided by 3, we could do that on the calculator, guys, and if we did, we would get £2.33. And we can see, guys, clearly that our first option is going to be better value for money, because £1.46 per litre is going to be far greater value than £2.33 per litre. That's going to be our answer then, guys. Our first option is better value.
This, guys, is going to be a pretty quick one, but it doesn't mean that it's not important. I would say this is actually the most important calculator skill in the entire course, outside, of course, of just regular multiplication and addition. How do we find a percentage of an amount using a calculator, specifically using the percentage multiplier method? What we're going to do, guys, is we're going to do a multiplication of our percentage written as a decimal and our number. In this case, we're going to firstly convert 87%, I should say, into a decimal. 87% into a decimal, guys. We're going to divide it by 100 to convert it into a decimal. We're going to get 0.87. So we now have our percentage as a decimal. To find the percentage of the amount, what we do is we multiply that decimal by our number. So in this case, we're going to do 0.87 times by 287, and if we binged that into our calculator, we would get 249.69 as our answer. So just to recap, guys, what do we do using the percentage multiplier method? We firstly rewrite our percentage as a decimal, and then we multiply that decimal by our number.
How to work with simple interest in 78 seconds, let's go. Whenever it comes to working with simple interest, guys, the key thing to remember is going to be that the amount of interest earned is going to be exactly the same every single year. Let's have a look at this question to see what I mean. The question says that Ben puts £1,700 in a bank account which pays 7% simple interest, and that's going to be per year. How much does he have after 3 years? What we're going to do is we're going to firstly find 7% of 1,700, then we're going to times it by 3 to find the total amount of interest earned, then we're going to add it on. Let's see what I mean. So first of all, 7% of 1,700, we're going to do 1,700 times by 0.07, which is 7% as a decimal. And if we work that out, that would be 119. From there, we're going to times it by 3 to work out the amount of interest earned in 3 years. So we're going to do 119 times by 3, guys. And if we did that, we would get 357. Where do we go from there? We're going to need to add that on, because that is the amount of interest earned, but we have that amount as well as the amount that we put in at the start, which was our 1,700. So we're going to do 1,700 plus our 357, which was our interest that we earned. And that, guys, is going to come out as £2,057, our final answer. How to work with compound interest in 106 seconds, let's go. Whenever it comes to working with compound interest, guys, the key thing to remember is going to be that the amount of interest earned in each time period actually depends on the amount of money in the account on the previous time period. And because of that, each time period, the amount of interest earned is actually going to change. But luckily, we don't have to worry too much about doing all of these different calculations. We can just use this formula here, which is going to be useful whenever we're working with compound interest. And this formula basically tells us that the end amount at the end of the overall set of time periods is equal to the start amount P times by 1 plus our interest rate as a decimal raised to the power of the number of time periods. Let's make this clear by doing this example. The question says that Ricky puts £11,750 in a savings account which pays 4% compound interest per year. Then the question asks us how much he has after 11 years of saving. So we're going to have to substitute in 11,750 as our start amount. We're going to have to substitute 4% in as our interest rate, and we're going to have to substitute 11 in as our number of time periods. Let's get it done. So we're going to have that our end amount is equal to 11,750 times by, we're going to have 1 plus our interest rate as a decimal, 4% as a decimal, dividing it by 100, that's going to be 0.04. Then we're going to raise this to our number of time periods, which is going to be 11. Now, guys, we can bing this into our calculator, and luckily, I've already done that. So when we do that, what are we going to get? We're going to get £18,088.59 to 2 decimal places, guys. Check that you can do that with your calculator, because this does come up a lot. Finding the initial amount in compound interest questions in 125 seconds. Let's go. Quite often, guys, questions involving compound interest won't actually give us the start amount and ask us for the end amount. They're going to give us the end amount and ask us for the start amount. Luckily, it's not going to be too much extra work, and we're still going to use exactly the same formula. Let's have a look at this example. The question says that Jess puts some money in a bank account which pays 8% compound interest per year. It then says that after 6 years, she has £2,758 in the account. The question then asks us to calculate the amount she put into the account in the first place. So this time, guys, we've actually been given our end amount, which is A, and we're asked to work out our initial amount, P. So what we're going to do is we're going to substitute in all of the variables that we know, and then we're going to rearrange it to find the value of P. Let's get it done. So we know our end amount, that's going to be 2,758. So we can say that 2,758 is equal to P, our initial amount that we're trying to work out, times by 1 plus R, which is our interest rate as a decimal, 8% as a decimal, divided by 100. That's going to give us 0.08. And then we're going to raise that to the power of T, our number of time periods, which is 6. Now, guys, how are we going to make P the subject of this formula? Well, at the moment, P is being multiplied by 1 plus 0.08 to the power of 6. So to make P the subject, we're actually going to have to divide both sides of our equation by 1 plus 0.08 to the power of 6. So what we're going to get is we're actually going to get that P is equal to £2,758 divided by 1 plus 0.08 raised to the power of 6. And guys, if we bing that into our calculator, we would get that P, our initial amount, is equal to £1,738.01 if we round that to 2 decimal places. And to be fair, if we said 1,738 or £1,738.01, they're not going to mind. How to work with compound decay in 89 seconds. Let's go. Whenever we're working with compound decay, guys, our method is actually going to be super similar to when we're working with compound growth. There's just going to be one small difference. Let's have a look with this example. The question says that Sam buys a car for £18,000, which reduces in value by 10% per year. The question then asks us to calculate the value of the car after 3 years. Now, because we're actually decreasing the value by 10% per year, what we're going to need to do is we're going to need to adjust our formula a little bit. And the only difference is going to be that this growth rate R is going to be negative instead of being positive. If it was increasing by 10% each year, this would be plus 0.1. 0.1 is 10% written as a decimal. If you're not sure about that, watch our previous couple of videos. But this time, because the value is actually decreasing, what we're going to do is we're going to swap that plus for a minus. So let's do that and see what we get. We're going to have that our end amount A is equal to P, our initial amount, which is £18,000. And that's going to be times by 1 plus R. And remember, this time we're going to be swapping our plus for a minus. So we're going to have 1 minus 0.1, which is 10% as a decimal, raised to the power of T, our number of time periods, 3, guys. And we can type that into our calculator. If we did, what would we get? We would get £13,122 as our end amount for the value of our car. Unfortunately, poor Sam, he's lost almost 5k. Not good for him. how to do calculations involving speed, distance, and time in 98 seconds. Let's go. Whenever it comes to working with speed, distance, and time, guys, the key is going to be to use the formula that speed is equal to distance divided by time. And if we want to, we can write this in this handy triangle to the right, which has an S in the bottom left, a D at the top, and a T in the bottom right. And that's sometimes going to be helpful for helping us to rearrange it, for example, to calculate time or to calculate distance. Let's have a look at these two examples then to see how it's applied. First off, Bolt runs 100 meters in 9.58 seconds. How are we going to calculate his average speed? What we're going to do is we're going to do that our speed is equal to our distance, 100 meters divided by our time, 9.58 seconds. And guys, if we type that into our calculator, we would get that our speed is equal to 10.44 meters per second to 2 decimal places. And our units, guys, are going to come from the fact that we're doing our meters divided by our seconds. Now, what about this next one, which says that Hammond drives at a speed of 128 miles per hour for 3/4 of an hour? How far does he drive in this time? So this time, guys, we want to calculate our distance. And to calculate distance, we're going to do our speed times by our time, because those two are at the bottom of our triangle. So we're going to do our speed divided times by our time, so we're going to have our distance is equal to our speed, 128 miles per hour, times by our time, 3/4 of an hour. And what's that going to be? 128 times 3/4 is going to be 128 divided by 4 times by 3. That's going to be 96, guys. So we get 96 miles as our answer. Density, mass, and volume calculations in 106 seconds. Let's go. Whenever it comes to working with our density, mass, and volume, guys, the key formula is going to be that our density is equal to our mass divided by our volume. And if we want to, we can put this into the handy triangle on the right-hand side, which is going to have density in the bottom left, mass in the top, and volume in the bottom right. Let's have a look at how we can use this triangle to do these two questions. First up, calculate the density of a steel sphere which has mass 78 grams and volume 10 centimeters cubed. So this time we want to calculate our density. We're going to do our mass divided by our volume. So we're going to have that our density is equal to our 78 grams, our mass, divided by our volume of 10 centimeters cubed. What's that going to be? 78 divided by 10, that's going to be 7.8. So we're going to have 7.8 grams per centimeters cubed is going to be our units, and that's going to be our answer to our first one. Moving on to this second one then, it says calculate the mass of a bottle of olive oil which has a volume of 2,200 centimeters cubed and a density of 0.8 gram per centimeters cubed. What are we going to do this time? We want to calculate our mass. So to calculate our mass, we're going to do our density times by our volume. So we're going to have our 2,200 centimeters cubed times by our 0.8 grams per centimeter cubed. 2,200 times by 0.8, that's going to be 1,760. So we're going to have 1,760 grams, guys, as our final answer. And that unit for our mass, where did it come from? It came from the fact that we're working in grams, and we're doing our grams per centimeters cubed times by our centimeters cubed. Those two cancel out, and we're just left with grams as our unit. Calculations involving pressure, force, and area in 108 seconds. Let's go. When it comes to working with our pressure, force, and area, guys, the key formula is going to be that our pressure is equal to our force divided by our area. Now, just like with density, mass, and volume, and speed, distance, and time, we can convert this into this handy triangle on the right, which is going to have pressure in the bottom left, force on the top, and area on the bottom right. Let's have a look then at how to apply this to these two questions. What are we going to do? First off, a force of 280 newtons acts on an area of 4 centimeters squared. Calculate the pressure exerted. What are we going to do? We're going to have pressure in the bottom left, and pressure is going to be equal to force divided by area. So we can do that our pressure is equal to our force, which is 280 newtons, divided by our area, which is going to be 4 centimeters squared. 280 divided by 4, that's going to be 70. So guys, we're going to have 70 newtons per centimeter squared. That's going to be our units. Next, let's have a look at this next one. Calculate the area if a force of 400 newtons creates a pressure of 120 newtons per centimeter squared. What are we going to do this time? We want to calculate our area, so we're going to do our force divided by our pressure. What are we going to have? We're going to have that our area is equal to our force of 400 newtons divided by our pressure, which is going to be 120 newtons per centimeter squared. What's that going to give us? Well, 400 divided by 120. We cannot do that easily. It's going to give us a decimal, but we can simplify this fraction, dividing top and bottom both by the common factor of 40. We're going to end up with 10 on the top, and we're going to have 3 on the bottom. What's our unit going to be, guys? For our area, it's going to be centimeters squared. So our answer is going to become 10 over 3 centimeters squared. And that is going to be, guys, how to calculate pressure, force, and area using that triangle. The standard unit conversions that you need to remember in 49 seconds. Let's go. Here, guys, we have a quick reminder for all of the standard unit conversions we need to know for our exams. When it comes to distance, what do we have? We're going to need to know that there are 10 millimeters in 1 centimeter, that there are 100 centimeters in 1 meter, and that there are going to be 1,000 meters in 1 kilometer. What about, guys, our mass? We're going to need to know that there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. And finally, what about volume? We're going to need to know that there are 1,000 milliliters in a liter. That's the only one that we need to memorize. Now, when it comes to converting from, for example, millimeters to centimeters, we're going to need to divide by 10. And when it comes to converting from centimeters to millimeters, we're going to need to times by 10. And we can apply that exact same logic for converting between all of the units we see on this screen. How to convert between areas in 48 seconds. Let's go. These area conversions trip people up all the time, guys, but luckily, when you know what you're doing, they're really not too bad. Let's have a look. Convert 24 meters squared into centimeters squared. What are we going to do? All that we're going to do is we're going to do our regular conversion from meters to centimeters, but instead of doing it once, we're going to do it twice. How would you go from meters to centimeters? Well, there are going to be 100 centimeters in a meter, so you would times by 100. So going from meters squared to centimeters squared, we're going to times by 100 once, and then we're going to times by 100 again. So timesing by 100, that would add 2 zeros. Timesing by 100 again, that would add 2 more zeros. So we can simply add 4 zeros in total. And what are we going to get as our answer? We're going to get 240,000 centimeters squared. Volume unit conversions in 53 seconds. Let's go. Whenever it comes to doing our volume conversions, guys, what we're going to do is we're just going to do our regular conversion. However, instead of doing it once, we're going to be doing it 3 times. And you can remember that because we have powers of 3 on our units. Let me show you exactly what I mean with this question here, which says convert 27,000 millimeters cubed into centimeters cubed. What are we going to do? Well, to go from millimeters to centimeters, we would normally divide by 10 because there are 10 millimeters in a centimeter. So instead of doing that once, we're going to be doing it 3 times. What are we going to have? We're going to have divide by 10, divide by 10, and divide by 10. Each time we divide by 10, we're going to knock off one of our zeros. So in total, we're going to be knocking off 1, 2, 3 zeros, and we're going to be left with 27. So our final answer, guys, is going to be 27 centimeters cubed. And that is, like I say, our answer. Converting compound measures in 108 seconds. Let's go. This, guys, is going to be a pretty tricky topic to get your head around, but don't worry, I'm going to do my best to make it clear. Let's have a look. The question says that the density of gold is 19.3 grams per centimeters cubed, and it asks us to convert this into kilograms per meters cubed. Now, the first thing to recognize is that there are going to be 2 unit conversions going on here. We're going firstly from grams to kilograms, and then we're going from a space of centimeters cubed to meters cubed. What are we going to do? Well, going from grams to kilograms, the effect of that is going to be that we're going to divide our number by 1,000, and that's because there are going to be 1,000 grams in a kilogram. So step number 1 is going to be to divide by 1,000, and when we do that, what are we going to get? Moving our decimal point 3 places, we're going to get 0.0193. Now, where do we go from there? We need to recognize that we're going from a space of 1 centimeter cubed to 1 meter cubed. So we're going to have to multiply our space effectively by 100, 100, and 100 again to get from, like I say, centimeters cubed to meters cubed. So we're going to times our number by 100 once, we're going to times it by 100 again, and we're going to times it by 100 again. Now, that might sound a little bit weird. If it does sound weird to you, consider watching our previous video on volume conversions. That should make it a little bit clearer. So timesing by 100, 100, and 100 again, what are we going to get? Step number 1, we're going to move our decimal point 2 places. We're going to get 1.93. Then we're going to move it 2 more places. We're going to get 193. 0.00 effectively, then moving it to more places finally. We're going to add on 2 zeros. We're going to get 19,300, and that's going to be our answer, guys. 19,300 kilograms per meters cubed. That one was pretty quick and difficult to explain. Hopefully it was clear enough. How to calculate currency conversions in 84 seconds. Let's go. Currency conversion questions like this, guys, are going to be pretty common in our foundation paper. Let's have a look at this one. It says, given that £1 is equal to 1.87 Australian dollars, calculate the value of firstly £27 in Australian dollars and secondly 38 Australian dollars in pounds. Guys, what are we going to do to go from pounds to Australian dollars? We know that £1 is equivalent to 1.87 Australian dollars. So to go from £27 to Australian dollars, we're going to do our £27 times by 1.87. 27 pounds times by 1.87. What's that going to give us, guys? Let's just have a quick look. 27 times by 1.87. That is going to give us, changing it to a decimal, 50.49 Australian dollars as our first answer. Now, what about this second one? 38 Australian dollars this time in pounds sterling. What's it going to be to go from Australian dollars to pounds? We know that 1.87 Australian dollars would be £1. So we're going to divide by 1.87 to convert from Australian dollars to pounds. So we're going to do our 38 divided by 1.87, moving from Australian dollars to pounds, guys. And when we do that, 38 divided by 1.87, what's it going to be, guys? Changing it again to a decimal is going to be, in pounds, 20.32 to 2 decimal places, guys, giving us our answer.
This, guys, is a key skill which comes up in pretty much every single set of exams, especially for foundation students. Let's have a look. How are we going to convert 147 minutes into hours and minutes? At the moment, this is written only in terms of minutes. How are we going to break this down into a certain number of hours as well as a certain number of minutes? The key is going to be to use the fact that there are 60 minutes in 1 hour. We're going to write out our multiples of 60. We're going to see how many times 60 goes into our number here. That's going to tell us how many hours we have. Then we need to find our remainder, and that is going to give us our number of minutes. So writing out our multiples of 60, we're going to have 60, 120, 180, 240, and so on and so forth. How many times does 60 go into 147? It's going to go in 2 times. And that's because 2 times by 60 is 120, 3 times by 60 is 180, and that is already bigger than the 147. So it goes in 2 times fully. That means that we have 2 hours. And then how many minutes do we have? Now we need to find the difference between our 147 minutes and the 120 minutes that we have in the 2 hours. 147 minus 120, guys. You could do this using the column method if you want, or you could do it in your head. 147 minus 120, that is going to be 27. So we can write this as 2 hours and 27 minutes. That, guys, is going to be 147 minutes in minutes and hours.
The fundamentals of probability in 84 seconds. Let's go. When it comes to understanding probabilities, guys, these 3 principles are going to be absolutely crucial. Let's have a look. Up first, we have the fact that the probability of an event occurring represents the chances that that event happened. So we would say that if the probability it rains tomorrow is 0.34, it means that there's a 34% chance of it raining tomorrow. Probabilities are about the chances of things happening. And just to be clear, that 0.34 going to 34% was just converting our decimal to a percentage by timesing it by 100. Second, what are we going to have? We're going to have the fact that all probabilities are going to be between 0 and 1. A probability of 0 represents the fact that that event is impossible. A probability of 1 means that that event is definitely going to happen. And then we have kind of a sliding scale between those, where a probability of 0.5, for example, would represent the fact that there's a 50-50 chance of that thing happening. Finally, guys, principle number 3 is going to be that all probabilities for an event always have to add to make 1. So if we were, for example, picking balls from a bag and the probability of red was 0.4, blue was 0.1, and we wanted to work out the probability of picking a green one, we could do 1 subtract 0.4 subtract 0.1, and that would give us 0.5 as the probability of picking a green ball. Once again, all probabilities always have to add to make 1. How to work with fair objects in probability questions in 49 seconds. Let's go. Guys, it's super common in a probability question to be told that we're working with a fair object. But what does it actually mean for an object to be fair? So what we would say is that for a fair object, all of the different outcomes have the same probability. You can think of a fair coin as having a 50-50 chance of landing on heads and tails. They're both going to be the same, and a fair dice as having a 1/6 chance of landing on each of the numbers. Again, all of the probabilities are going to be the same. Let's have a look at how it's applied in this question here. The question says that a fair spinner has 7 sides numbered 1 to 7, and we're asked to find the probability that the spinner lands on 5. What's it going to be? Well, there are going to be 7 sides, and one of those sides is going to be a 5. So our probability is simply going to be 1/7. It's going to be an even chance. So all of the options are going to have a 1/7 chance. How to construct sample space diagrams in 94 seconds. Let's go. This, guys, is a topic which always gets forgotten about. What is a sample space diagram? A sample space diagram is going to show us all of the different possible outcomes which could occur. And this question is going to be really good for showing us how it could come up in an exam situation. Let's have a look. The question says that 2 dice are rolled and the score is the sum of the numbers on the 2 dice. Construct a sample space diagram for the possible scores. So the scores are going to be the sum of the 2 dice. What we're going to need to do, guys, is find all of the different possible scores that could happen by finding all of the different possible combinations of numbers we could get and what they sum to. So we have 1 to 6 across the top and 1 to 6 across the side, representing the scores on each of the individual dices, and then we're going to need to add them all together in their combinations to find the sample space, which is all of the possible different scores. So this is going to take a while. Feel free to skip it. What's it going to be? 1 plus 1 is going to be 2. 1 plus 2 is going to be 3. Then we're going to go 4, 5, 6, 7, going across the columns. We can do the same thing. Feel free to skip this, guys. I'm going to try and fill the space by talking, just saying random stuff. We can fill it in going sideways or horizontally, finding all of the combinations in this situation, guys. Check this as I go. Am I doing it correctly? You tell me. Try and fill this in quicker than I can. What would you get? Okay, we're still talking, filling this space. Have we made any mistakes? Not yet, not yet. Hopefully. Okay, guys, that is going to be our sample space diagram. Hopefully that wasn't too annoying. We have here all of the different possible scores for adding together the scores on the individual 2 dice. How to find the probability of an event happening in 63 seconds. Let's go. When it comes to calculating the probability of an event happening, guys, what we're going to do is we're going to take the different number of ways that that event can happen, and we're going to divide that by the total different number of things that can happen. Now, that sounds a little bit weird when it's not applied to an example, so let's have a look at this one. The question says, if there are 3 red, 4 blue, and 8 green balls in a bag, calculate the probability of choosing a red one. There are going to be how many red balls, guys? There are going to be 3. So there are going to be 3 different ways that we can choose a red ball. And how many different things can happen? How many different balls could be chosen? Well, how many balls are there going to be in total? We're going to have 3 red plus 4 blue. That's going to be 7 plus 8 green. That's going to be 15. So there are going to be 15 balls in total. Now, we can simplify that fraction if we want to, dividing top and bottom both by 3, we're going to get 1/5. If we wanted to, we could write that probability as a decimal. It would be 0.2, or as a percentage, it would be 20%. But either way, guys, it's going to represent the same thing, and that's going to be that the probability of choosing a red ball is 1/5. How to apply the AND rule and the OR rule in 80 seconds. Let's go. This, guys, is a topic which trips people up all the time. Let's have a look at these 2 questions and see what we can do. The first one says that Dave rolls 2 dice, and then it asks us to calculate the probability that both of the dice land on 6. Now, because we want both of the dice to land on 6, we need the first dice and the second dice to both land on 6. So working out the probability of one event and another event, what are we going to do? We're going to multiply the probabilities of each of the events. So in this case, we're going to do 1/6 times by 1/6. That's going to be the probabilities of each of them landing on 6. And when we times fractions, we do top times top. That's going to give us 1. And bottom times bottom, that's going to give us 36. Now, what about this second question? Applying our OR rule. So we're told that a spinner is spun, and the probability it lands on each color is given in the table below. We're asked to calculate the probability of red or green. Now, because we want it to land on red or to land on green, we're going to add together the two probabilities of landing on red and landing on green. Now, if they could happen at the same time, we would have to also subtract that. But in this case, it's impossible to land on red and green, so we don't have to worry about that. So adding the probabilities of red and green, then probability of red, that's going to be 0.25. And we're going to add to that our probability of green, 0.35, 0.25 plus 0.35. That is going to be 0.6, guys. Our answer to our second question. Understanding independence in 79 seconds. Let's go. Here, guys, we have a quick reminder of what it means for two events to be independent. Let's have a look. We would say that two events are independent of each other if, crucially, they don't affect each other. So that first event, when it happens or doesn't happen, it would be independent of the second event if that first event happening or not happening doesn't affect the likelihood of the second event happening. Now, that might have been a bit confusing, so let's have a look at these three examples. We're asked whether they are independent. Let's have a look. Up first, two rolls of a dice. We would say that these events are independent. Why? Because the first roll of the dice, whatever number we get, doesn't affect the second roll. Okay, what about this next example? Choosing two counters from a bag with replacement. So we choose a counter from a bag and then we put it back in and then we choose another counter. Would the first choice affect the second choice? No, it wouldn't. Why? Because we're going to put that counter back in after we've taken it out. So the first event isn't going to have any effect on the second event. Finally, this one might be a bit obvious given what I've just said, but we have choosing two counters from a bag without replacement. In this case, guys, the events would not be independent. Why? That's because the first counter we choose is going to affect the likelihood of the different options in the second event, because after we've taken that first counter out, there's going to be a different number of counters in the bag, so the probabilities are going to change.
When it comes, guys, to expressing probabilities as fractions, decimals, and percentages, there really is actually no difference to our regular fraction, decimal, and percentage conversions. The key thing that I really want to drive home is simply that we can express probabilities in these different forms. It's something that people really often forget. If we have a probability of 0.7, for example, we can express it as 70%. We can also express it as 7 over 10. We can also, like I said at the start, express it as 0.7. So all of those things mean the same thing. We can express probabilities in those different ways. Let's have a look at this one just to show you a quick example. It says I can't even speak today. A fair four-sided spinner has sides labeled 1, 2, 3, and 4. Express the probability of it landing on a 3 as a fraction, decimal, and percentage. What's the probability of it landing on a 3, guys? Well, it's a fair four-sided spinner. There are 4 different options. We want the probability of it landing on a 3, which is just one of the options, so it's going to be 1 over 4. As a fraction, converting this then into a decimal and a percentage. Best way to do this is going to be to write it as something over 100. How do we get from 4 to 100? We times it by 25, so we do the same to the top. 1 times by 25 is going to be 25. So we've written this as 25 over 100. We can then read our percentage simply from the top. It's going to be 25%. And then writing it as a decimal, we just take that percentage and put 0 point in front of it, and we get our answer of 0.25. Guys, the key here, probabilities can be expressed as fractions, decimals, and percentages because they all mean the same thing.
The fundamentals of set notation in 164 seconds. Let's go. This, guys, is a topic which people always forget to revise, but it comes up a lot. So let's have a look. The question asks us to fill in these sets below. We're told that the universal set contains these numbers, the set A contains these numbers, and the set B contains these numbers. What are we going to do? First off, we want to find the set A apostrophe. Now, this apostrophe is going to mean not, so we want the set which is the set not A. So we want to find all of the numbers which are in our universal set but are not in A. 1, that wouldn't be in our not A set because it's also in A, so we can cross that out. What about 2? That's in A, so that's not going to count. 4, we can see that that is in our universal set, but it's not in A, so that is going to count. 5, we can see that are in both. We can see that 8 is only in our universal set, and we can cross off 11 because that's in both of them. So the set not A is going to be the numbers 4, 8. Let's write those in. We have 4 and 8. That is going to be the set not A. What about this next one? We want the set A and B. That's going to be A and B. This sign in the middle, guys, means and. So we're going to want to find the numbers which are in set A and in set B. What are they going to be? We can see that 1 is in only A, so that's not going to be, but 2 is in both. We can say that 4 is only in B, so that's not going to count, but 5 is in both, and finally 11 is also in both. So the set A and B, what's that going to be? It's going to be 2, 5, 11. Let's get that written in. We have 2, we have 5, and we have 11. Next up, guys, we have A, and then this weird looking shape, and then B. That is actually going to mean or. We can think of this as being like a bucket, which fits everything in. So this is going to mean A or B, and that's going to be, guys, containing all of the numbers which are either in A, or in B, or in both of them. We can see then that we're going to have the numbers, what are they going to be? We're going to have 1, we're going to have 2, we're going to have 4, we're going to have 5, and we're going to have 11. Double check and see that you're happy with that. Next up, we want the set, and this one's going to be a bit confusing, but don't worry, we're going to make it clear. A and B not. So we want to find, in other words, all of the numbers which are not in A and B. We've already found the set A and B, guys. It contained 2, 5, and 11. So we want all of the numbers which aren't these numbers. What's that going to be then? Going back to our universal set, we're going to have all of the numbers in here which aren't 2, 5, or 11. What's it going to be? It's going to be 1, it's going to be 4, and it's going to be 8. They're going to be the only numbers which aren't in A and B. Finally, A or B not. What are we going to do? We're going to go back to our A or B set, and we're going to look for any numbers that are in our universal set but aren't in A or B. What are they going to be? We can see that 1, 2, 4, 5, and 11 are in A or B, so the only number actually is going to be 8. That's going to be the only one which is in our universal set but isn't in the set A or B. So guys, our final answer is going to be 8. Sets and Venn diagrams in 88 seconds, let's go. In this question, guys, we're given a universal set, we're given a set A, and we're given a set B, and we're asked to represent these in the Venn diagram below. What are we going to do? Step number 1, we're going to look for all of the numbers which are in set A and in set B, and we're going to put those in the middle of our Venn diagram. So what are they going to be? Well, we can see that set A and B both contain the number 2, so we'll put that in the Venn diagram. We can see that they both contain the number 5, so we'll put that in the middle of the Venn diagram, and we can see that they both contain the number 11, so we can put that in the Venn diagram. Now, what's the next step going to be? We're going to write the numbers which are only in the set A, so in the set A and not in the set B, in the left-hand side of our Venn diagram. That's going to be the A side, and we're going to write the ones which are in B and not in A in the right-hand side. So we can see that we're left over with a 1 in our A and a 4 in our B, so we can write a 1 in the left and a 4 in the right. Finally, we want to go through and put all of our other numbers that are in our universal set but not in A or B in the space on the outside, this space here, and we can see that that's denoted with this universal set sign in the top left hand side. So let me quickly make this a little bit clearer. We're going to cross out the 1, cross out the 4, and we can go through and cross out all of the numbers that we've already put in our Venn diagram from the list. So we've put 1 in already, we've put 2 in already, we've put 4 in already, we've put 5 in already, and we've put 11 in already. We can see that 8 is the only number we have left, so that's going to be the only number in the outer side of our Venn diagram. How to work with sets and inequalities in 58 seconds, let's go. This, guys, is a bit of a niche topic and it really doesn't come up too often. However, it is in the course, so we are going to have a look at it. The question says, use set notation to describe the values of x for which 2x plus 8 is greater than 18. We can see here, guys, that we have a linear inequality and we just want to solve it and write our answer in set notation. Let's have a look. Step number 1, we're going to solve this linear inequality. So we're going to firstly take 8 away from both sides, minus 8 minus 8, and we're going to get that 2x is greater than 10. Then we're going to divide both sides by 2, divide by 2, and divide by 2. We're going to get that x is greater than 5. Now, how do we write this in set notation? This, guys, is kind of just something to remember. What we're going to do is this. We're going to write out a pair of curly brackets, and we're going to put an x and a colon at the start, and then we're going to close our curly brackets. And then we're simply going to write our answer in the space that we have here. So our answer is going to be x is such that x is greater than 5, and that, guys, is how we're going to answer this question.
When it comes to our probability questions, guys, these are one of the ones which trip people up the most often. However, the truth is that they're not too bad when you know how to do them. They actually work the same as any other probability situation. Let's have a look. The question says, consider the following set of numbers. Calculate the probability of choosing an even number. First off, what is a set of numbers, guys? A set of numbers, in this case A, is just going to be a bunch of numbers which are given to us in the question. To be honest, you can just think of it in that way. How do we find the probability of choosing an even number then? Well, we're going to find the number of even numbers that we have and do that out of the total number of numbers that we have. In other words, how many ways we can choose that even number out of how many ways we can choose a number in total. How many even numbers do we have? We have the 2, which is 1, we have the 6, which is 2, we have the 12, which is 3, and the 14, which is our fourth even number. So we're going to have a 4 on the top. How many numbers in total? We have 1, 2, 3, 4, 5, 6, 7 numbers in total. So our probability, guys, is simply going to be 4/7.
The fundamentals of Venn diagrams in 103 seconds. Let's go. Venn diagrams, guys, are going to be a super useful tool for understanding some information about the characteristics of different groups of things. Now, that sounds a little bit abstract, so let's have a look at this question here. The question says that the Venn diagram below shows the sports played by 120 students in a school. Then we're asked, firstly, to work out how many students play football. What are we going to do? Well, we're going to use the fact that this bottom left-hand circle down here is going to represent all of the students who play football. So we're going to add together all of the numbers which fall inside this bottom left-hand circle to find the total number of students who play football. What's it going to be? 40 plus 14 is going to be 54, plus 6 is going to be 60, plus 12 is going to be 72, guys. So we can say that 72 students play football. Now, what about the students who play hockey and football? So this time we're going to need only the students who are in the hockey circle and in the football circle. So the hockey circle, that's going to be this top circle up here. The football circle, that's going to be this bottom left-hand circle, as we said before. We want the students who are in both of these circles. That's going to be this group here. So we're going to have our 14 plus our 6. That's going to give us 20 guys, students who play hockey and football. Finally, what about the guys who play 2 or more sports? What's that going to be? Well, we want all of the groups, all of the sections, which are in at least 2 of the circles. So we can see that's going to be this section here, this section here, this section here, and it's going to be this section here as well. Why this section as well? Because it's 2 or more sports, and these guys all play 3 sports, so we can add together these, what's it going to be, 4 numbers here. We're going to have 14 plus 6, that's going to be 20, plus 8 is 28, plus 12 is going to be 40, guys. So we can say that there are going to be 40 students who play 2 or more sports. Constructing Venn diagrams in 107 seconds. Let's go. In this question, guys, we've been given 3 sets. We've got a universal set, we've got a set A, and we've got a set B. And we're asked to place the following numbers in the Venn diagram below. What are we going to do? We're going to put all of the numbers which are in A and B in our middle section. We're going to put all of our numbers which are in A and not in B in the left-hand side. And we're going to put all of our numbers which are in B and not A in the right-hand side. Finally, all of the other numbers which aren't in A or B are going to go on the outside of our Venn diagram. Let's work through our numbers then and get it done. First of all, we have that the set A is going to be all of our odd numbers between 1 and 10. We have that the set B is going to be the prime numbers between 1 and 10. And we have that our universal set contains all of the numbers from 1 through 10. Let's have a look. The number 1, that is going to be an odd number, but it's not going to be prime. So we're going to put that in the left-hand side. We have the number 2, that is going to be a prime number, but it's not an odd number, so that's going to go in the right-hand side only. We have the number 3, that's an odd number, and it's a prime number, so that's going to go in the middle. The number 4, that's going to be not odd and not prime, so it's going to go on the outside. The number 5 is a prime number and it's an odd number, so that's going to go in the middle. The number 6, that's not odd and it's not prime, so it's going to go on the outside. The number 7, that's an odd number and it's prime, so it's going to go in the middle. The number 8, that is not odd and not prime, so it's going to go on our outside. The number 9, that's a prime number, but it's not, that's an odd number, but it's not prime is what I meant to say, so that's going to go on the left-hand side. And finally, the number 10, it's not an odd number and it's not a prime number, so that's going to go on our outside. We need to make sure, guys, that all of the numbers in our universal set go into our Venn diagram, and we've got that accomplished and everything's in the right spot, so we're all good for now. How to find probabilities from Venn diagrams in 81 seconds. Let's go. When it comes to working with probabilities in Venn diagrams, guys, the key is going to be to do how many we have in that specific group that we want to choose out of how many we have in the larger group that we're choosing from. Now let's make that clear with this example here. The question says that the Venn diagram below shows the 3 sports played by 120 students in a school. A student is chosen at random, and we're asked to find the probability that that student firstly plays basketball and then plays 3 sports. So how many in that specific group? First of all, how many students play basketball is going to be everybody in this bottom right hand circle. Let's add together our numbers. 12 plus 6 is going to be 18, plus 8 is going to be 26, 26 plus 24 is going to be 50. So we can say that the probability of choosing a student who plays basketball, guys, is going to be our 50 students who do play basketball out of all of the students we're choosing from. There are 120 students in total, so we can say that the answer to part I is going to be 50 over 120. What about how many people play 3 sports? sports, guys, what's it going to be? Well, we're going to have our number of students who play 3 sports. That's going to be the people in this overlapping section here. Of all 3 of our circles overlapping, we have 6. So it's going to be 6 out of how many are we choosing from? Again, we're choosing from the total 120 students in the school. So our answer, guys, is going to be 6 over 120. Now, if you want to, you can simplify these probabilities, but it doesn't ask us to, so we don't have to. It's going to be completely up to us.
Conditional probability questions, guys, can be pretty tricky, and when they include Venn diagrams, they're often quite difficult examples. Let's have a look at this one. The question says, the Venn diagram below shows the sports played by 120 students in a school. A student is chosen at random. Find the probability that that student plays football given that he plays exactly 2 sports. Okay, so the probability that they play football given that they play exactly 2 sports. We're going to need to find out, guys, how many different students we can choose out of how many students there are in total in our group. So the probability that he plays football given that he plays exactly 2 sports. How many students are we choosing out of? We're choosing out of the students who play exactly 2 sports. We have 14 students over here. We have 12 students down here and 8 students over here. This 14 play football and hockey. This 12 play football and basketball, and this 8 over here play hockey and basketball. So how many do we have in total in those groups? 12 plus 8 is going to be 20, plus 14 is going to be 34. Now, what is the probability, given that it's one of these students, that they play football? How many students do we have playing football? Well, we have these 14 playing football and hockey, and then this 12 playing football and basketball. In total, that's 26 students, so we're going to have a probability of 26 out of 34. We found the probability that they play football given that they play exactly 2 sports. How many students play 2 sports? 34. How many play football? 26, giving us our answer, guys, of 26 out of 34.
The fundamentals of frequency trees in 96 seconds. Let's go. When it comes to working with frequency trees, guys, the first thing to understand is going to be what these frequency trees actually show. So we would say that frequency trees are useful tools for showing information, and particularly that information is going to be about frequencies, about the number of people falling into different categories. Let's have a look at this one here. So we're told that the following frequency shows some information about how 30 students get to school. Let's break it down and understand what's going on. So this 30 here, that's going to show the total number of students. And then we can see that this is broken down into boys and girls. And this shows that 17 boys go to school. And we have 13 girls who are going to school, and then we can see that this 17 is further broken down into 6 and 11. And what this tells us is that of those 17 boys, we have 6 who walk and 11 who don't walk. And we can see that our 13 girls are also broken down. They're broken down into 3 girls who walk to school and 10 girls who don't walk to school. So we can see how this frequency tree has been really useful for showing a lot of information in a very small space. We've got information about the number of boys, about the number of girls, and about the number of boys who walk, boys who don't walk, and girls who walk, and girls who don't walk. So loads of information in a very small space. That's what our frequency trees are going to be great for. Constructing frequency trees in 102 seconds. Let's go. Questions like this, which involve constructing frequency trees, guys, are going to be super common in our foundation papers. Let's have a look at this one. The question tells us that an office has 40 workers and also that there are 19 females. We're then told that there are 14 males and 11 females who like coffee, and we're asked to complete the frequency tree below. And what we can see is that we've been given directly the information to fill in some of our circles, but some of them we're going to have to figure out for ourselves. Let me show you what I mean. So first of all, we know there are going to be 40 workers. So the number which is going to go here, which is at the start, is going to be 40. We know there are going to be 40 workers in total. Now, we're also told that there are going to be 19 females, so we can fill in this circle here, but we haven't been told anything about the number of males. However, we can figure this out by doing our total number of people, subtract our number of females. So we can do our 40 total workers, subtract our 19 females, and that is going to give us 21 males. which we can put in there. Now, we're then told that there are 14 males who like coffee, so we can put that in this section, which is going to be our males who like coffee, and we're also told that there are going to be 11 females who like coffee, so we can put an 11 in here. Final step then, guys, we want to work out the number of males who don't like coffee and the number of females who don't like coffee. How are we going to do that? Well, we know there are going to be 21 males in total, and we know there are going to be 14 of them who like coffee, so to work out the number who don't like coffee, we can do our 21 total number minus 14, that's going to give us 7, and that's going to be our number of males who don't like coffee. Following a very similar logic for females, guys, 19 females in total minus the 11 who like coffee, that is going to give us 8 females who don't like coffee, and we can see that we've now filled in all of the gaps in our frequency tree. How to find probabilities from frequency trees in 59 seconds. Let's go. When it comes to working with probabilities and frequency trees, guys, our method is going to be the same as with many other probability questions. We're going to do the number of things in the group that we want to choose divided by the total number of things that we're choosing from. Let's have a look with this example. The question says that the following frequency tree shows how 30 students get to school. We're then told that a student is chosen at random, and we're asked to find the probability that the student walks to school. So what are we going to do? We're going to do the number of different ways that we can choose a student who walks to school divided by the total number of students that we have. We're told that we have 30 students in total, so that's going to be the number of students we're choosing from. So our fraction is going to be out of 30, and then how many students are in the group that we want to choose? How many students walk to school? Well, there are going to be 6 boys who walk to school, and there are going to be 3 girls who walk to school. 6 plus 3 is 9, guys, so we can do 9 over 30, and that's going to be our answer. We can simplify if we want, but we don't have to unless they ask us. The fundamentals of tree diagrams in 125 seconds. Let's go. When it comes to working with our tree diagrams, guys, the first thing to understand is going to be what they're actually useful for. Let's have a look at this one. We would say that tree diagrams are a useful tool for understanding and organizing information about 2 or more events. We can see down here that we have 2 events. We have bus 1, which is either going to be late or not late, and we have bus 2, which again is either going to be late or not late. Let's have a look at this prompt then to understand a little bit more about the information shown. We're told in the prompt that Bob has to catch 2 buses on the way to work, and we're told also that the probabilities of each bus being late are shown below. Let's try to understand this. So we can see that this part of our tree diagram is going to give us our information about bus 1, and we can see that there's going to be a 5/8 probability that bus 1 is late, and there's going to be a 3/8 probability that it's not late, and we can see that these 2 probabilities add up to make 1, and that is not going to be a coincidence. That's always going to be the case. Why? Because we know that the probabilities of all of our options always have to add up to make 1. Now, what about bus 2 then? This one's going to be a little bit more interesting, a little bit more stuff going on. So we can see down here that if we go along this stick, bus 1's been late, and then we can work out the probability of bus 2 being late given that bus 1 has already been late. And we can see that our probability of bus 2 being late after bus 1 is being late is 7/8, and the probability that it's not late is going to be 1/8. And this is actually going to be different to the probability that bus 2 is late and not late after bus 1 has not been late. So we can see that if bus 1 has not been late, the probability of bus 2 being late is 5/8, so it's a little bit less likely than in the case where bus 1 was late. And we can see that the probability of bus 2 not being late is 3/8, and we can see that it's more likely for bus 2 to not be late after bus 1 has not been late than it is for bus 2 to not be late after bus 1 has been late. So guys, there are going to be some key principles there when it comes to our tree diagrams. Hopefully everything made sense there. Let me know if you have any questions about understanding this and interpreting it in the comments. Constructing tree diagrams in 79 seconds. Let's go. Questions like this, which ask us to fill in the probabilities on tree diagrams, guys, are going to be super common in our higher papers. Let's have a look at this one and see if we can get it. The question says that Tom flips a biased coin and then rolls a fair dice. We're asked to fill in the probabilities on the tree diagram. What do we reckon? So first off, let's deal with this flip of the coin. What can we say? Normally when we have a fair coin, it would be a 50-50 chance, but in this case we have a biased coin. So So we might be wondering, how can we work out our probabilities? We're actually going to use this information that they've given us here. They've told us in the tree diagram already that the probability of a heads is 2/5, and we know that the probabilities of all of our events have to add up to make 1, so we can say that the probability of a tails then is going to be 3/5. That's because the only two options for our toss of our coin are going to be heads and tails, so both of those probabilities have to add to make 1. Now, what about this roll of the fair dice? Well, this is fair, which means that all of the options are going to have the same probability. It's going to be a 6-sided dice, a regular dice, so we can say that the probability of a 6 is going to be 1/6, and the probability of a not 6 is going to be 5/6. So we can fill those in for both of our trees, and there we go, guys. We've got our answer. All of those gaps are filled in, and we have probabilities for each of our options. Calculating probabilities from tree diagrams in 117 seconds. Let's go. Questions like this, which involve combining the and or rules with tree diagrams, guys, are pretty difficult and they do come up a lot. So let's have a look at this one and try to understand it. The question says that Tom flips a coin and then rolls a dice. We're asked to calculate the probability that he flips a coin, then rolls a 6, or flips a head, then rolls a not 6. So we've got quite a lot going on here. Let's break it down. First of all, we have the fact that we can either have the first option where he flips a tail, then rolls a 6, or we can have the second option where he flips a head, then rolls a not 6. So we're going to have two probabilities here, which we're going to add together. Why? Because we can have the first one, or we can have the second one. But what are going to be those probabilities that we add together? So let's work out firstly the probability that he flips a tail and then rolls a 6. So how are we going to work that out? Well, he needs to flip a tail and then roll a 6. So we're going to multiply the probability that he flips a tail and then rolls a 6. We can work down our tree diagram. We have a half times by a 6th. So let's write that in. We're going to have 1/2 times by 1/6, timesing our top by our top and our bottom by our bottom. We're going to get 1/12. Now, what about the second option then, guys, where we're going to, what does it say? Or flips a head, then rolls a not 6. So this time we're going to go down this section and then we're going to roll a not 6. So we're going to have a half times by 5/6. Let's write that in. 1/2 times by 5/6. 1 times 5 is 5. 2 times 6 is 12. So we're going to have 5/12. Now, guys, remember what we said. We can have the first option or we can have the second option. So we're going to add those together. We're going to do 5/12 plus 1/12. We have the same denominator, so we can just add the tops. We're going to get 6/12 as our answer. And if we want to, we can simplify that, dividing top and bottom both by 6. We're going to get 1/2 as our final answer. Conditional probability with tree diagrams in 125 seconds. Let's go. This, guys, is a topic which comes up a lot and it is a difficult one. Let's have a look. The question says that Tom has a bag with 3 red counters and 4 blue counters in it. He takes 2 counters out at random without replacement. The key words there, guys, without replacement. Using the tree diagram below, find the probability. He chooses a red counter and then a blue counter. Step number 1, guys, is going to be to fill in all of the probabilities on all of our branches, and then we can find the probability that we want. So first of all, our first choice for our red and blue counter, what are going to be our probabilities? Well, we have 3 red counters and 4 blue counters, so we can say that we would have 7 counters in total, which means that our probability of choosing a red is going to be 3 out of 7, and for blue we're going to have 4 out of 7 because there are 4 blue counters. Now, after we've taken our first counter out, let's say that we've chosen a red counter. How many counters are we going to have left? And how many counters are going to be red out of those ones that we have left? So we did have 7 counters in total. Now we're going to have 6 counters in total because we've taken 1 out. And we did have 3 red counters. We've taken out 1 red counter. So we're going to be left with 2 red counters. What about blue? We had 4. We've taken out 1 red counter. So our number of blue counters is not going to have changed. So the probability of choosing blue after that is going to be 4 out of 6. Now, what about choosing blue then red? Well, there were 3 red counters. There's still going to be 3 red counters because we took out a blue one, not a red one. So we're going to have 3 out of, and our total number of counters again is going to be 6. Finally, what about blue? Our second blue probability, well, we did have 4 blue counters. We've taken 1 out. So now we're going to have 3 blue counters out of 6 in total. Now, finally, guys, the probability of choosing a red counter and then a blue counter, we're going to go down our red stick and then we're going to go down our blue stick. Probability of red is going to be 3/7, and then getting the blue afterwards is going to be 4/6. So to find our probability, we can do our 3/7 times by our 4 over 6, 3 by 4, that's going to be 12, 7 by 6, that's going to be 42, and there, guys, we get our answer of 12 over 42. If we want to, we could simplify that fraction, but we don't have to unless they ask us. The fundamentals of two-way tables in 105 seconds. Let's go. When it comes to working with two-way tables, guys, the first thing to understand is going to be the type of information that they contain and how to read them. Let's have a look. We can say that a two-way table is a type of frequency table which contains information about two variables. So it contains information about two variables and it tells us the frequency with which these different variables occur. Let's have a look at this example. We can see that our two variables are going to be the type of seat that we're in, whether it's stalls or balcony, and it's going to be whether we're adults or children. So it's going to be a variable which contains information about people's ages. Let's have a look at how to read it then. What can we say? Well, if we wanted to work out how many people were adults and sitting in balconies, what we would do is we would read across the adults column and we would go down the balconies column and check whichever block is in the adults row and balcony column. We can see here that there would be 6 people who are sitting in balcony and are adults. Now, what about, for example, if we wanted the number of children who were in stalls? What we would do is we would go across the children's row and down the stalls column, and we would get to 18, telling us that there are going to be 18 children sitting in stalls. Now, another really important component of these two-way tables, guys, are going to be our totals row and our total column. We can see from these that the total number of people sitting in stalls would be 32. We can see that the total number of people sitting in balconies would be 14. We can also see that the total number of adults would be 20 because 14 plus 6 is 20. And finally, we can see overall that the total number of people would be 46. We could do that by doing our total number of adults plus our total number of children, or our total number of people sitting in stalls plus our total number of people sitting in balconies. Constructing two-way tables in 132 seconds. Let's go. Questions like this, which ask us to construct two-way tables, guys, are going to be super common in our foundation papers. Let's have a look at this one here, which asks us to complete the following two-way table. We can see that we've been given some information about whether people wear glasses or don't wear glasses and whether they are adults or children, and we want to fill in all of our gaps. What can we do? Well, we're going to look for rows or columns which have given us two pieces of information and use the differences to work out the gaps. Let me show you what I mean. So we've been told that there are 36 adults who wear glasses and that the total number of people wearing glasses is 45. So if we want to work out the number of children wearing glasses, what we can do is we can do our total number, which is 45, minus the number of adults. So we can do 45 minus 36, and that is going to give us 9, the number of children wearing glasses. Now, what about the number of adults not wearing glasses going in this box? Here again, we can use the difference between our total number of adults and the number of adults wearing glasses. We can do 47 minus 36, 47 minus 36, and when we do that, we're going to get 11, so we can put 11 in there. What about the total number of people wearing no glasses? We can also fill that gap in. Why? Because we know the number here, which is going to be the total number of glasses, and we know the number here, which is the overall total number of people. So we can do our 70 minus our 45, 70 minus 45, writing that in, that's going to give us 25. So we know the total number of people not wearing glasses is going to be 25. Now, just using that method, using the same method is what I meant to say, we can fill this gap in here. We can do our 25 total number of people not wearing glasses minus the number of adults wearing no glasses, which is 11. So we can do 25 minus 11, which is 14. And finally, we can add together the number of people wearing glasses and not wearing glasses, the number of children wearing glasses and not wearing glasses, that is. We can do 9 plus 14. 9 plus 14, that's going to give us 23, guys, and we can see that our answer must be right because we've ended up with 47 plus 23, which gave us 70, so that shows us that our working out must be correct throughout. I did mess up my words a few times there, guys, but hopefully it's clear. Calculating probabilities from two-way tables in 72 seconds. Let's go. When it comes to working with probabilities in two-way tables, guys, the method is going to be the same for many of the other areas of probability we've spoken about. We're going to do the number of things in the group that we want to choose, out of the total number of things we're choosing from. Let me show you what I mean with this example here. The question says that the table below shows some information about 70 people. We're then told that a person is chosen at random and asked to calculate the probability that they firstly wear glasses and secondly are an adult who doesn't wear glasses. So we're going to do firstly the number of people who wear glasses out of the number of people we're choosing from. How many people wear glasses? Well, we're going to go down the glasses column. The total number of people wearing glasses is going to be 45. How many people are we choosing from? We're choosing from 70 in total. So our probability, guys, is going to be 45 out of 70. We don't need to simplify that because they don't ask us to, but we could if we wanted to. What about the second one, which is going to be the probability that a person chosen at random is an adult who doesn't wear glasses. So adults who don't wear glasses, there's going to be 11 of those. So we can do 11 out of our total number of people we're choosing from, which is 70. So guys, our probability is going to be 11 over 70, and that's going to be our answer. Conditional probability questions involving two-way tables in 50 seconds. Let's go. Conditional probability, guys, is a pretty tricky topic, but luckily two-way tables can help us out a lot when it comes to working them out. Let's have a look at this one. The question says that the table below shows some information about 70 people. It then says that a person is chosen at random and we're asked to calculate the probability they wear glasses given that they are an adult. So we know that we're choosing out of our adults, so let's put a box around that group there. So we know we're choosing out of our adults, so we know there's 47 adults in total. We want the probability that they wear glasses given that they're in this group. So we know they're in this group. We're choosing out of our 47, so we can put our probability out of 47, the probability they wear glasses. We know that 36 adults wear glasses, so 36 out of our 47 is going to be the probability that given that they're an adult, a person wears glasses. How to calculate relative frequencies in 45 seconds. Let's go. In this question, guys, we're told that a dice is rolled 153 times and we're given the results in this table below. The question then asks us to find the relative frequency for rolling a 6 on that dice. What are we going to do to find the relative frequency, guys? We're going to divide the frequency with which that thing happens by the total possible number of times that that thing could have happened. In this case, we can see that we get 51 sixes, so that's going to be our numerator. We're going to divide that by the total possible number of times we could have gotten a 6. Well, we rolled the dice 153 times, so that's going to be the total possible number we could have gotten. So we have 51 over 153. Now, if we want to, we can simplify this, dividing top and bottom both by 51. We're going to get 1 over 3, our final answer. How to identify the best estimate when working with relative frequency in 93 seconds. Let's go. Questions like this come up all the time, guys. Let's have a look. The question says that a dice is rolled 40 times and the results are shown in the table below. We have the different scores, 1, 2, 3, 4, 5, and 6, and the different frequencies. We're then told that the dice is rolled a further 100 times and the results are shown in this table below. Again, we have our different scores, 1, 2, 3, 4, 5, and 6, and our different frequencies. Then we have our question, which says which set of results would give a better estimate for the probability of landing a 6 with this dice. Guys, we know we can estimate the probability in both of these cases by finding the relative frequency. In the first case, it would be our 5, the number of times we get a 6, divided by 40, so 5 over 40. And in the second case, it would be 17, the number of times we get a 6, divided by 100, because we roll the dice 100 times. But which one is going to be the better estimate, guys? The better estimate is always going to be the one with the bigger sample size. We can see in this case that we roll the dice 100 times in the second time and only 40 times in the first. In the second case, we roll the dice an extra 60 times, so we effectively have a bigger sample of rolls. Therefore, we can say that the second estimate is going to be better. How to calculate an expected frequency in 68 seconds. Let's go. In this question, guys, we've been told that a biased coin is flipped 200 times and that it lands on tails 74 of those times. We're then asked how many times we would expect the coin to land on tails if it were to be flipped 500 times. Now, what are we going to do? Our first step is going to be to find an estimate for the probability of the coin landing on tails using our first set of information. Then we're going to multiply that probability by 500 to find the expected number of tails that we would get when we flip it 500 times. Let's get it done. So firstly, estimating the probability of the coin landing on tails. What are we going to do? We're going to do our our 74 times that it landed on tails divided by the 200 times we flipped it in the first case. So we're going to do 74 divided by 200, which is going to be 0.37. And that's going to be an estimate for the probability of the coin landing on tails. Now, to find the estimate for the expected value of times that the coin is going to land on tails, flipping it 500 times, we're going to do our 0.37, the probability of tails, times by 500, the number of times that we flip the coin. And that, guys, is going to be 185. So if we flip that coin 500 times, we would expect 185 tails. How to identify bias in 99 seconds. Let's go. When it comes to identifying bias, guys, the key is going to be to look out for situations in which the probabilities suggested by the experiments are different to the probabilities that we would expect given what we know about those objects. Now, that was all a little bit abstract, so let me make it clear with this example. The question says that Rick flips a coin 250 times and that he gets 190 heads. We're then asked if the coin is likely to be biased based on these results. What do we reckon? Well, we know that a coin should have a 50-50 chance of landing on heads and tails. In other words, there should be a 0.5 probability of getting a heads. Let's calculate an estimate for the probability using these results and see whether it's close to 0.5. If it is close, we probably don't have a biased coin. But if it's a long way away from 0.5, we're probably dealing with a biased object. Let's have a look. So what would the probability be based on these results? Well, we flip the coin 250 times and we get 190 heads. So it would be 190 out of 250. Now we're going to simplify this and write it as a decimal so it's easier to compare to 0.5. Dividing top and bottom both first by 10, we're going to get 19 over 25. Then we can times top and bottom both by 4, making the denominator 100. We're going to get over 176. Now, this is pretty clearly going to be 0.76 as a decimal. How do we do that? 76 divided by 100 if you're not sure. And then now we need to compare this to 0.5. 0.76, that is very far away from 0.5. So we do have some evidence. We can say, yes, the coin is likely to be biased. Why? Because 0.76 is very far away from 0.5. How to calculate combinations in 36 seconds. Let's go. These questions come up all the time, guys, and I've got to say they are forgotten about so often. Let's have a look. The question says that a restaurant offers 6 starters, 11 mains, and 4 desserts, and then we're asked to calculate how many different ways there are to choose 3 courses. What we're going to do, guys, is we're going to multiply the number of starters, 6, by the number of mains, 11, by the number of desserts, 4. So we're going to do 6 times 11 times 4, 6 times by 11 times by 4, 6 by 11 is 66 by 4. That's going to be 264. So we can say, guys, that there are going to be 264 different possible ways to choose a combination of 3 courses. Combinations questions which involve problem solving in 77 seconds. Let's go. Here, guys, we have a pretty tricky question on applied combinations, but don't worry, I'm going to do my best to make it clear. Let's have a look. The question says that a meal deal consists of a sandwich, a snack, and a drink. And then it says, given that there are 7 types of sandwiches, 8 types of snacks, and X types of drinks, as well as 336 different meal deal combinations in total, find the value of X. Guys, what are we going to do? Well, we know to calculate the total number of combinations of snacks, sandwiches, and drinks, we can multiply the number of types of each of those things. In other words, to find the total number of combinations of these things, we could do our 7, which is our number of types of sandwiches, times by our 8, which is our number of types of snacks, times by our X, which is our number of types of drinks. And that's going to be equal to the total number of combinations which we've been given, which is 336. So we can say that 7 times 8 times by X is 336. Now, this is an equation which we can simplify and solve. 7 times by 8, that's going to be 56. So we have 56x equals 336. And finally, we can divide both of our sides of our equation by 56 to find the value of x. 336 divided by 56, that's going to be 7. So we can say that x is equal to, no, it's not, it's going to be 6. It's not going to be 7, it's going to be 6. So we can say that x is equal to 6. The difference between qualitative and quantitative data in 46 seconds. Let's go. Here, guys, we have a quick reminder on the difference between our quantitative and our qualitative data. We would say that our quantitative data is going to be our numerical data, whereas our qualitative data is going to be our non-numerical data. Here we have a few examples just to drive home the message. What are we going to have? Well, we would say that height and weight are both going to be quantitative data. Why? Because all of our values here are going to be numerical. They're going to be numbers, whereas whereas over on the qualitative side, we have a couple of examples which are colors and days of the week. Colors, for example, red and blue, days of the week, Monday and Friday. All of these are going to be non-numerical values. They are actually words, so they're going to be qualitative data. The difference, quantitative and quantitative data is going to be our numerical data, whereas qualitative is going to be our non-numerical. The difference between discrete and continuous data in 83 seconds. Let's go. Here, guys, we have the difference between our discrete and our continuous data. Let's have a look and see if we can understand. We would say that our discrete data is going to be data which can only take on whole number or exact values, whereas in contrast, our continuous data, that's going to be data which is quantities that are either rounded or measured. I said those in the wrong order, but you get the gist. Now let's have a look at a few examples to try and understand this. We would say that shoe size, score rolled on a dice, and quantity of cars, for example, in a car park are all discrete because they take on exact values. Your shoe size, that could be, for example, 7, 7.5, 8, 8.5, or 9, or any of those other shoe sizes that I didn't mention, but crucially, they are exact values. In the similar way, the scores on a dice, 1, 2, 3, 4, 5, or 6, they are all exact values. And quantity of cars in a car park, you can't have kind of an infinitely divisible number of cars. It's going to be a whole number value. In contrast, we would say on the continuous side that we have time, length, and mass. All of these are infinitely divisible. We could break down further and further and further. 1 second, maybe it's 1.0000001 seconds. You know, you could get infinitely more divisible, and there could be an infinitely greater degree of accuracy. So all of these ones are going to be continuous. They don't take on exact values. They are infinitely divisible. Whereas our discrete values over here on the left, they are going to be our exact values and our whole numbers. How to find a simple random sample in 69 seconds. Let's go. In this question on simple random sampling, guys, we're asked to explain how we could take a simple random sample of 35 students from a school of 180 students. Guys, when it comes to our simple random sampling, there's going to be a 3-step process that we follow every time. And this example is going to illustrate it really clearly. Step number 1, we're going to say is going to be to label our students from 1 to 180. Now, this could be a different thing. It could be, for example, labeling cars from 1 to 1,000 if you had 1,000 cars, but in this case we have 180 students, so we're going to label our students from 1 to 180. Step number 2 then, that's going to be to use a random number generator to generate 35 numbers in this range, ignoring any repeats. Now, the reason we generate 35 numbers is because we need a sample of 35 different students, and that's also going to be why we have to ignore those repeats. We're going to need 35 different numbers to get 35 different students. Step number 3 then, that's going to be finally to choose the students which have the numbers generated, making sure then that we have 35 students. Why? Because we have 35 different numbers. That's going to give us a sample of 35 different students. Pretty obvious. We just choose the students corresponding with the numbers that we generated. What it means for a sample to be biased in 75 seconds. Let's go. Here, guys, we have a quick reminder of what it means for a sample to be biased. Let's have a look. We would say that a sample is biased if it doesn't represent, if it's not representative of the population from which it is sampled. In other words, if the sample that we take doesn't paint a fair picture of the underlying population. That sounds a little bit abstract at the moment. Let's have a look at this example and hopefully it will clear it up. It says that Tom is interested in the average height of students in his secondary school, and he uses a sample of 25 year 11s to estimate this average height. Then we're asked whether the sample is likely to be biased, or I should say whether the estimate is likely to be biased, and to explain our answer. What do you think, guys? Is it going to be biased? I'm going to give you 3 seconds. 3, 2, 1. We would say yes, this is definitely going to be a biased sample, and the estimate therefore is definitely going to be biased. And what's the reason? That's because the year 11s are going to be some of the tallest people in the secondary school, and all of the people in our sample have been taken from that tallest group of the entire population. So we're not going to get a fair picture. Therefore, our sample is going to be biased. The capture-recapture method in 60 seconds. Let's go. This, guys, is a topic which trips people up all the time. Have a look and see if you can get it. The question says that a farmer wants to know how many mice are in his barn. One day, he places a trap and that trap catches 12 mice. He marks the mice and lets them go. And then 3 days later, he catches 18 mice, 6 of which have the marking. The question then says, estimate the number of mice in the barn in total. Guys, what are we going to do? Well, we know that after we re-catch the mice, so on that second time of catching the mice, 6 out of 18 of the mice have the marking, and that's going to imply that 6 over 18, which is going to be equal to 1 over 3. So 1/3 of the mice have the marking. How many mice have the marking? 12 mice have the marking. So we know that 12 of our mice represents 1/3 of our total number of mice. So we can say that 12 mice is 1/3 of the total. Therefore, we're going to times 12 by 3 to work out our total. That's going to give us 36. So we can estimate that 36 mice have the marking in total. How to find the mode from a list of numbers in 30 seconds. Let's go. In this question, guys, we're asked to find the mode of the following numbers. What are we going to do? We're going to use the fact that our mode is going to be the most occurring number in our list. We can think of both of these words as starting with MO. That's going to be a useful way to remember it. So which is going to be the most occurring number in this list? We have 1 2, we have 2 3s, we have 1 5, we have 1 7, we have 3 8s, and we have 1 11. Therefore, guys, the most occurring, that's going to be 8. Our mode from this list is going to be 8. How to find the median from a list of numbers in 49 seconds. Let's go. In this question, guys, we're asked to find the median of the following numbers. What are we going to do? We're going to use the fact that the median is going to be the number which is in the middle when we order those numbers from smallest to largest. Let's get it done for this example here then and see what we get. Ordering firstly the numbers from smallest to largest. We're going to have 1, we're going to have 2, we're going to have 2. Let's cross those out to show that we've used them. Then what are we going to have? We're going to have 4, then we're going to have 5, then we're going to have 6, then we're going to have 8. Again, let's cross those out. 4, 5, 6, and 8. And we can see that we've used all of the numbers there then. Now we're going to work out the number which is in the middle. What are we going to get? Let's cross off 1 from either side. We're going to cross off the 1, cross off the 8, cross off the 2, cross off the 6, cross off the 2, cross off the 5. And we can see that our number 4 is going to be in the middle when we order those numbers from smallest to largest. Therefore, our median, guys, is going to be 4. How to find the mean from a list in 43 seconds. Let's go. In this question, guys, we're asked to find the mean of the following numbers. What are we going to do? To find the mean, guys, we're going to add together all of the numbers that we have, and then we're going to divide that result by the number of numbers in the list. Let me show you what I mean with this example here. What are we going to have? Firstly, adding together all of our numbers, 7 plus 8 plus 11 plus 4 plus 6 plus 13 plus 7, that's going to be 56. Work that out, guys. Check that you get the same as me, and then we're going to divide that by the number of numbers that we have. We have 1, 2, 3, 4, 5, 6, 7 numbers in total, so we can do 56 divided by 7. 56 divided by 7, that's going to be 8. So, guys, we get our mean from this list. It's going to be 8. How to do questions involving the reverse mean in 88 seconds. Let's go. This, guys, is a topic which a lot of people struggle with. Let's have a look and see if we can get our head around it. What are we going to have? The question says that the average height of 7 students in a class is 154 centimeters. It then says that an 8th student is added to the class who is 146 centimeters tall. It then asks us to calculate the new mean height. Guys, what are we going to do? The first step is going to be to calculate the total height before that new student was added. Now, we know that we have 7 students in the class, and that the average height of those students is 154 centimeters. So to find the total height before that new student was added, we can do our 7, the number of students, times by 154 centimeters, the average height. 7 times 154, that's going to be 1078 centimeters. Now, what are we going to do? We need to find the new total height and then divide that by the new number of people, which is 8. So finding the new total height, we're going to do our 1078 centimeters plus our 146 centimeters, which was the height of that 8th student. 1078 plus 146, that is going to be 1,224 centimeters. Now we can do our 1,224, the new total height, divided by 8, which is going to be the new total number of students. So we're going to have 1,224 divided by 8, and that's going to be 153 centimeters. That, guys, is going to be our new average height, 153 centimeters. How how to find the range from a list of numbers in 25 seconds. Let's go. A quick reminder then, guys, of how to find the range from a list of numbers. Guys, to find the range, what we're going to do is we're going to do the largest number in the list, subtract the smallest number in the list. Looking down at this example, we can see that the largest number we have is 11 and the smallest number we have is 3. So to find the range, we're going to do 11 minus 3, and that's going to give us 8. So guys, the range from this list is going to be 8. How to find the mean, the mode, the median, and the range from an ungrouped frequency table in 234 seconds. Let's go. In this question, guys, we have absolutely loads to get through. We want to find the mode, the range, the mean, and the median from this frequency table. I'm going to have to speak very quickly for this one, so pay close attention. What are we going to do? First of all, finding the mode. The mode, guys, that one's going to be our most occurring age. It's going to be the age with the highest frequency. We can see here that our frequencies are 3, 4, 6, and 8. The highest frequency, therefore, is going to be 8, and that's associated with an age of 21. So our mode, guys, that's going to be 21. Let's write that in the mode, 21. What about our range? Our range, if we remember, that's going to be our largest value, subtract our smallest. We can see that the largest age recorded was 21. The smallest age recorded was 18. So to find our range, we can do 21 minus 18, which is going to give us 3. Now, what about the mean? The mean, guys, this one is going to be quite a lot of work. What are we going to do? The first step is going to be to find our total frequency, because to find the mean, we need to do our total value of things divided by our total frequency. So we're going to find the total number of years by doing our frequency times by our age in each case. That's going to give us a frequency times age column. Then we're going to add all of those together to find our total combined age of everybody in the experiment. Then we're going to divide that by our frequency. Let's get it done. So firstly, finding our frequency, 3 plus 4 plus 6 plus 8, that's going to be 21, guys. Pause the video now and check that you can get that. Now, what about our age times by our frequency? Let's put in another column for that, age times by frequency. What are we going to have? 18 times by 3, that's going to be 54. 19 times 4, that's going to be 76. Don't rush that too much, guys. 20 by 6, that's going to be 120. And 21 by 8, that is going to be 168. Now, where can we go from there? We can find the sum of all of these added together. 54 plus 76 plus 120 plus 168, that is going to be 418. Now, finally, what are we going to do? To find our mean, guys, we're going to do our total sum of all of those age times frequencies, and we're going to divide that by our frequency. So in this case, we're going to do 418, the total of all of the ages, divided by 21, our total frequency. What's that going to give us? That's going to give us, let me turn that into my calculator because I'm not going to do that in my head, 418 divided by 21, that is going to give us 19.9 to 1 decimal place, 19.9 to 1 decimal place. Okay, so we have our mean. What about our median? That is going to be the value which, when we line all of these up from smallest to largest, is in the middle. But it's not going to be very practical here to line all of our numbers up. Why? Because we have so many, we have 21 numbers to line up, so it's going to take too long. What are we going to do instead? Well, we can use a little trick. Our median, that's going to be the value which is in the middle, and to find which value that's going to be, what we can do is we can take our frequency, 21, we can add 1 to get 22, and then divide that by 2 to get 11. And what that basically tells us is going to be that our 11th value, when we line these up from smallest to largest, is going to be our median. How do we do that? We did our total frequency plus 1 divided by 2. Make sure you remember that because this does come up quite a lot. So how are we going to find our 11th value? What's it going to be? Well, we know that this column here, this row here, the 18 row, is going to take us up to our 3rd frequency. Add 4 to that because we have a frequency here. The 19 age group is going to take us up to our 7th frequency. We're still not there. And we can see that our 20 column, when we add 6 to that 7, is going to take us up to our 13th value. So our 11th value has to be in this row. It has to be in the 20 row. Why? Because this one took us up to 7. This one took us from 7 to 13. So the 11th value has to be in the 20 category. So we can say, guys, that our median is going to be 20. Guys, that was not easy and that was a lot to get through, and I did speak quickly, but hopefully it was clear enough. Feel free to watch again if you need to clarify. Just to recap, our mode, that was 21. Our range, that was 3. Our mean, that was 19.9 years. And our median, that was 20, guys. Have a look back through. That was fast. How to interpret a grouped frequency table in 63 seconds. Let's go. Here, guys, we have a quick reminder of how to interpret a grouped frequency table. What can we say? Well, first of all, we can say that a frequency table shows us how many times things were recorded. We have this frequency column, and this shows us how many times each of the rows over here were recorded, each of these heights. Now, what about in the case of a grouped frequency table? Well, this time we don't have specific values for our variable, for our height in this case. What we have instead is a group of values. So we can say that 3 of our heights were between 130 and 140, where crucially 130 is not included, but 140 is included. We can say that 7 of our heights were between 150 and 140. Again, here the 150 is included, but the 140 isn't. And finally, 5 of our heights were between 160 and 150, 160 inclusive, 150 not inclusive. So a frequency table, when it's in a group situation, works in exactly the same way as in an ungrouped situation. The only difference is going to be that we don't have exact values for our variable in the left-hand column here. Instead, we only have ranges. How to find the mean, mode, median, and the range from a grouped frequency table in 249 seconds. Let's go. Guys, in this question, we have absolutely loads to get through, so I'm going to be speaking pretty quickly just to give you a pre-warning. How are we going to find the mode, the range, the mean, and the median from this grouped frequency table? What do we reckon? First of all, our mode, guys, the mode, that one's going to be our most occurring, so it's going to be the one with the highest frequency. We can see here that our frequencies are 3, 7, and 5, so our modal class group is going to be the one which goes with our frequency of 7. We can see that it's our group that 140 is less than our height, which is less than or equal to 150. So that is our mode done. It's going to be that group there. Now, what about our range, guys? The range, that one's actually going to be the nicest. Why? Because it's impossible to calculate. We don't actually have any exact values for our heights. So we're just going to put a cross there, and we're going to recognize the fact that our range is impossible to calculate. What about our mean, guys? This one is definitely the meanest. Let's have a look how to do it. What are we going to do? We can see that we have these two added columns over here, and they're going to be the columns for our midpoint. Let me switch to blue. Our midpoint and our midpoint times by our frequency. Let me explain. So if you remember from our group frequency table, what we did was we found our overall total and then divided that by the sum of our frequencies, the total number of things that we had. In this case, because we don't have any exact values for our height, what we need to firstly do is estimate a value which represents each of the heights in these groups. How do we do that? We're going to use the number which is halfway between the lower bound and the upper bound of each of our intervals. How are we going to find that? Couple of different ways. We could find the difference between the lower and the upper. Here it's 10, halve it gets 5, and add that onto the lower. That would give us 135. The other way to do it is going to be to add the lower bound and the upper bound together. 130 plus 140, that's going to be 270, and then to divide that by 2, again we get 135. So in this case, for our first one, the midpoint is going to be 135. What about the midpoint of 140 and 150? 150 minus 140, that's going to be 10 divided by 2, that's going to be 5, adding that onto 140, that's going to be 145. Doing the exact same thing for 150 and 160, we're going to get 155. Now, the next step, guys, is going to be to do our midpoint times by our frequency to find an estimate for the overall total height. What are we going to do? 3 times by 135, that is going to be 405. 7 times by 145, I won't bother doing that in my head. 7 by 145, 7 times by 145, that is going to be 1015. Next up, we have 5 times by 155, that's going to be 775. Now, adding all of those together, what are we going to have? We're going to have 405 plus 1015 plus 775, and that is going to give us 2195 as our total. Next step, guys, we need to find our total frequency by adding together each of the numbers in this column. 3 plus 7 is 10, plus 5 is 15, so our total frequency is 15. Final step, guys, is going to be to do our total of our midpoint times our frequency divided by our frequency. What are we going to get? We're going to get 2195 divided by 15. Again, not going to do that one in my head. What are we going to get? We're going to get 146.3 reoccurring as our answer, 146.3 reoccurring. So that's going to be our estimate for our mean height. Finally, what about our median? Again, we can't pin down a specific value here, so instead we're going to give the group within which the median sits. What's it going to be? Our total frequency, that's going to be 15. Using our trick to find the which value is going to be the median. 15 plus 1 is 16. 16 divided by 2 is 8. That tells us that our 8th value is going to be our median. Let me write that in. The median is going to be the 8th value, which group is that going to sit within? We can say that it's going to sit within this second group here. Why? Because we have 3 in our first group. Adding 7 to that gets us to 10. So this group takes us from list number 4 to 10. So we can say that it's going to sit within this interval, the lower bound of height being 140. So 140 is less than h, which is less than or equal to 150. That is going to be our median interval, guys. That was a lot to wrap your head around. Feel free to watch again. What are we going to say? We're going to say that our mode was the group 140 to 150. Our mean was 146.3 reoccurring, and our median was 140 to 150. That group there, the 8th value in our table.
Even though they basically never come up in exams, guys, tally charts technically are in the spec. Let's have a look at how they work using this example here. The question says, complete the following tally chart. We're given the first row completed. We have the tally in the left-hand column and the frequency in the right-hand column. So first of all, what is a tally chart? A tally chart is a way of showing data. We can see that we have the frequency here on the right-hand column, and then we have the corresponding tally here in the left-hand column. We can see that we have 4 vertical lines with a line through it, and then we have 2 more vertical lines. What does this represent? Well, these 4 vertical lines represent the first 4 of that 7, and then the 5th of that 7 is this diagonal line here, which crosses through those 4 lines. We can see that there's a total of 5 lines here. We have 4 vertical, 1 diagonal, representing a frequency of 5, and then we have 2 more lines. Now, in general, whenever we tally, we always do 4 lines and then 1 diagonal line as the 5th line, and then we do stacks of those. The reason we do that is just so that we keep things nice and clear, so that we can count quickly. We know that there's 5 lines pretty quickly here, and then if, for example, we wanted to do 15, we could do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This would be pretty quick to read. We can just count up in our multiples of 5. We have 5, 10, 15. Let's say it was 18. We would add 3 more lines, 5, 10, 15, 18. Those diagonal lines allow us to count the 15 pretty quickly, and then we can add those 3 on at the end. So how would we fill in the rest of this table? For the tally over here, we have 4 vertical lines. That is just going to be a frequency of 4. How would we do the tally? Well, let's get rid of that spell correct. How would we do a frequency of 6? Well, that would be 1 set of 5. So we're going to do 1, 2, 3, 4, 5. And then we have 1 more added onto that to get to a total of 6. We have a tally which looks just like that. 4 vertical lines, 1 diagonal, and then 1 more vertical line representing a frequency of 6.
How to work with cumulative frequency tables in 109 seconds. Let's go. This, guys, is a topic which really divides opinion. Some people love it, some people hate it. Have a look and see if you can get it. The question says, calculate the cumulative frequency for the following data, which shows the time taken by 15 students to complete a test. We have our regular frequency table at the top and our cumulative frequency table at the bottom. What are we going to do? Well, if we have a look at our cumulative frequency table, we can see that in our left-hand column, our time intervals go from 0 to 10, from 0 to 20, from 0 to 30, and from 0 to 40. So in each case, we're going to have to add together all of the frequencies from the intervals which fall into those groups. Let me show you exactly what I mean. So the group from 0 to 10, what's it going to be? Well, that's just going to be all of the people in this group here, which goes from 0 to 10, and we have a frequency of 4. So our cumulative frequency is also going to be 4. Let's write that in now. What about our group from 0 to 20? This time, we're going to have all of the people in the 0 to 10 group, but we're also going to have the people in the 10 to 20 group because all of those are in the group from 0 to 20. So we're going to have to add together those 2 frequencies there. 4 plus 3, that's going to be 7. So that is going to be our next cumulative frequency. Next up, what are we going to have this time? We have the interval from 0 to 30. So we're going to have to add together all of the people who are in the groups from 0 to 10, 10 to 20, and 20 to 30. We have 4 plus 3 plus 2. That is going to be 9. And finally, finding the group from 0 to 40, walking in exactly the same way. We can add together all of those frequencies this time. 4 plus 3 plus 2 plus 6. That is going to be 15. And we're pretty sure that we're right. Why? Because our cumulative frequency goes up to 15, and that is exactly the same as the number of students. Now, another way of thinking about this, guys, is just adding on each time the previous value to get the new value. However, you don't have to do it that way. The way I explained it at the start is going to be the best way to understand exactly what's going on. How to sketch a cumulative frequency graph in 109 seconds. Let's go. When it comes to sketching a cumulative frequency graph, guys, we can really think of it as being a 3-step process. Step number 1, that is going to be to calculate our cumulative frequency. Step number 2 is going to be to plot all of our points at the end of our intervals. And step number 3, finally, is going to be to join all of those points with a smooth curve. Let's have a look at this example to see how it's done. It says, sketch a cumulative frequency graph for the following data, which shows the time taken taken by 15 students to complete a test. Step number 1, guys, let's calculate our cumulative frequency. We're going to have 4. Then we're going to have our 4 plus our 3, that's going to be 7. Then we're going to have our 7 plus our 2, that's going to be 9. Then we're going to have our 9 plus our 6, that is going to be 15, guys. If you're not sure on how to do that, watch our previous video. Next up, we're going to plot all of our points at our endpoints. So we're going to have between 0 and 10, so plotting at 10, a cumulative frequency of 4. So going along to our time, 10 is going to be a cumulative frequency of 4. Next up, between 10 and 20, so plotting this one at 20 minutes, we're going to have a cumulative frequency of 7. So we're going to go over to our 20 and up to 7. Let's plot that on. Next up, we're going to have a cumulative frequency of 9 for a value of time of 30. Let's plot that on. Time 30, value 9. Let's line this up. There we go. Time 30, value 9. Next up, from 30 to 40. So cumulative frequency of 40 here is going to be 15. So going over to our 40 and up to our 15, let's plot that on just there, making sure we do it in the right spot. Now, guys, joining these with a smooth curve as best as we can. Let's see how I do. Hey, that wasn't too bad, was it? That wasn't too bad. So there, guys, we have drawing a cumulative frequency graph. Step number 1, calculate that cumulative frequency. Step number 2, plot those values at the endpoint. Step number 3, join them with a smooth curve. That is how we're going to plot a cumulative frequency graph. How to find the median and interquartile range from a cumulative frequency graph in 129 seconds. Let's go. Questions like this, which involve finding the median and interquartile range from a cumulative frequency graph, come up all the time, guys. Let's have a look at this one and see how it's done. The question says, estimate the median and the interquartile range for the following, which shows the time taken by 15 students to complete the test. What are we going to do? Step number 1, guys, that's going to be to identify which of our 15 values actually represents our median. How are we going to do that? Well, what we're going to do is we're going to add 1 to our total frequency. Our total frequency of people, we know we have 15 students, so we're going to do 15 plus 1, which is going to give us 16, and then we're going to divide that by 2. 16 divided by 2, that's going to give us 8. So we know that our 8th value is going to be our median. So how are we going to find our 8th value? We're going to come over to our y-axis, which is our cumulative frequency, and we're going to read across over from our 8. We're going to draw a line over just like this. Make sure you use a ruler, guys, and then we're going to draw down from where that meets our line, and we can see that it meets the line at a time of 25, and that suggests, guys, that our median is going to be 25 minutes. Now, what about our interquartile range? That's going to be our upper quartile subtract our lower quartile. How are we going to find which values represent the upper and lower quartiles? Well, we're going to do our 16, which we found by doing our 15 times by 1 over 4, or divided by 4, you could say. That's going to give us our 4th value as our lower quartile. And we're going to times it by 3 over 4, or find 3/4 of that 16. That's going to give us 12th value, or our 12th value, I should say, as our upper quartile. So finding our 4th value, what's it going to be? Drawing across from our frequency of 4 and down, we're going to have a time of 10 minutes. Doing the same with 12 then, drawing over from our frequency. Let me go back to my orange pen there, drawing across from a frequency of 12 and down to our time. And we can see that it's associated with 35 minutes. So we can do our upper quartile of 35, subtract our lower quartile of 10, 35 take 10, guys. That's going to give us 25. So we now have our interquartile range of 25 minutes. How to draw a stem and leaf diagram in 86 seconds. Let's go. Guys, when it comes to drawing a stem and leaf diagram, the key is going to be to firstly look at our key. That's going to tell us the format that we want to put our numbers in. Here we're told that 3 line 2 means 32, and then we're going to apply that exact same format to each of our numbers, making sure that we write our smallest numbers at the top going down and also our smallest numbers at the left going right. Let me show you exactly what I mean. One final key principle, that's going to be that we only write our stem once over on the left hand side and then write our leaves from left to right. Let me show you exactly what I mean. So our smallest number, that's going to be 32, and that, just like in the example, is going to be 3 on the left as our stem, and then we have our line, then we have our 2. Let's cross it out so we know it's done. Our next smallest number, what's it going to be? It's going to be 34, so that's going to be 3 line 4, but we already have our 3, so we're just going to write in a 4 over here. That's going to represent our 34. We have our stem over here, which is the 30 part, and our leaf, which is the 4. Next up, what are we going to have? We're going to have 38. Let's cross that out, I should say. Now writing on our 8 as our leaf, we have 38. Now we're on to our 40s. We have 42 and 46. We're going to have a stem of our 4. First leaf is going to be a 2. That's going to represent the 42 up here. Now the next leaf is going to be a 6. That's going to represent the 46. Next up, we have our 51 and 54. We have a stem of 50 this time, so stem of 5, I should say. Next up, writing in our 1 for our 51, and then our 4 for our 54, guys. That is going to be exactly how we write stem and leaf diagrams. Feel free to watch again if it wasn't too clear. How to find the mean, mode, median, and range from a stem and leaf diagram in 140 seconds. Let's go. Here, guys, we've got quite a lot to get through. Let's have a look. The question says, calculate the mean, mode, median, and range for the following data. We're given this stem and leaf diagram. We're given this key. We're told that 2 line 4 represents 24, and then we're given our prompts for our mode, range, median, and mean. Let's get it done. First off, our mode, guys. The mode, that one's going to be the most occurring. Think of both of those words, mode and most, of beginning with MO. So what's going to be our mode? We can see that we have 2 4s over here. So we have 1 line 4 twice. What does 1 line 4 represent? That represents 14, because 2 line 4 represents 24. The 2 is in the tens column, the 4 is in the units column, so we have 1 4 as our mode, 14. Now, where do we go from there? We're going to do our range, guys. The range, what's that going to be? It's going to be our largest number minus our smallest number. In this case, we have 3 line 1 as our largest number, which is going to be 31. And we have 1 line 0 as our smallest number, which is going to be 10. So we can do 31 minus 10. 31 minus 10, that's going to be 21, giving us, guys, our range of 21. Next up, our median. What's it going to be? The median, guys, that one is going to be the one which, when we line them up from smallest to largest, is in the middle. So we can see conveniently that in our stem and leaf diagram, they're already lined up from smallest to largest. We have smallest, next smallest, next smallest, next smallest, etc. So the best way to do this is actually going to be to cross off one from the bottom, then one from the top, then one from the bottom, then one from the top, until we have just one number left. That's going to be our middle number. So what are we going to have? We're going to cross off our 10, then our 31, then our 14, then our 27, then our 14, then our 21. Then we're going to be left with our 6 in the middle. So it's going to be 1 line 6, which is going to be 16 as our median. Let's get that written in, guys. Finally, our mean. This one is definitely going to be the meanest. What are we going to do? We're going to add together all of our values and divide by the number of numbers that we have. So converting all of these into numbers and adding them together, what are we going to have? We're going to have 1 line 0, which is 10, plus 14, plus 14, plus 16, plus 21, plus 27, plus 31. That is going to be 133. So 133 is going to be the sum. Then we're going to do 133 divided by the number of numbers that we have. We can see that we have 1, 2, 3, 4, 5, 6, 7 numbers. So we're going to do 133 divided by 7, 133 divided by 7. That is going to be 19. So, guys, our mean, that is going to be 19, our final answer to our final part of this question. How to draw a bar chart in 168 seconds. Let's go. When it comes to drawing bar charts, guys, there's going to be quite a few principles to bear in mind. Let's have a look at all of them by doing this question. It says, draw a bar chart for the following. Then we're given a frequency table here, which has color in the left-hand column and frequency in the right. Principle number 1, that is going to be to always put our frequency on the y-axis and our other variable on the x-axis. Let's write those in then. On the y-axis, we have frequency. Let's draw that in, frequency, let's call it, and then on the x-axis we have color. Now, where are we going to go from there? The next thing we're going to have to bear in mind is that all of the jumps in our y direction, so all of our frequency jumps, have to be the same. We can see that our total frequency is 10, and we have how many boxes? We have 1, 2, 3, 4, 5 boxes to use, so we can go up in jumps of 2. That is going to fit nicely. So drawing in those jumps, then we have 0 at the bottom, then we have 2, then we have 4, then we have 6, then we have 8, and then we have 10. Next, we're going to draw in the spaces in which our color bars are going to go. So let's have our red one first. So we have R there. That's going to be the box dedicated to that. Then we're going to have our blue. Let's put B for that. Then we're going to have green. Let's do G for that. Then we're going to have orange. Let's do O for that. Now, bear in mind, guys, a couple of things here. We've made sure that our bars are not touching, first of all. Well, I've not drawn them yet, but you're going to see. And we've also made sure that they're not touching the axis over here. That's another key one. We've also made sure that they're all exactly the same width. Again, I've not shown you that yet, but we're going to do it. So drawing in firstly our red bar, that's going to have a frequency of 6. So we can draw a line over here for 6. Then we're going to connect that to the color axes just like so, and you can see that's our first bar. Next, we're going to have blue. That's going to have a frequency of 10. Drawing in that bar, then frequency of 10. Let's connect that to the bottom. Guys, make sure absolutely that you use a ruler for this. You're going to need to use a ruler to get all of the marks. Next, green, what's it going to be? It's going to have a frequency of 12. I did tell a lie. I said it went up to 10, but it actually goes up to 12. How can we amend this? So, well, we can just draw on another number there. Let's have a look. We're going to draw on our 12. We're going to go up to 12 there. So drawing that line over, let's have a look, bang, and then down to the G. Now, one thing I could do is I could remake this video for you guys, but what I actually want to teach you is a more important principle here, and that is going to be that even if you make a mistake throughout the question, you can always fix it by paying attention and keeping on your toes. There you go. So there's an additional thing thrown in there. Make sure you pay attention, and if you make a mistake, you can fix it on the fly. Now, next up we have orange. What's it going to be? That's going to have a frequency of 8, so we can draw a line across from there. We're going to have 8 over here. Now we can connect those to our line. And finally, guys, we can see that we've drawn our bar chart. All of our bars have the same distance between them. All of our bars have exactly the same width. We've got our frequency on there, our color. So our job is done, guys. That is going to be all of the principles for drawing a bar chart. How to identify common mistakes in bar charts in 62 seconds. Let's go. When it comes to drawing bar charts, guys, there are a bunch of different things that can go wrong. There are a bunch of different mistakes that can be made. However, these two are going to be the most common in exams. Let's have a look. The question says, identify 2 mistakes with the following bar chart. Pause the video now and see if you can get them. Mistake number 1. What's it going to be? It's going to be the fact that the gap between the orange and green bar is different to the gap between the orange and red bar. When we draw bar charts, guys, the gaps between all of the bars have to be the same. Here there is a different gap between orange and green and red and orange. Therefore, that is going to be mistake number 1. Mistake number 2, have you spotted it? It's going to be the fact that our frequency values don't go up in the same jump. So when we draw a bar chart, all of the jumps and the frequencies have to be the same. Here we go 0 to 2, which is a jump of 2. Then we go 2 to 4, which is a jump of 2. Then we go 4 to 8, which is actually a jump of 4. So there's a mistake. Some of the jumps are of a value of 2, and some of the jumps are of a value of 4. Therefore, guys, that is going to be another mistake. In this case, they don't jump by the same amount. So we have that as our second mistake. How to draw a line graph in 58 seconds. Let's go. Believe it or not, guys, this is a topic which really often trips people up. Let's have a look. The question says, draw a line graph to represent the following data. We're then given the different days of the week. We have Monday, Tuesday, Wednesday, Thursday, and Friday. And then we have the TV sales on those days, 3, 4, 2, 1, and 5, respectively. What are we going to do? Step number 1, that is going to be to plot all of our points. So Monday, we have 3 TV sales. So we're going to put a cross above the 3 on the Monday. Next up, we have 4 on our Tuesday, putting a cross there. Next up, 2 on Wednesday. Let's put another cross. 1 on Thursday down here, and 5 on Friday. Good there on Friday. Now, next step, guys, what's it going to be? It's going to be to connect all of our points together. Now, this is a part which trips people up pretty often. We don't actually connect our origin to our first point. So we don't draw a line there. So let's get rid of that. Instead, we just join our first point to our second, second to our third, third to our fourth, and fourth to our fifth, all using straight lines, guys. And that is going to be our answer for this line graph. How to identify common mistakes in line graphs in 65 seconds. Let's go. Just like when we're drawing bar charts, guys, there are going to be a bunch of different mistakes that can be made when drawing line graphs, just like this one. Pause the video now and see if you can spot the 2 mistakes made here. Let's have a look. The question says, identify 2 mistakes with the following line graph. We're given our table here and our line graph below. First of all, let's check each of our points and check they're plotted correctly. On Monday, we should have 3 TV cells. Let's have a look at Monday. Yep, we do have 3 TV cells. What about Tuesday? There should be 4. Yep, there are going to be 4 there as well. Tuesday, 4. What about Wednesday? Wednesday, we should have 2. Looking at Wednesday, oh, we can see actually that this point has been plotted incorrectly. It should be 2 cells, but it's actually 1. That is going to be our first mistake, guys. Wednesday is plotted incorrectly. Now, have you spotted the second mistake? The second mistake is actually going to be the fact that this original point here, the origin, is connected to the first coordinate. That shouldn't be the case. When we join line graphs, guys, we don't connect the initial point to the first coordinate. We just leave that empty. In fact, the line graph should look like this. So that is going to be our second mistake. There should be no connecting line between that original point, the origin, and that first coordinate. How to draw a pictograph in 147 seconds. Let's go. Questions like this involving pictographs, guys, are super common in our foundation papers. Let's have a look at this one. The question says, draw a pictograph to show the following set of data. We're given a table of data up at the top. We're given a key which tells us that 1 circle represents 2 students and a half a circle represents 1 student. And then we're given a table down here to draw our circles in, making sure that we represent the data at the top. What are we going to do? The best way to approach these pictographs questions, guys, is going to be to start drawing our pictures in the table and then to count as we go along, stopping when we get to the desired number of things. Let me show you what I mean. So first off, drawing our red, we know that we need 8 students to be represented in our red row. So we're going to start off by drawing one circle. That circle is going to represent 2 students. So we're going to draw another circle carrying on because we've not gotten to 8 yet. So we draw another circle that's going to take us from 2 to 4. Drawing another circle, we're going to go from 4 to 6, and then we need one more circle that is going to take us from 6 to 8, and now we can stop because we've represented our 8 students. Now what about our blue? Well, we need to represent 5. Let's draw a full circle, that's going to be 2. Now we can draw another full circle, that's going to take us to 4. Now we can recognize that if we draw another full circle, that's going to add 2 more and take us to 6, which is actually going to be bigger than we need to go. Instead, we're going to need to draw another not another half circle, but we're going to need to draw a half circle. That's going to add 1 student and take us up to our desired total of 5. We're going to go from 4 to 5. So drawing in a semicircle here. Let's do that now. That's not the best semicircle in the world, but luckily you can hear me, so it's clear what I mean now. What about this final one, which is drawing 11 in our green row? What are we going to have? Let's start off by drawing one circle. That's going to represent 2. We can carry on. Drawing another circle, we're going to have 4. Drawing another circle, we're going to have 6. Drawing another circle, we're going to have 8. Drawing another circle, we're going to have 10. Now we can stop and take a step back. If we draw another full circle, that's going to take us to 12, which is too far. So instead, we're just going to draw a half circle. That is going to add on 1 to take us to 13, not 13, sorry. That's going to take us to 11 in total, I should say. So we've now drawn in that semicircle again. It's not the best semicircle on here, but you can hear me, so you know what I mean. Guys, that's going to be the best way. Draw those circles in, draw those shapes in, whatever the shape is, and count up. And then when you get close to your desired quantity, slow down a bit, take a step back, and see whether you're going to need to draw a full shape in, or a half shape, or a quarter shape, or whatever it might be to get the desired quantity. How to interpret pictographs in 46 seconds, let's go. Questions like this, guys, which involve interpreting pictographs, are going to be super common in our foundation papers. Let's have a look at this one. The question says, given the following pictograph, how many students chose blue? We're given a key. We're told that a full circle represents 2 students, and a semicircle, a half circle, represents 1 student, and then we're given 3 colors, red, blue, and green, and our number of students in the right-hand column. So how many students chose blue? In this case, we're going to have 4 full circles. So we're going to do 4 times by 2 because a full circle represents 2 students, and then we're going to add to that one semicircle that represents 1 student, so we're going to plus 1. 4 times by 2, that's going to be 8, guys, plus our 1, that's going to be 9. So we can say that 9 students chose blue. That's going to be our answer to this one. How to draw pie charts in 173 seconds, let's go. This, guys, is another topic which comes up all the time, and it is quite tricky. Let's have a look. The question says that 20 people were asked their favorite color, and then it says draw a pie chart to represent the data. Now we're given a formula here which tells us that the angle for each of our categories is going to be the individual category frequency divided by the total frequency times by 360. Now, where does this actually come from? The category frequency divided by the total frequency, that's going to tell us what share of the pie chart goes to each of our categories, and then we times that by 360 to represent the fact that all of the angles for all of the categories are going to add up to 360, representing all of the angles around a point. Let's get it done. So working out firstly the angle for the color red, we have a frequency of 3 and we have a total of 20. So we're going to do our category frequency of 3 divided by 20 times by 360. Now we can work that out with a calculator, or in our heads, what's it going to be? It's going to be 54 degrees. So we know that we're going to have 54 associated with our red. Now, I'm not going to be drawing this perfectly to scale. It's just going to be approximate because I can't use a protractor here. What are we going to do? Let's draw on one initial line here going from the middle to the right. And then we know that a 90-degree angle would be a quarter. We know that 45 degrees would be half of that 90 degrees, but we have 54. It's going to be a little bit more than that. Let's put it there. Let's draw on 54 degrees, and that is going to be for our red. Let's mark that with an R. Now, what about our blue? For our blue, we're going to do our 7, our category frequency, divided by 20 times by 360. That is going to be 126 degrees. So we can draw that on 126 degrees. That is going to be let's call it over here. Why did I choose over here? 90 degrees again would have been that quarter turn, and then we can say that this is our 26 degrees. So let's write that on 126 degrees. Again, guys, in your exam, make sure you use a protractor. This one is not done to scale. So we have 126 degrees for our blue. Let's draw that on right in our B. Now, what about our green and our yellow? These are both a frequency of 5, so they're going to be the same. How we're going to work out the angle associated them, we're going to do with them, we're going to do 5 divided by our total, which is 20, times by 360, and we can see that that is going to be 90 degrees. So we're going to have two 90 degrees angles here, and it looks like we've actually done it very accurately. So what are we going to have? We're going to have 90 degrees, and let's draw in those degree signs for those, 90 degrees and 90 degrees. So we're going to split this in half. Oh, let's go with a straight line, please, not a curved line. Let's draw that down. We can mark those with these right angle signs because they're 90 degrees. We can draw one in. We write a G for green, and we'll write a Y for yellow. And let's write in 90 degrees, even though those right angle signs do show that they're 90 degrees. And there, guys, we have our sketch of our pie chart. Remember, we use that formula. Category frequency divided by total frequency times by 360 to get our angles, and then we draw them with a protractor. How to interpret pie charts in 74 seconds. Let's go. Here, guys, we have a couple of questions about the pie chart down here. Let's have a look. The question says that Bill spent £140 at the supermarket, and then it says that his shares of spending are shown by the following pie chart. Question number 1 asks us what he spent the most money on. What do we think, guys? We're going to say that he spent the most money on food. Now, how do we know that? We know that because that is going to be the section of the pie chart which is the largest. It takes up the largest share of his spending. Therefore, he must have spent the most money on food. Now, we can't tell the exact amount he spent on food because we don't have the angle. However, we can tell it's the largest share because it's clearly the largest portion. Now, what about question 2, which asks us exactly how much he spent on fuel? Now, we can see over here that we have a right angle for our fuel, which means that 90 degrees of that pie chart are dedicated to fuel. How do we work out the amount he spent on fuel then? Well, 90 out of our 360 degrees, which is going to be a quarter of our pie chart, represents fuel. We can multiply that by the total amount that was spent, 140. 90 over 360 is 1 over 4. 1 over 4 times 140. We can halve it again. That, guys, is going to give us £35. Slow that down if you want and try and break down what I said. We're going to have £35 then as the amount that we spent on fuel. How to draw a box plot in 78 seconds. Let's go. Whenever it comes to drawing a box plot, guys, the best method is going to be to firstly draw on our vertical lines at each of our values for our minimum, lower quartile, median, upper quartile, and our maximum value, and then to join them to get our kind of box plot shape. Let me show you what I mean with this question here. The question asks us to draw a box plot which represents the following information. So we're going to draw our vertical lines on firstly for our minimum value. That's going to be at a value of 5, halfway between our 0 and our 10. Next up, our lower quartile of 15 is going to be halfway between 10 and 20. We then have our median at 30. We can draw on a vertical line there, and our upper quartile at 35, drawing on a line halfway between our 30 and our 40. Finally, we have our maximum value of 50. Now, to join them together, what are we going to do? We're going to draw a line at the top of our 3 middle lines, just like so, and we're going to do the same at the bottom of our 3 middle lines, just like so, and then we're going to join our lower value to our lower quartile and our upper value to our upper quartile by using a straight line, which looks like this, and we get that classic box plot shape, guys. This is exactly how we want it to look. So we have our lower quartile, we have our minimum value, I should have said. We have our lower quartile, we have our median, we have our upper quartile, and we have our maximum value joined with lines just like this. How to compare distributions using box plots in 111 seconds. Let's go. Whenever it comes to comparing distributions using box plots, guys, the key is going to be to make one comment on which data is higher on average, and that's going to be by comparing our medians, and to make one comment on which data is more consistent by comparing either our ranges or our interquartile ranges. Let me show you what I mean. This question says that the following box plot gives data about the test scores of students in 2 classes. We have class A and class B, and then it asks us to compare the 2 distributions. What are we going to say? Well, first of all, we're going to say that the score in class A is higher on average. The score in class A is higher on average. And how do we know that? We know that because the median in class A is going to be 35, halfway between our 30 and our 40, and the median in class B is going to be 25, halfway between our 20 and our 30. So first of all, we're going to say that the score in class A is higher on average. Now, what about comparing the consistency of the data using our range or interquartile range? We could use either. I'm going to use interquartile range here, but you could have done range. So what can we say? We can say that the interquartile range in the case of group A is going to be the upper quartile of 40, subtract the lower quartile of 10. 40 minus 10, 40 minus 10, that is going to be 30. So we have an interquartile range of 30. What about in class group B? Well, the upper quartile this time, that line there is going to be 30. The lower quartile is going to be 20. So we can do 30 minus 20, which is going to be 10. We can see clearly that the interquartile range is far higher for class group A, and that tells us that the data in distribution B or class group B is going to be more consistent, more closely paired together. So we can say finally that the average score is higher in group A, however the score is more consistent in group B. The pros and the cons of the range and the interquartile range in 117 seconds. Let's go. Here guys, we have a really quick reminder of the biggest pros and cons of the range and the interquartile range. Let's have a look. First of all, talking about our range, the biggest benefit of our range, guys, is going to be the fact that it takes all of our data into consideration, all the way from the smallest piece of data that we have to the largest. However, the biggest disadvantage is going to be the fact that it can be affected by extreme values, including those outliers, which are mismeasured pieces of data. If, for example, one of our pieces of data is measured inaccurately, that's going to throw off our range completely and give us a massively inaccurate perception of what's going on in that data. What about the interquartile range, guys? This is going to be our upper quartile minus our lower quartile, and the biggest disadvantage associated with that is going to be the fact that it doesn't take all of our data into account. We miss off those values at the bottom end and at the top end of our data. So the biggest drawback of the interquartile range is going to be the fact that it leaves some data out. Now, what about the biggest advantage? It's going to be the fact that it's not affected by those extreme values at the top or at the bottom. If we mismeasure a piece of data and either it's way too big or way too small, that's not going to affect our interquartile range, because those really high values in the distribution and the really low values aren't going to affect the upper quartile and the lower quartile. Therefore, they're not going to be affected by those extreme values. How to sketch histograms in 140 seconds. Let's go. This, guys, is definitely one of the most challenging topics in the course. Pay close attention and see if you can get this one. The question says, draw a histogram to represent the following data. We're given a table over here with one empty column, and then we're given a graph down here to plot our histogram on. Now, when it comes to drawing a histogram, we're going to do our frequency density on the y-axis and our other variable on the x-axis. Now, when it comes to calculating our frequency density, what are we going to do? We're going to use the formula that the frequency density for a given group is going to be our frequency for that group divided by the class width of that group. Now, that's not too clear at the moment, so let's have a look at this one. What are we going to do? Firstly, we're going to write in our column heading, frequency density. I'm going to write FD for that, and then we're going to do each of our frequencies divided by our class widths. Now, for our first group, what's it going to be? Our frequency is 4. Our class width, that's going to be 10 minus 0, which is going to be 10. So we're going to have 4 divided by 10, which is going to be 0.4. What about in this next one then? We're going to have a frequency of 10 divided by a class width of 15 minus 10, which is 5. So we're going to have 6 divided by 5. That's going to give us a frequency density of 1.2. Now, what about in this next case? Our frequency of 10 divided by our class width is going to be 20 minus 15, which is 5. So 10 divided by 5, that's going to give us a frequency density of 2. And finally, doing this for our frequency of 12, in the age group 20 to 30, we're going to do 12 divided by the class width of 10, which is 30 minus 20. 12 divided by 10 is going to be 1.2. Now, guys, we can plot our different ages against the frequency densities for those ages. The first group, that's going to be from 0 to 10, and that's going to have a frequency density of 4. So from 0 to 10, that's going to have a frequency density of 0.4. Sorry, I think I said 4 before. I meant 0.4. So from 0 to 10, that's going to be 0.4. What about from 10 to 15? That's going to have a frequency density of 1.2. So we can draw that bar on then. Drawing a bar just there from 10 to 15, a height of 1.2. Now moving on, the next group is from 15 to 20, and that one's got a frequency density of 2. So from 15 to 20, we're going to do a frequency density of 2. I'm speaking quickly, guys. Hopefully you can follow me. Drawing that group on there then. Let's draw that bar in nicely. Next up, what do we have? We have the group from, we've done 15 to 20, now 20 to 30. That's got a frequency density of 1.2. So from 20 to 30, 1.2, where's that going to be? It's going to be just up here. 20 to 30, going over to there, and 1.2. Guys, we can see now we have our histogram drawn. We have our frequency density on the y-axis against our age on the x-axis. How to interpret histograms in 81 seconds. Let's go. Guys, when it comes to interpreting histograms, the most important thing to recognize is going to be that to calculate the frequencies, we can work out the areas of our bars. Let me show you what I mean with this example here. The question says that the following histogram shows information about the heights of plants in a garden. It then asks us to estimate how many plants have a height between 10 centimeters and 25 centimeters. What are we going to do, guys? We're going to work out the areas of the bars between 10 and 25 centimeters. Let's get it done. We can see that our 10 centimeters is down here and 25 centimeters is over here. Now, we don't currently have a vertical line up giving us a bar from 25, so we're going to draw that line in there just like this. Now, guys, we have a couple of bars which we can calculate the area of. We have this bar here and we have this bar here. What are we going to do in the first case? We can see that we have a width of 5. That's going to be 15 take 10 and a height of 0.8. So calculating the frequency there, we can do 0.8 times by 5, that's going to give us 4. Now, what about calculating the area of this next bar? We have a width of 10, that's going to be 25 minus 15, and we can calculate that multiplied by 0.4, which is our height. So we're going to do 10 times by 0.4, 10 times by 0.4, again, that's going to give us 4. Then we can add both of those together, guys, and we can see that we're going to have 8 as our answer. That's going to be the number of plants which have a height between 10 centimeters and 25 centimeters. How to find the median from a histogram in 202 seconds. Let's go. I've got to be honest, guys, this is a really tricky topic. However, it doesn't mean you're not going to be able to do it. Pay close attention and see if you can get it. The question says that the following histogram shows information about the heights of the plants in a garden. We're then asked to estimate the median. Guys, what are we going to do? When it comes to finding the median from a histogram, we're going to have to find our total frequency. That's going to allow us to work out which value represents our median. Then we're going to find an estimate for the height associated with that value. Let me show you what I mean. So first of all, calculating our total frequency, we're going to find the areas of all of our bars and add them together. What are we going to have in this first case? We had a width of 10 and a height of 0.9. That's going to give us 9. We're going to have a width of 5 for the next one and a height of 1.2. 5 by 1.2, that's going to be 6. In the next case, we have a width of 5 and a height of 0.6. 5 by 0.6, that's going to be 3. Next up, again, we have a width of 10 this time, and we have a height of 0.3. 10 by 0.3, that is going to give us 3. Now, finding our total frequency, we're going to add together all of those frequencies. 9 plus 6 plus 3 plus 3, that, guys, is going to be 21. So the total frequency, let me write total frequency, is equal to 21. Now, if we can remember, to find the median value, to find which value represents the median, what we can do is we can add 1 to our total frequency and then divide that by 2. That's going to tell us which value, which of our 21 frequencies essentially represents our median. Let's get it done then. So we're going to do 21 plus 1, that's going to be 22. Then we're going to do 22 divided by 2, and that's going to give us 11. So now we know that our 11th value is going to be our median. Let me write 11th value equals our median. Now, how are we going to find an estimate for our 11th value? Well, we know that we have a frequency of 9 represented by our first bar. So that's going to take us up to 9 out of our 11. How many more do we need? We need 2. We need to get from 9 to 11, I should say, we need to add 2. Now, looking at this next bar, we can see that this total next bar represents a frequency of 6. We don't need 6 though, we need 2. 2 is going to be 1/3 of 6, so we need to go 1/3 into this bar. We need to go 1/3 into this bar. That's going to take us up to a frequency of 11. Like I say, because the first bar represents 9, we're going to need to add 2 out of this 6 to that 9 to get to 11. What is 2 as a fraction of 6? It's 1/3 of 6, so we need to go 1/3 of the way into this bar. So going 1/3 of the way into this bar, what height is that going to take us to? So we essentially start at 10, we end at 15 in that bar. We need to go 1/3 of the way into that bar, so we can do 1/3. Let's write it down here. 1/3 times by 5. That is going to represent how far into that bar we go. We're going to add that to the value of 10, which is our starting value, to work out the height, which is going to be 1/3 of the way into that bar. We have the initial 10. And then we're going to add 1/3 of this bar. The width of the bar is 5, so we add 1/3 of 5 to 10 to find our new value. 10 plus 1/3 times by 5. 1/3 times 5, that's going to be 1.6 reoccurring. 10 plus 1.6 reoccurring, that is going to give us 11.6 reoccurring, guys. And that's going to be our answer for our median, 11.6 reoccurring. Now, there was a lot of words in there. Some of it was a bit of a mouthful. Guys, watch the video back, break it down, and see if you can understand it. This is a tricky topic, definitely grade 9. It's going to be really good if you can get it. How to draw a frequency polygon in 69 seconds. Let's go. When it comes to drawing a frequency polygon, guys, we can really think of it as being a three-step process. Step number one is going to be to find the midpoints of each of our intervals. Step number two is going to be to plot each of our coordinates, which is going to be our frequency against those midpoints. And step number three is going to be to connect our points with a straight line. Let's get it done for this question here. Step number one, let's find the midpoints of each of our classes. Halfway between 0 and 20, that is going to be 10. Halfway between 20 and 40 is going to be 30. Halfway between 40 and 60 is going to be 50. And halfway between 60 and 80, that, guys, is going to be 70. Now, plotting our frequency against each of our midpoints. At a time of 10, we have a frequency of 40. At a time of 30, we have a frequency of 30. At a time of 50, we have a frequency of 45. Let's get that drawn on just there. And finally, at a time of 70, we have a frequency of 30. Let's get that drawn on just there. Final step, guys, is going to be to connect each of our points with a straight line. I don't want to rub that out, do I? I want to connect it with a straight line. Let's get that done. Connecting number 1 to 2, 2 to 3, and 3 to 4, guys. Now we have a perfect frequency polygon showing our data. Identifying mistakes with frequency polygons in 58 seconds. Let's go. There are loads of mistakes that can be made, guys, when it comes to drawing a frequency polygon, but these two are going to be the most common in exams. Let's have a look. The question says, identify 2 mistakes with the following frequency polygon. What are they going to be, guys? Our first mistake is going to be that we've incorrectly, or they, I should say, have incorrectly connected the origin 0, 0 to our first point. When it comes to drawing a frequency polygon, we don't need to connect our origin to the first point. We just have an empty space there. So instead, it should look like this. So that is going to be our first mistake. Second mistake, guys, when it comes to drawing a frequency polygon, we should be plotting each of our frequencies against the midpoints of our classes. So this 40 frequency should be plotted against 10, which is halfway between 0 and 20. But instead, we can see that they've plotted all of the frequencies at the endpoints of the intervals. Now, if we were drawing a cumulative frequency graph, that would be correct. However, not for a frequency polygon, guys. For a frequency polygon, we have to plot our frequencies against our midpoints.
This, guys, is another one which doesn't come up too often in exams. However, technically it can have to do it for completeness. Let's have a look. Construct a relative frequency graph for the following. We're given the colors, red, blue, green, frequencies of those colors, 3, 6, and 1, and then we're given the relative frequencies 0.3, 0.6, and 0.1. The relative frequencies, guys, to work those out, we would just do the frequency divided by the total frequency. So in the case of red, the reason that it is 0.3 is because the total frequency is 3 plus 6 plus 1, which is 10, and then 3 divided by 10 is 0.3. That's why the relative frequency is 0.3, because 3 divided by 10 is 0.3. So that's how we work them out. That was also covered in another video, which is why I did it pretty quickly. How, though, do we draw the graph? We just draw this like a simple bar chart, guys. So red has been done for us. We can see that that is a relative frequency of 0.3. What about the next one, guys? We're going to do blue next, so I'm going to write a B down here, and then we're going to need to draw a bar which goes up to 0.6. So let's draw a cross there, little cross there. Now let me draw these lines. Hopefully we can get them pretty straight. There we go. There's 1. Let's draw the second. There's 2, and let's draw the third. There is 3. What about the next one, guys? Green frequency, sorry, a relative frequency of 0.1. 0.1 is going to be here, halfway between the 0 and the 2, so we're going to need to draw one which is just 1 unit up this time. Let's draw the bar. It's going to look like that, and then we're going to draw a G down at the bottom to represent the fact that that is green. What did we do, guys? We simply drew a bar chart, but on the y-axis, instead of having frequency, we had relative frequency.
The fundamentals of scatter graphs in 59 seconds. Let's go. Scatter graphs, guys, are one of the most important graphs in the whole of statistics. What do they show us, though? They show us how one variable changes as another variable changes. They can show us, for example, that 2 variables like temperature and ice cream sales are positively correlated. For example, when the temperature is higher, ice cream sales will tend to be higher because people like to have them to cool down and all of that good stuff. They can also show us that 2 variables are negatively correlated. As one variable goes up, for example, as it gets hotter, another variable can go down. For example, hot chocolate sales, because nobody wants to drink hot chocolate when it's 45 degrees outside. Now, finally, they can also show us that there is no correlation between 2 variables. For example, there's nothing that would suggest, I should say, that car sales would be higher or lower when temperature is higher or lower. So car sales and temperature would have no correlation probably, because you wouldn't expect people to be buying more cars when it's hotter or colder. It shouldn't really affect it, so there should be no correlation. How to use a line of best fit to predict values on a scatter graph in 69 seconds. Let's go. A line of best fit, guys, is going to be a line on our graph which goes roughly through the middle of all of our data, and we can use them to predict the value of one variable for a given value of the other variable. Let me show you what I mean. This question says, draw a line of best fit and use it to estimate the height of somebody who weighs 53 kilograms. First of all, let's draw that line of best fit and see what we get. So drawing a line which goes roughly through the middle of all of our data, let's have a look and see how accurate we can get. Yeah, that looks all right. That looks all right. Make sure you use a ruler, guys, when you do that. And we want to use this to estimate the height of someone who weighs 53 kilograms. So we know that the weight is 53 kilograms. So we can draw a vertical line upwards from our weight of 53 kilograms. That looks pretty good. And then we can draw a horizontal line away from where it crosses our line of best fit to our y-axis. And we can see there that it's going to be associated with a height of, what's that going to be, roughly 137? Yeah, that looks about right, 137 centimeters. So guys, we can draw a line of best fit going roughly through the middle of all of our data. And that is how we're going to use it to estimate one value of one of our variables for a given value of the other variable. The dangers associated with extrapolation in 86 seconds. Let's go. This, guys, is a topic which comes up pretty often. Have a look and see if you can get it. The question says, use the line of best fit to predict the height of a person who weighs 70 kilograms. Why is this prediction risky, guys? What do we reckon? What are we going to do? First of all, we're going to work out the height of a person who weighs 70 kilograms. We're going to go over to our weight axis. We're going to go to our 70 kilograms, draw a line up to our line of best fit, draw a line across to our associated height, and then we're going to see that the height of a person who weighs 70 kilograms is predicted to be, what's that going to be, roughly 167 centimeters. So that's going to be our prediction for our height. But why is this risky? This, guys, is risky because we are extrapolating. We are doing extrapolation, Now, what does that mean? It means that we're working in an area of our graph which is away from all of our data. We can see that all of our data is over here, and we're making a prediction about a weight which is very far away from all of our other data. We can see that it's quite a long way past our greatest weight. What that's going to lead to is a likely situation in which our prediction is inaccurate. Why? Because we don't have any data around that value, so we have no reason to think that that pattern is going to persist as we get up to those higher weights. So the reason that it's risky, guys, is going to be because we are extrapolating. We're making a prediction which is very far away from all of our data. How to work with the 4 quadrants on graphs in 94 seconds. Let's go. When it comes to working with graphs, guys, it's going to be super important to recognize that we have 4 distinct quadrants. We have the positive quadrant in the top right, the negative positive quadrant in the top left, the negative negative quadrant in the bottom left, and the positive negative quadrant in the bottom right. Now, how can we use that information to plot these 4 points? What do we reckon? First of all, plotting on the coordinate 4, 3, we have a positive value of x and a positive value of y. So this is going to go in the positive quadrant. We're going to go along the corridor to 4 and up the stairs to 3. We have the point 4, 3. Now, what about our next coordinate here, which is going to be 3, negative 2. 3, negative 2. This time we have a positive value of x and a negative value of y. So we're going to be in the positive negative quadrant. We're going to go along the corridor to 3 and down the stairs to -2. That is going to lead us to this point here. We have the point 3, -2. Next up, what are we going to have? We're going to have the point -1, 5. Where's it going to go? This time we have a negative value of x and a positive value of y. So we're going to go to the negative x, we're going to go in the negative x direction and in the positive y direction over to -1, 5. That is going to be up here, -1, 5. And finally, what are we going to have? We're going to have -4, -1. This time we're in the negative quadrant. A negative value of x and a negative value of y along the corridor to -4, down the stairs to -1, and we have the point down here, -4, -1. Let me write that 1 in there. We have -1, -4, -1, I should say, as our point, guys, and that is going to be how we work with coordinates in the 4 quadrants.
This key skill, guys, is a pretty tricky one. It definitely requires a good understanding of what our equations of straight lines actually represent. Let's have a look at how to do it. The question asks, is the point 1738 on the line with equation y equals 2x plus 4? Let's have a think about it, guys. Is this point 1738 on the line with equation y equals 2x plus 4? What does the equation of a straight line actually represent? It represents the relationship between the values of x and the values of y at every point on that line. This equation tells us that for this line here, y equals 2x plus 4, to get from a given value of x to a given value of y, we have to multiply that x by 2, that's the 2x part, and then we have to add 4. So, if this point is in fact on this line, then when we multiply the value of x by 2 and then add 4, we should get the value of y. The x-coordinate is the first one, guys, 17. The y-coordinate is the second. Let's substitute x equals 17 into the equation of our line and see what value of y we get. So we're going to do 2 times by x, so 2 times by 17, and then plus our 4. 2 times by 17, guys, that is going to be 34, and then we can add 4 to that. 34 plus 4 is going to be 38. So we can in fact say that this point is on the line because the value of x when multiplied by 2 and then having 4 added to it does in fact give the value of y in this coordinate.
How to calculate the distance between 2 points in 118 seconds, let's go. These guys are a really sneaky type of question. Why? Because they are actually hidden Pythagoras' theorem questions. Let me show you what I mean. The question says, calculate the distance between the points -2, and 1, 2. Step number 1, guys, to help us understand this, I'm going to draw these on a graph. Let's have a look. The point -2, that's going to be down here, and the point 1, 2, that's going to be up here. Now, how are we going to work out the distance between these 2 points? Let's firstly join them with a line, because that's going to be the distance we're looking for. How can we work this out? We're actually going to draw a right angle triangle which looks like this. We're going to draw a line which represents the x distance between the 2 points and another line which represents the distance in y between the 2 points. Can you see where this is going? We've actually drawn a right angle triangle there. Now we can work out the bottom length of this triangle and we can work out the vertical height of this triangle. Then we can use Pythagoras' theorem to work out what is essentially the hypotenuse of our right angle triangle. Let's get it done. So in the x direction we go from -2 to +1. That's going to give us a width of 3 along the bottom. In the y direction we go from -2 up to +2. That's essentially going to give us a height of 4. Now guys, we can use Pythagoras' theorem. Pythagoras' theorem, that tells us that a squared plus b squared is equal to c squared, where a and b are our 2 non-hypotenuse sides and c is our hypotenuse. So we're going to substitute in the values of 3 and 4. That's going to give us 3 squared plus 4 squared, that's going to be equal to c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so we can say, let's work out over here that 25 is equal to our hypotenuse squared. Now guys, to find the value of c, our hypotenuse, we can square root both sides. We're going to get that c is equal to the square root of 25, which is going to be 5. So guys, we found our distance, it's going to be 5. Don't tell me that wasn't a sneaky question. Let me know in the comments if you got it. A table of values in 97 seconds, let's go. When it comes to sketching straight lines, guys, there are going to be a few different methods that we can use. I would say this is one that comes up the most in exams. Let's have a look. This question asks us to sketch y equals 2x plus 1, and we've been given this table of values. What are we going to do? What we're going to do is we're going to substitute these different values of x into our equation to find the values of y, which correspond with each of those values of x. That's going to give us a set of coordinates so we can plot on our graph, and then we can connect those points to give us our line. Let's get it done. First of all, substituting x equals -3 into our equation. What are we going to have? Well, we're going to have that y is equal to 2 times by -3, which is going to be -6 plus 1. That's going to give us -5. Now we can do the same with x equals -2. We're going to substitute this time at x equals -2 into our equation. We're going to have y equals 2 times by -2, which is -4, plus 1. That's going to give us -3. Now we can do the same with each of our other values of x. Give it a go, guys. Check that you get the same as me. That's going to yield results of -1, 1, 3, 5, and 7. Check those, guys. Make sure that you get how I got them. Now we're going to plot each of our points. We can see from our table that when x is equal to -3, y equals -5. Along the corridor to -3 down to -5, we're going to have a point there. Next up, when x equals -2, y equals -3. So we can plot this point on here. When x equals -1, y equals -1, we have this point here. And we can carry on the trend, guys, plotting our points like so. Now, guys, the final step is going to be to connect all of those points with a straight line. And we can see that this is the line that we're going to get, and we're going to be sure to carry on through our coordinates, representing the fact that the line doesn't just go up to the coordinates of x and y that we've plotted, it actually goes on forever. How to plot a straight line using y equals mx plus c in 95 seconds, let's go. Whenever it comes to sketching a straight line, guys, the quickest way of doing it is definitely going to be using our understanding of y equals mx plus c. Now, what actually is y equals mx plus c? Y equals mx plus c, which we have up here in the top right-hand side, is going to be the general equation of a straight line. In that equation, m, the number next to the x, is going to be the value of the gradient, which is going to be the steepness of the line, and c, the number on the end, is going to be the value of the y-intercept, which tells us where our line crosses the y-axis. Now, how can we use our understanding of this to quickly sketch a line? What are we going to do? Well, step number one, we're going to plot on our y-intercept. We can see for this line here that we have a y-intercept of -3 because our number on the end, our c, is -3. That's going to tell us that our line crosses the y-axis at -3, so we can plot on one coordinate. Then, how can we use the gradient to finish that off? Well, if we have a gradient of 3, which we do in this example, our value of m, the number next to the x, is 3, that tells us that when we go 1 unit to the right, we're going to go 3 units up. Why? Because the line has a steepness of 3. When we go 1 unit to the right, we're going to go 3 units up. Now, we can use that to plot on our second point. Well, we can go 1 unit to the right, 3 units up, and this is going to take us to the point 1, 0. So we can plot that on the point 1, 0. Now we have 2 lines, guys, and we can connect those with a straight line, and that is going to give us our straight line just like so. And we can see that we've done this by plotting just 2 points. Literally, we've put on that y-intercept, we've used our gradient to get a second point, and then we've connected them, guys, the quickest way to plot a straight line. Rearranging to the form y equals mx plus c in 96 seconds, let's go. Sometimes, guys, we might get given a question like this, which gives us the equation of a straight line, but it isn't in the form y equals mx plus c. What are we going to do? Well, firstly, we're going to rearrange our equation to get it in the form y equals mx plus c. Then we can find our gradient and our y-intercept and sketch it that way. Let's have a look at this one. It says sketch 2x plus y minus 2 equals 0. Step number 1, let's rearrange this to the form y equals mx plus c. We need to add 2 to both sides, add 2, and we need to minus 2x from both sides, minus 2x, minus 2x. That's because at the moment the y is having to minus from it, and it has a plus 2x on the same side. So we're going to move those to the other side. What's that going to give us? That's going to give us, switching to an orange pen, y equals minus 2x plus 2. Now we can use our knowledge of y equals mx plus c. M is going to be the gradient. It's going to be the number next to the x minus 2. And c is going to be the number on the end. It's going to give us a y-intercept. It's going to be 2. So we can say that our gradient is minus 2 and our y-intercept is 2. Now, how are we going to plot this? We're going to put on our y-intercept. It crosses the y-axis at 2. Then we know, because we have a gradient of -2, when we go 1 to the right, we're going to go 2 down. And we can use that to find another point and another point. Finally, guys, we can connect those points to give us our line. What's it going to give us? It's going to give us this line here. Don't know why that took so long to draw. And now you can see, guys, that is exactly how we would plot a straight line, or draw a straight line, I should say, when it's not given to us in the form y equals mx plus c. Firstly, we rearrange it. Then we use our knowledge of the gradient and the y-intercept. How to find the gradient of a line in 52 seconds, let's go. When it comes to finding the gradient of a line, guys, there are going to be a couple of different methods we can use, but when we've been given 2 coordinates, the best method is definitely going to be to use the fact that the gradient of a line is equal to our change in y divided by our change in x. Let's have a look at how we can apply that to this question here. The question says, calculate the gradient of this straight line which goes through -3, 6 and 7, 11. What are we going to do? We're going to find our change in y. We go from a y coordinate of 6 to a y coordinate of 11, so that change is going to be plus 5. And we're going to divide that by our change in x. In the x direction, we go from -3 to +7. How do we get from -3 to +7? We add 10. So the change in x is going to be 10. So we now have, funnily enough, our gradient is going to be 5 over 10. But we can simplify that. Let's divide top and bottom both by 5. That's going to give us, guys, 1 over 2 as the gradient of our line.
Identifying the x and the y intercepts of straight lines, guys, comes up pretty often in exams. Loads of people know how to find the y-intercept, but not many people know how to find the x-intercept. Let's have a look at how to do it. The question then asks us to find the x and y-intercepts of the line with equation y equals 4x plus 28. Now, let's start with the y-intercept because that's the one that most people know. To find the y-intercept, we're simply going to take this number on the end. It's going to be the number on the end. So the y-intercept here is going to be y equals 28. Now, why actually is that? If we think about our axes, the value of the y-intercept is going to be the value of y when x is equal to 0, when we're 0 across. So what we essentially do is we substitute in x equals 0. We effectively have y equals 4 times by 0 plus 28. The 4 times by the 0 goes down to 0, so we're just left with y equals 28. Now, why am I telling you this? I'm telling you this because we're going to use the exact same logic to find the x-intercepts. So, if the y-intercept is the value of y when x is equal to 0, the value of the x-intercept is going to be the value of x when y is equal to 0, when we're 0 units up or down on our axes. So, to find this, we're going to substitute in y equals 0, and we're going to solve that equation. Substituting in y equals 0, we're going to get when y equals 0, 0 is equal to 4x plus 28. This is now an equation which we can rearrange and solve for x. We're going to start off by subtracting 28 from both sides. We're going to get that 4x is equal to negative 28, and then we're going to divide both sides of our equation by 4, and we're going to get that x is equal to negative 7. To anybody watching on the vertical video, I'll just move out the way so you can see what I wrote. If you're watching on the horizontal video, then everything should be clear just over there. So, finding the x and the y-intercepts. To find the x-intercept, we substitute in y equals 0 and solve. To find the y-intercepts, we substitute in x equals 0 and solve. However, in the case of the y-intercept, this middle term is always just going to cancel down into nothing, so we can think of it as just taking that number on the end.
How to sketch vertical and horizontal lines in 56 seconds? Let's go. This, guys, is a topic which trips a lot of people up, and I can see why. To be honest, it is a little bit counterintuitive. Let's have a look. This question says, firstly, sketch y equals 3, and then it asks us to sketch x equals minus 2. What are we going to have? Firstly, y equals 3. That is going to be a horizontal line which crosses through 3 on the y-axis. Now, why is that going to be the case? That's going to be the case because this is the line at which every single value of y is 3. In other words, at every single point on this line, we are exactly 3 units up. The y value of every single coordinate on this line is 3. Now, what about applying this same logic to x equals minus 2? What's this one going to look like? Well, this one is going to be a vertical line which cuts through minus 2 on the x-axis. Again, why is this? This is because this is going to be the line which connects every single point where the value of x is minus 2. This is going to be the line which connects every single point which is exactly minus 2 units in the x direction. How to find the equation of a straight line when you're given 2 coordinates on that line in 130 seconds. Let's go. This, guys, is a pretty tricky topic. Pause the video now and see if you can get it. Let's have a look. The question says, calculate the equation of the straight line which goes through the points 4, 7 and 8, 15. What are we going to do? Well, to have the equation of a line, what do we need? We need the gradient and we need the y-intercept. Why? That's because the general equation of a straight line is y equals mx plus c. So if we can find our gradient and our y-intercept, we've pinned down our line. What are we going to do? Step number 1, we're going to use those 2 coordinates to find the gradient of the line. How are we going to do it? We're going to use the fact that the gradient of a line, we're going to have our gradient is equal to our change in y between those 2 coordinates divided by our change in x. Now, what's the change in y? In the y direction, we go from a coordinate of 7 to a coordinate of 15. That's a change of 8. So the change in y is going to be 8. We're going to divide that by the change in x. What's the change in x? We go from 4 to 8. That's going to be a change of 4. So we can say that the value of the gradient is 8 divided by 4, which is going to be 2. Now, guys, we've done half the battle. We found the value of the gradient. So we can rewrite the equation of our line, y equals mx plus c. Now we know the value of m. The value of m is going to be 2. So we can write this as y equals 2x plus c. Now, where do we go from there? We need to find the value of c. How are we going to do it? We're going to substitute one of our coordinates and can be either either one of them into the equation of our line. That's going to eliminate the y and the x, and it'll allow us to rearrange to find the value of c. What are we going to get? Let's substitute in this coordinate, the smaller one, 4, 7. What are we going to have? Well, we know that when x is equal to 4, y is equal to 7, so we can say that 7 equals 2 times by our value of x, which is 4, plus c. 2 times by 4 is 8. Taking 8 from both sides, what are we going to have? We're going to have 7 minus 8, which is minus 1. So we can say that minus 1 equals c. I said that pretty quickly, guys. What we did was we did our 2 times by 4, which was 8. Then we tucked that away from both sides to get the value of c, get c on its own. We now know that c is equal to minus 1. Where do we go from there, guys? Now we just rewrite the equation of our line. We have that y is equal to 2x. Now we can substitute in our c, which is minus 1. So we have y equals 2x minus 1, the equation of our straight line. How to find the equation of a straight line given a point and a gradient in 95 seconds. Let's go. Questions like this, guys, are super common in exams. Let's have a look and see if we can do it. The question says, calculate the equation of the straight line which has a gradient of -2 and passes through the point 4, 6. What are we going to do? First of all, we're going to recognize the fact that the general equation of a straight line is y equals mx plus c. Now, how is this going to help us? This is going to help us because it kind of shows us that all we need to do to pin down this straight line is find the value of m, the gradient, and find the value of c, which is our y-intercept. We've been told in the question that the gradient of our line is -2. So we can start off by subbing in that value of m, the gradient of our line is going to be -2. So we can say that y is equal to -2x plus c. Now the final step is going to be to find the value of c, and how are we going to do that? We're going to use the other piece of information we've been given, which is that the line passes through the point with coordinates 4, 6. We know therefore that when x is equal to 4, y is equal to 6. So we can substitute those values into this equation and rearrange to find the value of c. Let's get it done. So we're going to have that 6 is equal to -2 times by the value of x, which is 4, plus our c. Where do we go from there? We're going to simplify it. We're going to have 6 is equal to -8 plus c. Now we can add 8 to both sides. That's going to give us a value of c. 6 plus 8 is going to be 14. So we can say that c is equal to 14. Now, guys, final step, we're just going to substitute that value of c back into our equation. We're going to have y equals -2x plus 14 as the answer to this question. When it comes, guys, to finding the equation of a real-life graph, it is actually exactly the same as finding the equation of a regular graph. In this case, we can see that we have a straight line, and we are going to use exactly the same method as we usually would to find its equation. Let me show you what I mean. The question says, use the following graph to write an equation for the volume of water, V. We can see that on the y-axis. In the bucket at time, T, we can see that on the x-axis in the form V equals mt plus c. So what do we actually have going on here? We actually have a regular straight line. The normal equation of a straight line is y equals mx plus c. The only difference here is that we've swapped the y for a v and we've swapped the x for a t. We can see that just like the y normally is, the v is on the vertical axis, and just like the x normally is, the t is on the horizontal axis. So we're going to use the same method. The m is going to be the gradient of the line, the c is going to be the y-intercept. So we have to think of those two things, the gradient and the y-intercept. When we have them, we can just plug them into that equation, v equals mt plus c. So first off, how do we find the y-intercept? Well, the y-intercept is the point where the line crosses the y-axis, in this case the v-axis, and we can see that it crosses the axis at the point 0, 20. So in this case, we can say that the value of c is equal to 20 because the axes intercept, the y-axis, the v-axis intercept is 20. Now, what about the value of m, our gradient? How do we work out the gradient of a straight line, guys? We take 2 points and we do rise over run. We do change in y divided by change in x. We can see that we've been given 2 points here. We have the point 0, 20 and we have the point 60, 60. What's our change in y, guys? Well, in the y direction, we go from 20 to 60, so the change is plus 40. And what about in the x direction? The change is from oh, did I say that wrong? No, I didn't. The change is from 0 to 60, so it's going to be a change of plus 60. So we go 60 across in the x direction and 40 up in the y direction. Let me just write change in y
divided by changing x. To make that super clear, we can simplify this, guys, dividing top and bottom both by 20. 40 divided by 20 is 2, 60 divided by 20 is 3, so our gradient there is 2 over 3. Final step, guys, we're going to substitute our values for the gradient and the y-intercept into our equation v equals mt plus c. So we're going to have v equals, m is going to be the gradient, 2 over 3, then we have our t plus our y-intercept of 20. We get our answer, guys, v equals 2 over 3 t plus 20. What did we do? We treated this just like a regular line, worked out our y-intercept, worked out our gradient, and then substituted those both into our equation.
A quick reminder of the general shape of a quadratic in 27 seconds. Let's go. Here, guys, we have a really quick reminder of the general shape of a quadratic. What's it going to be? We're going to say that when we have a positive coefficient of x squared, for example, here we have an imaginary 1, we're going to have this kind of U shape. And when we have a negative coefficient of our x squared, for example, here we have our negative 1. What's it going to be? It's going to be an upside down U shape. So positive coefficient of x squared, we have a regular U shape. Negative coefficient of x squared, we have an upside down U shape. How to sketch a quadratic by plotting coordinates in 205 seconds. Let's go. When it comes to sketching a quadratic, guys, there are a few different methods we can use, but one of them is going to be to plot a table of values and then to join all of the coordinates with a smooth curve. Let's have a look at how to do it for this one. We can see that we've been given the quadratic y equals x squared plus 7x plus 12 and a table of values which takes us from x equals minus 5 all the way up to x equals 0. What we're going to do, guys, is substitute each of those values of x into our quadratic, find the corresponding values of y, plot them, and then join them. Let's have a look. So first of all, substituting in x equals minus 5, what are we going to get? We're going to have that y is equal to x squared, so minus 5 squared, plus 7 times by x, so minus 5, plus 12. What's that going to give us? We could use a calculator, or we could take our time and work it out by hand. Minus 5 squared, that's going to be positive 25, plus 7 times by minus 5. 7 by minus 5 is going to be minus 35. 25 minus 35 is going to be minus 10, plus 12, guys, that is going to give us positive 2. Like I say, you could use a calculator, or, guys, work it out by hand. What about substituting in x equals minus 4? What are we going to have? We're going to have that y is equal to x squared, so minus 4 squared, plus 7 times by minus 4, plus 12, what's that going to be? Minus 4 squared is 16, plus 7 times by minus 4, that's going to be minus 28. So we're going to have positive 16 minus 28, that's going to give us minus 12. Minus 12 plus 12, that is going to give us 0, guys, so we can put that in. Subbing in minus 3, that is going to give us, what's it going to be? Y is going to be equal to minus 3 squared plus 7 times by minus 3, plus 12 minus 3 squared, that's going to be positive 9, plus 7 times by minus 3, 7 by minus 3, that is going to be minus 21, 9 minus 21, that's going to be minus 12, minus 12 plus 12, that's going to be 0, so again, we're going to have that when x is equal to minus 3, y is equal to 0. Now, substituting in minus 2, let me just write that in, yep, substituting in minus 2, what's it going to be? Y is going to be equal to minus 2 squared plus 7 times by minus 2, plus 12, what's it going to be? Minus 2 squared is 4, plus 7 times by minus 2, that's going to yield minus 10. Minus 10 plus 12, that is going to give us positive 2, guys. I know I'm going quickly. Are you keeping up? You can pause it, check that you understand what's going on. What about substituting in minus 1? That is going to give us y is equal to minus 1 squared. That's going to be 1 plus 7 times by minus 1. That's going to be minus 7. 1 minus 7, that's going to be minus 6. Minus 6 plus 12, that, guys, is going to give us positive 6, so we can write that in. Finally, substituting in 0, x equals 0, that is going to give us 12. So now we have a bunch of coordinates that we can plot. We know that when x is equal to minus 5, y is equal to 2, so we can plot that on. X equals minus 5 along the corridor up the stairs, y is equal to 2. When x is equal to minus 4, x is equal to minus 4, y is equal to 0, let's plot that one on. When x is equal to minus 3, y is equal to 0, putting that one on. When x is equal to minus 2, when x is equal to minus 2, y is equal to 2. Hey, guys, I think I'm speaking way too quickly in this one. When x is equal to minus 1, y is equal to 6, and we can put that on as our final point that's going to fit on. Finally, guys, we can connect all of these with a smooth curve. What are we going to have? Let's see how good of a job I do. Coming down and going up like that. A bit of a cheat code because I'm on the iPad. Guys, that is what our quadratic is going to look like. Joining it with that smooth curve, getting that U shape. Hopefully everything made sense there. Feel free to watch again if it was a little bit fast. How to find the x-intercepts of a quadratic graph in 87 seconds. Let's go. Questions like this, guys, are really common in exams. Let's have a look. The question says, find the x-intercepts of the graph with equation y equals x squared plus 4x plus 3. What are we going to do? Well, what we're going to do is we're going to recognize that the x-intercepts are going to be the points on the line where y is equal to 0. It's going to be crossing the x-axis when the value of y is equal to 0. So what we're going to do is we're going to substitute y equals 0 into our equation. That's going to give us 0 equals x squared plus 4x plus 3. Now what we can do, guys, is we can solve this quadratic by factorizing or using the formula, but factorizing is going to be easiest, and that's going to tell us the values of x when y is equal to 0. Let's get it done. So solving this quadratic, we're going to have 0 equals. We need to solve this, and we're going to factorize it. We need two numbers which times to give positive 3 and add to give positive 4. That's going to be 3 and 1. So we can write this as x plus 3 times by x plus 1. Now, guys, finding the solutions to this, we're going to have the two values as x equals minus 3 and x equals minus 1. If you're not sure how to do that, guys, consider recapping how to solve a quadratic. Now we have the values of our x-intercepts, guys. They're going to be minus 3 and minus 1. Now, just as a bonus, what's the quadratic going to look like? It's going to look something like this. We can plot those on minus 3 and minus 1. And the graph, we know the y-intercept is there. Don't worry about that for now. So our quadratic is going to look something like that. That was a pretty good sketch, actually. Give it a go, guys. See if you can get the same answer. How to find the y-intercept of a quadratic graph in 38 seconds. Let's go. Luckily, guys, when it comes to finding the y-intercept of a quadratic, it's really not too bad. Just like with a straight line, all that we're going to do is we're going to read that number on the end. In this case, it's minus 4. So we can say that the y-intercept of our quadratic here is y equals minus 4. Now, why actually is that? That's because we're technically finding the value of y when x is equal to 0. We technically have y equals 0 squared plus 3 times 0 minus 4. 0 squared is 0, 3 times 0 is 0, so we just are left with minus 4. That's why it's going to be minus 4, but guys, you can just remember it as that handy number on the end. How to find the turning point of a quadratic graph in 93 seconds. Let's go. When it comes to finding the turning point of a quadratic, guys, there are going to be a couple of different methods that we can use. My personal favorite is going to be to use completing the square. So I'm going to show you how to do it that way. Let's have a look. The question says, calculate the turning point of the graph with equation y equals x squared plus 10x plus 24. Now, we can tell that this is a quadratic because of the x squared. How, though, do we find the turning point? First things first, we're going to complete the square. So we're going to write out that y is equal to, we're going to put our brackets in. There's going to be an x at the front. We're going to look at the number next to the x, which is 10. We're going to halve that. It's going to give us 5. So we're going to have x plus 5 in our brackets. We're going to square those brackets. We're going to copy down that plus 24. And then we're going to look at the number in our brackets, which is 5. We're going to square it and we're going to take it away. 5 squared is 25. So we're going to have minus 25. Now, guys, we can simplify this. We're going to have y is equal to x plus 5 squared. 24 minus 25, that's going to be minus 1. Guys, if you're not sure how to do that, consider revising completing the square. It should make it really clear. Now, how do we read our turning point from this completed the square form? All that we're going to do is we're going to look at the number next to the x. Here it's a 5, and we're going to reverse the sign of that to get our x coordinate. So our x coordinate is going to be minus 5. Then to find our y coordinate, we're going to look at the number on the end, and we're going to leave the sign the same as it is. So the y coordinate of the turning point, guys, is going to be minus 1. Now we have our turning point, minus 5, minus 1. Make sure to remember, with the x coordinate, you do change the sign, but with the y coordinate, you don't change the sign. The full process for sketching a quadratic in 170 seconds. Let's go. Questions like this, guys, which involve sketching quadratics, come up all the time, and they're normally worth a lot of marks. Let's have a look at this one. The question says, sketch y equals x squared plus 8x plus 12. What are we going to do? Step number 1, we're going to find our x-intercepts. Step number 2, we're going to find our y-intercept. Step number 3, we're going to find our turning point. We're going to put all of those on our graph down here and join them with a curve. Let's get it done. First of all, finding our x-intercepts, what are we going to do? We're going to substitute in y equals 0, and we're going to solve that quadratic. So what are we going to have? We're going to have 0 equals x squared plus 8x plus 12. Now to solve this quadratic, guys, we can factorize. We need two numbers which multiply to give our 12 and add to give our 8. That's going to be positive 6 and positive 2. So we can write this as 0 equals x plus 6 times by x plus 2. Now, guys, to find the solutions to this equation, all we need to do is swap those signs. So we're going to have minus 6 and or minus 2 as our two values for x. Let me write that in, x equals -6 or x equals -2. Now we can put those on our graph down here approximately. We're going to have -6 over there and -2 down there. Now guys, how are we going to find our y-intercept? When it comes to finding the y-intercept of a quadratic, it's just going to be this number on the end. Why is that? That's because if you imagine substituting in x equals 0, both of these terms are going to go to 0, and we're just going to be left with y equals 12 when x equals 0. So we can plot on now our y-intercept of 12. Finally guys, how are we going to find our turning point? One method would be to find halfway between the two roots of the equation, and then to substitute that value of x into our equation. But I'm going to do it by completing the square because that's my favorite method, guys. How are we going to complete the square for this equation up here? Step number 1, we're going to write out a pair of brackets. So we're going to have y equals, and then we're going to have a pair of brackets. We're going to write an x at the front. Then we're going to look at the number next to the x over here. It's an 8. We're going to halve that. That's going to give us 4. So we have x plus 4. Then we're going to write in our squared. We copy down that plus 12 from the end, and then we're going to subtract this number squared, the number inside the bracket squared. That's going to be -16. Now, guys, we can simplify. We're going to have y equals x plus 4 squared, and then we're going to have 12 minus 16, that's going to be -4. Now, guys, we can read our turning point from that equation by swapping the sign next to the number next to the x. So we're going to have -4 as the x coordinate of the turning point. We're going to have -4, and as the y coordinate, we're just going to copy down that number on the end, which is -4. Now, guys, we have our turning point. It's going to be -4, -4. Drawing that on approximately, let's put it down there. We have -4, -4. And now, guys, the moment of truth, we can join all of those with a hopefully smooth curve. How good are we going to be? Let's have a look. Hey, that's not bad at all. That's not bad at all. Guys, that is the full method for sketching a quadratic. Now, if that was really confusing, watch our previous few videos. We talk about finding the x-intercept, the y-intercept, and also finding the turning point.
When it comes, guys, to answering questions about quadratics, which include diagrams in our exam, understanding this key skill is going to be key. Let's have a look. The question says, given the following sketch of y equals x squared plus 7x plus 12, solve x squared plus 7x plus 12 is equal to 0. Now, we know how to solve quadratics by now. We can use the quadratic formula, we can factorize them, we can complete the square. In this case, x squared plus 7x plus 12, we would probably factorize it. Why? Because it's not too bad to factorize. We could find two numbers which multiply to give 12 and to give 7, and it really wouldn't be too bad. However, in this example, it does say given the following sketch. Given the following sketch of y equals x squared plus 7x plus 12, solve x squared plus 7x plus 12 equals 0. What we see, guys, is that the x section of the quadratic here above, x squared plus 7x plus 12, is actually the same as down here, x squared plus 7x plus 12. In the first case, it's equal to y. In the second case, it's equal to 0. So what can we do? To solve this quadratic, guys, we can simply take the x-intercepts of the quadratic down here. We've simply swapped the y for 0, so we want the values of x when y is equal to 0. We can see from the diagram that when y is equal to 0, when we're 0 units up or down, the values of x are -4 and -3. So the solutions to this are going to be x equals -4 or x equals -3. Now, when it comes to using this in exams, guys, it's often going to be the case that we have decimal solutions or fraction solutions. For example, we could have been given x-intercepts here of -0.7 and -0.2. That is going to be the case in which using the diagram is really handy for solving them. I use this example so that you could see that it checks out if you did solve it by factorizing, using the formula, completing the square, whichever method you prefer. But in general, what is the key lesson here? The key lesson here, guys, is going to be the fact that when it comes to solving a quadratic, we can use the sketch. The solutions are going to be the x-intercepts of that quadratic.
How to plot a cubic graph in 78 seconds, let's go. Plotting cubics, guys, is a pretty tricky topic, and to be honest, it doesn't really come up too often. However, it is technically in the syllabus, so let's have a look. This question says, sketch y equals x cubed plus x squared minus 4x minus 6 from x equals -3 to x equals 3. And we can see that I've already got the answer on the screen here, so let's have a look. How would we attempt this question? Well, what we would do, just like with plotting linear graphs or with plotting quadratics, is we would plug each of our x values in our table into our equation to get the corresponding y value. So, for example, for this point, -3 minus 12, what we would do is we would substitute in x equals -3. We would get y equals -3 cubed plus minus 3 squared minus 4 times by minus 3 minus 6. If we type that into a calculator, guys, that would give us minus 12, and that gives us this point down here. Now, we would repeat the process for all of our coordinates, all of our x values, and we can see that I've done that here and got a bunch of coordinates. Then, guys, you can plot them on your graph, as we've done here, 1, 2, 3, 4, 5, and 6, and also 7. Don't know why I stopped at 6. And guys, we then, just like with any other graphs question, join them with a smooth curve following the general shape of a cubic, and we get our answer just like that. How to solve linear simultaneous equations graphically in 84 seconds. Let's go. This, guys, is a pretty tricky topic, and to be honest, a lot of people do forget to revise it. Let's have a look. This question says, solve the simultaneous equations y equals x minus 2 and y equals minus 3x plus 2 by first sketching them. Guys, what do we reckon? Step number 1, we're going to draw both of our lines on our graph, and then the solutions to the simultaneous equations are going to be given by the point where these two lines meet. Let me show you what I mean. First of all, let's sketch y equals x minus 2. This one is going to have a y-intercept of minus 2, and it's going to have a gradient of 1 because there's an imaginary 1 next to that x, and we can join those points together, drawing our line on like so. That wasn't perfect. Let me draw that again. Make sure you use a ruler for this, guys. Drawing our line on, yeah, that's a bit better, isn't it? Y equals x minus 2. Now, guys, drawing on y equals minus 3x plus 2. This one is going to have a y-intercept of 2, that number on the end, and a gradient of minus 3. Drawing this on, then we're going to have a y-intercept of 2, gradient of minus 3. So we're going to go 1 to the right and 1 down, joining those points together. Then, guys, what are we going to have? We're going to have this line here, writing it in, y equals minus 3x plus 2. Now, guys, we can see the point where these two lines cross is just here. It's at the point where x is equal to 1 and y is equal to minus 1. So, guys, the solutions to the simultaneous equations are going to be given by x equals 1 and y equals minus 1. If you want, guys, check that with a different method if you know how to do that and see if we got it right. How to solve quadratic simultaneous equations graphically in 77 seconds. Let's go. This, guys, is a topic which trips pretty much everybody up come exam day. Let's have a look. The question says, solve the simultaneous equations y equals x squared and y equals x plus 2 using the graph below. What do we reckon, guys? Just like when we solved linear simultaneous equations graphically, that was a mouthful. We're going to be looking for the coordinates, the points where these two lines meet. The difference, though, is that here we're going to have the lines meeting at 2 points. Let's have a look. We can see that our two lines, y equals x plus 2 and y equals x squared, meet at this point here and this point here. Those coordinates is what's going to give us our solution. So we can see firstly this point here, we have an x value of minus 1 and a y value of 1. So our first solution is going to be that x equals minus 1 and that y equals 1. We then have our other solution, which is going to be given by the other coordinates. So we're going to have x equals 1 and x equals minus 1, I should have said, and y equals 1. Or we're going to have our other point, which is going to be up here. Now, what's the value of x going to be? It's going to be 2. What's the value of y going to be? It's going to be 4. So we can say that our other solution is going to be that when x equals 2, y is equal to 4. That, guys, is how to solve quadratic simultaneous equations graphically. We're going to be looking for the points where the lines cross. Questions involving the properties of parallel lines in 101 seconds. Let's go. When it comes to working with parallel lines, guys, one of the most important skills is going to be showing that two lines or more are parallel. And how do we do that? We show that they have the same gradient. Why? Because parallel lines are lines which have the same gradient. How are we going to do that, though? Let's have a look at this question here to make the process clear. The question says, show that the lines with equations y equals minus 4x plus 7 and 2x plus a half y equals 8 are parallel. What we need to do, guys, is rearrange the second equation to the form y equals mx plus c. Then we can show that the values of m are the same in both cases. Let's get it done. So copying out our equation, first of all, we're going to have that 2x plus a half y equals 8. We want to make y the subject. So we're going to firstly minus 2x from both sides of our equation. We're going to have that a half y is equal to minus 2x plus 8. Now, the reason that I've put that minus 2x at the start is just so that it's in the form y equals mx plus c, so that mx comes first. You don't actually have to do that, but it is going to make our life a little bit quicker. Now, what are we going to do? We're going to get the y on its own by multiplying both sides of our equation by 2 to get rid of that a half. So we're going to have y equals minus 2x times by 2. That's going to be minus 4x. And then 8 times by 2, that is going to be 16. So we have y equals minus 4x plus 16 as the equation of our second line. The equation of our first line is y equals minus 4x plus 7. Now, guys, we have shown that they are parallel. Why? Because both of the lines have a gradient, writing as quickly as I can. Both of the lines have a gradient of minus 4. Therefore, guys, we've shown that they are parallel. How to work with the properties of perpendicular lines in 126 seconds. Let's go. Questions involving perpendicular lines, guys, really divide opinion. Some people love them, some people hate them, but they do come up a lot. So let's have a look. The question says, show that the lines with equations y equals 2x minus 7 and minus a half x minus y equals 8 are perpendicular. Guys, what are we going to do? We're going to use the fact that for perpendicular lines, the gradients multiply to give negative 1. So we're going to find the gradient of our first line, we're going to find the gradient of our second line, and we're going to show that when we multiply them, we get minus 1. Now, what are we going to have for our first line? This one is already in the form y equals mx plus c, so we can just look at the number next to our x. Here it's a 2, so the value of m is 2, so the gradient of our first line is equal to 2. So let's just make a note of that. We're going to have that the gradient of y equals 2x minus 7 is equal to 2. Now, what about our second line? This one's not currently in the form y equals mx plus c, so we're going to rearrange it to that form first of all. Let's copy down the equation of our line. We have minus a half x minus y equals 8. Now, to rearrange this to the form y equals mx plus c, we want the y to be on its own on one side, and we want it to be positive, and we want everything else to be on that other side. We're going to move the minus y to the other side by adding y to both sides. We're going to subtract the 8 from both sides. That's going to get the y on its own on the right-hand side, and on the left-hand side, we're going to be left with minus a half x minus that 8. So we're going to rearrange this to the form y equals minus a half x minus 8. Guys, I did that pretty quickly. Pause it if you want to and have a look. Check that you understand that. Now, guys, how are we going to show that these two are perpendicular? Well, we need the gradient of this line. The gradient of this line is going to be minus a half. So we can say that the gradient of y equals minus a half x minus 8 is minus a half. Now, guys, we're going to show that the two gradients multiply to give minus 1. So we're going to do 2 times by minus a half. 2 times by minus a half, guys. That is going to be minus 1. Therefore, our lines must be perpendicular. Reciprocal graphs in 49 seconds. Let's go. When it comes to working with reciprocal graphs, guys, luckily, there's really not too much we need to know. We just need to know the general form of the graph, which is going to be y equals a over x. The value of a can change. It could be, for example, y equals 2 over x, y equals 1 over x, or y equals 5 over x. And we also need to know the general shape of the graph. It's going to look like this. We have what's called two hyperbolas, these curved shapes, and it's really important to know that these get increasingly close to the y and x axes, but they never touch them. So we have a curve like this in the positive quadrant, a curve like this in the negative quadrant. Both of these curves get increasingly close to the axes, but they never touch them. The most common questions on this topic, I should say, guys, is just asking us to identify which graph out of 4, for example, is reciprocal, and it's going to be the one which looks like this. Exponential graphs in 46 seconds. Let's go. When it comes to working with exponential graphs, guys, luckily, just like with our reciprocal ones, there's not going to be too much we need to know. We just need to know the general form of the equation of the graph. It's going to be y equals a to the power of x. Again, a can be any number. It could be, for example, 2, 5, or 10. Y equals 2 to the power of x. That would be an example of an exponential graph. And we need to know the general shape of the graph, and it's going to be like this. This line here to the left-hand side of the y-axis gets closer and closer to y equals 0, but never touches it, so it never touches that axis. And on the right hand side of the graph, it blows up pretty quickly. We can see that we have this exponential shape which goes up and up and up. Now, one other important thing to note about this graph is that it's always going to cross the y-axis at the point 0, 1. Direct proportion graphs in just 30 seconds. Let's go. When it comes to working with our graphs of direct proportion, guys, there are only a couple of things we need to know. First of all, the general form of the equation of the graph, that's going to be y equals ax, where a is some number. Could be, for example, y equals 2x or y equals 5x, and the general shape of the graph is going to look just like this. It's going to be a straight line going upwards, passing through our point 0, 0. Guys, see if you can understand the fact that the greater the value of a, the steeper this line is going to be, and the lower the value of a, the less steep this line is going to be. Graphs of inverse proportion in 30 seconds, let's go. When it comes to working with our graphs of inverse proportion, guys, just like with our direct proportion graphs, we're only going to need to know the general equation of the line and the general shape of the line. What's it going to be? The general equation is going to be y equals a over x. For example, we could have y equals 2 over x or y equals 5 over x, and then the general shape, that's going to be this hyperbola shape like this. It's going to get increasingly close to the x and the y axis as the values of x increase and decrease, just like shown on this graph, and crucially, it's never going to touch them.
This, guys, unfortunately, is a key skill which is often forgotten about in school. Let's have a look at the equation of a circle. This question says, what is the radius of the circle with equation x squared plus y squared equals 36? We can see down here that I've written in green, x squared plus y squared equals r squared. How is this going to help us? Well, in the same way that there is a general equation of a straight line, y equals mx plus c, or a quadratic, y equals ax squared plus bx plus c, there is also a general equation for the equation of a circle. And that general equation is x squared plus y squared equals r squared. Now, this is going to be a circle which is centered at the origin and has a radius of r. So, in the case of x squared plus y squared equals r squared, the radius would be r. What about in the case of x squared plus y squared equals 36? Well, in this case, we can say that the value of r squared is going to be 36. The value of the radius squared is going to be 36. Using this then to find the value of the radius, what can we do? If the radius squared is 36, we can square root both sides, and we're going to get that the radius is equal to the square root of 36, which is equal to 6. So, the general equation of a circle is x squared plus y squared equals r squared, where r is the radius of the circle. In this case, x squared plus y squared equals 36. So r squared is 36, and the radius is equal to 6.
How to sketch a circle using the general equation of a circle in 93 seconds, let's go. This, guys, is a topic which is so often forgotten about in revision, but when you know how to do it, it's not too bad. Let's have a look. This question says, sketch the circle with equation x squared plus y squared equals 16. Now, to answer this question, we're going to use our understanding of the general form of the equation of a circle, which is x squared plus y squared equals r squared, where r is the radius of that circle, and that circle is centered at the origin. Now, what does that actually mean? It means that the center of our circle is going to be the point 0, 0, and it also means that the radius of the circle is going to be the square root of the number which is on the right hand side of our equation here. So in the case of x squared plus y squared equals 16, what do we have? Well, we have that r squared is going to be equal to 16. If the value of our radius squared is going to be 16, we're going to have that our radius is equal to the square root of 16. The square root of 16 is 4, so we have that the radius of our circle is 4. Now, our circle is going to be centered at the origin, and what that basically means is that it's going to go through the points 0, 4, 4, 0, 0, minus 4, and minus 4, 0. Why is that? That's because each of these lines is going to represent a radius of our circle going from the center straight out to the circumference of our circle. Now, guys, we can join those with a line. Let's have a look. I'm going to cheat because I'm on an iPad, and that's not bad, is it? When you do this, guys, make sure you use a pencil because it's really easy to mess up when drawing a circle. That, guys, is how we're going to use the general equation of a circle to sketch a circle. How to find the equation of a tangent to a circle in 165 seconds. Let's go. This, guys, is a topic which is famous for being one of the most difficult in the course. Hopefully, we're going to make it clear with this quick video. Let's have a look. The question says, calculate the equation of the tangent shown below. If you're not sure, guys, the tangent is going to be this line here. How are we going to do it? Well, to find the equation of a straight line, we need two things. We need the gradient and the y-intercept. Why? Because the equation of a straight line is y equals mx plus c. Now, how are we going to find the values of m and the value of c? The first thing we're going to do is we're going to draw a line from our origin, the point 0, 0, to the point where the tangent meets the circle. Now, why are we going to do that? We're going to do that because we know that the radius of a circle meets the tangent of a circle at that point at a perpendicular point. Now, what do I mean by that? Now, I mean that these points here are going to be perpendicular. How's that going to help us? It's going to help us because for perpendicular lines, we know that the gradients are the negative reciprocal of one another. In other words, the gradients of those lines multiply to give -1. So what we can do is we can find the gradient of this line here, take the negative reciprocal, that's going to give the gradient of this line here. Then we can go from there and work out the equation of that line. So the gradient of this line here, what's it going to be? The gradient is equal to the change in y divided by the change in x. We go from the point 0, 0 to the point 5, 10. The change in y is 10, the change in x is 5, so the gradient is going to be 2. Let's write that in. We know that the gradient of that line there, the gradient is equal to the change in y divided by the change in x. The change in y is 10, the change in x is 5, 10 divided by 5, that's going to be 2. We know that the gradient of the tangent, like I say, is going to be the negative reciprocal of that, so we're going to find the negative reciprocal. And what's that going to be? It's going to be -1/2. We do -1 over that number. Now, guys, we have the we have the gradient of that line. We know, therefore, that the equation of the line is going to be y equals -1/2 x plus c. Now, the final step is going to be to find the value of c. How do we find the equation of a straight line given a point and the gradient of the line? What we do is we substitute in the point that we know, and then we rearrange to find the value of c. Let's do that now. I'm going to switch to a different color just to make this clearer. We're going to have that when y is equal to 10, so we have 10 equals -1/2. X is going to be equal to 5, so 10 equals -1/2 times by 5 plus c. 10 is going to be equal to 1/2 times by 5, that's -2.5, plus c. Now we can add 2.5 to both sides, we get 12.5 equals c. Now, guys, we can substitute that into the equation that we constructed before to find the final equation of our line. It's going to be y equals -1/2 x plus 12.5, the equation of that tangent to the circle. How to translate graphs in the x and the y direction in 141 seconds. Let's go. This, guys, is a topic which trips people up all the time, and I can understand why. There's a few different moving parts. Let's try and make it clear. What are we going to do? What is the equation of the line y equals 7x plus 12 when it is firstly translated 2 units right? Guys, when we translate a graph in the x direction, we make the change to the equation directly to the x, and we do the opposite to what we would expect. We're moving positively in the x direction. We're moving to the right. So what we're going to do is we're going to subtract 2 from the x in our equation, and we're going to be left with y equals 7 times by, affecting the x directly, x minus 2 plus 12. Because it's in the x direction, we've done it directly to the x, and because it's also in the x direction, we're going to reverse that sign, moving right. That would be a positive movement in the x direction, so instead of adding 2, we subtract 2. Now, what about translating 2 units left? This time we're still moving in the x direction, so the effect is going to be directly to the x in our equation. However, this time we're going to be adding 2 because we're moving in the negative x direction. So the new equation of our line is going to be y equals 7 times by x plus 2 plus 12. Now, in both of these cases, guys, we could simplify, but we've not been asked to here, so we're not going to bother. Now, what about translating 2 units up this time, guys? Because we're moving in the y direction, we're going to add 2 to the end of our equation, and we're moving in the positive y direction, so we're going to be adding 2. In the x direction, remember, we reversed the signs. If we were moving in the positive x direction, we subtracted 2. However, moving in the y direction, we're going to be keeping the sign the same. So what are we going to have? We're going to have y equals 7x plus 12 plus 2. Now we could simplify that. It's going to give us 14, and I'm not going to do that because I don't have space, but you can imagine what it would look like. Finally, we're going to have translating 2 units down, again moving in the y direction, this time in the negative y direction. Because it's in the y direction, we do it on the end, and because it's in the y direction, we keep the sign as what we would expect it to be. So what are we going to have? We're going to have that y is equal to 7x plus 12, and then we're going to take our 2 away. That guy, not take 10 away, take 2 away. We would be left with 10. What are we going to have? We're going to have y equals 7x plus 10. That would be the simplified version. How to find the new equation of a line when it's been reflected in the x or the y axes in 92 seconds. Let's go. Guys, when it comes to reflecting a line in either the x-axis or the y-axis, the thing that we need to understand is that when we reflect in the x-axis, all of the y's in our equation become negative y, and when we reflect in the y-axis, all of the x's in our equation become negative x. Now, that's a little bit counterintuitive, so why actually is that? Let's have a look down here. Let's take this point 2, 3, and say that we reflected it in the y-axis. What would we get? Well, the new coordinate, after being reflected in the y-axis, would be this point here, minus 2, 3. We can see that when we reflect in the y-axis, the value of y actually stays the same and the value of x is reversed. Now, what if we were to take the same point, 2, 3, the original one, and reflect it in the x-axis instead? Where would it come? It would come just down there, and the new coordinate would be minus 3, 2. Just like in the previous case, we can see that when we reflect in the x-axis, we actually get a change of signs in the y, not in the x. And that, guys, was just a quick explanation of this counterintuitive point at the top. Now let's have a look at the question. It says calculate the new equation of the line y equals 2x plus 3 after it has been reflected in firstly the x-axis and then the y-axis. Guys, when it's reflected in the x-axis, the value of y becomes minus y. So we're going to simply take our equation and swap our y for a minus y. We have minus y equals 2x plus 3. Now what about reflecting in the y-axis this time, guys? We're going to take our x and swap it for minus x. We're going to get that y is equal to minus 2x plus 3. And that, guys, is going to be our answer. How to sketch the graphs of linear inequalities in 104 seconds. Let's go. When it comes, guys, to sketching a linear inequality, we're going to treat it just like sketching a regular graph, pretending that our inequality sign was an equal to sign. But we're going to make sure a couple of things. The first thing is that if we have an or equal to sign, like in this example, we use a regular line. But if we don't have the or equal to sign, so if we just had a less than or a greater than sign, we would use a dotted line instead of a regular line. And then the second thing that we're going to make sure is that we shade the correct region of the graph, which I'll talk about, towards the back end. Let's have a look. The question says shade the region of the graph which satisfies y is greater than or equal to x plus 2. First of all, sketching y equals x plus 2, what's it going to be? We have a y-intercept here, the number on the end of 2, so we can plot that point on. We have y-intercept of 2 there. And then we have a gradient of 1 because there's effectively an imaginary 1 in front of that x. So the m part of the y equals mx plus c is 1. So we're going to go 1 across 1 up, 1 across 1 up. That gives us a few points which we can join with a straight line. And we can see there, guys, that we have our line y equals x plus 2. Now, where do we go from there? We need to either shade above the line or below the line. Which one's it going to be? Well, we want all of the points, the region on our graph where y is greater than or equal to x plus 2. So we need the value of y, we need the height to be bigger than our line. So, guys, we're going to shade above our line. And let me get a nicer highlighter out than that. Yeah, we're going to shade above our line, and that is going to be our region. Now, some people talk about the method where you can substitute in a point, normally 0, 0, and check whether the inequality is true or not. You can also use that method, but it's not really necessary here. We can just say that because we want the places where y is greater than or equal to x plus 2, it's going to be above that line. Sketching quadratic inequalities in 110 seconds. Let's go. This, guys, is definitely one of the most challenging topics in the course, but don't worry, I'm going to do my best to make it clear. Let's have a look. The question says, shade the region on the graph which satisfies y is less than or equal to x squared plus 7x plus 12. What are we going to do? Step number 1, guys, that's going to be to sketch our quadratic, most importantly showing where the graph crosses the x-axis. How do we find our x-intercepts, guys? We're going to factorize this, finding two numbers which multiply to give 12 and add to give 7. That's going to be 4 and 3. So we can write this as x plus 4 times by x plus 3. Now, to find the x-intercepts, we can reverse those signs. We have minus 4 and minus 3, drawing those on very approximately. Now, guys, we know the general shape of a quadratic is this kind of U shape, so we're going to draw this just like so. That wasn't too bad. If we want to, we could put on the y-intercept, guys. It would be that number on the end, the 12, but we wouldn't have to in this question. Finally, shade the region. How are we going to know whether it's going to be this side of our graph or the side below? What we're going to do, guys, is we're going to substitute in the point 0, 0, this coordinate here. Now, if that gives us an equation which is correct, if it makes sense, if the answer is correct when we substitute it in, then we're going to be shading the side of the graph which has the point 0, 0 on. And if it's not correct, if the equation doesn't make sense, then we're going to be shading the other side. Let me show you what I mean. So, substituting in 0, 0, we're going to have y equals 0 and x equals 0. What's that going to give us? It's going to give us that 0 is less than or equal to 0 squared plus 7 times by 0 plus 12. Now, the 0 squared and the 7 times by 0 will just go to 0. So the equation becomes that 0 is less than or equal to 12. Is that correct? Yeah, it is correct. 0 is less than or equal to 12. So we know that we're going to be shading the side of the graph which has the origin on it, which has the point 0, 0 on it. So the final step, guys, is going to be to do our shading. Let's use a nice yellow color. So just coming around the graph like this, we're going to be shading the entire side of the line which has the point 0, 0 on it. That, guys, is how we're going to be shading regions defined by quadratic inequalities. If you weren't sure there about the moving parts, for example, sketching the quadratic in the first place, make sure you watch our video on that. Hopefully it will clear it up. How to shade regions on graphs defined by multiple different graphical inequalities in 140 seconds. Let's go. When it comes, guys, to shading regions on graphs which are defined by multiple different inequalities, what we're going to do is we're going to identify the regions which are satisfied by each of the individual inequalities. Then we're going to use that to identify the region which satisfies both. Let me show you what I mean. First of all, let's sketch on the graphs of y equals minus 2x plus 1 and y equals 3x minus 3. If you're not sure why we're doing that, guys, watch our previous video which involves sketching individual inequalities. So firstly, sketching on y equals minus 2x plus 1 and y equals 3x minus 3. Firstly, let's deal with the orange one, y equals minus 2x plus 1. This one's going to have a y-intercept of 1 and a gradient of minus 2, guys. So we can plot that on just like so, joining those lines together nicely. And in this case, guys, because we have a greater than sign here without the or equal to, we're going to need to use a dotted line. Again, if you're not sure about that part, guys, watch our previous video. That should clear it up. I'm just going to turn this from a solid line into a dotted line. Now, guys, we can come over to sketch y equals 3x minus 3. What are we going to do this time? Switching to green, a y-intercept of minus 3 and a gradient of 3. So we're going to go 1 across 3 up, 1 across 3 up. That's going to allow us to identify a few points, and then we can join those together like so. Now, guys, we have both of our lines drawn onto our graph. What can we do? We can identify which side of the lines we want. For the orange one, what are we going to have? Well, we want the area of the graph where y is greater than minus 2x plus 1. So it's going to be above that line that we want to shade. I'm going to mark that just with a nice little shading. Let's use a small size there. So it's going to be the side which is above that orange line. What about in the case of our green line? We have y is less than or equal to 3x minus 3. So this time, guys, it's going to be the other side of that line. It's going to be the right-hand side, or underneath that line, I should say. So we can shade that, the right-hand side or underneath that line. That's because y is going to be less than that. And now, guys, what can we see? We can see that the region of the graph which satisfies both of these inequalities is going to be this one over here. Why? Because it's simultaneously above the orange line and below the green line. So that, guys, is going to be our answer. Let me shade that a little bit more just to make it clear, guys. Now we can see which region of our graph it's going to be. It's going to be this region on the right-hand side. How to identify key regions on distance time graphs in 87 seconds. Let's go. When it comes, guys, to working with our distance time graphs, one of the most important skills is going to be identifying key regions on the graph. Let's have a look at this question here to see what I mean. The question says that the distance time graph below shows Tom's journey on his weekend hike. It then asks between which hours is he firstly walking fastest, secondly stationary, and thirdly walking home. What do we think, guys? When is he going to be walking fastest? He's going to be walking fastest when his rate of change of his distance is the highest, and that's going to be where the gradient of the curve is the highest, where the curve is the steepest. We can see that the curve is the steepest here between hours 4 and hour 5. So that's going to be our answer to the first one, between hours 4 and 5. Now, when is he going to be stationary, guys? That's going to be our second one. What does stationary mean? It means that he's not moving, and we can see that his distance stays the same. When he gets to 2 miles away from home, when is that going to be? It's going to be between hours 2 and hour 4. His distance doesn't change, so that's going to be the time period for which he's stationary. So what's our answer, guys? It's going to be between hours 2 and 4. Finally, guys, when does he start walking home? He starts walking home when his distance away from home starts decreasing. We can see that he gets all the way to 5 miles away from home. And then after that, it starts going down. When does it start going down, guys? It starts going down after hour 7, and he gets home at hour 11. So we can say, guys, that the time period in which he's walking home is between hours 7 and 11. How to calculate average speed using a distance time graph in 84 seconds. Let's go. Sometimes, guys, we might get given a question like this, which gives us a distance time graph like so, and asks us to calculate an average speed between two different times. What do we do in that situation, guys? We're going to do our change in distance divided by our change in time between those 2 points. Let me show you what I mean. So this question says that the distance time graph below shows Tom's journey on his weekend hike. It then asks us what his average speed is between hours 2 and 7. We're going to work out the change in distance between hour 2 and hour 7, the change in time between hour 2 and hour 7, and then we're going to do our change in distance divided by our change in time. Let's get it done. So we're going to write down that our speed is equal to our change in distance divided by our change in time. Now at hour 2, what's our distance? Our distance is 2. And at hour 7, what is our distance? Our distance is 5. So we can see that our change in distance is going to be 3. We get that by doing 5 minus 2. So our change in distance is 3. What about our time? We go from hour 2 to hour 7. So guys, our change in time is going to be 7 minus 2, which is 5. So our answer, guys, is going to be 3/5. If we wanted to, we could convert this to a decimal. It would be 0.6. And finally, guys, we cannot forget our units. What are they going to be? We're working in speed. We have our units in distance. Sorry, we have our distance in miles. We have our time in hours. So guys, our answer for our units in speed is going to be miles per hour. How to identify the key regions on speed time graphs in 106 seconds. Let's go. Just like with our distance time graphs, guys, sometimes we could get given a speed time graph and be asked to identify some key regions. Let's have a look at this question here. It says that the speed time graph below shows Tom's speed on the way to work. It then asks between what hours is he firstly accelerating, secondly at a constant speed, and thirdly decelerating. Guys, what do we think he's going to be accelerating when his speed is increasing? We can see that the value of his speed is increasing firstly between hours 0 and 3 because we have a positive gradient there, and then between hours 5 and 7. So there's actually going to be two regions of this graph where his speed is increasing, which means he's accelerating. That's going to be between hours 0 and 3. Let's get that written in. So we have 0 and 3. And the other region, guys, what's it going to be? Let's write and in there. It's going to be between 5 and 7. So that's going to be the second part to that first answer. Now, what about the second one, guys, which asks us when he's at a constant speed? Guys, he's going to be at a constant speed when his speed is not changing. We can see down here that we have this flat part on the curve between hours 3 and 5, and between hours 3 and 5 his speed is at a constant of 3 miles per hour. So guys, that's going to be our answer to the second one. It's going to be between hours 3 and 5. Let's get that written in. Finally, guys, when is he decelerating? What do you think? Pause the video now, give it a go. He's going to be decelerating at the end of his journey because his speed is decreasing at the end of his journey. He starts off at a speed of 6 miles per hour and he ends at a speed of 0 miles per hour. He goes all the way from 6 down to 0, just like so. When, guys, is he going to be decelerating? It's going to be between hour 7 and hour 9 when he finally stops. So that, guys, is going to be our answer to the final one. He's going to be decelerating between hours 7 and 9. How to calculate acceleration from a speed time graph in 87 seconds. Let's go. Sometimes, guys, we might get given a speed time graph like this one and be asked to calculate our average acceleration between two times. What do we do then? We're going to use the fact that our average acceleration is going to be equal to our change in speed divided by our change in time. So let's write that in. We're going to have that our acceleration is equal to our change in speed divided by our change in time. Let's have a look then at how to apply this to this question here. It says the speed time graph below shows Tom's speed on his weekend hike. It then asks us to calculate his average acceleration between hour 3 and hour 7. Let's have a look for our change in speed and our change in time. First of all, our change in time, we go from hour 3 to hour 7. 7 minus 3 is 4. So our change in time is going to be 4 hours. Let's write that on the denominator. Now let's have a look at our change in speed. What's it going to be? We can see at hour 3 that his speed is going to be 3 miles per hour. Let's circle that. And we can see at hour 7 that his speed is going to be, what's it going to be? Let's read across. It's going to be 6 miles per hour. So guys, our change in speed is going to be 6 minus 3, which is 3. Now we have our answer, 3/4. If we want to, we could write this as a decimal. It would be 0.75. And what are our units going to be, guys? Well, we have acceleration. Our speed is in miles per hour and our time is in hours. So guys, our answer is going to be miles per hour squared. That is going to be the units for our acceleration. How to calculate total distance traveled from a speed time graph in 158 seconds. Let's go. Questions like this, guys, are pretty tricky and they do come up a lot. Let's have a look at this one. The question says that the speed time graph below shows Tom's speed on his weekend hike. Our guy Tom, he does like to hike, doesn't he? It then says calculate his total distance traveled. Guys, how do we find total distance traveled from a speed time graph? We're going to find the total area under the curve. Step number one then, guys, that's going to be to split our area up into a few shapes, which we can nicely work out the area of. We can divide our shape here, here, and here. Why did I choose to divide them here, guys? Because it gives us a nice triangle down here in the bottom left. It gives us a rectangle and it gives us a trapezium here. We know how to work out the area of all of those shapes, so we can do that and add them together. What are we going to have? We're going to have that the area of this triangle is going to be a half times by the base times by the height. We have a base of 3 and a height of 3, so we're going to have a half times 3 times 3. That, guys, is going to be 4.5. See if you can get that. What about the rectangle here then, guys? This time we're going to have a base of 2, taking us from 3 to 5. We have from 3 to 5, and we're going to have a height of 3, taking us from 0 to 3 up here, so we're going to do 2 times by 3. That, guys, is going to be 6. Now, finally, the area of this trapezium on the end, what's it going to be? To work out the area of a trapezium, guys, we're going to do a half times by A plus B times by H, where A and B are the top and the bottom of our trapezium, and H is our height, which is going to be this distance here. Let's get it done. So we're going to have a half times by A plus B. So we're going to have A, that's going to be the side over here from 0 to 3. It's going to have a height of 3. So we can do a half times by 3 plus our other side length here. What's it going to be? It's going to take us from 0 to 6, so it's going to be a side length of 6. And then, guys, we're going to times that by our height. Our height, we go from 5 to 10. Our height, guys, is going to be this length here for the trapezium. From 5 to 10, that's going to be a height of 5, because 10 minus 5 is 5. Now, guys, we can calculate this. What's it going to be? 3 plus 6, that, guys, is going to be 9. 9 times by 5, that's going to be 45, and then we can halve that. We're going to get 22.5 as our answer for the area of that trapezium, guys. Finally, we can add all of our areas together. We're going to have 4.5 plus our 6 plus our 22.5. What's that going to give us, guys? 4.5 plus 22.5. That is going to be 27 plus our 6. That, guys, is going to give us 33. So now we have our answer, 33. What about our units? So, well, we're working in total distance traveled. Our speed is in miles per hour and our time is in hours. So, guys, our distance is going to be in miles. We get then our answer, 33 miles. How to estimate the area under a curve in 213 seconds. Let's go. These questions, guys, which ask us to estimate the areas under curves, can be pretty challenging. Let's have a look at this one. The question says, estimate the area under the curve below and hence the total distance traveled. Guys, why is this one going to be tricky? It's going to be tricky because we actually have a smooth curve here. And what that means is that we can't divide this nicely, or perfectly, I should say, into a group of shapes. However, what we can do is we can approximate it by drawing a few shapes under that curve. Let me show you what I mean. So we can see that our time goes from 0 to 12. So we're going to start off by deciding to divide this into 3 shapes. And that means that each of our shapes is going to have a width of 4. So we're going to divide this into 3 shapes. Each one's going to have a width of 4, drawing this on. Now, why did I choose 3 shapes? That was fairly arbitrary, to be fair. Now, I chose 3 because it was a nice convenient number for this. And it's going to give us a few shapes which fit closely to this curve. Now, guys, connecting these points together, we're going to see that we get 3 distinct shapes which come close to our curve. And I didn't actually draw that final line on, did I? Let me draw that on here. So we have the final line on there at the 12, allowing us to have our third part of that shape. And then joining those together, guys, we can see that we have 3 shapes here. We have a triangle here. We have a trapezium in the middle, and we have another trapezium on the right-hand side. Finally, guys, what we're going to have to do is estimate the areas of these. To work out the area of the triangle, we're going to use a half times by base times by height. We can see we have a base of 4 and a height of 4, so we can do a half times by 4 times by 4. What's it going to be? A half times by 4 times by 4. That is going to give us 8, guys. Check that you can get that. Pause the video if you want to have a look. Now, guys, how do we work out the area of a trapezium? We do a half times by A plus B times by H, where A and B are the top and the bottom of our trapeziums, those 2 parallel sides, and H is our vertical height. That, guys, this time is going to be this distance here. So what are we going to have? We're going to have a half times by A plus B. What's A going to be? A is going to be 4. What's B going to be? B is going to be, oh, it looks like it goes up to 5.5 there. So we're going to have 4 plus our 5.5, and we're going to multiply this, guys, by our vertical height. What's our height going to be? We go from 4 to 8, so again, our height is going to be 4. Where can we go from here? We're going to simplify this. What are we going to have? 4 plus 5.5, that's going to be 9.5. 9.5 times by 4, guys, that is going to be 38. 9.5 times 4, that's going to be 38. Then, guys, times by a half, that is going to give us 19. So we have the area there of 19. Now, guys, finding the last one, what's it going to be? We have a vertical height here of 5.5. We have a vertical height here of 6. So working out the area of this trapezium, we're going to have a half times by 5.5. Plus 6, and then we're going to multiply that by our height of our trapezium, and that's going to take us from 8 to 12, so it's going to be 4, so we're going to times this by 4. Now, guys, simplifying this, what are we going to have? 4 times by a half, that's going to be 2. 5.5 plus 6, that's going to be 11.5. 2 times by 11.5, guys, that's going to give us 23. Now, guys, we can finally add together all of our different values. We have the area of the triangle, which is going to be 8, plus the area of the center trapezium, that's going to be 19, plus the area, guys, of the final trapezium, that's going to be 23. What's this going to simplify to? We're going to have 19 plus 23, that's going to be 42. 42 plus 8, that's going to be 50, guys. So our final answer is going to be 50. Our units, total distance traveled, we have speed over here in miles per hour, and we have time in hours. So, guys, our units for our distance is going to be miles. How to use conversion graphs in 73 seconds. Let's go. Questions like this, guys, which ask us to convert one unit to another using a graph, are pretty common in exams. Let's have a look at this one. The question says, use the graph below to estimate how many pounds are equivalent to 4 kilograms, guys. What we're going to have to do is go to our kilograms axis, find our number 4, draw a line up to our curve, then read it across to see how many pounds it is. Let me show you. So going to 4 on our kilograms axis, what are we going to have? We're going to have this point down here. Then we're going to draw a line up to our curve. We can see that they meet at this point here. Then what are we going to do? Crucially, we're going to use a ruler and we're going to draw a line across to where this point will go and meet our y-axis, which has our pounds. Now, guys, we can see that it crosses the axis just here. What is that going to be in pounds? We can see that halfway between our 8 and 10, we have another line there, which is going to be 9. And now we can see that our orange line there that we've drawn across meets just below our 9, and it doesn't look like 8.9, does it? It looks more like 8.8. So, guys, we're going to go with 8.8 as our answer. We're going to say that 4 kilograms is equal to 8.8 pounds. Don't worry, guys, about being too precise here. They're going to be pretty lenient. As long as you follow the right method and get it roughly right, you're going to get all of the marks. How to match different shaped containers to graphs in 151 seconds. Let's go. Questions like this, guys, are going to be super common in our foundation papers. Let's have a look at this one. The question says that the following containers are filled with water at a constant rate. It then asks us to match each container with the graph, which shows how the depth of water changes over time. We can see that we have 4 pictures here. Hopefully you like my drawing, and we have 4 graphs to match them to. Let's have a look. First of all, graph number 1. Which one are we going to match this to? We can see that for this graph, initially the depth of water is increasing slowly, and then suddenly the depth of water starts increasing much faster. This one, guys, do you know which one it's going to go with? It's going to go with this picture here. Why is that? That's because initially we have a very wide base, which means that the depth of water in the container is going to fill slowly, but then suddenly it gets a lot narrower, and that means that the depth of water is going to start increasing faster. So when the water gets to this point, it's going to be associated with this point down here on the graph. Now, what about this graph here? We can see again initially that we're increasing in depth slowly, and this increases gradually over time, so that the depth of water is increasing at a faster rate over time in a smooth way. Which one's it going to go with, guys? It's going to go with this graph over here. Why? Because we start off with a very wide base, which means we're going to be filling slowly, and then over time we get gradually thinner and thinner, which means that gradually over time the rate of increase of the depth is going to increase. Now, what about this graph here? We can see that in this graph, the depth is increasing at a constant speed over time. Which one's that going to go with, guys? It's going to go with our picture on the left over here. Why? Because for this container over here, the width is the same all the way up. So what's going to happen if the width is the same? The depth is going to increase at the same rate for the entire duration of the container filling with water. Finally, guys, process of elimination. You could have probably told already, I don't want to rub it out, do I? You probably could have told already that this graph over here goes with this picture here. How do we know? We know that because initially the depth of water is increasing very quickly, but gradually over time, the rate of increase of the depth decreases and the gradient of that line gets smaller. That's going to go with this picture here, guys. Why? Because initially we have a very thin container which is going to be increasing in depth very quickly. It's going to be filling up quickly, and over time as it gets thicker, the rate of change of the depth is going to decrease. That's why it's going to go with this graph over here. That, guys, is how we're going to match different pictures with different graphs. That one was a lot to get through. Hopefully everything made sense. How to use a gradient to work out a rate of change in 81 seconds. Let's go. Sometimes, guys, we're going to be given a graph like this and be asked to calculate a rate of change. What do we do in that situation? Well, we can use the fact that the gradient of our line is going to give us the rate of change. Let me show you what I mean. The question says that the graph below shows how Tom's speed changes over time on his weekend hike. It then asks us to calculate the rate of change of his speed between hour 5 and hour 7, guys. What are we going to do? We're going to find the gradient of the line between hour 5, which is here, and hour 7, which is here. Guys, we know how to find the gradient of a line. We're going to do our change in y, otherwise known as our change in height, divided by our change in x, which is going to be how far across we are. What's our change in y? Our change in y in this situation, guys, we're going to go from a speed of 3 to a speed of 6, so it's going to be 3. So our change in y, our change in speed is going to be 3. Let's write that in. So change in y divided by change in x, we're going to have 3 on the top. And what about our change in x, guys? We go from a time of 5 to a time of 7. So that's going to be a change in x of 2. So, guys, our answer is going to be 3 over 2, otherwise known as 1.5. Now, what about our units here? Well, let's have a look back at the question. The question says, calculate the rate of change of his speed. Now, what's our units going to be? It's actually going to be miles per hour. So how many miles per hour he changes every hour. We can write that, guys, as miles per hour squared. Let me write that in, miles per hour squared. And that is going to be our answer to this one. How to calculate the average gradient of a curve between 2 points in 53 seconds. Let's go. Sometimes, guys, we might get given a question like this one, which asks us to calculate the average gradient of the curve below between the points 1, 3 and 4, 17. What are we going to do? Just like with any other gradient question, guys, we're going to do our change in y between those 2 points divided by our change in x. Let's get it done. So we're going to have our change in y divided by our change in x, our change in y. In the y direction, we go from 3 units up to 17 units up. 17 subtract 3 is 14, so the change in y, guys, is going to be 14. What about our change in x? In the x direction, we go from 1 across to 4 across, so that change in x is going to be 4 minus 1, which is going to be 3. And there, guys, we have our answer, 14 over 3. If we wanted to, we could write this as a decimal. If we did, what would it be? It would be 4.6 reoccurring. That, guys, would be our answer as a decimal, but we could have left it as a fraction in this one because they didn't ask us to convert it. How to calculate instantaneous rates of change in 124 seconds. Let's go. Questions like this one, guys, are super common in exams, especially our higher paper. Let's have a look at this one. The question says, the graph below shows the altitude of a balloon which is falling from the sky. It then asks us to estimate the rate of descent of the balloon after 8 minutes, giving our answer in kilometers per minute. Guys, what do we reckon in this case? We're not just going to be able to do our change in y divided by our change in x between 2 points on the curve. Why? Because the gradient of the line is always changing. We can see that the gradient of the line here is decreasing. It's getting steeper and steeper in a negative direction. So what are we going to do? The first step is going to be to draw a tangent to the curve at the time at which we're trying to find the gradient. So in this case, we're going to have a tangent just at this point here. Now, why is this a tangent? This is because this is going to be the tangent to the curve at the time of 8 minutes. And why did we choose 8 minutes? Because we're looking for the rate of descent of the balloon after 8 minutes. So we draw a line which is parallel to the curve, touching it at exactly 1 point at the time 8 minutes. Now, guys, what we can do is find the gradient of this tangent to the curve. How do we do that? We choose 2 points that we know on that line and do our change in y divided by our change in x. Let's get it done. So first of all, choosing 2 points, which ones shall we choose? Let's choose this one here. That looks pretty clear. This one is 6 across and 30 up. And let's choose this one down here. That one's also pretty clear. This time we have 10 minutes. And how many up is it? It's going to be 10. Now, guys, we can do our change in y divided by our change in x. Switching to orange, we're going to have change in y divided by change in x. What's it going to be? In this case, we go from 30 units up to 10 units up. That's a decrease of 20. So our change in y is going to be minus 20. What's that change in x going to be? We go from an x value of 6 to an x value of 10. So the change is going to be positive 4. That's going to take our denominator now. We can simplify this. Minus 20 divided by 4. What's it going to be? It's going to be minus 5, guys. So that is going to be our answer. And luckily, they've given us our units, kilometers per minute. So let's write those in. We have minus 5 kilometers per minute. And that, guys, is going to be our answer. How to use Pythagoras' theorem to work out a hypotenuse in 77 seconds. Let's go. This, guys, is another super common exam topic. Have a look and see if you can get it. The question says, calculate the value of x. And then we've been given this right angle triangle down here. We've been told two side lengths of 5 centimeters and 12 centimeters, and x is going to be that hypotenuse, the side length opposite the right angle. What are we going to do? We're going to use Pythagoras' theorem. Why? Because we're dealing with 3 side lengths of a right angle triangle. What does Pythagoras' theorem tell us, guys? It tells us that a squared plus b squared, I don't want to rub that out, I want to circle it. It tells us that a squared plus b squared is equal to c squared, where a and b are our 2 non-hypotenuse sides and c is our hypotenuse. So we can substitute our values in and solve it to find the value of x. Let's see what we're going to get. A and b are going to be 5 and 12. Doesn't matter which one is which, so we're going to have 5 squared plus 12 squared, that's going to be equal to c squared, which is our x squared. Simplifying this, what are we going to have? 5 squared is 25, plus 12 squared is 144. That's going to be equal to x squared. 25 plus 144 is going to be 169. So 169 is going to be x squared. Now to find the value of x, guys, we can square root both sides. We're going to get that x is equal to the square root of 169, which is going to be 13. So we found our hypotenuse. It's going to be 13 centimeters. How to use Pythagoras' theorem to work out a non-hypotenuse side in 89 seconds. Let's go. Questions like this, guys, trip people up a lot, and I've got to say they do come up all the time. Let's have a look. The question says calculate the value of x, and we've been given this right angle triangle here. We've been told 2 side lengths of 4 centimeters and 5 centimeters, where 5 centimeters is our hypotenuse, and we've been asked to calculate the size of x, which is our other non-hypotenuse side. What are we going to do in this case, guys? Because we're dealing with a right angle triangle and a question which involves 3 side lengths, we're going to be using Pythagoras' theorem, which tells us that a squared plus b squared equals c squared, where c is our hypotenuse and a and b are our other 2 sides, guys. How are we going to solve this? We're going to substitute in all of our values, including our x, and then we're going to rearrange this to find the value of x. Let me show you what I mean. So we know that a squared plus b squared equals c squared, where x and 4 are our a and b. Doesn't matter which one is which. So we can write in then that x squared, let me switch to a nice orange pen. We can say that x squared plus 4 squared is equal to 5 squared. We can simplify this. We can say that x squared, 4 squared is 4 times by 4, which is 16. That's going to be equal to 5 times by 5, which is 25. Now, guys, we can solve this to find the value of x. We can take 16 away from both sides. We get x squared equals 9. And then we can square root both sides. We're going to get that x is equal to the square root of 9, which is going to be 3, guys. So now we have our answer. The value of x is 3, and the length of this side is 3 centimeters. How to calculate the distance between 2 points in 118 seconds. Let's go. These guys are a really sneaky type of question. Why? Because they are actually hidden Pythagoras' theorem questions. Let me show you what I mean. The question says, calculate the distance between the points -2, and 1, 2. Step number 1, guys, to help us understand this, I'm going to draw these on a graph. Let's have a look. The point -2, that's going to be down here, and the point 1, 2, that's going to be up here. Now, how are we going to work out the distance between these 2 points? Let's firstly join them with a line, because that's going to be the distance we're looking for. How can we work this out? We're actually going to draw a right angle triangle which looks like this. We're going to draw a line which represents the x distance between the 2 points and another line which represents the distance in y between the 2 points. Can you see where this is going? We've actually drawn a right angle triangle there. Now we can work out the bottom length of this triangle, and we can work out the vertical height of this triangle. Then we can use Pythagoras' theorem to work out what is essentially the hypotenuse of our right angle triangle. Let's get it done. So in the x direction, we go from -2 to +1. That's going to give us a width of 3 along the bottom. In the y direction, we go from -2 up to +2. That's essentially going to give us a height of 4. Now, guys, we can use Pythagoras' theorem. Pythagoras' theorem, that tells us that a squared plus b squared is equal to c squared, where a and b are our 2 non-hypotenuse sides and c is our hypotenuse. So we're going to substitute in the values of 3 and 4. That's going to give us 3 squared plus 4 squared, that's going to be equal to c squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so we can say, let's work out over here that 25 is equal to our hypotenuse squared. Now guys, to find the value of c, our hypotenuse, we can square root both sides. We're going to get that c is equal to the square root of 25, which is going to be 5. So guys, we found our distance, it's going to be 5. Don't tell me that wasn't a sneaky question. Let me know in the comments if you got it. The fundamentals of the SO, CAR, and TOA acronyms in 72 seconds. Let's go. Here, guys, we have a really quick reminder of some of the fundamental ideas when it comes to using SO, CAR, and TOA for right-angled triangles. First of all, what actually are SO, CAR, and TOA? They're actually just going to be useful acronyms for helping us remember these three formulas here. Now, what actually are these formulas? These formulas are going to be useful for helping us work out angles and side lengths in right-angled triangles. I've drawn this triangle down here to give us an example of how SO, CAR, and TOA can be used. So, x here is going to be one of the angles in our right-angled triangle. The opposite side is going to be the side length, which is opposite that angle. The hypotenuse is going to be the side length, which is opposite the right angle, and the adjacent side is going to be the other side, or we could think of it as being the side which is next to the angle in our question. What does SO, CAR, and TOA help us with then? They help us to remember that the sine of our angle, in this case, is equal to our opposite side length divided by our hypotenuse. Cos of our angle is equal to our adjacent side divided by our hypotenuse. Tan of our angle is equal to our opposite side divided by our adjacent, and that is going to be really all that there is to it. Now, I know I haven't gone through how to work out side lengths and angles in this video. I'm going to cover that in the next 2 videos. How to use SO, CAR, and TOA to find a missing side length in a right-angled triangle in 118 seconds. Let's go. In this question, guys, we've been given a right-angled triangle. We've been told that the hypotenuse of the triangle is 12 centimeters. We've been told one of the angles is 32 degrees, and we've been asked to calculate the value of x, which is going to represent the length of the bottom side. What are we going to do? Because we have a right-angled triangle, we've been given one side, one angle, and asked to work out another side. We're going to be using SO, CAR, and TOA. Step number 1, we're going to write out SO, CAR, and TOA, and we're going to decide which one to use. How do we do that? We label the side lengths on our triangle. Opposite the angle, we're going to have our opposite side length. Opposite the right angle, we're going to have the hypotenuse, and our other side length is going to be the adjacent. Now, which one are we going to use, guys, in this question? The question is going to be involving the hypotenuse, which we've been given, and the adjacent side, which we want to find. So we're going to use CAR. That's the one which contains the adjacent and the hypotenuse. What, guys, does CAR actually stand for? It stands for the fact that cos of our angle, let's go back to green, cos of our angle, let's call it theta in this case, is going to be equal to our adjacent side divided by our hypotenuse. Now what can we do, guys? We can substitute in the values that we know and rearrange to find the value of x. Let's get it done. So cos of our angle, in this case, our angle is 32 degrees. So we're going to have that cos of 32 is equal to our adjacent side, which is x centimeters, divided by our hypotenuse, which was 12. Now, guys, we have an equation which we can rearrange to find the value of x. At the moment, x is being divided by 12, so we're going to multiply both sides of our equation by 12. When we do that, we're going to get that 12 times by cos 32 is going to be equal to x. Now, guys, we can type that into our calculator. 12 times by cos 32. What's it going to give us? It's going to give us 10.18 to 2 decimal places, guys. Give that a go. Type it into your calculator and see if you can get the same answer as me. How to find a missing angle using SO, CAR, TOA in 119 seconds. Let's go. Even if you've had a bunch of practice, guys, it's really easy to forget how to answer questions like this. Let's have a look at this one for a quick refresher. The question says, calculate the value of x. We've been given a right angle triangle. We've been told that 2 of our side lengths are 12 centimeters and 17 centimeters, and x is going to be this angle down here, guys. What are we going to do in this question? We've been given a right angle triangle, 2 side lengths, and asked to work out an angle, so we're going to be using SO, CAR, TOA. Let's write out SO, CAR, TOA. Now, which one of these are we going to use? To do that, let's label our side lengths opposite our angle. We have our opposite side. Opposite our right angle, we have our hypotenuse, and our other side is going to be our adjacent. We can see in this question, guys, that we've been given our opposite and our hypotenuse, so we're going to be using so. What does so actually stand for? Let's write it out. It stands for the fact that sine of our angle, let's go to orange here, sine of our angle is going to be equal to our opposite side divided by our hypotenuse. Now, guys, we're going to substitute in those values of the opposite and the hypotenuse that we know. We're going to substitute x in for our angle, and we're going to solve to find the value of x. Let's get it done. So we have sine of our angle, so we're going to have sine x here. That's going to be equal to our opposite side, which is 12, divided by our hypotenuse, which is 17. Now, guys, how do we get the x on its own? We're going to move that sine to the other side. And how do we do that? We use what we call sine to the minus 1. So we're going to write out that x is equal to sine to the minus 1 of our fraction 12 over 17. Now, guys, that is going to be a button on our calculator, which is located just above the sign. So if you hit shift and then sign, or function then sign, you should find it. So we're going to type in sine to the minus 1 of our fraction 12 over 17. And when we do that, guys, what are we going to get? We're going to get 44.9 to 1 decimal place, and that is going to be the size of our angle.
Questions like this, guys, which involve finding angles of elevation or depression for real life scenarios, actually come up pretty often in exams, and not many people at all get them right. However, the truth is that if you know how to do your so-called toa, then you should be getting these ones. Let's have a look. The question here says, given the following diagram of a boat and lighthouse, find the angle of elevation from the boat to the lighthouse. Guys, angle of elevation, what does it mean? It means that we want to find the angle between this horizontal line down at the bottom and the top of the lighthouse. We can see that we have this horizontal line here drawn for us. Not horizontal, I actually meant diagonal. Yeah, this diagonal line here drawn for us. We also have two lengths, 1.4 kilometers is the length of this diagonal line, and then 1 kilometer is the length of this horizontal distance at the bottom. Guys, what do? What we're going to do is we're going to turn this situation into one in which we have a right angled triangle. We're going to draw a straight line over the dotted line that they've given us. We're going to draw a line over our horizontal situation, and then we are also going to draw a line from the base of the lighthouse up to the top of the lighthouse. Let me just redraw that one, getting it nice and straight to make things clear. We essentially have a right angle triangle like this, and this here is going to be our right angle. Now that we have our right angle, guys, we might be able to spot, finding this angle here, that we have a so-called toa situation. We have a right angle triangle, we've been given two side lengths, and we want to find an angle. Step number one, we're going to label our side lengths. We have the side opposite the angle. We have the hypotenuse, which is opposite our right angle, and we have our adjacent side, which is next to our angle. Next step, based on the two side lengths that we have, we're going to select either so, car, or toa. We can see that the two side lengths that we have here, guys, are the adjacent side of 1 and the hypotenuse of 1.4. Because we have the adjacent and the hypotenuse, we're going to be using car. That is the one that has the adjacent and the hypotenuse. What does car stand for, guys? It stands for cos of our angle, in this case x, is equal to our adjacent side divided by our hypotenuse. In this case, our adjacent side is the one next to the angle of 1. And the hypotenuse is the side length opposite the right angle. It is going to be 1.4. So we can say that cos of our angle is equal to 1 over 1.4. And from there, guys, to find the size of x, we just need to do cos to the minus 1 of both sides. We're going to get that x is equal to inverse cos of 1 over 1.4. This, guys, is something we can bing into our calculator. I'm just going to move my head so you can see it on the vertical video if you're watching over there. Cos to the minus 1 of 1 over 1.4, guys. Let me just type that into the calculator. When we do so, we are going to get 44.42 to 2 decimal places, 44.42 to 2 decimal places. That, guys, is going to be our angle of elevation. Just a quick recap. What did we do there? We firstly converted it into a right angled triangle, and then we used our so-called toa to find our angle. Now, if the so-called toa part confused you, consider watching the video dedicated to using so-called toa to find angles in right angled triangles. This, guys, is a type of question that might come up towards the start or even middle of your paper, and not many students would actually get this. this because it does require us to use a little bit of initiative. Let's have a look at how to do it. The question says, find the height of the following equilateral triangle. First of all, guys, what is an equilateral triangle? An equilateral triangle is a triangle which has all side lengths the same size. So we can say that this side length over here is 6 centimeters, and this side length here is also 6 centimeters. Now, finding the height, guys, how are we going to do it? Let's just draw on a dotted line to represent our height. What we're going to do is we are actually going to use Pythagoras' theorem. Now, as the question says here, the diagram's not been drawn to scale. However, if it was, this vertical line, where would it go through? It would go directly through the center of this 6 centimeters. That actually stems from the fact that all of the angles in an equilateral triangle are the same as well. Now, what does it mean if it goes through the center? It means that this length on the left-hand side of our dotted line would be 3 centimeters, and the length on the right-hand side would also be 3 centimeters. Now, how can we use this? Have you spotted it? What we actually have here is 2 right-angled triangles in our triangle. If we turn this into a non-dotted line, I'll rub out that 3 centimeters as well, just to give us a little bit more room. We can see that this would actually be a right angle. So, how can we use Pythagoras' theorem to solve this? We know that for right-angled triangles, a squared plus b squared equals c squared. So a squared plus b squared equals c squared, where a and b are our 2 non-hypotenuse sides and c is our hypotenuse. In the case of the equilateral triangle here, the hypotenuse, the side opposite the right angle, is going to be 6. One of the side lengths, the side length down here, is going to be 3 centimeters, and then the other one is the one we're going to try and find out. So we're going to substitute those 2 values in. A is equal to 3 squared plus b squared is equal to, c is equal to 6, so 6 squared. 3 squared is 9 and 6 squared is 36, so we can say that 9 plus b squared is equal to 36. Now to find the value of b, guys, we can subtract 9 from both sides. We're going to get b is equal to 27. And then, b squared is equal to 27 is what I meant to say there. And then to find the value of b, we can square root both sides. We're going to get b is equal to the square root of 27. Now, if we wanted to, we could type that into our calculator. If we did so, what would we get to 2 decimal places? We would get 5.20. b equals 5.20 to 2 decimal places. But if it didn't ask us to write it as as a decimal is what I mean to say, we can just leave it in that form as the square root of 27. I've got to say, guys, bearings questions like this are definitely not the most intuitive. So if you haven't seen one before, make sure to pay very close attention to this key skill. The question says that Sarah is 8 kilometers west and 3 kilometers north of Laura. So 8 kilometers west and 3 kilometers north of Laura. Let's just write those 2 distances in, 8 kilometers west and 3 kilometers north of Laura. The question says, what is the bearing of Laura from Sarah? The bearing of Laura from Sarah. How are we going to think about this, guys? Well, the first step is going to be to draw a straight line connecting Laura and Sarah. That's not a straight line. That is a very curved line. Let's do that again. So Sarah and Laura. The bearing, guys, remember we measure bearings from the north line. So the bearing is going to be this angle here. Let's call it X for now. So how are we going to do this? Have you got any ideas? What we're going to do is we are actually going to use trigonometry to help us. We're going to turn this little situation down here into a right angle triangle. That is going to allow us to work out this angle here. We know that this is going to be a right angle, and that's going to allow us to work out this angle here. Or to be honest, we can actually just work out this angle here directly. And then we can subtract it from 180 to find the size of angle X here. So we're going to draw a right angle triangle and then use trigonometry to find this angle here, subtract it from 180. Let's get it done. Let's firstly convert these 2 arrows that I drew into straight lines. So I'm going to draw a straight line from here to here. And then I'm going to draw a straight line from here to here. We're going to draw a little square here to represent the fact that it's a right angled triangle. Now we can use trigonometry, we can use so-called TOA to work out this angle here. If you're not sure how to use trigonometry, guys, make sure to watch my videos on so-called TOA because you're going to want to go through that before this one. So, given this right angled triangle, how do we find the size of angle y? Step number one, we're going to label our side lengths as either the opposite, adjacent, or hypotenuse. Let me switch to a little green pen just to make things a little bit clearer. Yeah, that should be better. So opposite the angle, we have the opposite side. Opposite the right angle, we have the hypotenuse, and our other side length is the adjacent. We write out so, car, toa. We have so, car, and toa, and then we need to decide which one we are going to use. In this case, we have the opposite and the adjacent, so we're going to be using the one which includes O and A. We are, in fact, going to be using TOA. What does TOA tell us, guys? Switching back to orange, TOA tells us that tan of our angle, in this case tan y, is equal to our opposite side. In this case, our opposite is 8, divided by our adjacent side. In this case, it is 3. Next step to using so-called TOA to do this, guys, we're going to do tan to the minus 1 of both sides. So we're going to have tan to the minus 1 of 8 over 3, and that is going to be equal to, let's type it into the calculator, we have tan to the minus 1 of 8 over 3. Typing that in, what do we get? We are going to get 69.4 to 1 decimal place. How is this going to help us? Well, now we've found that the size of angle y is going to be equal to 69.4. We know that angles on a straight line add to 180, and we actually see that we have a straight line up here between the x and the y. Final step then is going to be to do 180, subtract our 69.4, 180 minus 69.4, that, guys, is going to be 110.6. Yep, 110.6. Guys, if you got that, superb work. Very tricky question there. Hopefully that made sense. We used trigonometry to find the size of angle y and then subtracted it from 180 to find the size of angle x.
A quick introduction to the sine rule formula and what it's used for in 93 seconds. Let's go. The sine rule, guys, is a really useful formula for working out missing side lengths and missing angles in non-right angled triangles. What are the two different versions of it? We have the version for finding side lengths, which is that a over sine A is equal to b over sine B, which is equal to c over sine C. And we have the version for finding missing angles, which is going to be that sine A over A is equal to sine B over B is equal to sine C over C. Now, in practicality, we never really use more than the first two parts of these formulas. And what's the relationship between the two formulas? Just to make them a bit easier to use, this version is just this version flipped upside down. So this version has the lowercase a and b on the top, whereas this version has the uppercase a and the uppercase b on the top. Now, when do we actually use the sine rule, and what are these lowercase and uppercase a's and b's? The lowercase letters, guys, are going to represent the side lengths in our angles, and the uppercase letters are going to represent the angles opposite those sides. So it's really crucial that our angle uppercase a is opposite our side length lowercase a, our angle uppercase c is opposite our side length lowercase c, and our angle uppercase b is opposite our side length lowercase c. Now, finally, when do we use the sine rule? We use it when we're working with a non-right angle triangle and our questions involve two pairs of opposites. It might be, for example, we have lowercase c and uppercase c in the question, as well as uppercase a and lowercase a, two pairs of opposites, guys. That's when we're going to use it. Watch our next two videos to see how to use the sine rule to work out missing angles and missing sides. How to find a missing side length using the sine rule in 129 seconds. Let's go. In this question, guys, we've been given a non-right angle triangle here, and we've been asked to calculate the value of x, which is one of our side lengths. What are we going to do? We're going to use the sine rule. Now, how do we know we're going to be using the sine rule? It's because we're dealing with a non-right angle triangle and two pairs of opposites. We can see this x and 62 degrees and this 14 and 84 degrees are pairs of opposite sides and angles. We have two of them, so we're going to be using the sine rule as opposed to the cosine rule. Now, which version of the sine rule are we going to be using? We're looking for a side length, which which is going to be x, and therefore we're going to be using this version over here, a over sine a equals b over sine b. This one's going to be a little bit easier, guys, because it has our side lengths on the tops of our fractions. So step number one, guys, we're going to label our sides and our angles. What are we going to have? We're going to have 62 degrees as uppercase A, and the opposite side length as lowercase a. We're going to have 84 degrees as uppercase B, and the opposite side length as lowercase b. Now, it doesn't matter which angle is A and B, but we have to make sure that the angles are the uppercase letters, the side lengths are the lowercase letters, and they're in pairs of opposites, where uppercase B is opposite lowercase b, and uppercase A is opposite lowercase a. Now, where do we go from there, guys? We substitute our values into our formula. Let's get it done. What are we going to have? We're going to have A, which is x, over sine A, which is going to be sine of 62. And that's going to be equal to lowercase b, which is going to be 14, over uppercase b, or sine of uppercase b, I should say, so sine 84. Now, guys, how do we get the x on its own to solve this equation? At the moment, it's being divided by sine 62, so we're going to multiply both sides of our equation by sine 62. We're going to get that a is equal to 14 over sine of 84. Times by sine of 62. This, guys, is now something that we can type into our calculator. What are we going to do when we get that? Let's type it in. 14 over sine of 84. And we're going to be multiplying that by sine of 82. Not 82, sorry. Sine of 62, I should say. Sine of 62. What's it going to give us? It's going to give us, going back to our orange pen, it's going to give us 12.43 to 2 decimal places. Our final answer. How to use the sine rule to find a missing angle in 135 seconds. Let's go. I've got to say, guys, this is probably one of the least popular topics in my course, but it comes up a lot and it's worth a lot of marks. Let's have a look. The question says calculate the value of x, where x is this angle in this triangle. We can see that the triangle is a non-right angle triangle. We've been given one angle, we've been given two sides, and we're working with two pairs of opposites. We can see that our x degrees is opposite our 14 centimeters, and our 82 degrees is opposite our 18 centimeters. What does that mean? It means that we're going to be using the sine rule. And which version of the sine rule are we going to be using? We're going to use sine A over A equals sine B over B. We could use the other one if we want to, but this one's just going to be easier. It's going to be less working out because it already has our angle on the top. So how are we going to apply the sine rule here? Step number one, we're going to label our angles and our sides. Remember, guys, angles are going to be our uppercase letters, and sides are going to be our lowercase letters, and our capital A is going to be opposite our lowercase a, and our capital B is going to be opposite our lowercase b. What can we do now, guys? We can substitute in our values to our formula. We have sine A, so we have sine of 82, over lowercase a, so we have 18, and that's going to be equal to sine of b. B is our x, so we have sine x, divided by lowercase b, that's going to be 14. Now, guys, we want to get x on its own. What are we going to do? First of all, we're going to move this divided by 14 over to the other side of our equation. That's going to give us that sine of x is equal to 14 times by sine of 82 over 18. Now, next step, guys, we can simplify that if we want to. What are we going to get? We're going to get 14 times by, typing this into our calculator in real time, sine 82 over 18. What's that going to give us, guys? It's going to give us that sine of x is equal to 0.770 to 3 decimal places. Final step then, guys, we're going to move that sign over to the other side. How do we do that? We're going to do sine to the minus 1 of both sides, and we're going to get that x is equal to sine to the minus 1 of 0.77. We can just type in there, and when we do that, what are we going to get? We're going to do sine to the minus 1 of 0.77. We type that in and we get 50.35 to 2 decimal places, and that is going to be, guys, our answer for x.
Questions like this, guys, which combine the sine and the cosine rule, actually come up quite often in exams, and they're worth a lot of marks. Now, I do want to make it clear, when going through this, I'm going to assume that you're really confident with both the sine rule and the cosine rule, so if you're not, make sure you watch my previous videos first. Let's have a look then. This one says, given the following diagram, calculate the length of AD. Now, AD is going to be the side length, which is between the point A and the point D. We can see that it's going to be this side length here on the left-hand side of our larger triangle. However, we don't actually have that much information about this left-hand triangle at the moment. We know that this side length down here is 8, but we don't actually have any other information to help us. That is where, guys, the other triangle is going to come in, and we are going to be using the sine rule to work out the common side length between these two left and right-hand triangles. That is going to be this side length here, connecting point B and point D. How do we know we can use the sine rule for this, guys? We know because we're going to be working with two pairs of opposites. We have this angle 50 and this opposite side length of 6, and then we have this angle 48, and we want to work out this opposite side length, which is side DB. Now that we know we're going to be using the sine rule, guys, we need to decide whether we're going to be using the one that has the side lengths on the top or the angles on the top. Because we want to work out a side length here, we're going to have the side lengths on the top of our fractions. Writing out the sine rule then, we're going to have that A over sine of A is equal to B over sine of B. And we have to remember, guys, that our lowercase letters are our side lengths and our uppercase letters are our angles. Next step, we're going to label our two pairs of opposites. We're going to label this side length A, the one that we want to work out, and the opposite angle is going to be uppercase A. And then we're going to have lowercase b for that side of 6 and uppercase B for the angle. Next step, guys, we're going to substitute in and rearrange for A. So subbing in, we're going to have A over sine of big A. Big A is 48, so we have A over sine 48. That is going to be equal to lowercase b, which is 6, over sine of uppercase B, which is 50. Next step, guys, we're going to rearrange this to make A the subject. In order to do that, we are actually going to multiply both sides of our equation by sine 48. Now, just to save a little bit of room on the screen, I'm going to do it like this. So I'm going to times this side by sine 48. And then I'm just going to rub out the over sine 48 on the left-hand side. That is going to be the effect of multiplying by sine 48 there. Next step, guys, we can bring this into our calculator. Let me do that now. We're going to have 6 over, and then we have sine of 50, and then we have times by sine of 48. Close those brackets. What are we going to get? We're going to get 5.82, I should say, to 2 decimal places. So we can say that the value of A is equal to 5.82. Where are we going to go from there, guys? We're going to write that onto our diagram. So we can say that this side length is 5.82. And now I'm just going to shift into my green pen to move on to the next part of this question. We see now that we want to work out this length of AD. So that's going to be this side length on the left. And we currently have two side lengths. We have the 8 centimeters and the 5.82. In order to use the cosine rule to work out a side length, though, what else do we need? We also need the angle in between the two sides that we know. So we need this angle here, angle ABD. How are we going to find that, guys? Any ideas? We are actually going to firstly find this angle here, angle DBC, using the fact that the angles in a triangle add up to 180, and then we can subtract that from 180 because these two angles on a straight line are also going to add up to 180. So doing that now then, we're going to do 50 plus 48, 50 plus 48. That is going to be 98, and then we're going to do 180, subtract 98, and that, guys, is going to be 82. So we know that this angle here is 82, meaning that this angle on the left is going to have to be 98, because 98 plus 82 is 180. Now, guys, that we've done all of that, we can do our final step, which is going to be using the cosine rule. What's the cosine rule formula, guys? You should know this if you're watching this video. It is a squared equals b squared plus c squared minus 2bc cos A, where uppercase A is the angle that we know, lowercase b and c are the two side lengths either side of that angle, and lowercase a is the side length opposite the angle that we know. Final step, guys, let's substitute in and rearrange to solve for A. We're going to have that a squared is equal to 8 squared plus 5.82 squared minus 2 times by 8 times by 5.82 times by cos of our angle, so cos of 98. To rearrange this for A, guys, we currently have a squared as a subject. We're going to square root both sides of our equation. Again, just to save a little bit of room, I'm going to write this on the same line of working out. So we're going to square root that left-hand side, we get A. Square rooting the right-hand side, we're going to have the square root of all of that. Final step, guys, let me type this into my calculator and see what we get. We're going to have the square root of 8 squared plus 5.82 squared minus 2 times by 8 times by 5.82 times by cos of 98. Close those brackets, calculate it. Guys, as our answer, we are going to get that A is equal to 10.53. And our units, guys, are going to be centimeters because all of our side lengths are currently in centimeters. Guys, that was a mammoth of a question. If you're watching on the vertical video, my head kind of got in the way a bit there. Hopefully that was clear enough. We had to use the sine rule first of all, and then we finished off by using the cosine rule.
The fundamentals of the cosine rule formula in 72 seconds. Let's go. The cosine rule, guys, just like the sine rule, is going to be a useful formula for working out missing side lengths and missing angles in non-right angled triangles. We have, again, just like with the sine rule, two versions of the formula. Let's have a look. When we want to find a missing side length, we're going to be using a squared equals b squared plus c squared minus 2bc cos a. And when we're finding a missing angle, we're going to be using that a, our missing angle, is equal to cos to the minus 1 of b squared plus c squared minus a squared over 2bc. Now, guys, I've got to say, these formulas are long and they do look pretty intimidating, but don't worry. When it comes to applying them, they're really not too bad. For that, watch our next couple of videos. Now, when do we use these formulas, guys? We use them when we're working with, like I say, a non-right angled triangle, and we're finding either a missing side length or a missing angle. And in particular, we're dealing with a question which involves all three of our side lengths, A, B, and C, lowercase letters, and a missing angle, uppercase A. Now, we could be given, for example, uppercase A and B and C and asked to work out lowercase a, or we could be given B, A, and C, all lowercase, and asked to work out uppercase A, our angle. All of those are possibilities, guys, and I'll be covering them in the next couple of videos. How to find a missing side length using the cosine rule in 107 seconds. Let's go. In this question, guys, we've been given a non-right angled triangle down here, and we've been asked to calculate the value of x, which is our missing side length over here. What are we going to do? We're going to be using the cosine rule. Now, how do we know we're going to be using the cosine rule? We know because we have a non-right angled triangle here. We've got a question which involves all three side lengths. We have 8, 7, and x, the side that we want, and crucially we've been given the angle opposite the side length that we're looking for, that's side length x. So we're going to be using the cosine rule. Step number 1, we're going to label all of our angles and our sides that we need for this question. Our missing angle, that is going to be our uppercase A, and the side length opposite is going to be lowercase a. The other two side lengths there are going to be our B and our C. It doesn't matter which one is which in this case, so we're going to have B and C. Let's say that we give B to that 8 and we give 7 to that C. Again, doesn't matter which one is which. Now, guys, what we're going to do is substitute all of our values into the cosine rule. What are we going to have? We're going to have a squared, so we're going to have x squared, and that's going to be equal to b squared plus c squared, so 8 squared plus 7 squared, minus 2bc cos a, so 2 times by b, which was 8, times by c, which was 7, times by cos a, so cos of our angle, 62. Now, guys, we can simplify that right-hand side, typing it into our calculator. Now, luckily, just to save a bit of time, I've already done this, and what do we get? We get 60.419 to 3 decimal places. Now, guys, to find the value of x, we have the value of x squared, so we're going to square root both sides. That's going to give us x. We're going to have x equals the square root of 60.419, and when we type this into our calculator, guys, the square root of 60.419, what are we going to get? We're going to get 7.77 to 2 decimal places, and that is going to be our answer for the value of x. How to use the cosine angle rule in 97 seconds. Let's go. This, guys, is another topic which looks super difficult when we don't know how to do it, but when we do understand it, it's not actually too bad. Let's have a look. This question gives us a non-right angled triangle down here and asks us to calculate the value of x, which is this missing angle. To answer this, guys, we're going to have to use the cosine angle rule. And how do we know that? We know it because we have a non-right angled triangle and we're finding a missing angle where we've been given all three sides. Because we've been given all three sides, guys, we can use the cosine angle rule. Let's get it done. Step number 1, that's going to be to label our angle and our sides with A, B, and C. Our uppercase A is going to be given to our angle. Our lowercase a is going to be given to the side length opposite that angle, and then our other two side lengths are going to be lowercase b and lowercase c. It doesn't matter which one is which. Now, guys, what we can do is we can substitute all of our values into our formula up here and then calculate it using a calculator. What are we going to have? We're going to have that capital A is equal to, so x equals cos to the minus 1 of this huge fraction here. We're going to have b squared plus c squared, so we're going to have 8 squared plus 6 squared minus a squared, so minus 5 squared. And all of that is going to be over 2bc, so 2 times by b, which is 8, times by c, which is 6. Now, guys, this is something which we can type into our calculator. Make sure we have these brackets here and make sure that we have this fraction. When we type that in, guys, luckily I've already done it. What are we going to get? We're going to get that x is equal to 38.62 to 2 decimal places. And that, guys, is going to be how we can use the cosine angle rule to find a missing angle.
Just like the previous example, guys, which required us to use the sine rule and the cosine rule, this is going to be another mammoth question. Let's have a look at this, and just to reiterate, I'm going to assume that you know the sine rule and also the cosine rule confidently for doing this question. I'm not going to explain those in detail. I'm going to assume, like I say, that you already know how to use them. Let's have a look. This question says, calculate the size of angle ABD. Angle ABD, guys, we're going to go from A to B to D. So that is going to be this angle here in our triangle. How are we going to do it? Well, first off, let's look at our triangle ABD, and see what information we're given. We can see that we have one side length here, we have another side length here, and that is actually all of the information that we have for ABD. We know that if we have all three of the side lengths for a triangle, we can use the cosine rule to work out any of the angles. So straight away we're thinking, can we work out this side length here, side length BD? In order to do that, we're going to look over at the right-hand triangle and we're going to see what information we have. We can see that we have one angle down here and the opposite side length, and then we have another angle down here of 50, and the opposite side length to that is actually the side length that we need in order to use the cosine rule for the other formula. For the other triangle, I should say. Let's work this out then. Let's use the sine rule, let's work out BD and take it from there. So, two pairs of opposites, we have 68 and 8.4. Let's label 68 capital A, 8.4 lowercase a, and then let's label uppercase B as the 50-degree angle, and the side length opposite that is going to be lowercase b. Doesn't matter which one's A, which one's B, guys, but we have to make sure that uppercase A is opposite lowercase a and uppercase B is opposite lowercase b. We also have to make sure that our lowercase letters are our side lengths and our uppercase letters are our angles. Let's write out our sine rule then, guys, and we're going to be using the version where the lowercase letters are on the top. We have A over sine A equals B over sine B. Next step, guys, we're going to substitute in our values and rearrange to find the value of B. So we're going to have 8.4 over sine 68 is equal to the other opposites, B over sine of 50. To rearrange this to make B the subject, guys, we're going to have to multiply both sides of our equation by sine 50. That is because B is currently being divided by sine 50. So to get the B on its own, we multiply both sides by sine 50. Now, to save a little bit of space, I'm going to write this below, then rub out the one on top and move it upwards. So we're going to get that B is equal to 8.4 over sine of 68 times by sine of 50. Like I say, I'm just going to quickly rub out what we have on top. In your exam, of course, you would leave that information there, and then we can move this up. Next step, guys, let's use our trusty calculator and calculate the value of B. So we're going to have 8.4 divided by sine of 50, and then, divided by sine of 68, I should say. Need to be very careful, guys. And then we're going to multiply that by sine of 50. We bring that into our calculator, and we're going to get that B is equal to 6.94 to 2 decimal places. So I'm going to write about B on our diagram and write in 6.94. Next step, guys, how are we going to work out the size of angle ABD? We're going to have to use our cosine rule. And in particular, we're going to have to use the cosine rule, which is optimized for working out the angle. What is that? How do we get it? I'll quickly go through this again, even though I did go through it a few videos ago. So what we're going to do is we're going to start off with our regular cosine rule. We have a squared equals b squared plus c squared minus 2bc cos a. And then we're going to rearrange this to make uppercase A the subject. At the moment, we have minus 2bc cos A. We don't really like that, so we're going to actually add 2bc cos A to both sides of our equation. We're going to get 2bc cos A equals, And then I'm also in this step going to subtract a squared from both sides of the equation, again, just to save a little bit of space. If you're not sure how to do this, or if this is a little bit confusing, watch the video a few videos ago, which goes through this method in detail for rearranging this cosine rule. So we have 2bc cos A equals b squared plus c squared minus a squared. What we did there, guys, was add 2bc cos A to both sides and subtract a squared from both sides. Now, guys, to make cos A the subject, we're going to divide both sides by 2bc, and that is because cos A is currently being multiplied by 2bc. What are we going to get? We're going to get that cos of A is equal to b squared plus c squared minus a squared over 2bc. Now what we can do, guys, is we can substitute our values of A, B, and C into this equation and then rearrange to find our missing angle. Let's do it now. I'm just going to rub out this little bit of working out for us to make things a little bit clearer. I'm going to move this formula up a bit, just like so. Guys, this is a longer one than normal. Let's see what we can do. The next question becomes which angles and which side lengths are we going to label with our uppercase A, our lowercase b, c, and a. Whenever we're dealing with the cosine rule, guys, the uppercase A is always going to be given to the angle that we're trying to work out or that we're given in the question. In this case, we're trying to work out the size of angle ABD, so that is going to be the angle that we're going to label A. This, by the way, has nothing to do with the fact that this point is currently labeled A. We just have to kind of ignore that. We can also ignore this one that we've labeled A down here. We're now dealing with a new triangle, so we have a new set of A, B, and C. So we're going to label that angle that we want as A. And then what we need to make sure is that the side length opposite that angle is our lowercase a. So we're going to label this one lowercase a, and then the other two sides, guys, are going to be our b and our c, and it doesn't matter which one is which. So we're going to label the 6.5 as b, and also the, 6.94 as our C. I'm going to quickly go over this stuff in green, guys, just to make it a little bit clearer, because I know there's a lot going on in this question. This is the information that we're now dealing with. Okay, substituting these values in, then what are we going to get? We're going to get the cos of our angle, and we're going to leave that as A for now, is equal to b squared plus c squared, so 6.5 squared, plus, and we're going to move this down a little bit. So we have 6.5 squared plus 6.94 squared minus 5 squared over 2 times by b times by c, so times by 6.5 times by 6.94. And then, guys, to get the value of A, what do we have to do? At the moment, we have the value of cos A. It's this entire expression over here. To find A, then, we're going to have to do inverse cos, or cos to the minus 1 of both sides. Again, just to save a little bit of room here, I'm going to do that on this same line of working out. So we do it to the left-hand side, and we're just left with A. We're going to have A equals, and then we're going to have cos to the minus 1 of this entire thing here. This is a mammoth, guys. If you're watching on the vertical video, my head has gone a little bit in front of it. Let me just move out of the way so you can see it there. Let's bring this into our calculator then and see what we get. So we're going to have A equals, and then getting our calculator out, we're going to hit shift cos. We're going to hit the fraction button, and we're going to do 6.5 squared plus 6.94 squared minus 5 squared over 2 times by 6.5 times by 6.94, and then we're going to move right, we're going to close those brackets, we're going to click equals, and guys, we're going to get 43.53 as our answer. 43.53 to 2 decimal places. That, guys, is going to be our answer to this question. An absolute mammoth. Feel free to watch that one again. So much going on. If that did make sense for you, good job, because that was tricky.
How to calculate the area of a triangle using a half AB sine C in 86 seconds. Let's go. This, guys, is a topic which is missed out in revision so often. Let's have a look. The question asks us to calculate the area of the following triangle, and we have this triangle here which has one side length of 9, another side length of 7, and the angle in between them is 63 degrees. Now, sometimes, guys, we can calculate the area of a triangle using a half times base times height, but in this case, we've not actually been given the height of the triangle. We've been given kind of a diagonal length here. So what are we going to do? We're actually going to use a different formula. We're going to use the area area rule, which is going to be that the area of a triangle can be calculated using a half times by A times by B times by sine C. Now, C is going to be one of the angles in our triangle. We can see here that our angle that we've been given is 63 degrees, so that's going to be our C, and then our A and our B are going to be the two side lengths either side of that angle. Now, it doesn't matter which one's A and which one's B, but they have to be the side lengths which are either side of that angle. Now, guys, finally, we can substitute those values in, and we're going to get that our area is equal to a half times by 8 times by B, so times 7 times by 9 times by sine of 63. Now, guys, when we type this into your calculator, luckily I've already done that. What are we going to get? We're going to get 28.07 to 2 decimal places, and that is going to be our answer. What about our units, guys? We're going to have centimeters squared because both of our side lengths are in centimeters. How to use a half AB sine C to find a missing side length of a triangle in 96 seconds. Let's go. Questions like this, guys, are pretty common in exams. Let's have a look. The question says, given that the area of the following triangle is 34 centimeters squared, calculate the value of x to 1 decimal place. Now, this is a little bit weird because normally we would be asked to work out the area. We wouldn't be given the area of the triangle, but we can actually do it using the same formula as we would use to work out the area. So what are we going to do this time? We're going to set up our equation knowing the value of the area. So we're going to substitute 34 in for our area, and then we're going to substitute our other values into the other side of our equation and rearrange to find the value of x. Let me show you what I mean. So we're going to have that our area is equal to, so we're going to have that 34, the area of our triangle, is equal to a half AB sine C, so a half times by 8 times by B. Let's label our sides. We have A and B here, and our angle is going to be C. So a half times 8 times B is going to be a half times by 8 times by x, times by sine C, so sine of our angle, sine 78. This, guys, is now an equation which we can rearrange to find the value of x. So first of all, let's simplify the right-hand side. We're going to have 34 equals a half times 8, that's 4. So we're going to have 4x times by sine 78. Now, guys, to get x on its own, what do we need to do? At the moment, it's being multiplied by 4, and it's being multiplied by sine 78. So we're going to divide both sides by 4 sine 78. What's that going to give us? We're going to get that x is equal to 34 divided by 4 sine 78. Guys, this is something we can type into our calculator, and when we do, I've already done it luckily, what are we going to get? We're going to get 8.7 to 1 decimal place.
When it comes, guys, to finding the area of a parallelogram, there are a couple of different types of ways the question can get asked, and one is definitely far more difficult than the other. This one is the more difficult kind. So, what are the two different kinds? This question says, find the area of the following parallelogram. Now, one way to find the area of a parallelogram is to multiply the base by the vertical height of the parallelogram. To multiply the base, in this case 30, by whatever the vertical height from the base to the top of the parallelogram would be. However, in this case, we've actually not been given the vertical height. We've been given the length of this diagonal side length on the left-hand side. We've also been given this angle down here. So what can we do? We can actually use a trick. And that trick is going to be to firstly split this parallelogram into two equal-sized triangles. So we can draw a diagonal line from the top left-hand corner to the bottom right-hand corner. And then we can see that we have two triangles. How do we work out the area of a triangle when we have two side lengths and the angle in between them? We can actually use the formula that the area of a triangle is equal to a half AB sine C. Now, if you're not sure about that one, watch my video, guys, on the area of a triangle using half AB sine C. This is a formula, guys, for working out the area of a triangle when we're given two side lengths and the angle in between them. The A and the B refer to the two side lengths, it doesn't matter which one is which, and the capital C is the angle in between them. So, in the case of the parallelogram with two equal-sized triangles of this side, we can actually use half AB sine C and then multiply it by 2 because we have two of those triangles. So we're going to do 2 because there's two triangles times by a half times by 24 times by 30 times by sine 57. We can grab our calculator, guys, and we can type this in. 2 times by a half times by 24 times 30 times sine 57. What's it going to give us? We type it in and we get 603.84 to 2 decimal places. Our units, guys, it's going to be centimeters squared because we're working with area and all of our lengths are in centimeters. So guys, we've had a look at how we can use area equals half AB sine C to find the area of a parallelogram. Now what about finding the area of an isosceles triangle? Now the first step here, guys, would always be to actually identify that this is in fact an isosceles triangle. How can we tell? We can tell from these 2 lines here, which indicate that these 2 side lengths have to be the same. So we can write on the side length on the left-hand side is 8 centimeters. And because these 2 side lengths are the same, we also know that the bottom 2 angles are also going to have to be the same. So this is 64. Where can we go from here? Well, we spot that if we had this top angle, then we could use area equals half AB sine C. Because we would have our A and our B, the angle in between them would be our C. So how can we work it out? We can actually use the fact that the angles in a triangle add up to 180. So we can do 180 minus 64 minus 64. What's that going to be? 64 plus 64 is 128. 180 minus 128 is actually 52. So we know that this top angle then is going to be 52 degrees. From there, what we can do is we can use area equals half AB sine C. So we have area equals half AB sine C. This is our formula. If you're not sure about this one, like I say, watch the previous few videos. We're going to substitute our values in. We're going to have a half times 8 times 8 times sine 52. We bring that into the calculator, guys, and when we do so to 2 decimal places, this is going to be behind my head if you're watching on the vertical video, this is going to be 25.22. Our units, guys, our lengths are in centimeters, and we're working in area, so it's going to be centimeters squared.
Applying the exact trig values in 79 seconds, let's go. I've got to be honest, guys, these questions which involve applying the exact trig values can be pretty annoying, but luckily we kind of follow the same process every time. Let's have a look. This question says, show that tan 30 plus tan 60 is equal to 4 root 3 over 3. What's the first step, guys? The first step is going to be to convert tan 30 and tan 60 into their exact values. Do we know them? Pause the video, have a think about it. Tan 30, guys, that is going to be the square root of 3 over 3. And what about tan 60, guys? That is just going to be the square root of 3. Now, how can we manipulate this left-hand side to make it look like the right-hand side? Well, we can see that we have our fraction here over 3. So we're going to rewrite this root 3 as some fraction over 3. And then we're going to add our fractions. Why? Because they're both going to be over 3. Now, what's root 3 as a fraction over 3? It's going to be 3 root 3 over 3. And that's because those 3's on the top and bottom would, in effect, cancel each other out. So we can write this as 3 root 3 over 3, I said, didn't I? Now, guys, simplifying this, we have the same number on the denominators, so we can just add those numerators. Root 3 plus 3 root 3, guys. What's that going to be? It's going to be 4 root 3. And on the bottom, we're just going to keep that 3. And now, guys, we can see that we've shown that the left-hand side of our equation is equal to 4 root 3 over 3. So we've done our proof.
I'm going to be honest with you guys, questions like this are super annoying. However, they do actually come up a fair bit in exams, so let's have a look at how to do it. The question says, find the value of x without using a calculator. In other words, this question is coming up in our non-calculator paper. We spot that we have a right angle triangle here. We've been given an angle and a side length, and we're asked to work out another side length. Here it's the hypotenuse. Step number 1, just like with any other right angle triangle like this, we're going to write out SO, CAR, TOA. We're going to have to use our trigonometry here. So we start off by writing out SO, CAR, and TOA, ignoring the spell check there. We label our side lengths. Opposite the angle, we have the opposite side. Our side length next to the angle is our adjacent side, and the side length opposite the right angle is the hypotenuse. Where do we go from there? Based on the information that we are given and want to work out, we choose either SO, CAR, or TOA. In this case, we've been given the adjacent, it's 5 centimeters, and we want to work out the hypotenuse of x, so we're going to use the one which includes the A and the H, that is going to be CAR. Okay, what does CAR actually tell us? CAR tells us that cos of our angle, so cos of our angle, in this case 60, is equal to our adjacent side divided by our hypotenuse. In this case, what are we going to have? We're going to have that our adjacent side is 5 and our hypotenuse is x. So let's substitute those in. Adjacent side is 5 and our hypotenuse is x. Where do we go from there? Normally what we would do is we would rearrange this. We would multiply both sides by x and divide both sides by cos 60. Guys, that's exactly what we're going to do. We're going to follow the regular process. So we multiply both sides by x. We get x times by cos 60 is equal to 5. And then we divide both sides by cos 60 to make x the subject. We're going to get x equals 5 divided by cos 60. Now, why is this annoying? This is annoying because we have to know the value of cos 60. If you haven't yet memorized your exact trig values, watch my video on the hand method. For me, that one's by far the best. You could also look up the table method. That one's pretty good. The hand method is going to be best. In this case, cos 60, I'll give a very quick demonstration. We put our left hand in front of our face. We have 0, 30, 45, 60, 90. This, our, what's it called, index finger, our pointy finger, let's call it, is our 60 degrees. We count the number of fingers above it. It's 1. So we have 1 over 2 as the value of cos 60. Now, I didn't explain that in detail. I have a full video for it, guys, hand method for exact trig values. We're going to substitute in then that cos 60 is equal to a half. We're going to get that x is equal to 5 divided by 1/2. 5 divided by a half, guys, that's the same as 5 times by 2. So x is going to be equal to 5 times 2, which is 10. If you were watching on the vertical video, it should be just down there. I'll move my head out the way. Hopefully that was clear enough, guys. This was like any other so-called tower question. The only difference was that we had to know the value of cos 60. Cos 60 is a half. We did that using the hand method. Watch my video on that if you're not sure how it's done. And then we just, follow the regular process and we get that x is equal to 10.
How to work with 3D Pythagoras in 208 seconds. Let's go. This, guys, is definitely one of the most challenging topics in the course. Let's have a look at this one and see if we can get it. The question asks us to find the length of the straight line connecting point F and point D. Where are those going to be? So point F, that's going to be in the top left-hand corner. And point D down here in the bottom right. Drawing on a straight line to join them, we can draw on that line there. Now, guys, when it comes to using 3D Pythagoras, what we're going to be trying to do is looking for opportunities to draw right-angled triangles in our diagram. In this case, if we draw a straight line over here connecting point B and point D, we can see that we've constructed a right-angled triangle, which is going to be that line there, FB, this line here, BD, and this line here, FD. Now, if we can find the hypotenuse of our triangle, then we found the length of FD. How are we going to find the hypotenuse, though? We're going to need FB first of all, and we're going to need BD, so let's work those out. First of all, FB, we know that GC, the height of our triangle, is 3 centimeters, and FB is going to be the same as that, so we can write in 3 centimeters for FB. Now, finding BD, that one's going to be a little bit more challenging. We're actually going to have to use Pythagoras' theorem in a different situation. Let me explain. Down here, we can see that we actually have another right-angled triangle. It's going to be the right-angled triangle which connects point A, point B and D, and also point A and D. We have another right-angled triangle there, guys, where the right angle is in this corner of our base rectangle. Now, what are we going to do? We're going to use Pythagoras' theorem. We can write on that the side length AB is 5, and that's because CD is 5 and AB is opposite that side length. Now, guys, we can use Pythagoras' theorem because BD is going to be the hypotenuse of the triangle, which has one side length here of 5, another side length here of 12. So we can use the fact that A squared plus B squared is equal to C squared. A and B are going to be our 5 and 12. We're going to have 5 squared plus 12 squared equals C squared. So that's going to be our C squared. 5 squared plus 12 squared. 5 squared is 25. 12 squared is 144. 25 plus 144, that's going to be 169. So we have 169 equals C squared. Now, guys, we can square root both sides. C is going to be the square root of 169. C is going to be equal, therefore, to 13. Now, where can we go from there, guys? Just like I was saying before, we can use Pythagoras' theorem in this bigger right-angled triangle here. We can see that there's a right-angled triangle which joins FBD. just like this. The right angle is down here. We have a base of 13, we have a height of 3, and the hypotenuse is going to be that length that we're looking for, the straight line connecting F and D. So what are we going to have? We're going to have a squared plus b squared equals c squared, where a and b are 3 and 13. So we can write in that 13 squared plus 3 squared is equal to c squared. 13 squared is 169. 3 squared is 9. That's going to be equal to c squared. 169 plus 9, that, guys, is going to be 178 equal to c squared. Now, guys, to find the value of c, we can do the square root of both sides. C is going to be equal to the square root of 178, which, guys, if we type into our calculator to 2 decimal places, is going to be 13.34. And that, guys, is going to be our answer for the length of the straight line connecting point F and D. I know that was hard, guys. Feel free to watch again. Hopefully it will make it clearer. How to answer questions involving 3D trigonometry in 166 seconds. Let's go. These questions, guys, involving 3D trigonometry are really going to put our visualization skills to the test. Let's have a look at this one. The question asks us to calculate the size of angle DFE. Now, first of all, which angle actually is DFE? Let's draw a line from D to F. Switching over to orange there, D to F, and then let's draw a line from F to E. And we can see pretty quickly, guys, that this is the angle we're looking for. Let's call it X. Now, we know whenever we're dealing with 3D trigonometry that what we want to be doing is looking for opportunities to create right angled triangles on our shape. And we can see pretty quickly that if we include this side length DE and draw a line like that, we have a right angled triangle DEF, which is going to look like this. We can also draw on that our right angle is down here in the bottom left hand side. Now, we also know maybe that whenever we're using SOHCAHTOA and TOA to find an angle, like in this case, we need to know 2 of the side lengths of our right angle triangle. We have our hypotenuse of the right angle triangle, which is 8, and we can also identify that this side length here, DE, is going to be 6. Why is that? That's because it's going to be the vertical height of this triangular prism, which we can see over here is 6 centimeters. So drawing that on, what are we going to have? We're going to have 6 centimeters over here. Now, guys, we can see that we have a right angle triangle linking D, E, and F. We have 2 side lengths, 6 centimeters and 8 centimeters, and we have this angle down here, X, that we're looking for. Now, guys, we're ready to use our SOHCAHTOA. What are we going to have? We're going to have, first of all, that the side length, which is labeled 6, is going to be our opposite side. That's going to be opposite our angle. And then the 8, that's going to be our hypotenuse. That's because it's opposite our right angle. So we know, guys, that we're going to be using which ones, SOHCAHTOA or TOA. Which ones are going to be? Let's write them out. We have SOHCAHTOA and TOA. Is going to be, guys, so. Why is it going to be so? It's going to be so because that's the one which includes the opposite and the hypotenuse. So we can write out, guys, the formula that so stands for is going to be that sine of our angle theta is equal to our opposite side length divided by our hypotenuse. Now, guys, finally, we can substitute in our values and see what we're going to get. We're going to get that sine of our angle, which is X, sine X, is equal to our opposite side length, which is 6, divided by our hypotenuse, which is 8. And finally, guys, we can find the value of our angle X. How do we do it? How do we get the value of our angle? We're going to do sine to the minus 1 of both sides, and we're going to get that X is equal to sine to the minus 1 of 6 over 8. Let me type that into my calculator, guys. Let's see what we're going to get. We're going to get that X is equal to sine to the minus 1 of 6 over 8. Typing that in, we're going to get 48.59 to 2 decimal places, guys. 48.59, and that is going to be our answer. How to sketch the key trigonometric graphs in 134 seconds. Let's go. Here, guys, we have a really quick reminder of all 3 of our trigonometric graphs. Let's have a look. First of all, y equals sine x. It's going to have this wave shape. It's going to start at 0, 0, go up to 91, over to 180, 0, over to 270 minus 1, and up to 360, 0. So, guys, the key facts are going to be the fact that it has this wave shape, the fact that it goes up to 1 and down to minus 1, and also the fact that it has a key point every 90 degrees. We have this first key point, second key point, third key point, fourth key point, and fifth key point. These are going to be the key points which are going to help us sketch the graph. What about y equals cos x then, guys? This one is going to be exactly the same as y equals sine x. It's just going to be shifted 90 units to the left. What are we going to say? We're going to say that we have this curve shape again, this wave kind of shape, just like with the sine graph. We have a maximum point of 1, minimum point of minus 1, and again a key point every 90 degrees. Finally, Finally, guys, onto y equals tan x. This one is going to be our odd one out. We can see the y equals tan x. Again, it's going to have a key point of being 0 units up or down every 180 degrees this time. We have one here, one here, one here, and one here. We have these asymptotes again at every 180 degrees, starting from minus 90 on this diagram. Next one's going to be at 90, next one at 270, etc., etc. And those asymptotes are going to be lines which our curve gets ever closer to, but never touches. We can see that we have this shape here, which gets kind of ever closer to minus 90 degrees as we go to the left, and then gets ever closer to 90 as we come to the right. This next one is going to get ever closer to 90 degrees as it goes to the left, and then ever closer to 270 degrees as it goes to the right. And this curve here starts at 270, just past it, I should say, goes up to 360, and then gets ever closer to 450. And this graph, guys, is going to repeat itself, but we're never really going to see it with more lines than this one. How to transform trigonometric graphs in 67 seconds. Let's go. Transforming trigonometric graphs, guys, is going to work exactly the same as transforming any other graph. Let's have a look at this one here. The question says, given the following graph of y equals sine x, sketch y equals sine of x minus 90. What are we going to do in this case, guys? We're subtracting 90 directly from our x, and what that means is that we're going to have a transformation of 90 units right. It's going to be in the x direction because we're doing it directly to the x, and because we're subtracting 90, we're going to be adding 90 units in the x direction. If you're not sure what I'm talking about there, guys, watch our other video on transforming graphs. It will hopefully clear it up. So, guys, we want to take this curve and transform it 90 units to the right. What's it going to give us? It's going to give us this curve here. We can see if, for example, I was to select this curve, well, let me select that. If I was to select this curve, move it 90 units to the right, it would look like this. And we can see that that overlaps our curve perfectly. And then all I've done is I've continued the curve down here following the sine pattern, and there, guys, we're gonna have our answer. Let me move that back. Hopefully that was very clear. We've moved our curve at 90 units to the right.
Questions like this, guys, which require us to use trigonometric graphs to find exact values of trig functions, have been coming up more and more in recent years. First, they're pretty tricky to get your head around, but once you've got it, they're not too bad at all. Let's have a look at this one. The question says, use the graph to find the values of cos 90 and cos 270. We've been given this graph. The graph is y equals cos x. We see that it starts up at 0, 1, comes over to 90, 0, 180 minus 1, 270, 0, and back up to 361. We need to find the values of cos 90 and cos 270. The graph is for y equals cos of x. So we need to find the value of y when x is equal to 90, and the value of y when x is equal to 270. We can come over to the x-axis, come to the value of 90, and then y is equal to cos x. We need the value of y at this value of x. What is the value of x when, what is the value of y when x is equal to 90? The value of y is 0, so cos 90 is equal to 0. Let me write that in. Cos 90 is equal to 0. Now, what about in the case of 270? We come over to 270 in the x direction, and we read across to the value of y. Again, we can see that this is actually on the x-axis, so the value of y is equal to 0. Again, we can say that cos 270 is also equal to 0. Now, just to make this clear, what about, guys, the value of cos 180? We go over to 180 in the x direction. We go down to our graph and we read across to the y-axis. We can see that this would be lining up with -1. So we could say that cos of 180 would be equal to -1. That, guys, is how we read values from our trig graphs. What we have to do is find the value in the x direction and read over to what the corresponding value is in the y-axis. Coming up right at the end of the course, guys, this is a pretty tricky topic to get your head around. Let's see what we can do. The question says, given the diagram, estimate the two solutions to sine x equals 0.6 for x is greater than or equal to 0 and less than or equal to 360. We can see that we've been given this graph of y equals sine x. It starts down here at 0, 0. Over at 90 degrees, it goes up to 1. At 180, it comes back down to 0. At 270, it's back down at -1. And at 360, it comes back up to 0. We want the two solutions to sine x equals 0.6 for the range of values x being between 0 and 360. Now let's break this down. So x is between 0 and 360. So this is the range of the graph that we're working with. And we want the two solutions to sine x, which by the way is equal to y, equals 0.6. We can have a look over at our y-axis, and we can see that we've been given the value for x when y is equal to 0.6. When y is equal to 0.6, in other words, when sine x is 0.6, the value of x is 37, and that is the value between 0 and 90. So one value of x, which makes sine x equal to 0.6, is 37. So we have one of our solutions that's been kind of given to us on the diagram. It's x equals 37. That is a value of x which makes sine x equal to 0.6. So we can say that one solution is x equals 37. Now, how do we get our other solution? We're going to use the diagram, and we're actually going to continue this horizontal line over to the other side of this curve. So I'm going to continue it over just like so. It's a little bit rough, but you can see what I'm trying to do. And then we're going to draw a line down to our x-axis. This value of x down here then is going to be the other value of x, which has a value of y associated to it of 0.6. It's going to be the other value of x, which has a vertical height associated with that point on the curve of 0.6. How then do we find this point here? We're actually going to use the symmetry of the sine curve. We know that this value is 37 above the point 0. We also know that the shape of this curve is the same from 0 to 90 and then from 90 to 180. So, in the same way that this value is 37 above 0, 37 to the right of 0, the other value is going to be 37 to the left of 180. So it's going to be 37 to the left of 180. Finding our value then, guys, we can actually do 180 subtract 37, 180 subtract 37, which is going to be 143, and that is going to be the other value of x, so x equals 37, or x equals 143. What did we do, guys? We used the fact that we've been given that when y is equal to 0.6, which means sine x is equal to 0.6, x is equal to 37. That's given us one of our values, and then we've used the symmetry of the sine curve to find the other value. In the same way that the first point was 37 to the right of this point, 0, 0, the other point is going to be 37 to the left of this point over here, 180, 0. So we do 180 minus 37, we get 143, and that is going to be our second solution to the equation.